Welcome to this particular video, and before we start the video, I want you all to mark your attendance in the comment below. In the comment, go to the comment section and write I am present and watching this particular course. That's a commitment that you are doing to yourself that I'm going to finish this course. So this course, as you can see over here, it's Java. It's basically a microservices architecture course that we are going to learn microservices architecture using Java Spring Boot. And we are not just going to learn about microservices, but we are going to build things while learning. So we are actually going to build a full-fledged e-commerce application. So it's an e-commerce project masterclass wherein we learn microservices using Java Spring Boot. Okay. See, it's not that kind of tutorial wherein you watch and learn. It's a kind of course wherein you go hands-on, you build things with me. That's what is expected over here. And we cover a lot of concepts around microservices because microservices is in need these days. A lot of job openings you see out there, demand for candidates with the knowledge of microservices. So this is all that we are going to cover, like Spring Boot. So Spring Boot, I don't go in depth into Spring Boot because that is not the scope of this course. We cover Spring Boot until we build the Monolith application. So I touch base on Spring Boot just to give you a refresher about Spring Boot concepts, APIs and everything. We build a Monolith e-commerce application first, and then we convert that Monolith e-commerce application. It's a simple app. We convert that into microservices. Now this I've done purposely to give you a gist of how a Monolith application is converted into microservices architecture. Because generally what happens is companies or enterprises, they start building products using Monolith architecture. And then when things scale, they realize, okay, they need a microservices architecture or they need to switch to microservices. And that is when you as a developer or engineer are asked to do that transition. So you should definitely have that sort of experience, understanding as to how you can navigate through. So that is why I've included this. We also cover Docker, Kubernetes, Kafka, RabbitMQ, Cloud Streams, Spring Cloud Streams, distributed tracing, API gateway, configuration management, service-to-service communication, inter-service communication, the recommended approaches. So we have covered a lot in the course. I have not mentioned all the points over here, okay? But a lot is covered and you're going to love it. And if you love this kind of content, and if you want to, if you want me to post a lot more of this, do subscribe to the channel, like, and let me know in the comments what more sort of videos I should bring on this particular channel. I read all the comments and I would be happy to see your inputs there. So without a further ado, I'm not going to take a lot of time. Without a further ado, let's jump right in. Also, one last thing I would like to mention, people who have taken my full stack courses, this is the next logical step to those courses. Okay, because after learning Spring Boot, and building a full-fledged application. So full stack courses, I have a lot of full stack courses, and one major course that I have, the flagship one, is the Spring Boot e-commerce full stack application. Okay, so that's a course wherein we build a full stack application using Spring Boot in a monolith architecture, not microservices. Okay, so yeah, this course is a next logical step after that one. If you have good knowledge, or even if you have not taken that course, this course stands on its own. It's not like that course is a prerequisite to this one. It's not like that. Okay, if you have taken that course, well and good. If you have not taken, that's absolutely okay. You need to have knowledge of Spring Boot, and rest we take you from there. Okay, so any sort of Spring Boot course or any sort of videos you have watched on the channel, those are going to help you. So without a further ado, let's jump right in. So now it's the time that we begin talking about the application that we are going to build. So I'll explain you the entire module, the components that we are going to have in our application and how things are going to function. So first of all, this entire piece in the center is our application. It has this database part, and this entire application is hosted on a server, as you can see here at the bottom. And then we have a browser or a client like Postman accessing our application depending on how he wishes to access. Okay, so if he's doing requests from the browser, browser will be the client over here. If you're making use of Postman, Postman will be the client over here. Okay, so here requests are coming into our application, and then application has different layers. Like this is the controller layer, then you have service layer, and then you have the repository layer. And finally, in the backend or behind the scenes, you have database. Now, controller is doing the job of intercepting all the requests that are hitting your application or hitting the server. based on the kind of request that has come in, it does the job of routing the request to different controllers. Now, you can see over here, the controller layer has different controllers over here, like user controller, product, cart controller, and the order controller over here. And depending on the kind of request, for example, if the request is coming in, which is related to creating a user, then the application would, or this particular request will be routed to this particular controller, which is doing the job of creating the user. If the request is coming in for product related task, it will be routed to this particular product controller. So likewise, for cart and order, the request will be routed, and at the controller level, the requests are handled by the respective controllers. Then once the request is intercepted on the controller layer, the request is forwarded to service layer, which contains the business logic, and at the service layer, the request is processed, and if there are any database related operations, the repository layer is taken into or taken help from. Now, service layer is the layer wherein all the business logic resides. Repository layer is the layer which does the job of interacting with the database, and controller is where all the requests are intercepted, right? Now, service will have all the business logic, like I said, and if database operations are needed, it will take help from repository layer, which acts as an interface to communicate with the database. And then with the help of repository, the application is going to do the job of communicating with the underlying database. So this way, the communication flows, and then once the response comes in from the database, the service layer takes the response and processes it, and then it forwards it to the controller, and controller will do the job of responding to the client, whoever requested. So you can see over here, the response flows back in the reverse direction. Okay, so this is the entire application that we are going to set up, we are going to build, and I just wanted to give you a complete overview. Yes, as we go further, we will be learning a lot, and we'll be building each and everything. But this is one overview, or I should say a high level overview of what to expect going forward. So I hope it's been useful and clear to you all. So now it's time that we begin creating our project. And what I'm going to do is I'm going to head over to Spring Initializer over here. Okay, and this is a website that will help us set up our Spring Boot project. So what I'm going to do is I'm going to select the settings that I want along with the details that I need to fill in for my project, select the dependencies, and then we are good to go. So I'm going to select Maven because Maven is the build tool that I'm going to make use for my project. You can select Gradle if you wish to. I'll make sure I select Java, the latest version of Spring Boot. Now, if you see any other version apart from 3.4.3, don't stress out. Okay, now there are new versions being released every now and then, so it's likely that you will see a different number by the time you're watching this video. But make sure you select the non-snapshot version, and you select any non-snapshot version that is available, and don't worry that, oh, I'm seeing a different version number, because there are not going to be a lot of changes there, or things would work fine like it's working for me. If there are any changes that are introduced in a new version, I'll make sure I update. Okay, so here what you need to do is here you'll enter the project metadata. So I'll enter the project metadata like the group is com.ecom, and here I'll say com.ecom, and I'll say ecom application. Okay, and the package name is automatically generated, but I don't want the package name to be something like this, so I'll say com.ecom.app over here. Okay, so this is something that you can define over here. What I would do is, I'm not liking this group, so I'll say com.app, and I'll have the artifact as ecom app over here, e-commerce application, and here I'll just get rid of this hyphen application. So this is the group com.app. This is the artifact, this is the project name, and this is the package name. Okay, and I'll select the latest version of Java, and here I'll come over and I'm going to add some of the dependencies. So first dependency that I'm going to need is the web, which is going to make sure that the project that we are working on is a web project based web project on Spring Boot. Okay, so we are going to build REST APIs, and here I'll say more, and I'm going to select Lombok. Now, what is Lombok? Lombok is an annotation library that helps us generate the boilerplate code. So basically, if you want to generate getters, setters, so all of that, you don't need to generate manually. But what you can do is you can just make use of simple annotations and Lombok will generate it for you. Okay, so it's really helpful to have something like this in our application. Okay, I'm just going to have these two dependencies right now because we can add dependencies while building as well. So to begin with, I'm just adding these two, and I'm going to say explore. You can explore the project structure from here as to what is Spring Initializer generating for you. Okay, you can see it over here. All right. If you take a look at pom.xml here, you're going to see the dependencies that have been added over here, right? So you can explore this, or you can directly click on generate. Now what generate will do is it will give me a zip file of this entire project for me to make use of on my local machine, which otherwise would have been very tedious to set up without the use of a Spring Initializer. So I would have had to set this entire thing up manually, which would be error prone, and it would be like cumbersome as well. So this is really easy, and I can click on generate and get the zip file onto my system. Now on your local machine, what you need to do is you need to set up your workspace. So I'll create a directory wherein I'll be creating all the projects and all the files that are needed for this particular thing over here. Okay, and I've added a zip file over there. And what I'm going to do is I am not going to make use of zip file, of course. So I'm going to extract it over here. Okay, and you will get this kind of a unzipped file, and now you can safely delete this zip file because you've unzipped it. Right now, once you have this unzipped file, what you need to do is you need to head over to IntelliJ, click open, and just make sure that you select pom.xml that you have got along with this particular zip file that we unzipped. Now here I'm on IntelliJ. Now, of course, I have been making use of IntelliJ a lot. So you will see a lot of recent projects over here. And if you're new to IntelliJ, you won't see these recent projects, right? But what I'm going to do is I'm going to hit open and navigate to the folder where I've unzipped that particular project. So now this is my project ecom application, which I've unzipped. I'm going to select pom.xml. Why pom.xml? Because pom.xml has the structure of the entire project. Okay, and it's one of the main files that exists in the application. So I'm going to say okay, and you can see IntelliJ identified it that pom.xml is a project file. So do you just want to open this particular file, or you want to open the project? So it's giving you two options. Okay, and this blue one is highlighted, open as project. So I'm going to select open as project, and it's asking me whether I trust the project. Okay, so I trust all the projects in this folder because that's the folder that I've created. Now this is important, the trust part, because sometimes it might happen that some malicious code on your local machine might get executed. So that is why it's asking you from the security standpoint. Now here on the right hand side at the bottom, it will do some sort of processing. You saw a little bit of progress bar over here, wherein all the dependencies were fetched, downloaded, and everything was set up. And all the dependencies that you added over here in pom.xml, okay, here you can see this dependency. These two dependencies, we have added only two. Okay, so these two, all the relevant library files for these two dependencies were added over here in the external libraries. Okay, so this thing is being taken care of by Maven because IntelliJ identifies this project as Maven. So if you see over here, this little icon, okay, beside this folder icon, it tells that this is a project, okay, Maven based project. And you will see this Maven icon as well, okay, wherein you can see like this ecom application is added as a Maven project. All right, so this is done, and you can try running the application. So you can go over here to Spring ecom application. This is a main file over here under this Java package, and just say run over here. Now the moment you say run, you should successfully see your application running up on the default port, which is 8080. Okay, so that is what you should see. You can see over here Tomcat started on port 8080. Right, so I hope you have been able to follow along this project setup steps, and I hope this has been helpful for you. So now it's time that we understand what we are going to build. So it's time that we structure our thoughts and go in a step-by-step way so that it's easier for us to build and follow the application. Right, now what we are going to do is we are going to pick this user module. Okay, and that is what we are going to build first. So we are going to build this user module, and we are going to have the controller and service layer for the user module. Yes, we are simplifying it. We are just picking things parts by part so that we go in an incremental fashion. And like I said, it should be easier to follow, understand, and build as well. Right, so that's the goal. Okay, we don't want to dump the entire application at once so that it becomes confusing as to oops, what happened. Okay, so we don't want ourselves to be in that situation, and that's why we are going step by step. So we'll first have the controller and the service layer for the user module, and this will be accessed by browser or a client like Postman, right? We are going to have a server also that will be running. So these two things will run on the server. So you will be sending requests to the controller and the response will be going back through the service layer. Okay, so let's focus on only this thing, and then yes, later on we will have many more components, like we will have the repository layer and all of that. Okay, we'll have other components or other modules like after user we'll have product, cart, whatever we want to build in. Okay, but let's go step by step. So let's build this. So now it's time that we start defining the functionality to fetch all the users in our application. So what I'm going to do is I'm going to come over here, okay, in the main package, and I'm going to create a new Java class, and I'm going to call this as user controller. Okay, because controller is the one who is going to handle all the API requests that would hit our server. Okay, so we have defined a controller, and we also need over here, so we would need some mappings created, right? So what I'm going to do is here I'm going to say public. Okay, let me start by creating a method public, and I'm going to say list of users over here. Okay, and I'm going to say find all, or you get all users. Okay, get all users, something like this. Okay, and I'll have this endpoint, and I'm going to say return, and we'll return a list of all the users. Okay, now this user is not defined, so we need to have a class that represents the user in our application. So what I'm going to do is I'm going to have a new class created over here, and I'm going to call it a user class. Okay, and I'll have certain attributes that would be representing our user. So I'll say first of all we have an ID from using which we can uniquely identify the user. I'm going to say private string first name, something like this, and then we can have a private string last name, something like this. Okay, so right now I'm having only 3 attributes. We can extend this later on. Okay, but for now let's begin with something. Now I have this user, and right now list is, it's not able to identify or detect list, so I'll just import this list from java.util. Okay, so this is done, and over here what I would need is I would also create a list of users. Okay, so I'll say private list, and I'll say list of user over here, and I'll say user list over here is equal to new. I'll have it as an array list. Okay, and from here I'll just say return a user list. Okay, so this is done, and then here I'll mark this as a REST controller. Okay, this is a REST controller. Now after marking this as a REST controller, I need to define the endpoint this would be representing. So I'm going to say a get mapping over here, because this is going to be a get mapping, right? And here I'm going to say /API /users, and then okay, I think we can leave it here. Okay, because we are getting all the users from here, right? So this is defined, and what I would do is let me run this application. Okay, so if we run this application, we now have a REST controller with our application returning some data. Okay, and you can see the application is up and running on port 8080. So now let us head over to browser. Our application is up and running, but we are getting a empty list over here, or empty data, no data whatsoever, because there are no users that exist in our application. So what we are going to do is we are going to create an endpoint that will enable us to add new users or register new users into our application. So I'll come over here to IntelliJ, and what we would do is I would come over here. Okay, instead of doing all the typing again, I would just copy this, duplicate this, and we would modify this as per our requirements. Now first thing, we want to create the users in our application. So this won't be a get mapping, but instead this would be a post mapping, because we are making some sort of changes in our application. Okay, we are not just getting data. Here we were getting data, so it was get mapping. Here we'll make use of post mapping. Now instead of get all users, I'm going to say create user over here. Okay, and I am also going to add the user, right? So what we need to do is we need to accept the object of user as to what user the user wants to add or what are details, right? So I'm going to say user over here, and I'm going to say user, something like this. Okay. And how will this data come in over here? So we need to add an annotation over here, which is request body. So whoever is calling the API has to add this details in the request body. Okay. And now then what we are going to do is I'm going to say user list dot add, and I'm going to add the user over here. Okay. So then we have the user. All right. And what we can do is we can return the list of user if you wish to. So basically the list of user which is the updated list basically. Okay. So this is done, and what I would do over here is now we can restart the application. Okay. And we are ready to test it. Now the application should be up and running without any problems. Okay, if you find any sort of issues, be sure to take a look at the code and where the issue is. So here you will see the stack trace just in case you find any sort of issues. Okay, now come over here. Since this is a post request, browser won't work for this, right? So for us to test whether this request is working absolutely fine, we need to make use of a tool called Postman again. So I have this tool over here, and I've opened it. I've created a new request over here, which is a untitled request. So what I'm going to do is I'm going to come over here. I'm going to take this endpoint and I'm going to paste it over here because the endpoint that we are triggering is same. Okay, so if you take a look over here, the endpoint is same. Okay, this is same as the get endpoint. It's just that on this endpoint, we have a post mapping, which is a post request. So you come over here, and instead of get, you have to select post over here. Now, of course, you can execute get request over here as well in Postman instead of just executing it in the browser. Okay, but I'll select post over here, and in the request body, what you need to do is you need to select raw over here, and we need to add a JSON. So you'll select JSON over here, and we need to add JSON over here. Now to add JSON, we need to create JSON of user. Okay. Now what does user have? It has ID, first name, and last name. So what I'm going to do is I'm going to take help of a tool called JSON lint over here. Okay, so search for JSON lint or JSON online validator and formatter. So you can search for JSON online validator. There'll be tons of tools that you will find in, but I personally use JSON lint. Okay, come over here and you can create JSON over here. So I'll simply come over here. I'm going to say first name over here. Okay, first name. Now what is first name? So first name, you can add first name as John over here, something like this. Add a comma, you'll have last name. Okay, what is last name? You can have Doe. Okay, we are just creating dummy users. And then here you can have ID. Okay, what should be the ID? ID can be 1. Okay, so just add this and just say validate JSON. Okay, so we are getting an error. You can see parse error, and the error is because we have added a colon in the end. Okay, so it should be a closing inverted comma. Okay, so this is done. This is taken care of. We can say validate JSON, and you can see the JSON is valid. Just copy this JSON. You can copy it from here. Okay, now we'll come over here and we'll add this JSON to the request body. Okay, now make a note, we have not added we are not passing this as a string. Okay, because this is a this is going in as a long. Okay, so let me try sending this, in fact. Okay, so I'm going to send this, and you see an error. So what is an error? So let us take a look at the error. Okay, now I'll show you how you can debug the error also. Okay, so you can see invalid definition exception. Okay, so it says util array, something like this. So the reason we are getting this error is because we have not added getters and setters here in our user class. So I'm going to add an annotation called data. Okay, this is an annotation coming in from Lombok. So if you go inside this annotation, okay, you will see this annotation is a single annotation equivalent to getter, setter, required args, constructor, toString, and equals hash code. So all these getters and set, all these annotations combine into the single annotation called data. So I've added this, and let me rerun the application and let us see if it works well. Now, once you add a Lombok, you are going to see this message, enable annotation processing. So just enable this, or if you don't see this message and if you don't see Lombok working, just come over here and head over to build execution. You can go to compiler and go to annotation processing over here and enable annotation processing. So just be sure this is ticked. Okay. Now coming back to Postman, if you trigger this, okay, we are still getting this. Now even after adding this annotation, it is not working. It is giving me this issue wherein it says there are no properties discovered, okay, for this bean serializer, which means that these properties are not exposed in user. Okay. Now it could be because this Lombok, the Lombok annotation that we have added is not working and it's not generating getters and setters, because getters and setters is what exposes all the properties that you have defined inside any class, okay, like user, for example, over here. So what I'm going to do is I'm going to tweak the settings a bit. So I'll come over here in settings. I'll make sure that I've selected annotation processing under build execution deployment compiler annotation processor. So how you can navigate is come over here, okay, go to this thing and then go over here under compiler annotation processing. Now this setting window, okay, for Windows user you will see the setting window over here under file, but for Mac users you will see something called as preferences in IntelliJ, okay, in the menu options. So just select that, okay, come to annotation processing. The window will be same. Make sure you have enabled annotation processing. Go to your application, select the application name, and make sure you select this obtain processors from project class path, and then say apply, and then say okay. And then after making these changes, so be sure to select apply, okay, don't close this just by saying okay. If you just say okay and don't select apply, then the changes that you have done are not applied, okay. So now you can see the changes are applied, okay, the selection is updated. But then come over here, say rebuild the project, so it will rebuild the project, okay, and then restart the application, okay. So then we need to restart. All right, so the application restarts now, and let us come over here. Let us try sending this request again, and now it works. You can see we have 200 okay in the response, and you also get this this response over here, okay. Now if you trigger the earlier request, which was API/users, and if you refresh this, you're going to see this request over here, right? So basically you can see the data coming in from the endpoint, okay. So yeah, this user is added into the application and this should be working fine, okay. Yes, there were some errors, but don't worry about the errors. Errors are natural. If you're building softwares, you should not be scared of errors. Be sure to check out the stack trace over here, okay. Stack trace is really important, and it will pinpoint the issue as to what issue you are facing, why you are facing. You can just Google some issues, or you can make use of AI tools to get some insights as to what the error is, okay. And then you can come over here, and like I followed all the steps, you can follow those steps to make sure Lombok is generating the stuff for you, okay. And with this, I believe you should be able to get the right response and the APIs should be working fine. So right now we have made some progress onto our application, and what is happening is we just have the controller that is managing all the logic of getting the users and also creating the users. But we need to add a service layer, which we have not added. So what I'm going to do is I'm going to come over here and I'm going to create a job, I'm going to create a user service, something like this, okay. And what I'm going to do is I am going to add a few methods over here, okay. So one method would be to get all the users and return the list of user, okay. So I can have a similar looking method over here as well, okay. So I'll say get all users, or I can call it fetch all users, something like this, okay. And it will return the user list, okay. And to return the user list, I'll move this user list into our service over here, something like this, okay. So this is done, and we also need to define the create user logic over here. So I'll come over here and I'll paste this over here. I don't need request body, because for service we don't need request body, because directly the parameter will be passed in from the controller, right? So create user is done, and I can say add user over here. I'll just rename this method to something else, okay. I'll say add user, okay, something like this. And yeah, we are done with this service. And now what I will do is I will add a service annotation over here. Okay, so this will mark this as a Spring managed component, and it will allow us to get this get the instance of this injected dynamically as well. Okay, now one thing I would like to highlight over here, what I've done is I've directly created a class of user service and I've defined everything into it. Okay, but if you want to promote modularity, what you can do is you can create a class of public service, sorry, not a class, an interface of user service over here. Okay, and then you can have an implementation that implements that particular interface. That is something you can do, and that is going to promote modularity into your code if you want to. Okay, for future from future standpoint, if you think that the implementations might change, but for me, I don't think implementations would change, and I'm directly defining it into a class. So both the approaches are valid, whether you create a interface of user service first and then you create a user service implementation that will implement that particular interface. Both the approaches are valid, but it all depends. The choice depends on your requirements over here. Okay, but right now I am just making it this way, and I'll get rid of this unused import over here. Okay, now what we will do is we'll come over here and we will point the user controller. We'll make use of user controller. We'll make use of user service inside user controller. So I'll get rid of this over here first of all. Okay, so I'll get rid of this list, and I'm going to say over here private. Okay, now over here we need to say private service because we need a instance of user service. So I'm going to say user service. I'm going to say user service, something like this. Okay, now Spring should auto inject a instance of user service over here because it's a Spring managed component. But for doing that, there are multiple things. One is you make use of auto-wired annotation. Okay, you can make use of auto-wired annotation. So this will make sure that user service is automatically wired to its instance. Okay, if you don't want to make use of auto-wired over here, what you can do is you can add a constructor over here. Okay, so you can say generate constructor, select user service, and this will make sure that user service is initialized and the instance of user service will be provided over here by Spring itself. Okay. Or alternatively, you can make use of Lombok based annotation over here. You can say required args constructor. Okay, required args constructor. Okay, and over here to this you can say final. Okay, something like this. Okay, so this is done. We have user service. So what this will do is if you go to requires args constructor, if you don't know what this is, it will generate a class with required arguments. Required arguments are final fields and fields with constraints such as not null. Okay, so since this is final, it is going to generate a constructor with this field. Okay, and tomorrow essentially if my requirement changes, let's say, and I don't want if I add a field, let's say, so if I say private user ID or private string user ID or private object user ID, object, and I can say user over here, for example. Okay, will it generate the constructor or will it add this particular thing into constructor? No, because this is not final, right? So don't worry about that. So I'll just get rid of this. I hope you understood and this made sense to you all. Okay, but this is done and we have this part over here. Okay, now what we need to do is here we'll make use of user service. So I'm going to say user service dot, and I'm going to say fetch all users from here. Okay, and over here I'm going to say user service again, something like this, and I'm going to say add user, and over here I'm going to say user, something like this. Okay, and what am I going to return? I'm going to return the user that is added or user list. Okay, so user list is what we are returning over here, right? But right now the fun part is we don't have the user list. So what I can do is I can in fact call this fetch users, or I can simply have void over here. Okay, so don't return anything, something like that, or return a message if you wish to. Okay, so you can have string over here and you can add a message like user added successfully. Okay, something like this. Okay, like so. Okay, so what we have done is we have added a service layer, and I'll just optimize the imports and remove all unnecessary import statements. Okay, so I've added a service over here, which is a service class. Okay, like I said, instead of adding a service class, you can add a service interface and you can create an implementation of that service called user service implementation, and you can implement the interface. That is one way of doing things. Okay. If you want to promote loose coupling and modularity, and if that's your requirement because you think like in future implementations will change, but that is not my requirement right now, so I'm not doing that. But I'm telling you different ways of doing same things so that you have a good grasp and clarity on the concept. Okay. Over here, like I said, there are multiple ways to get this wired. Okay, one way was making use of auto wired. Another way is by adding a constructor yourself manually, and other way is by adding required args constructor. Okay, so this is done, and let us run this application and let us see if this is working absolutely fine. It should, because everything is working, everything is added properly. So I'll just refresh this. You'll see like it's giving in the empty array, which means it's working fine. But what I will do is I'll make use of Postman itself over here. Okay. Now here in Postman, I have these two endpoints. So I'll just trigger this get user. So you can see 200. Okay. I'll also trigger create users. So I'll trigger this and you'll say user added successfully. Okay. This is a message. And here, if you come now to get the users, you will see the user has been added successfully. Okay. Now let me create a problem over here. Okay. And then we will talk about the solution as well. Okay. But creating problems is fun. So right now we have one user. Okay. Let's say I add one more user. Now, if you take a look at the way we are adding users is we are passing in the ID, right? Ideally, from a system design standpoint, you are not supposed to give the user or the end user who is making use of your APIs or application to define IDs in your application. Okay. Here what we are doing is we are exposing the endpoints wherein user can define IDs. IDs are normally system generated and user should not be able to define IDs because they are the unique identifier that exists in your system. So let me see if I get rid of this ID over here in the request, what happens. So if I create this user, let's say I'll keep the details same, John and Doe, and let me create this. It says user added successfully. Now if I try to get the user, you will see the ID is being added as a null. Okay. Why is it being added as a null? Because we did not pass it. So it's completely relying on the end user or the consumer who is consuming your APIs to add things like ID. And identifiers for every record, you have unique identifiers in your application. So ID is one such identifier. So identifiers should be system generated. Your application or the backend should generate it, and you should never give the control of this to your end user. Okay. So with this, we have a problem now. Okay. Wherein we need to have a better control on IDs, and we need to have a way that we should be able to define IDs in our application. Okay. So I'll close this with this problem and we'll come to the solution as well. So right now we have a problem in front of us wherein if we are creating a user without passing in the ID, the user gets created, but with the ID as that of null, which indicates that our application or the backend service that we are building does not have the ability to generate unique identifiers right now. All right. So why don't we do this thing? Let us take this up as a challenge. So I want you all to take this up as a challenge and make your backend application capable of doing things. Okay. We should have active participation, right? So come over here. I'm also going to give you enough of hints. Don't get scared. Oh, I have to do this challenge. Don't worry. I'm going to give you hints which will help you, or it will be enough of hand holding for you for being able to complete this. Okay. So let me tell you, here in user service, just before saving the user, just before adding the user, keep a track of a variable at the class level. Okay. That keeps tracks of IDs, and increment it and add it for every new user that is being added just before it is added. Okay. So just do that. I hope it's clear as to what we have to do. We have to make sure that every user that is being added has a unique identifier. So here basically just before adding the user, make sure the ID is incremented and set against a particular user. Okay. So attempt this yourself. If you're not able to complete this, don't worry. Okay. We all are learning. Don't get disheartened, because the goal of the challenge is to make sure you go hands-on. Okay. I'll tell you the goal. The goal is not to get the right answer in the first attempt, but instead it's to get you hands-on with writing code. The moment you start writing code, you will gain confidence even though your code is incorrect. Okay, so I want you to get into that mode of coding. So pause the video right now and attempt this. It's fine if you're not able to complete. If you're not able to complete, play the video and watch the solution. Welcome back. I hope you all had a chance to pause the video and attempt it yourself. Like I said in the hint, what we are going to do is we are going to create a variable to keep track of the IDs. So I'll create this variable, of course, at the class level and not at the method level, but I'm going to say private long over here, next ID, and I'm going to assign it long 1L. Okay. And I'll come over here. And just before I add the user into the user list, what I'm going to do is I'm going to say user dot set ID, and I'm going to say next ID plus plus. Okay, this is being taken care of. And then what I will do is, okay, we need to make one more tweak. I can rerun the application, but this part we are returning over here. Okay, here to the user controller, to the user control over here. Okay, so we can get rid of this actually, and we can just have void over here, and I can get rid of the return as well. Okay, so this is done. Let me rerun the application. Let us see if this works successfully. Okay, so this should work ideally, and application is up and running. Come over here. What I would do is I would say create the user, and this time you can take a look. So there are no users right now because we restarted the application and the variable list got reset. If you come to create user, let me create this user without an ID. You can see user ID successfully. And if you go over here, you can see John Doe being created with the ID 1. Now let me pass in an ID and let me see. So I'll try creating ID over here. Okay. And I'll say 2000, something like this. Okay. And I'll say send. Now user added successfully, but if you come over here, you won't see 2000 being populated. The ID would be 2. So even though the user is sending ID, okay, it comes in until service over here, the service layer. And here it is overridden by the actual ID that we are generating over here. Okay, that is what is happening. Okay. And once that is happening, it is overriding and then the user is being added. Okay. So irrespective of whether the user adds the ID or he doesn't, our application is fine because we are generating the IDs by ourselves and we are adding it to the user over here. Okay. And we don't need ID. So I'll get rid of this and I'll save it. Okay. But you understand this, why we did this, and you understand the importance of why we took this approach, because whenever you're working in an application, whenever you are allowing users to create a resource in your application, it's crucial that you don't give away the control of things like unique identifier for a record in your database. Okay, because this is a unique identifier that you should have control over. Yes, rest of the data like first name, last name, if you add more properties in user over here, like address and so on, then you can allow user to update it, add it, fetch it. All of that you can allow the people who are consuming your APIs to do. Okay, that's completely fine. But unique identifier is something not recommended. You should have control over it strictly. Okay, take a look at account number. So if you have a bank account, of course you will have a bank account, or you must have seen someone have a bank account. So you get an account number, customer ID. Do you have the privilege of defining the customer ID or account number yourself? No, right? Because that's a unique identifier for the bank, right? Using your account number or the customer ID, the bank identifies you. So that is generated by the bank and not by you. You cannot say that I want an account number like this or like that. Okay. He will tell you sorry, or the banker will tell you sorry. It is assigned by the bank and we have systems in place to assign it to you. So that's the example over there. Okay. You don't have control over the IDs. IDs have to be controlled by the application logic itself. I hope it's clear and I hope you had fun completing this challenge. If you are not able to complete, don't get disheartened. Like I said, what is the goal of the challenge is to make you go hands-on, and I don't expect a right output or the correct. You should not, it's not like you should not play the video and watch the solution, but you should get it right at the first attempt. It's not like that. So it's all about trying things. We are learning something new. So try things and it's time to grow as well, right? This will help you grow. Okay. So I hope this has been useful. So right now, what we need to do is we need to allow our end user or people who are consuming the APIs to get a particular user from our application. So what I'm going to do is I'm going to create a new endpoint for this. And how are we going to identify as to what user the end user wants to access? For example, if we have a multiple user, how do we know which user the end user wants to access from our system? So we will identify that with the help of something called as path variable. Okay. Now what does path variable mean over here? Okay. So if you come over here, take a look at this endpoint, or let me head over to Postman, take a look at this endpoint over here. Okay. So if I duplicate this one, let me duplicate this. Okay. So I duplicated this endpoint, and here, if you see, a path variable is a dynamic piece of value that is being added in the URL itself. Okay. So here I can add something called as ID over here. Okay. So I can create a URL something like this, which is localhost/API/users/ID. Now this ID part is dynamic and it can change. For example, today it can be 1, tomorrow it can be 2, it can be 10. So it depends on which user or what kind of data the end user who is consuming your application wants to fetch. Okay. For example, someone using the API wants the user with ID 1, he can enter 1 over here. If some other person who is willing to get the user 2, he can enter 2 over here. So this is dynamic. This part of URL is dynamic. And this is known as the path variable. Okay. Now this concept of path variable is pretty common in internet. Okay. So if you come over here and if I head over to Amazon, okay, everybody is aware of Amazon. Just search for Amazon and just select Amazon over here. So you can see over here, I'm on the official website of Amazon. And now you can search for anything. For example, I'll search for yoga mat over here. Okay. And I'll select any one yoga mat that I see. Okay. So I'll select this one. Now here in the URL, you can see some things over here. So if you take a look at this URL closely, you will see this. After DP, you will see this string over here. Okay. So what is the string? So if you copy this string and if you come over here and do Control F and search on this particular page, you will see this is the ASIN of this particular product. Now, what does ASIN mean? This is a unique identifier which Amazon uses to keep track of products. Okay. So if you come over here, okay, it is being used in the URL. Okay. Now, if you take a look at the URL, you have something called as ref is equal to and this entire part. So if you get rid of this part, okay, it's pretty long. I'll just get rid of this part. So you can see there are a lot of things like keyword over here and all of this keywords. Okay, so I'll just get rid of this part because this is just extra information that is being passed to Amazon as to how you arrived on this particular product. Okay, so a lot of tracking information is being sent. Okay, but I'll just ignore that. I'll just get rid of that. And you can see this is the URL of the product without the noise. Okay, so this part is dynamic, and depending on what value is being passed in over here, the appropriate product is loaded. So if I change this to MH to MD, for example, and if I press enter, okay, if there is no product that exists with this particular ID, okay, it's going to show you an error. You can see the error that we got. Sorry, we could not find that page. So if I go back, this is what we found. Now let me scroll down. If I search for any other product, okay, and if I open any other product, so for example, if I open this one over here, this will have a different ID over here. You can see this is the ID. Okay, let me get rid of this ref, like everything that starts with ref. So you can see this is the unique ID for this particular product. Okay, and if you search for this on the entire page, Control F and search, you will see this is the ASIN. Okay, now based on this, Amazon is deciding which product to load here in the interface. Okay, that's a unique identifier. So this is pretty common, like a website like Amazon using this as a concept. It's pretty common in the internet world, wherein if you are checking out something on a particular website, it's likely that there is a unique identifier in place, which is helping that website provide a better user experience so that the user can see the right things in front of it. Okay, so I'm going to switch over now back to our application. So now in our application, we are going to make use of something called as ID. Okay, this is going to be a path variable like that of Amazon we saw. Okay, and yeah, this is going to help the application identify as to which user you want to fetch, because this endpoint is going to allow us to fetch a single user from the application. Okay, so I'll come over here, and since it will be a GET request, I'll just duplicate this one over here. Okay, I'll just duplicate this. And here in the end, I'm going to add something called as this, and I'll say ID. Now, what happens is when you add this kind of a syntax in the URL, you are telling Spring Boot that, hey, this part of the URL is dynamic and you have added ID over here in between, right? So what this tells is that this part between these two curly braces is the variable that accepts this dynamic part. Okay. For example, if you're passing in 1 over here, ID is the variable that will accept this. Okay. And you can have ID defined over here. So you can say long ID over here, and you will have to add a annotation over here called path variable. Okay. So this tells that look for this ID in path variable. Now, where is this ID? This ID is over here, and this ID has the same name. So this is going to, whatever you pass in over here is going to be added over here, and this will come in as a parameter over here. Okay. So I hope this is making sense. Now get all users, right? So I'll say get user. Okay. Get a user, something like this. And instead of returning a list of user, I'm going to say user over here. Okay. And of course, this needs to change now. So I'll say get user or fetch a user. Fetch a user, something like, or fetch user. Okay. And I'll pass in an ID over here. Now this does not exist. So I'll get this method created here. Okay. And now what we will do is we will have to actually compare and get the user. Okay. So we'll have to compare the ID of all the users. So I'm going to make use of a for loop over here. I'm going to say for every user, okay, for every user over here, okay, from all the users list, okay, and I'll say if, add a if statement, if user dot get ID dot equals ID over here, okay, then in that case, you will return, what you return? User over here. Okay, so you return this particular user because there's a match and the ID of this user has matched the ID that you have passed in. Okay, that is something that I'm going to do over here, and I'm going to return null over here, something like this. Okay, so this is something that I'm doing over here, and I think this is it. Now let me run this. Let us run and let us see if this is working absolutely fine. Okay, so you can see the application worked fine. And if you come over here, instead of this ID now, you can pass in 1 over here. And let me trigger this. So you can see 200, okay, all right. I'm not seeing the response though. Okay, ideally, I should be seeing the user over here. So I'm not seeing the response because there's no data. So if you try to get all the users, there's no data, right? The data got cleared. So I'll just create one user and I'll just try to get the user. So you can see we are able to. Now if you add one more, okay, if I add John 1 and John 2, Do 2, and if I say over here 2 over here, so this is going to return John 2, Do 2 to me. Okay, so this is working absolutely fine, and you can see over here. So if I add 22 over here, you can trigger this and you will see no data or nothing over here. Okay, but yeah, here you are seeing 200. Okay, so request was successful, but there was no data that came in. Okay. Now you should have better control over this wherein you are getting 200. Okay. So ideally this can be like you should have a control on status code wherein if you want to pass in some other status code, you should be able to. Okay. So we'll be taking a look at that as well. But right now this is working absolutely fine. So if you add 1 over here, you get the right user. All right. So I hope you are able to follow this. Okay. So I'll say get a user over here. So I hope you have been able to follow along and understand as to what we are doing and why we are doing. And I hope this has been useful. So right now, what we are able to do is we are able to get the user with the help of the ID in the path variable. So here, if I say 1, I get this user ID 1. If I say 2, I get the user with ID 2. Okay. But if I say 3, I don't get any response, but I get a status code of 200. Okay. Now, how would I customize this status code? Right now, it seems that I have no control over this status code. This is decided internally by Spring Boot, and I'm getting 200 okay, irrespective of whether I get any sort of result or not. Now, when you're working and building REST APIs, there is a way wherein you can have better control on what sort of status codes are sent. Okay, and that is with the help of ResponseEntity. Now, ResponseEntity allows you to wrap the response in it, and basically you can return it in the controller. So let me show it to you as to how it works. So if you come over here, okay, I'll come over here in the controller. Now here in the controller, before customizing anything, what I would do is I would type in response entity first. Okay, so I'll show you the package. So here you can see this response entity, org.springframework.http. Okay, so there is no sort of additional dependency or anything, any sort of configuration you need to do. This is coming in from Spring Framework, as you can see over here. Okay, so this is a response entity, and you can see it allows you to wrap an object type over here. Okay, so that is something that we'll do over here. Okay, this is one. Another thing I want to talk about, or another class that you should be aware of, is HTTP status. So this is also coming in from the same package. If you see over here, HTTP status is coming in from org Spring Framework HTTP. Let me select this and let me hit control. So if you continue pressing control, this thing will be converted into a hyperlink. And if you click on this, you'll go inside this particular class over here. Okay. Now here you can see this download sources option over here. Okay. Because this is a decompiled class file. Okay. So if I say download sources, it will download, and you can see here at the bottom, downloading Maven library sources and documentation. So it is getting documentation for me, and you can see the documentation now over here. Okay. So this particular class HTTP status is the enumeration of status code. You can see it's enum status HTTP status. Sorry, it's not a class. I had told that it's a class, but it's a enum. I'm sorry about that. Okay. Now here, if you see, okay, you'll see you have access to different status codes over here, which is okay. You can see what is okay, 200 okay. So here you are getting in the endpoint, you're getting 200 okay. So this is being returned over here. Okay. Created is 201, accepted, no content 204. So there are all sorts of status codes over here. If there is a redirect, you will have status code related to redirect as well. You can see temporary redirect, permanent redirect 308, bad request, unauthorized. You can see payment required, forbidden, not found. A lot of status code. So all the status code that you can imagine, you'll find them all over here. You can see internal server error 500. Okay. And with the help of this HTTP status, you can make use of these status codes. So here you can see HTTP status dot, and you can see internal server error, bad request, not found. Okay. So that is something that you can access. And along with response entity, you can define the status codes that you want to have for the user for a particular scenario. Okay. Also, if you see over here right now, there is no consistency in the response in the controller. So one is returning list of user, other is returning user, and then you have string. So you can bring in a little bit of consistency over here with the help of response entity. Okay. So what I'm going to do over here is for get all users, I'm going to say response entity over here, and I'm going to wrap it inside this response entity. Okay. And here, what I can do is I can say over here, response entity. You can see response entity. I'll say dot okay. So there are two ways now of returning. One is this response entity dot okay over here. Okay. And if you run this, you will get okay as a response. All right. Now, if you go over here, okay, it is giving okay as a response. You can see status set to okay. All right. But there is one more way. So instead of okay, what you can do is you can say response entity, something like this. Okay. Like so over here. And then over here, you can say comma HTTP status, something like this dot. And I'll say, what do you want to say? So you can say, okay over here as well. Okay. So there's something you can do. And this has to be object of type response entity. So this will be new over here. Okay. So I'm getting an error over here. Okay. So what's the problem? Oops. So let me get rid of this entire thing over here. Okay. So this is working fine now. You can see over here. So this is another way of writing the same thing. So I showed you two ways. One is this, and other way was over here without this new keyword. Okay. But response entity dot okay, something like this. Okay. So, and closing things over here. Okay. Oops. So you go over here and you go back like so. Okay. So these are two ways of doing the same thing over here. All right. So you can choose whichever way you want. All right. And here also you can make use of response entity. So let me run this first and let us see how response entity behaves with just if we use it in just one controller endpoint. Okay. So it's up and running. If you come over here to get users over here. So this is get users, actually it should be plural. if I send this, you'll see 200 OK. And you can create the user and you'll get 200 OK. Now I can customize this. Instead of sending 200 OK, I can just say to HTTP status OK and not found, something like this. Okay, it's my wish. I'm having control over status codes now. So even if I'm getting the response, I can just send not found. Okay, it's totally my choice. You come over here, you send this, you'll see not found. Okay, but you're getting the array as the output. So if you create a user, if you come over here, you can see user is getting, you're getting the users, but you're getting 404 not found. Why? Because you're sending it, you're customizing it, right? So you have better control on this now. I hope this is making sense as to what is the importance of response entity. Okay, but we are getting the response over here. So sending not found is not good. Okay, this was just to demonstrate to you all. So I'll just have OK. And I'll also take this on a new line, something like this. Okay, so this is now clear to you all, right? Now, likewise, what we are going to do is here, we are going to modify or add response entity for all the other controller methods. So I'm going to say response entity, something like this over here. Oops. So it will be user over here. And over here also, I'm going to say response entity dot OK. And I'm going to add this. Okay. So this is done. And for this also, I'm going to add response entity over here. Okay, so I can say response entity and then it's of type string, something like this. And then over here, you can say response entity dot OK. And you can have like so. Okay, so if you run this now, okay, so I'll just close this HTTP status over here, the status class that was open. So the application is up and running. And now if you come over here, you should see, okay, so this is working fine. You can create the user. This is also looking fine. You're getting the response over here. This is also looking fine. You're getting this user over here. And if you try to get a user, so you're getting 200 OK over here. All right. So if the user is not found, what you can do is you can throw like user not found or 404 or something like that. So here, if you come, okay, so if you are getting the user over here, okay, let me go to user service. Okay, so you are fetching the user. So you are returning user over here. Now, if you come to controller, okay, so what I will do is I'll add a check over here. Okay, so I'll say user is equal to this. Okay, and I can say if user is equal to null. Okay, then in that case, response entity dot not found. Okay, something like this. So this is something that we will return. So return response entity dot not found. Okay, but it has to be of the user type. And we're getting this red mark. So here we need to say dot build. Okay, so this is done. And this is again throwing an issue. Okay, so response entity dot OK, and this will be the user over here. Okay. So this is done in my opinion. And if I restart, let me restart and let us see how this behaves. So yeah, the application is up and running. Now, if you come over here, if you try to get a user who does not exist, so you would get 404 not found. You can see 404 not found. And now if you create a user and if you try to access the user that exists in the system, so you will get 200 OK. But if you say give me 2, it won't work. Okay. So now with this, we have really good control over the API is what I would say, right? What do you think? So with the help of response entity, I hope this is clear to you as to why we are making use of response entity and how it is helping us. Response entity is pretty common. You will see it in a lot of your projects. And if you are already a Spring Boot developer, it's likely that you are aware of what response entity is and its importance. I hope this has helped you and I hope you found this to be really valuable. So right now we are making use of Java version 8 and above. And of course, we should leverage some of the Java related features. So right now we have, if you take a look at this in this user service, here we are making use of for loop for going through the user. right? Or the user list. So what I'm going to do is, just to find the user, we don't need to write a for loop. Instead, we can make use of some modern features that exist. So what I will do over here is I'll make use of streams. So I'm going to say user list. I'll convert this into stream. And then I'll say over here, okay, 1 second. So I'll convert this to stream. Then I'll say filter over here. Okay. And inside filter, I'll say for every user, what you do is you give me user.getID dot equals, and if it equals ID, then I'll get this and I'll say find first, something like this. Okay. Now, the moment you add this, what this will do is this is returning an optional of user type, right? This is returning an optional. So we will say make fetch user return optional. So this will return an optional. This is now wrapped in optional. Okay. And if you come over here to the controller, okay, this is now returning an optional. So what you can do is you can basically optimize this as well. Okay. So I'll get rid of this completely over here. Or 1 second, before getting rid of this, let me add the new code. So I'm going to just add one return statement over here. Return user service, user service over here, dot, I'll say fetch user ID, which is the ID over here. Okay. Now this is returning an optional, right? So what I will do is I'll say dot map over here. Okay. So you can make use of map, and if it's found, then you will say response entity. Okay. Over here. Okay, so you are making use of method reference over here, and then over here, or else you can say, or else get, say I'll have a response entity dot not found dot built. Okay, and I'll add a semicolon in the end. Okay, so this one line is a replacement of this entire thing over here. Okay, and this new approach is much more concise, readable, makes use of modern syntax in Java. So what we are doing is we are calling fetch user over here. This is returning optional of user type. You can see this return type also mentioned over here. Then we are saying if it's found, then what you do is, so you can see over here, map. So if a value is present, returns an optional describing the result, applying the given mapping function to the value. Otherwise, returns an empty optional. Okay. So if the mapping function returns a null result, then this method returns an empty optional. Okay. So what we are doing is we are saying response entity okay. Okay. So if whatever response we are getting, we are saying response entity okay. Okay. Otherwise, we are saying not found over here. Okay. So I'm getting rid of this over here. Okay. And then let me rerun this. Let us see if this is working in the same way. So ideally it should. Now if I come over here and if I try to query second user, I'll get not found. You can see. Now if I create one user and if I try to get the first one, I'll get the first user. Okay. You can see this. So it's working exactly the same way, but with a much more concise and better syntax. So I think this is it. We have successfully I hope you have successfully understood the changes as to what we did and why we did. I hope this has been useful. So far, we have built quite a few APIs, and what are we going to do next is we are going to have a way for our end users who are making use of the API to be able to update the user information in our application. So here we have this user entity. We are having the mapping for, we are having the endpoint for getting all the users, getting a particular user. Even we have an endpoint for creating the user, right? I would want you all to take this up as a challenge wherein you create an endpoint which will enable the end users of our application to update a user information in our app. Okay. So basically I need something called as put mapping to be created. Okay, and this is, you can take this up as a challenge. Now remember, the goal of this challenge is to get you hands-on with writing code so that you can build enough confidence. Now, just by watching me doing things, you're not going to learn things. Yes, of course, you're learning things, but you will actually learn and get into the zone of programming by actually doing stuff. So I would encourage you to pause the video right now and attempt this endpoint. And there are no right or wrong answers over here. Even if you're not able to complete it, that's completely fine. Even if you feel the need of playing the video and watching the solution a bit, that's absolutely fine. But just be honest to yourself and give it a try, an honest try. And if you are able to do it, well and good. If you're not able to, that's absolutely okay. I've always said the goal of these challenges is to get you hands-on with writing code, okay, so that you can learn faster. Okay, so pause the video right now, come back, play the video, and watch me do the solution. It's time that we take a step forward and we allow our end users who are consuming the API to update the user information in our application. So what I'm going to do is we are going to have a separate endpoint for the same. But before defining the endpoint now, I'm going to first define the service over here, right? Now, what do we need in the service? So in our service, basically what we will do is we will scan through this user list and we will update with whatever updated information user has passed into us. So the user will share this or share the updated information from via the controller. Okay, so this will be called via the controller. So what I'm going to do is here, I'm going to say public and I'm going to say Boolean update user over here, something like this. And here I'm going to say long ID and I'm going to say user and user, or let's say updated user, something like this. Okay, so this is something that I'm going to get in. Okay, so here this contains the ID of the user that we want to update, and this is the updated user information. Okay, so these are two parameters that we need. Now simply I'm going to write return. I'm going to say user list dot stream. I'm going to say filter over here, and I'm going to say user, and here I'll say user dot get ID dot equals ID over here. Okay, so if this happens to be true, then I'll say find first. Now after the user is found, I'll say dot map over here and I'll say existing user, and here I will say existing user dot set first name, and we'll say updated user dot get first name. Okay, and then I'll say existing user dot set last name. Okay, and I'll get the last name from the object that we have received, and then I'll say return true over here. Okay, so this is done, and otherwise I'll say or else I'll say false over here, something like this. Okay, so this is taken care of. So what we are doing is we are first finding the user that we want to update whose ID matches the one that is passed over here. Once we get this, we are actually making use of map to update the existing user information. This is the user that is found. And once this is done, we are returning true. Otherwise, we are returning false. Okay, so this is the function that we or method that we have written over here. Okay, now what I will do is I'll come over to controller and I'll duplicate this over here, something like this. And here, since this is an update call, I'll make use of put mapping over here. I'll say API/users and I'll say ID over here, because whenever we are updating any user, we need its ID information. So we are accepting the ID of the user that we want to update in the path variable over here. And then over here, I'm going to rename this to update user over here. This is done. And then we have this request body, which is the user. Okay. Now this user is actually the updated user. Okay. Which this is not a normal user. This is an updated user with the updated user information. Okay. I'll accept one more parameter over here. I'll say long ID over here, something like this. And I'll say path variable, something like this. Okay. Now over here, okay, I'll take this to new line. And here I'm going to say, so here I'm going to say Boolean updated is equal to user service dot update user, and you have to pass in ID and updated user information. Okay. Now over here you'll say if updated, then what we will do is we will return response entity. So wait a minute, let me copy this. So response entity dot okay and user updated successfully. This is what we'll return. Otherwise we'll say response entity dot not found dot build, something like this. Okay, and I'll add a semicolon over here. which we have missed. Okay, so this is what the endpoint is going to look like. Now what I will do is I'll restart the application. Okay, it's a pretty straightforward endpoint. We have the updated user information over here, and we have the ID that is coming in through path variable. So we are making use of request body and the path variable in a single go. All right, come over here. Let's create a new endpoint. So I'll duplicate this because the create user endpoint closely resembles the update user, right? So I'll say update user over here, API/users/1, and we have this body over here. Okay, so now what I will do is first I will create the user. So let me try updating this user. This user does not exist. So now you'll see, okay, method not allowed. All right, let me see what is not. Oops. So instead of post, it will be put. Okay, let me run this now. So you will see not found over here, which means that this user was not found. Why was it not found? Because there are no users in the system right now. We have restarted, right? So I'll just say create a user. This user is created. Now, if you try to get the user, you will get one user. Okay. Now let me update this to John updated over here, and I'll say do updated, something like this. Okay. So right now we are getting John to do to. I'll send this user added successfully. Oops. So it should not be user added successfully, but in fact it should be user updated successfully. So I forgot to update this message, which is absolutely okay. All right. But user added successfully. Okay. Which means it was updated. And here, if you see John and do updated. Okay. But I've actually updated the message. So now if you restart this, okay, it should work fine. All right. So application is up. If you come over here, let me create this user. If you try to get this user, you get John to do to. If you trigger this, you will see user updated successfully. And now if you try to get the response, you will get John updated, do updated. So this is working fine. Absolutely fine, I should say. How does this work? So here in the put mapping, we are accepting ID as the path variable. Okay, there are two things we need first of all. So whenever you're designing the API, okay, think of it this way. Whenever you're designing this endpoint, what do you need for making sure that the updation of the user is successful? You need two things. One is you should know which user you want to update. Second is what you want to update or the updated information. Okay, so these two things you need. So which user you want to update, how will you know in your system? With the help of a unique identifier. Okay, what is a unique identifier in your system? It's ID. So you need to accept the ID from the system or from the user, right? Then you need the updated user information, right? Which means like all the updated stuff that you can accept in the request body, like you are doing for creating the user, right? So this you are accepting as a path variable over here, okay? Because you are already using it over here as a path variable for getting a user. And then you are accepting the updated user information in the request body. And you are doing this again in another API, which is when creating the user, this one, right? So you combine these two, path variable and request body, into one, and you have created this put request, and you are handling it this way. And here in the service, what you are doing is you are making use of this thing over here, and you are updating all the information with whatever updated user object has. All right. So it's pretty straightforward. Controller is calling the service is getting back to the controller with the response. And here Spring Boot is doing an amazing job wherein, just by adding annotation request body, okay, the JSON that you're sending in the request body over here, the JSON that I'm sending in over here, for example, this JSON, this is automatically being converted into this object type by just adding this annotation, So that's the beauty of using this framework. And there are a lot of things that are being abstracted from you. You have to just make use of annotations and all, and things are taken care of, So take a look at this. This ID is being passed over here. Where does this ID go? You just have to add this path variable, and you have to keep this name same over here to what you have added over here. And it just comes and sits over here. It's so amazing. So I hope you have been able to follow along, and I hope this has been useful. So I want to take this opportunity to talk about request mapping annotation. Now, request mapping is an annotation that is available in Spring MVC to map a web request to a specific method within a control class or even a controller. Okay, so let me talk about both the things. So first of all, I want to mention that this particular annotation can be used at the method level over here, and also at the controller level. Okay, so we'll talk about both. First, we'll talk about the method level. Okay, so here what we are doing is we are making use of get mapping annotation. What does get mapping mean? Get mapping means, so if you hover on this, you'll see the documentation. It says annotation for mapping HTTP get request onto specific handler method. Okay, and it's a shortcut for, so can you see over here? It's a shortcut for request mapping method is equal to request method dot get. Okay, so can you see this? So it's a shortcut actually for making use of request mapping annotation. You can see over here, you can specify the method over here. Okay, so let me comment this out over here. Okay, so let me define this method with the help of request mapping. So I'll say request mapping over here, something like this. Now over here, I can pass in parameters. So the first parameter that I'll pass in is the value over here. So here I can say value. Now what is the value? Value is the value of the endpoint. So here it's /API/users. Okay. And then over here, you'll have to define the method. Okay. So what is the method? Method is request method dot get over here. Okay. Now what is request method? If you go to request method over here, it's an enum. So you can see it's an enum over here of HTTP request methods intended to use with request mapping dot method attribute of request mapping annotation. And it has stuff defined like get, head, post, patch, delete, put, trace, options and all. Okay, so all the types of request is added over here. So it enables you to define it this way. And if you stop and run this, okay, if you stop and run this, it will work the same way like it was working for get mapping. Now if you come over here, okay, and if you go to get users, and if you trigger this, you'll see 200. Okay, and if you create a user, and if you say again get the users, you'll see users you are getting. Okay, so this is working absolutely fine, and this is how request mapping can be used at the method level. Okay, so it basically simplifies the URL pattern that a particular method can handle. Okay, but in my opinion, get mapping is much more concise over here. This is a far more longer sort of syntax. Okay, you have to write a bit more over here, but this is much more concise and it is used more often. But I want to tell you about this also because you will find code bases that are making use of request mapping, and I don't want you to get confused about that. Okay, but I'll just switch over to the get mapping annotation. Okay, so now you are aware of request mapping over here. Okay, now request mapping can be used to add you can add post request also over here. Okay, you can define put request also over here. So depending on what sort of request you want to define, you can add the appropriate thing over here. Okay, now request mapping, this was request mapping at method level. Now let us talk about request mapping at the class level. Okay, so at the class level or the controller level, a request mapping can be used to set the base URL path for all the handler method within that particular class. Okay, now what does this mean? Base URL path. What does this mean? So I said base, it is used to set the base URL path for all the handler methods of the class. Okay, so take a look at all the URLs over here or all the endpoints. This is /API/users. This is /API/users/ID. This is /API/users. /API/users/ID. So what is there in common in this entire controller? Yes, one thing is common, which is /API/users. It is common across all the endpoints over here. So rather than repeating /API/users, what you can do is you can have a request mapping annotation applied at the class level, and you can have this as a base URL /API/user for this particular controller over here. Okay, and whenever any request is sent at /API/users, that request will be sent to this particular controller, and then whatever is the forward URL or URL ahead of that, okay, that particular method will be called or executed. So let me show you how it works. So I'll come over here. Okay, and here at the top, I'll say request mapping, something like this. And over here, I am going to say /API/users. Okay, so I've added this. Now I don't need to repeat /API/users over here. So I will simply get rid of this from here. Okay, from here also I'll get rid of /API/users. From here also I'll get rid of /API/users. So you can see there is very less repetition now over here. Okay, so you can see how things have gone simple now, right? And now anyone taking a look at this over here will know, like, hey, if there is any sort of request that hits this endpoint, okay, so that particular request will be redirected to this particular controller. Okay, and for Spring Boot, if you're sending in request /API/users, it will come to this controller. And then if you're passing in ID and it's a GET request, so it will come over here. If you're passing in an ID and it's a put mapping, it will come over here. If it's a post request, it will come over here. If it's a GET request, it will go over here. So depending on what is there ahead of this base URL, the appropriate method is executed. Okay, so I'll rerun this and let us test if everything is working absolutely fine after incorporating request mapping into our controller. Okay, so if you come over here, first we'll try creating the user. Okay, so you can see user added successfully. We'll try getting the user. You can see you're able to get the users. We'll try getting one user. You can see it's working fine. We'll try updating the user. So you can see updated successfully. Now, if you try to get the user, you'll see the updated user. If you try to get all the users, you'll see updated users, and everything is working normally for the end user who is consuming your APIs, as like nothing has changed in the hindsight. But behind the scenes, you have actually added request mapping and pushed out an update, and basically you have simplified the URLs of individual controller methods, right? So I hope you are now clear on the significance of request mapping annotation. Okay, if you take a look at request mapping annotation, it is so if you go inside over here, okay, you can take a look at the documentation as well. You can see annotation for mapping web requests onto methods in request handling classes with flexible method signatures. Okay, so this is the entire documentation for the same. Okay, and yeah, it's one of the annotations that you should be aware of, because a lot of projects make use of request mapping annotation, right? So I hope this has been useful, and I hope you have been able to follow along. Now it's time that we begin talking about JPA. Now, what is JPA? So JPA stands for Jakarta Persistence API, and it's a framework that helps Java application store, retrieve, update, and delete data in the database without writing complex SQL queries. Okay, so let me explain this as to how things work when we start talking about JPA. It makes our life much more easier, and it makes working with database a lot simpler. Okay, so imagine this. Okay, so let's say you have this kind of a class created in your application. Okay, and this is representing a user, and it can be any sort of user, or it can be any other class. Okay, I'm just giving you an example over here of a user class. Okay, so you have this kind of a class, and you have these fields like ID, first name, and last name. And now you would want to store this information into the database. Okay, so you would want to have a database table, something like this. So you would have ID, first name, and last name, and you would have information like for user ID 1, user with ID 1, you have first name as Michael and then last name as Cole. Okay, so this is how you are storing information, and you have a class that is representing the information that is representing the user. In traditional Java world, you would have to create this particular class with these columns. For example, ID, first name, and last name. These columns and this table should be manually created in the database so that the table can store this information for this particular application. But with JPA will do the automatic translation of this particular class to this table. Okay, so it will do it automatically without you being involved. That's the magic of JPA, and that's how it makes your life much more easier. Now, at this point in time, it might not look like a huge benefit because we are just taking a look at a small class and a example over here. But in reality, there could be like you might have a lot of entities in a complex project, right? And you might have tons of classes representing them. There would be relationships between them. So you might have foreign keys or mappings being created amongst them. And creating this table or translating this requirement into a database is a task. And I've been through this. Okay, so I've been working with Java since even in the days when JPA did not exist. Okay, so I have created those tables manually. I've done that work. Okay, and it's really cumbersome, wherein things, you are prone to errors. You can make errors, you can make mistakes because, you are doing stuff manually. So in that case, what JPA does is JPA comes into picture and it would automate this thing, and you don't have to worry about doing this thing manually. So talking about some of the advantages of JPA, number one, it's easy and simple to follow. It's much easier to write and understand rather than handwritten mapping. Also, JPA makes querying data easier. It helps us write queries in the form of entities rather than SQL. It also helps us save and update objects without using any sort of data manipulation language for SQL at all. Okay, and JPA is very easy to integrate with Spring Boot. Okay, now when I talk about integration, okay, we have something called as Spring Data JPA. So if you search for Spring Data JPA, okay, you can see over here, it's basically a part of Spring Data family, and it makes easy to implement JPA based repositories. Okay, so you have to just make use of this Spring project. This is a Spring project that exists, and it enables you to add all these features wherein as a developer, you can basically work with databases, persist data in a very easy way. Okay, so this is a project, and if I have to give you an example of how cumbersome things are without JPA, so take a look over here. Okay, so you have this example over here wherein we are making use of manual SQL. So I've written this code in my early days. Okay, so I know this code. So you have connection, you first create a connection, and with the help of driver manager, you get the connection. Now here, what you're doing is you are mentioning the protocol, the type of database. So protocol is JDBC, type of database, you're mentioning the connection string and the database, and you're also specifying the credential. And then you're preparing a statement. So this is a dynamic statement that you're preparing. You can see over here, it is having a question mark. So basically this value over here in the next line. So you can see statement dot set long. So this value is being substituted in the placeholder over here. So you're making, or you're preparing this statement over here. Then you are substituting the values here, and then you are getting the result set after executing the query. So you're executing the query manually and you're getting the result set. Now result set might have multiple rows, right? For example, if there are multiple users that match this ID, you have to iterate through this result set, and you have to basically do whatever you want to do with that data. So this is really cumbersome. Now take a look at the JPA based approach. You know, you are making use of a repository. You are saying user repository dot find by ID. So here you are writing an SQL in Java code. Here you are just making use of a method find by ID. You're mentioning like what is the ID, and you're also making use of or else null. This is making use of optional over here, and you are just printing out the data. Okay, it's really simple. This syntax is much more simpler, wherein you are not writing in SQL code over here. You know, you're not writing SQL. You are simply making use of methods over here. Okay, and you can think of JPA as a translator between your Java code and a database. So here earlier you had to write SQL code manually within your Java code, right, in your Java files. But over here, you're making use of methods, and JPA is doing the job of translating and it acts as a translator essentially between your Java code and a database. So instead of writing SQL queries manually, you simply use Java objects, and JPA handles the database part automatically. You don't have to worry about it. Okay, so JPA allows you to convert objects into relational tables, and it's like a specification that you specify. Okay, so you mention like this is my class, and you know, this is the mapping that I want to create, this is the linking, this is how it's related to the other class and all. And then this specification that you specify is converted into relational tables with the help of JPA. Okay, and I've already told you, and here you can already see an example of how things look like before JPA existed. Okay, so that's a very manual way, and now with the help of JPA you can just add the specification in your code and things are taken care of. Okay, so it's indeed much more simpler, much more easier, and much more better way of doing things today rather than doing things manually. Okay, so if this code of JPA is not understood by you, but you can take a look at the code. There are like just few methods that you're making use of. But if it's not understood, that's absolutely okay. When we start working with JPA, you will have full clarity as to what this is. Okay, so don't stress about it. Just understand that you are not writing SQL code like this you were writing earlier over here. Okay, you're just making use of some pre-built methods, and you have the data for which is ready to use. Okay, So yeah, I hope you have been able to follow along, and I hope this has been useful. So let us take our application forward and let us talk about the data layer and understand it. So we now have a presentation layer which presents the data and the application features to the user. And this layer is where all our controller classes are existing right now. We have a service layer wherein the business logic is residing of the application. So tasks such as doing evaluations, decision making, processing the data is done at this layer right now. What we don't have is the data access layer, and this is the layer where the repository classes will reside. Okay, so we'll be creating some special interfaces which will do the job of talking to the database and doing the database related operations for us with the help of JPA. So that is what we are going to do. So we are now going to create a data access layer for performing the CRUD operations. Now, what are the CRUD operations? So CRUD operations stands for create, read, update, and delete. So like over here on the screen, you can see find all. This is the standard operation to get the data from the database, right? You have get user, update user, delete user. So with find all, basically you are getting all the records for a particular entity. So basically, if we are talking about user, you're getting all the users from the database. Get user and you're passing in ID means you are trying to get a particular user from the database. Update user and you're passing in the user information means you are wanting to update a particular user with the information that you're presenting. Delete user meaning you want to delete a particular user from the database. So these are standard set of operations which usually are performed on the entity class, and hence you don't have to define this, but the good news is you get this ready-made with the help of repositories, and we'll see this in a while. Okay, so what you have to do is you just have to create an interface that make use of JPA repository which has these standard implementations. Okay, so you need to define only for the special cases which are not the standard ones, and they are an exception, so you need to define them only. But the standard operations on an entity, like getting all the entities, updating entities, like deleting an entity, all of these are provided to you with the help of JPA repository. And we are going to make use of this kind of a syntax over here. JPA repository, we are going to specify entity name and the primary key type. Now, if primary key is of string type, we are going to mention string over here. If it's of long type or integer type, whatever type it is, you mention that over here. And entity name is the entity name that exists. Okay, so that is what we are going to do, and that is how we are going to proceed further. Let us start talking about the H2 database. So what is H2 database? So H2 database is a open source relational database, and it has been written in Java, and it's incredibly fast for building Java based applications. So that is something that we are going to use. So what you can do is you can head over to Google and search for H2 database, and you will be shown this official website over here, H2 database engine. So you can go to this website, and I have this open over here. So what is H2? So these are some of the features of H2. So it's an SQL database which is based on Java. Now what I mean by it's based on Java, it's written in Java and it can run anywhere wherever Java runs. And this makes it perfect for development testing or even deployment in certain scenarios. Now it is pretty lightweight and it is not supposed to be used for production based environments. So as long as you're building applications for testing, and if you need something that is really fast and get you started quickly, that is where H2 comes into picture. So as you can see, it's fast, open source. Now it has embedded and server mode. So what do you mean by embedded and server mode? So embedded mode means the database runs within the same JVM as your application. So that's what is embedded mode. While server mode means that it is running on its own, which means it has a separate process of its own and it's running as a server, and it can accept connections from the clients over the network. So this embedded mode is beautiful and it makes sure that we can embed it into our application. Also, H2 database has a browser-based console application using which you can see what tables have been created and what data is being stored from our application into this particular database. Also, it is pretty lightweight, as you can see over here. It has a jar file of around 2.5 MB in size, which is really small. And it is also known for its quick start. Okay, so it's really fast and it also makes your application faster. So you can see over here, it's fast, open source. So these are more features that have been mentioned over here. So this is something that we are going to use, but right now you don't need to download or install this database. So you can use this website to learn more about what this is and how does this database work. But instead, we will be activating this particular database within Spring Boot with the help of a small dependency that we will add. So that's about H2. So now it's time that we begin configuring our application, which we have created using Spring Boot to work with JPA. Okay, so it's a very straightforward process, and thanks to auto configuration capabilities of Spring Boot, wherein we don't have to do a lot of things to get JPA into action and working with our project. So to begin with, what we are going to do is we are going to come over to Google and I'm going to search for Spring Data JPA. Okay. Oops, I didn't type JPA. So it will be Spring Data JPA, and you can take a look at this project by Spring. Okay, so this is what we are going to make use of. Okay, and this is the official page of Spring Data JPA, wherein you can read more about what this project is and what are the things that it provides. You can go over here to Learn tab. You can check out the reference documentation. But this is just for you to learn. This is not how we are going to add it into our application. This is just an official page that I'm showing it to you. So you can see there are tons of projects that exist under Spring Data. So you have Spring Data JDBC, LDAP, Mongo, Redis, REST, and so on. Okay, so you can take a look if you are interested over here. But what we are going to do is we are going to go to start.spring.io over here. This is our favorite website when we are building Spring Boot based applications. Now over here, since I need to add some extra dependencies into our application, we are going to add the dependency over here. And we are going to copy the dependency that we need to add in pom.xml from here itself, okay? So that we can make less mistakes. So I'll select Maven over here because this is a build tool that I'm using. You can select the appropriate build tool. If you are making use of Gradle, you can choose that. So I'll select this. You can select the Spring Boot version you wish to. You don't need to modify this metadata setting. We just need dependencies. So I'll say add over here and I'll just type in JPA. Now you can see this Spring Data JPA project over here, and you can see the description. It persists data in SQL stores with Java Persistence API using Spring Data and Hibernate. So you can select this. Okay. Now along with this, we are going to need one more, which is H2 database. So this is, you can see it provides a fast in-memory database that supports JDBC API and R2DBC access with a small 2 MB footprint. So this is very lightweight is what I mean to say. Okay, it is very lightweight, and you can see over here it supports embedded and server modes as well as a browser-based console application. So you get a free, or actually this database is free. So you get access to a browser-based console application. Okay, so you select this and you come over here, you say explore, and here you are going to see some set of dependencies being added. So you can see these 2 dependencies. Okay, so what I'm going to do is I'm going to copy these dependencies. I'm going to head over to my project over here. Okay, this is my project. Come over here to pom.xml. Okay, now here in pom.xml, go scroll down to dependencies tab, and here you can add this dependency. Okay, so for example, you can see over here. Okay, so you can see over here, you can paste this. Okay, now this dependency is added. Now, the moment you make any sort of change in pom.xml, what happens is you have to reload Maven changes so that the dependencies that you have added or removed is synced with local, right? So I'll do this Maven reload over here. So you can see over here, this icon, Maven project structure has changed, load changes into IntelliJ IDEA and make it work accordingly. So you can either click this icon, or if you're not seeing this icon, you can go over here to M icon and you can just click on this reload all Maven projects. Okay. But since I'm seeing this, I'm going to click this over here. Now, the moment I click this, you will see this progress at the bottom, wherein it is reading this pom.xml, you can see, and it is resolving all the dependencies of our application, and it is getting all the dependencies locally. Now, where is it getting all the dependencies? So here, if you open this external libraries, you're going to see all the dependencies being added over here. Okay, so there will be a dependency related to JPA as well. Okay, so if I just expand this over here, okay, so we are not seeing JPA related dependencies here. So if we take a look at the dependency that we copied from the pom.xml, we have not copied the Spring Data JPA. We have copied these two, but I think we missed Spring Data JPA. So here we copied these two, okay, and we didn't copy this one. Okay, so this is Spring Data JPA, which you should actually copy over here. Okay, and Spring Boot starter test is actually added in your project already. So this dependency that you copied from pom.xml is actually added over here already. Okay, so here if you see, we copied these two, right? But ideally we were supposed to copy these two. Okay, so there was a mistake at my end. I'm sorry about that. So I'll just copy JPA1 over here. This is just the tag. Okay, so I'll copy this. I'll come over here and I'll actually scroll up and I'll get rid of this dependency and replace it with this one. Okay, so I have H2 database and Spring Starter Data JPA. I'll resync it. And now we should see the dependencies, our libraries being added for JPA. Okay, so let me expand this over here. Okay, so here now you can see org Spring Framework Spring Data JPA over here. Okay, so this is added over here. So here you can see this is the dependency added for H2 database. You can see over here. Okay, and you'll see some dependency from Jakarta over here. Okay, which is added. You can see tons of things like Lombok as well, because you've added Lombok into our project. Okay, so this is done. I'll just do a little bit of configuration. So I'll come over here. Okay, and I'll head over to resources over here, and here you have this file called application properties. Now inside application properties, you have the liberty to set any sort of configuration that you need to do. And since we have added a database related dependency, we need to configure the database and we need to add some dependencies related to it. Sorry, not dependency. We need to add some configuration or settings, I should say, related to it. Now here we are making use of application.properties. Now there are different preferences when it comes to making use of properties file. Some people prefer making use of YAML files rather than properties. So you have application.yaml as well, or application.properties. It's totally your choice. Okay. So over here, I'm going to say spring.h2.console.enabled is equal to, you can say, true over here. So we are enabling an H2 console. So this is going to give us a H2 database web console that we can open in the browser and see our database visually. Okay, it is going to be available at a specific URL, which we'll be taking a look at. But for now, this property is just enabling the H2 console. That is what you need to know. Okay, and that is what it clearly says as well. So if you read this, it says Spring H2 console enabled. Okay. Next thing is we need to set the data source URL. Okay, so I need to add a property saying spring.datasource.url over here, and I need to say jdbc:h2:mem::test. Okay, so what is this? This sets up an in-memory database called test over here. Okay, that is what it's setting up. And in-memory means the database only exists while the app is running. Data is lost when the app restart. And this is great for testing and learning because it requires literally no sort of setup, no manual installation. You are just configuring this along with your Spring Boot application. Okay, so this will be our data source URL, and this is what we are going to make use of. Okay, and if you rerun the application, you should not see any sort of issues, but we are not going to rerun the application. Okay, it's going to be like that only. Now I also want to talk about YAML files. Okay, so there will be some people who prefer YAML files as well. So what you can do over here is, if you prefer YAML, I can rename this over here. Okay, so I'll come over here. I can rename this, in fact. So here you should have an option to refactor, rename, and you can say over here application.yaml. Okay, something like this. So this now becomes a YAML file. Okay, and now you can say Spring application, and then over here name. Okay, and you can say ecom-application, something like this. And then over here you can say H2 console enabled, and then you can say true over here. Okay, and then you can say data source URL, and then you can specify the data source URL over here, something like this. Okay, so you can comment this out. Okay, this is also an option if you prefer YAML based configuration. All right, so yeah, this is the same thing we have specified in a different format, which is the YAML format. Okay, so I hope this is clear, and I hope you have been able to follow along as to what changes we did, why we did, how we added the dependencies, and how are we moving, or how are we integrating JPA into our application. I hope it's pretty clear to you all. All right, so I hope this was fun, and I shall see you all soon. So now it's time that we talk about entities in JPA. Now, first of all, let's understand conceptually what is an entity. So in the context of JPA, an entity represents a table in a relational database, right? Now, if you come over here in our application, okay, so here we have this user. This is the user class. Now this user is representing how user is represented in our application, right? That is what it's standing here for, right? So you can mark this as an entity because this is how the user table will also be there in the database, right? And each instance of an entity that you create. So if this is an entity, each instance of an entity will correspond to a single row within that table. So if it's not clear right now, don't worry. Okay, when we do things, when we see things in practical, it will be clear to you. But right now, understand this conceptually. Entity represents a table in the relational database, and each instance of an entity correspond to a single row within that particular table, right? And what are entities? Entities essentially in JPA are nothing more than plain old Java objects, which is POJOs, and they are annotated to define how they correspond to the underlying database structure. And this is something you'll see in a while. Okay. So like I said, here in our application, we need to store users' information to database, right? Right now we are storing it in a list this way, which is absolutely not a good way of doing things, because if you restart your application, your data is not persisting, it is lost, right? Database is how you store things. So how would you create a table, or how would you create, or how would you structure the database? So for user information, this kind of like this class can be used to define the table, right? For example, you can have a table named user. You can have a field or a column over there called ID. Then you can have a column called first name. You can have a column called last name, right? And a single user will have ID, first name, last name, which means a single user can represent a row in this particular table that will be created inside the database. So we need to mark this particular class as an entity if we want this entity to map to a table in the database. And let me show you how you can do this. So since we have added all the dependencies, you can come over here inside this class. And if you want to tell JPA that, hey, persist this class or create a table for this class inside the database, you need to mark this as entity over here. So if you type in E, you can see over here entity coming in from this package called Jakarta Persistence, right? And if you select this, okay, you can see there is an import statement that is being added at the top. Now this class will be persisted into the database, which means there will be a table created with the name user inside the database, right? Just by adding this single annotation. Okay. Now, if you don't want to have this default name, so the default name of this table will be user. So let's say I don't want this default name to be there. I want to customize the name. So what you can do is you can add these round braces. You can say name over here, and you can add your own table name over here. So you can say user table. Okay. So with this, what will happen is there will be a table created inside the database, which will represent this class, and it will be called user table. Okay. And within this particular table, these fields that you have defined over here, these three fields will become columns. Okay. So that is how JPA comes to the rescue over here. Now, every table in the database will also have primary keys. If you're aware of RDBMS concepts, there is a concept of primary key, which serves as a unique identifier for each record that is created in the table. For example, if there is a user information being stored for a single user, okay, you will have a unique identifier which will uniquely identify that particular user. If you add another user, there will be a unique identifier for that user as well, which will identify that user, right? So there has to be a column that is marked as a unique identifier or a primary key. So you're going to mark this ID field over here as a primary key with the help of ID annotation. So you can see this ID annotation that is coming in from Jakarta persistent. So don't select this one, but this one. So I'll select this one. And yeah, this is something that we have done. Okay. Now whenever you are designing a system, you don't want to give the control of IDs to the end user, right? So this ID should be system generated, right? So whenever it comes to JPA, you can add an annotation which can tell the database or JPA to automatically generate the primary keys. So you can add one more annotation over here, which is generated value over here. Okay. And here you can say strategy is equal to generation type identity. Okay. So what this will do is it will generate a unique value for the ID field, irrespective of whether it's being passed or not. Okay. So this will be unique then always at the database level. And this is what can be shown to the users. This is how it will work. Okay. Now, what we will also need is we will need a constructor for all the fields over here. Okay. So I'll add this all field constructor over here. Okay. And from the JPA standpoint, we also need a default constructor. Okay. So we'll need something like this. So I'll say generate. Okay. I'll say constructor and I'll say select none. We'll need this default constructor. Okay, so in JPA, entities are objects that represent persistent data in the relational database, and JPA relies on Java bean conventions, and it is one of the requirements for JPA entities is to have a default no argument constructor. So this default constructor is needed to create instances of entity class during the retrieval of data from the database. Okay. And that is why this is needed. Without this default constructor, JPA won't be able to instantiate or create any instances of entity objects. Okay, so this is really important. It's important to note that JPA entities, so this is a JPA entity now, right? Because we have marked it as a entity. Okay, so this JPA entities can have additional constructors with arguments, but the presence of default constructor is mandatory. Okay. Now the question is, do you want to add constructor this way or make use of Lombok, because we are already making use of Lombok based annotation. So you can either add it this way, or we have already added this data annotation, which is coming in from Lombok over here. You can see. So if you go inside data, okay, it's a combination of, it is equivalent to getter setter, requirement argument constructor, toString and equals hash node. Okay. So what I will do is I will come over here. I will also add a no args constructor over here. No args constructor, something like this. Okay. So I'm getting an error over here. Okay. Constructor without parameters already defined. So you can get rid of that. Okay. So you can get rid of this. And this constructor is also, we are getting this constructor also with, the data annotation. So I'll get rid of this. Okay. So if you come over here, you're getting you are not getting a all args constructor, but that is absolutely okay. You can create an all args constructor, something like this. Okay. So this is done. Okay. We have our entity set and defined over here. So there were few changes we did over here in the user class over here. So first of all, we have added this data annotation, which was already present there. Okay. We have added this entity annotation, which is telling JPA that, hey, this class is now an entity and you need to persist this into a database, right? And how will it persist into a database? So it has the configuration set. Okay. So if you go to application.properties or application.yaml file, it should be able to find the configurations, right? Then over here in the class user, we are saying that, hey, this particular field is an ID, which means it's a unique identifier and it has an auto-generated value. You can see over here. So annotation type generated value. So this is the documentation for generated value. It provides a specification for generation strategies for the values of primary keys. Okay. And it can be applied to the primary key property or a field of an entity over here. Okay. So this is what you can do over here. And it has also given you some examples over here. Okay. So yeah, that is what we have done. Now, here we also added no args constructor, which is important, and it is important from the JPA standpoint. Now all args constructor I would want to mention, since I've already added all args constructor, it is not mandatory, but it is useful if you are creating this object user with all the values being passed in. Okay, so then that is important on mandatory, but for JPA it's not mandatory. So you can comment this out. You can even comment this out. this name thing, you can comment this out. Okay, so if you just want to mark entity over here, you can absolutely do that. Okay, so you can say entity over here. Okay, so this all args constructor I had added for the sole purpose to show you that along with this no args constructor, you can have all args constructor as well with JPA. Okay, there's no harm in having additional constructor. You can absolutely have it. Okay, and if you want to rename the table or have a custom name for table, you can basically have this particular annotation enabled and comment this out. Okay, so I hope you have been able to follow along, and I hope this has been super useful. So now it's time that we begin talking about repository. So what is a repository? A repository is an interface that allows us to perform various operations involving database, such as create, read, update, and deleting records without writing any sort of boilerplate code. So let me show it to you. So here we are going to come over here, okay, and we are going to head over to our main package. I'm going to say new class. And then I'm going to say over here, we can call this repository as user repository. Okay, user repository, something like this. And I'll select an interface because it has to be an interface. Okay. Now understand this over here. Okay, we have this as an entity. This is marked as an entity which will be persisting to the database. Okay. Now, if there is a table that is being created with the name user in the database, it is storing the information in these columns like ID, first name, and last name. We would want to save the data, retrieve the data, we will want to show the data in the endpoint. We would want to update the data and even perform delete operations. Now, these kind of operations are known as CRUD operations, wherein you are doing create, read, update, and delete. So CRUD stands for create, read, update, and delete. Okay, this is the standard operations on any sort of entities or database objects that you create. Okay, so here this repository is going to help us with that. But the question is how? So here what we are going to do is we are going to extend over here. Okay, extend an inbuilt repository that exists, which are being provided to us over here by Spring Data JPA, and they make our life easier. So first one I'm going to talk about is CRUD repository. So you can see this CRUD repository that is coming in from Spring framework.data.repository package over here. Okay, and this is one repository that you can make use of to get CRUD functions or CRUD operations like save, find one, find all, count, delete. So these all kind of operations you get access to with the help of this CRUD repository. Okay, but I'm not going to make use of CRUD repository because there is even a better way that exists, which is JPA repository. So this is what I'm going to make use of. Okay, and if you take a look, this is coming in from the same package. Okay, so I'll get rid of CRUD repository over here, but CRUD repository is something that you should be aware of, because you might find projects that are making use of CRUD repository. Now, how would you make use of this repository? Just don't specify it this way. Okay, but in fact, you have to add a couple of things over here. Okay, so I'll add this kind of a syntax over here, and now here I'll add two things. Okay, so one is the kind of entity that I have. So one is user. And another thing is the kind of the primary key that exists. So what is the kind of primary key? It is long over here. So if you come over here, the type of entity is user. So why are we creating this repository? We are creating this repository for this user over here, right? So that is what we have mentioned over here. And what is the kind of primary key over here? The kind of primary key or the data type of primary key is long. So that is what we have specified over here. So these two things you need to specify, and we will also mark this as a repository with this annotation over here so that it becomes, or it is taken care as a Spring managed component, or it becomes as a Spring managed component. Now, what do you think is the benefit of doing things this way? The benefit over here is, you don't have to write any sort of implementation code for this repository. You just define this and you leave it. That is it. You just do this. So you create an interface first of all, you have extended it with inbuilt JPA repository, and then you're making use of user and long. Okay, you can make use of CRUD repository also, but JPA repository has better performance and it has some additional JPA specific methods like flash, save and flash, delete in batch and all of this. It's generally a better choice if we are using JPA because it allows for batch operations which can potentially improve performance. Okay, so I would recommend you make use of JPA unless you have any specific need to go for CRUD repository. Okay, and you are not writing any sort of implementation here. You have just written or created this repository, which is an interface, and things are taken care of, right? So you get access to ready-made methods which will allow you to talk to the database. And this is something that you will see in action. But right now, just remember, like, this is what you have to do and this is what you have to define. Okay, so I hope you have been able to follow this and I hope you found this valuable. So now it's time that we start making our users persistent, right? So right now we are dealing with things wherein we have everything being defined and managed with the help of a list. So we need to transition from a list-based storage to a database-based storage, right? Which is much more persistent. So what I'm going to do is I'm going to come over here, okay? And here we are going to work on this. So for doing this, we need to talk to a database, right? And what do we need for talking to the database? We need a way to talk to the database. And in our application, we have a way which is the user repository. So we are going to make use of user repository over here to talk to the database. So what we are going to do is we are going to have an instance of user repository over here. So I'm going to say private, okay, final, and I'm going to say user repository, and I'm going to say user repository, okay, something like this, okay. Now we want Spring to inject the object of user repository over here, okay. So you can see over here, variable user repository might not have been initialized. So add a constructor parameter. So you can add a constructor this way, okay. This is a constructor which is taking in one object as the parameter and it is initializing this user repository here. This is one way of doing things, okay, because Spring, since this is a Spring managed component, right? This is a Spring managed component. So Spring is going to auto inject it over here in the constructor and then it is going to initialize over here. Okay, this is one way of doing thing, or else you can get rid of this constructor over here. Okay, so I'll get rid of this and you can add over here, you can say required args constructor. Okay, something like that. Okay, so I can say required args constructor like so. So this will also take care of, initializing this. So this is done. Now what we will do is we'll make use of this repository in all the methods, and basically instead of these methods talking to the list, it will talk to the database. Okay, so I will comment this list first of all because we'll be getting rid of the list and we'll be moving to database operations, right? So you have user repository, okay, and you need to fetch all the users. So we'll get rid of list over here. So we'll say user repository dot find all. Now this method is being provided to us by JPA. We have not defined this method. Did we define this? Have we defined this? No. This is provided to us by JPA and we are making use of it to fetch all the users in the database. Okay. Come over here and here what you can do is here we don't need this ID thing. Okay. Because this ID is auto generated. So I'll just comment this out. Okay. And here you can say user repository dot save over here. Okay, and you can pass in the entity over here. Now what is the entity? The entity is the user over here. Okay, so this is something that you are doing and this is done. Did we define this save? No, we haven't. Okay, now over here what we are doing is to fetch a particular user, we are basically making use of stream over here, wherein we are converting this list to a stream. So here I can get rid of this entirely. We are not making use of list now. So I'm going to say user repository dot find, and you have this access, you have this method which you have access to, find by ID. And since we have access to ID, you can mention ID over here. Okay. Now this method itself is returning optional over here. You can see optional of type. Now what is the type over here? Type is user. So it's returning this over here. Okay. And then if you scroll down here, you have this update user method wherein you are making use of this stream and you are updating the user. Okay, so what I'm going to do over here is we actually don't need this. Okay, so we need to convert this to JPA based operations. So here what I will do is I will make use of, I'll get rid of this list over here first of all. So I'll say user repository dot find by ID and I'll pass in the ID over here. And we don't need to do this filter and find first. You know why we did filter and find first? Because we had a list. So we had to filter that list and find the first element that matches. So I'll get rid of this as well. Okay, we'll make use of map. And for map, what we are doing is we are updating the data over here. Okay, But after data is updated, what we need to do is we need to save it into the database. So I'm going to say user repository dot save over here, and I'm going to pass in the existing user over here. Okay, this is the existing user which has been updated. I'll add a semicolon, and yeah, it's taken care of over here. Okay, now understand what we did over here. Okay, we made use of repository to basically transition from a list-based operation to a database-based operation. Okay, so this repository is actually extending JPA repository. Okay, now if you come over here, we are saying user repository.find all. What this is doing is it is returning all the users that exist in the database. Okay, so whenever you are extending a repository and you are specifying JPA repository over here, okay, you are extending this JPA repository and you are specifying some types over here. You are saying user and long over here. So what happens is you are given access to methods for this user entity type and this primary key type. Okay, so here it is returning all the objects or the list of users over here. Why list of user? Because you have mentioned user over here. User is the type. Okay, so JPA is doing that job for you. Here you have mentioned user repository.save. So this is doing the job of persisting this user into the database. And if you hover on this and if you press command or control, so command on Mac and control on Windows, it will convert to an hyperlink, and you can see over here. Okay, you can see it saves this given entity and it returns the instance for further operations. Okay, so it is returning the saved object as well. If you want to have that saved object, you can have it over here. Okay, so you can say saved user and you can get the saved user as well. Okay, but I don't want the saved user, so I'm just not assigning it to a variable. Okay, but you can take a look at the method over here. This is pre-existing. We have not made use of it. Okay, now over here, if you come fetch user, for fetching a particular record from the database, you are making use of find by ID. Okay, and you're passing in the ID over here. Okay, and ID is of long type. How does it know that ID should be of long type? You have mentioned it over here in the repository. ID should be of long type. Okay, and here you are again fetching the ID, fetching the user by ID, and you are updating that user. And after making updates, you are saving it to the database again, right? So you can see how your life has become simple. Okay, I would encourage you to basically explore this object user repository and just press dot over here and just go through the list of all the methods that you have access to. So this repository object is so powerful. You can see over here you have access to save, find by ID, find all in a paginated way. So you're getting this paginated response. Okay, sort, find all. Okay, you can even mention the sort order over here, find by over here, find all. So you can see there are tons of versions of doing things, and you can see you have access to so many things. Did we write all these methods? No. We got this ready-made, inbuilt, pre-built, predefined, whatever you want to say. Okay, but we have not defined this. Now imagine your life or imagine doing things without having access to these methods. So for fetching all the users, you would have to write an SQL query over here. So first establish the connection with the database. Query the table, select star from users. And you have to hardcode that query into your Java code. There can be syntax issues. You should be aware of SQL syntax as well. Okay, so a lot of learning curve has also reduced over here. You just make use of these Java style objects. You just do a few method calls in Java style and you have all the data over here. And in fact, these things are doing the job of translating this in the hindsight into SQL queries. Okay, so these calls, these method calls like find all, these are being translated to SQL queries in the hindsight without your knowledge, and you are seeing the result over here. Okay, and you can see how simple our service class is now. Okay, so this is how you would persist our user into the database, and I hope you have been able to follow along, and I hope this has been useful. So now it's time that we start testing the changes that we have done in our application. So what I'm going to do is I'm going to restart our application after making all the changes successfully. Now let us wait for the application to start. Okay, so I am getting an error over here. So user service is not initialized by a default constructor. Makes sense. Okay, so Okay, so I'm getting an error related to Lombok, and this error is likely related to the settings that might have got changed when we changed the pom.xml. So go to annotation processing under build execution deployment, select ecom application and make sure you have obtained processor's path from project class path selected. Say apply, say OK. And let us rerun the application. So the application is running now, and you should see everything working successfully. Okay, so the application is up and running, and now let me expand this over here. So let us take a look at some of the logs that are happening over here. So we are seeing this error on the console, and the reason for this error is because we are trying to create a table called user. Okay, and user is being created in the H2 database, but user is a reserved keyword in SQL, okay, or a lot of databases. So we are making use of H2 and it's not allowing us. So what I will do is I'll come over here, I'll say that create a table for me with the name user table. Okay, and here in the user service I'll also get rid of this variable is not needed. Okay, so I'll just, so main change that we did was adding a table name, and I'll restart the application. Okay, so this adding this table name, this won't impact anything in our code. It would just impact how the table is being created, right? So it's done, and we have like no issues or no errors over here, no exceptions. Okay, now take a look at logs and understand what is happening over here. So if you start from the beginning, okay, you will see like there are no active profiles set, bootstrapping. Now here you'll see finishing Spring Data JPA repository scanning found one JPA repository interface. Okay, so it is understanding what configurations or what you have defined in your application, and based on that, it is going to create the database for you, right? You can see bootstrapping Spring Data JPA in default mode. You can scroll down further and you can see all the logs that are related to H2 or JPA. You can see over here. So you can see Hibernate ORM core version 5. So this is coming into action. Okay, second level cache. So basically JPA makes use of Hibernate. Spring Boot actually makes use of Hibernate in the hindsight to persist data and all. Okay, so here this ORM is coming into picture, which is object relational mapper, which does the job of mapping the entities or the classes into tables, right? So that is coming into action. And here you will see a database info, you can see. And if you scroll down further, you are going to see over here JPA also doing some stuff, and you can see over here H2 console is coming into action. Now this over here, the database is available over here. It is what it says. Now this is the connection string, okay, or the database details that you have mentioned over here in application.yaml. So whether you have application YAML or application properties, you must have defined this URL into the configuration file, and that is what you are seeing over here. Now if you scroll down further, you will see Tomcat is available on this port and the application is started. Okay, also one thing to note is there is also an H2 console which you have been given access to. Okay, so you are seeing that also over here. All right, now this table is being created in the database. Right now, how do we see it? So we can come over here in the browser, and here you can say localhost : 8080, and you saw a message over here which is the console is available at H2 console. So you can copy this. Okay, so it's your localhost / H2 console. So if you go to this URL, you will be taken to this particular page. Okay, now this is the login page of H2 console. Okay, you have to mention the JDBC URL, your username and the password. Okay, so if you come over here, you can see the URL over here. Okay, or you can get this from the application YAML. You don't need to scan the console for this. So I paste this, and for username and password, if you see over here, okay, so the username should be available over here. Let me see. So if I do a Control F, I'll say user is equal to SA. You can see over here. So this log over here, it said added connection 0, URL is this, and user is this. So SA is the username over here. Okay, so it was available in the log itself. So I have added SA, and this is the default username for H2 database. Okay, so even if you don't want to check the logs, you can just enter this and just say test connection. There's no password needed. Okay, and you can say connect over here. So you should get this response over here, test connection. Now if I'm enter anything wrong over here, 221 or 23, if I say test, you can see over here, wrong username password. Okay. So username password has to be correct. Say test and then say connect over here. Okay. So you have now connected to the database and you can see the user table appear over here, right? Now the question is what happened in the hindsight? Okay. What happened in the hindsight? How was the table created? Were SQL queries being generated? Okay. So you can search for H2 over here and you should see a lot of H2 related activities. Like there was like console auto configuration in picture, for which console was made available. Okay, so you can perform search and you can take a look at all the activities that have happened with regards to JPA as well as H2. But you are not seeing the queries and all being generated. So to see queries and all being generated and what is happening in the hindsight, you have access to a property that you can add over here in the application properties or YAML file. Okay, so I'll add the properties over here. Okay, the property is you can say spring.jpa.show SQL is equal to true. So this is the property for application property, and there is one more property that you can even add over here. So you can say spring.jpa.hibernate.ddl-auto. Okay, and you can say create. Okay, now what do these two properties do? Okay, so this first property, which is spring JPA show SQL is equal to true. This enables logging of SQL queries in the console. So whenever your app interacts with the database, wherein some fetching, saving, retrieving of data is happening, you see the actual SQL statements onto the console. Okay. And this is true whenever the application even starts, whenever the tables are being initialized, you will see at that point in time as well. Okay. Then you have this another property that you can add over here. Now this will automatically create the database tables based on your entity classes. That is what this property is telling to JPA. Okay. Now understand this, this DDL auto, meaning how the database schema is being generated. Okay. So you have specified create over here. Okay. Which means that the database deletes and creates tables on every restart. So for every restart, the tables will be recreated after deleting it successfully. Okay. There are multiple properties for this over here. You can mention update as well. So what this update will do is it will keep the existing data, and if you restart the application, it will keep the existing data and modify the tables if needed, if there has been any change in the entity classes. For example, if you added a new field in entity classes. So the update will be performed, but the old data won't be deleted. Then you have validate or none over here. Okay. So all these kind of properties you can mention, but you can mention create over here for now. Okay. And create, remember, is dangerous for production. It is just for development. In production, you can't have this kind of a setting called create, wherein if the server restarts, the database gets wiped out. Okay. This is not a production level setting. So you have to mention either update or something equivalent over there. Okay. So what I will do is I will translate these properties to that of YAML. So I'm going to say JPA and show SQL over here, and I'm going to say true over here. I can add JPA :hibernate. Okay, so JPA is already added. So here I'll say hibernate over here. Then I'll say DDL auto, and I'll say create, something like this. Okay. Now with this, if you restart your application, you are also going to see queries over here, and your database will be recreated. Okay, so you can see over here. Okay, so if you scroll up, you see everything, like this connection was created. Then if you scroll down, you can see database info. This is a database info. A connection pool was created. If you see over here, drop if exists user table. So if there is any user table that exists, drop it and then create this user table. So data is being deleted and recreated over here. Okay. And you can see there was only one table that we had defined, only one entity. So you are seeing the query only for one entity. If there are 10 entities or 1000 entities that you have created, you will see those many logs over here. Now this is helpful for production level debugging. If you want to see what is happening at the database level, if there is any API call happening or something like that, then you can enable these settings. But right now we are enabling this for learning purpose. Okay. For learning purpose also, you can enable these kind of logs. You can learn a lot from logs as to what is happening in the hindsight. Okay. Now our objective was to persist data into the database. So we are already seeing our application up and running. We can see like the table also being created. Okay. So now since we restarted the application, if you refresh over here, you'll see you will be locked out. So you have to connect again and you'll see the table being created. So if you select user table, you'll see this query being auto-populated. You can run it and you'll see there are no rows. What I will do is I will come over here to Postman. The goal is everything should work as expected, like it was working earlier, right? So first thing, I'll try to get users. There are no users. You can see 200. Okay, everything working fine. And now if you come to here to console, you will see select query being auto-generated by Hibernate over here. You can see why the select query was generated, because we tried to fetch all the users from the database. So you can see select ID, select first name, select last name from user table, and this is the alias of user table, u10. Okay, u1_0. Okay, this is something we saw. And if you come over here, let me try to create a user. So I'll create this user with the name John2. Okay, John2 and Do2. User added successfully. If you come over here, if you run this query again, you'll see user1, John2, Do2. Okay. Now if you come over here to the console over here, you'll see insert into user table, first name, last name, ID, and the values were populated over here this way. Whatever values were passed, those were populated. So insert query was generated by Hibernate. Okay. If you come over here and get users again, you'll see you are getting the list of users, and you'll also see the corresponding select query being generated. Okay. Now, if you try to update the user, so if I say John updated, Do updated, it got updated. And if I do a select star again, you can see John updated, Do updated. It's working fine. Okay, so update is also working fine. And if you come over here, select did well, and then we had an update as well. Okay, so update happened. Okay, so now if you come over here and if you try to create one more user with the name John Doe, so I'll just remove 2 from here, or we have anyways updated the name. So this user got added, and now if you come, you'll see one more user being added, right, with ID 2, and you can get all the users over here. You can see you can get a particular user over here as well. You can see, and you can even update the user, which is something that we just saw. Okay, and for everything, you can see the queries are being generated over here. So everything is working fine. Now imagine writing these queries in the SQL, like writing these SQL queries in the Java code is what I mean to say. Okay, it would have been a nightmare. Let me tell you, I've been through this. So I have been coding in Java since the time wherein we had to write these SQL queries hard coded in Java code. Okay, and we used to make tons of mistakes. Sometimes you missed a colon, or sometimes you missed a inverted comma or something like that. You are not formatting it properly. Okay, and it used to be a difficult task or a nightmare to debug things. Okay, so it's great. Like today, these tools are there, and they've made our life so much easier. We have not defined any of these. We are just making use of Java-based syntax over here, right? And these Java-based syntax have been exposed to us by the repository that we have created. And what have we created? We have just created an empty interface, which is extending JPA repository. And JPA repository is giving us access to everything. If you take a look, right? It is giving us access to, if you go inside JPA repository, okay, you can see it has all the methods. Okay, you can see get one, delete in batch, get by ID, a lot of methods over here. Okay, and you have to just make use of this. You don't have to worry about defining all of this and playing with the syntax. You should know SQL as well. No, that's not the case. So you just see over here, everything is working automatically like how it should. Okay, and whatever operations you are doing, there are database queries that are being generated. Okay, and tomorrow here we are connecting to H2 database, right? Tomorrow you can plug in any other database and your application would work like it is working today. So that's the magic of JPA, persistence, and H2 database when you're working with Spring Boot. In fact, there is a huge contribution of Spring Boot auto configuration as well. Like you have not literally created a connection. You have just added the database details here in application.yaml, and the application takes care of creating the connection and, you know, connecting to the database, talking to it, generating queries, and so on. It's all possible with the help of Spring Boot and amazing tools like JPA and all, right? I hope this has been useful, insightful, and I hope you have been able to follow along. It's time that we take a look at a user entity and decide if we want to store more information. So here we are storing just two pieces of information, which is first name and last name. This ID is a unique identifier for the user entity. So I would say that we are just storing two pieces of information, first name and last name. And there's a lot more that can be stored when it comes to a user information. Like for example, you can store things like email, phone number, addresses, user role, a lot of stuff. Okay. So let us start adding some information and start making this user entity a bit more comprehensive. So here I'm going to say, let us add something called as private string, and I'm going to say email over here. Oops, something like this, email. I'm going to add a phone number. So I'm going to say phone over here. I'm going to basically add user role over here. Okay, so I'm going to say private user role. Now what is user role? User role is a enum, so that we will be creating. So I can have this as the enum type. So I'm going to come over here. Okay, and inside over here, I'm going to add enum over here. Okay, I'm going to say user role over here, and this is going to be an enum. And over here, I'm simply going to say customer and admin. Okay, customer and admin, something like this. Okay, I'll just close this, and here you can assign this user a role, whether it can be a customer or an admin. So I'm going to say role over here, and it can be user role dot customer, something like this. So this is the default one that is being assigned to this particular user, okay, or whoever user is being created into our system. So this is it. We have added a few fields and made this user entity a bit more comprehensive. So yeah, if I rerun this application, let me rerun this application and let us see what is happening over here. Okay, so I restarted the application and it's running. Let me come over here to the database. Let me reconnect. Let me go over here. You can see all this information is coming in now. And if I now create a new user over here. Okay, user added successfully. Actually, I should have updated the JSON. So this email and phone number will go in as null over here right now. Okay, so let me add email as well. Okay, so I'm going to say email, something like this. And I'm going to say john@gmail.com. Okay, and I'm going to say phone over here, something like this. And I'm going to say some sort of a phone number. Okay, so I'm going to have like any sort of random digits right now, and let me create a user now using this. Now if you come over here and if you run this, you're going to see this user being added over here. Okay, and you can see the role is 0, which means 0 is over here. So if you go to user role, 0 is customer. Okay, you can even assign him an admin, it will be 1. All right. So yeah, that's, with that said, we have updated the user model, and I'll save this. If you come to get users, you'll see the updated list of information over here. You can see. So here we missed sending this information, so we are getting null, but that's absolutely okay. All right. So yeah, we have updated the user model. Now we have increasing number of files, and it's important that we organize everything into the right way so that we can scale up accordingly. So here I'm going to add a new package. I'm going to call this controller over here. And within this package, I'm going to have all the controllers defined. So right now we have only one controller. So I'll just move this controller over here. We can have one more package called as model over here. And I can have the models move in over there. Okay, so if we have user role, which is an enum, which will also go over there. I will have a package called as service, and we can have all the services move in there. Okay, and we will have a repository, which will have the repositories, something like this. Okay, something like this, and it will have all the repositories underneath. Okay, so this way we have a better and organized way of doing things, wherein every file exists along with likewise. Okay, so we have this particular package which has all the repositories. This one has all the models or entities. This one has all the controllers, and this one has all the service. Okay, I hope this is good enough. So I would want our users to also keep a track of the addresses into our application as well. And for that, what I would be doing is I would be having a separate entity created which would represent a address that can be associated with the user, right? And for the same, we would have a relationship between this new entity that we'll create, which is address, and the user. Okay, so that is what I'm going to do over here. So first of all, here I'm going to add this new entity. I'm going to say address over here. Okay, and within this over here, I'm going to define all the fields that we want to be part of this address. So I'm going to say entity over here, something like this. I'm going to say table name over here, and we can have table name defined as addresses. Okay, or you can define the table name something like this as well. Okay, so you can use a separate entity or separate annotation, or you can just get it done in a single annotation as well. Okay, like so. So here, instead of user table, I'll rename this to addresses over here. Okay, something like this. And now what we will do is we'll have all the fields defined that we want to be part of address. Okay, so I'll say ID. First of all, I'll say generated value. And what is the strategy? It's generation type identity. And over here, I'll say private long ID. Okay, and then over here, you will add a data annotation. And here I'll say no args constructor, which will be needed for JPA. Then I'll say private string street over here. Okay, and I'll copy this over here, and I'll come over here and I'll say city, then state, then country, then zip code. Okay, so these are all the fields of the address that we want user to have. Okay, and whenever user is storing any sort of address related information, he has to share all these things with us, and I believe this is more than enough over here. Okay, so this is done, and now what we will do is we will have a relationship between user and address over here. Okay, because in the end we want a address to be associated with the user, right? You can have address like this standalone entity as well, but after having it as a standalone entity, you won't know which address is associated with which user. Okay, so you need to have a relationship, and what we will do is we'll come over here. Okay, and here I will create a join. Okay, so something like this, and here I'm going to say one-to-one. One-to-one. So this is a one-to-one relationship wherein I'm saying private address, and I'm going to say address over here, something like this. Okay, and for one-to-one relationship, I'm also going to define the cascading. So I'm going to say cascade, and I'm going to say cascade type as all over here. Okay, oops, so I don't see all over here, so I'm going to say cascade type dot all. So now I see all. Okay, so this is done, and what I would be also doing is okay, so I'm getting a red line over here. What it says, I would add one more thing over here. I would say orphan removal to that of true over here. Okay, so this is done, and then we will have join column also defined over here. So I'll add this annotation over here, and I'll say join column name. Now, what is the name of join column? So I'm going to specify, this is going to allow me to define the name of the join column. So I want to have the join column as address underscore ID. Okay, and then I'm going to say referenced column name as that of ID over here. Okay, so I'm having something like this over here. Okay, and we are getting this red mark over here still. So I'm getting this because I've added cascade type from org.hibernate.annotations, but cascade type should come in from jakarta.persistent. So if I select this, you can see this go away. Okay, now I hope you have understood as to what we are doing over here. We are creating a relationship between address and the user entity. Okay, because it's important for data to make sense, it's important that we have a relationship over here. Okay, and with this thing over here, this piece of code that I've written, these 3 lines, we are creating a one-to-one relationship between user and addresses, and this is linking user entity to an address using address ID as the field over here, and this is the foreign key in the users table. Okay, now foreign key means there is a field in the user table which is referring or keeping a reference to the address table over here. So that is a reference that we are creating over here. Then we are saying cascade type as that of all, which means we are propagating all the operations like save, update, delete from user to that of address. Okay, so if we save user, the address will also get saved, and if we delete user, the associated address will also get deleted. Okay, if there is an update in address, if there is an update in user, the address will also get updated. And there is this property called orphan removal as that of true. Now what this does is it will delete address if it's removed from user. So it is going to prevent any sort of orphan records that might exist in your database. Okay, so yeah, this is what it's going to do over here. And yes, one more thing, if you delete the user, then it does not make sense for address to exist. So these definitions are making sure that if user does not exist, it's linked in a way to address such that if user is deleted, the address is also deleted. Okay, so this is how we are managing these mappings and the relationship between the user and the address. Now this is important for our data to make sense, like I said before as well. Okay, and additionally, what I want to do now is I want to add a couple of more fields over here. Okay, so I'm going to add a couple of more fields. I'm going to say private local date time over here. Okay, and I'm going to say created at over here, and private local date time updated at, something like this. Okay, now created at represents the time when a particular record for a user was created, and updated at represents the time at which the record for a particular user was updated. Okay, so they both are representing created at and updated at timestamps. I hope it makes sense from the naming standpoint. Now what I'm going to do is I'm going to make sure that Hibernate populates this data of created at and updated at automatically. And we can do that with the help of simple annotations. Okay, so I'm going to add an annotation. I'm going to say created, or it's creation timestamp. Okay, so you can see this org.hibernate.annotation. Go over here and add this. Now if you go inside this annotation, or if you hover on this, you're going to see the documentation over here. Hovering specifies that annotated field of properties generated is a generated creation timestamp. The timestamp is generated just once when an entity is inserted in the database. Okay, and by default it is generated by in memory, and this may change by specifying the source and all of that. Okay, so this is created only once when the record is inserted for the first time. Okay, and then I'll make use of one more annotation over here, which is update timestamp over here, and it's coming in from the same package org.hibernate.annotations over here. So I'll make use of this. Now update timestamp will also auto populate this update time over here. You can see over here. Okay, it's a similar description, but for update, it's regenerated every time an entity instance is updated in the database. Okay, but creation timestamp makes sure that the timestamp is generated only once. Okay, so this is something that we have done. Now our user model is looking much more comprehensive. What I will do is I'll restart our application and let us see how these changes are being reflected into the database. Okay, so the application starts fine. You come over here and let me take a look at the schema first. So I'll just do a refresh, connect, and you can see address table and user table over here. So if you do a select star, you can see address ID being populated over here. Address ID, created at, ID, updated at, everything. Okay. Then you have addresses as well, which you can take a look. Okay. So I'll select addresses and you can see this is addresses. Okay. Now, if you want to create a user, you need to pass in address information as well, right? Because, you know, we are doing cascading over here. If you take a look at the code, we are doing cascading. Okay. And address is now a part of user. So what I will do is I'll come over here. Okay, let us come over here. And okay, not here, but here. When creating the user, we'll pass in the address as well. So I'll add a comma. I'll go to the next line. I'll say address over here. Okay, and here I'll add a new JSON over here, something like this. Okay, so we are having these two curly braces because now here this is an object, right? So I need to add these two curly braces, and within this I'll have the definition for the address over here. So I'm going to add street, I'm going to add city, something like this. I'm going to say empty curly braces over here. Oops, not curly braces, empty inverted commas. Then I'm going to have state, something like this, and we can have this empty data. So right now I'm defining it as empty, but I'll just update it in a while. Okay, so give me some time. So you can see I've defined it the JSON this way. Okay, you can define it the way you want, the kind of values you want to populate, but I've defined it this way. So this is done. And now since we have the user and address model, user and address JSON set, what I will do is I'll save this and I'll say send. You can see I got 200. Okay, user added successfully. You come over here, and if you select user table, you will see address ID, created at, updated at. You can see these timestamps are being populated automatically. We did not populate it. It is being generated by Hibernate. You can see ID as 1, email, everything remains same. Just as created at, updated at have been updated. Address ID is added. Now if you go to address over here, you will see address is also populated over here. So users now have an address associated with them. Okay, and this is done for all the operations. You can see over here, you can get user over here. You'll see user is coming in along with the timestamps. You can see. Okay, get a user. You can get a user if you want. See, take a look. Okay, then you have update user. If you want to update the user, you can update it from here. So everything is working absolutely fine. Okay, if you want to update the user, you will need this JSON over here. Okay, and then you will have to update it. So you will say John Doe updated, something like this, and this will be updated, something like this, and you'll save this and you'll send this. And now if you go to get users, you'll see John Doe is updated. Okay, and here if you see updated at will get updated, but created at won't get updated. Okay, so remember and keep this in mind, okay, as to how this is working fine. So in this particular video, we did quite a few of changes wherein we basically linked the address and user. We first of all created an address entity wherein we defined all the fields that we want user to store against his or her address. Then we linked the entity to that of user, wherein we created a first relationship wherein this user entity is now linked to addresses. And we have defined things in a way wherein we have this one-to-one relationship between address and user. There is a join column, reference column is defined, and we have a cascading as well enabled. Then we executed this, and we have a couple of more fields coming in, which is created at and updated at, which we don't need to pass in through the JSON when creating user entity. They are auto handled by Hibernate. So that's the power of JPA Hibernate. They all are coming together to make our life so much easy. I hope you have been able to follow along so far, and I hope this has been useful. So we have APIs working right now in our application, and there is one problem or a challenge you can say that I would want to talk about. So here, whenever you are fetching the user information, you're seeing all the fields that are being stored in the database coming in over here and being exposed. For example, unique identifier, first name, last name, and things like this are okay. But things like unique identifier, created at, updated at, so all these are exposed. So whatever is there in the database is being exposed over here. And tomorrow, if you add a field like password, that also would be exposed over here. Now, as a developer or as a designer who is designing the system, I would want to have better control on what I expose to the outer world, right? And for that better control, I need to make use of a pattern called as DTO pattern. Okay, so DTO pattern is a solution that will help us get better control on what we are exposing to the outer world. Okay, so let's talk about DTO pattern. So what is DTO pattern? So DTO pattern is a design pattern used to transfer data between software application subsystems. Now, what I mean by transfer data between software application subsystems. So imagine this, in the context of APIs, you have two systems that would be communicating with each other. So there are a set of APIs that you're building right now. These APIs will be consumed tomorrow by another system or an end user. But someone, whether it's a client like a mobile application or a web application, will be communicating with your backend and consuming these APIs and this data that you are exposing, right? Now, DTOs over here can be very useful to design the structure of data you want to expose over the API. It gives you a better control. And by using DTOs, you can easily avoid problems like, exposing sensitive information, having better control of what others see with respect to your system. So what are DTOs now in a way? So DTOs are simple Java classes that represent a subset of your domain model and are specifically designed just for transferring data between different components or services. And these DTOs act like a lightweight representations of original objects tailored specifically for data transfer purpose. Okay. If this is not making sense, don't worry. Just understand the problem that we are facing right now. Okay. But this would soon start to make sense when we start implementing things, and you will be crystal clear as to what is this and why we are doing this. Okay. So understand this DTO pattern, this design pattern is used to transfer data between software application subsystems. What is a DTO? What is this term DTO? This is nothing but a simple class that is representing the subset of the model that you have created. So here, if you take a look at our application, we have all of this defined in the model. I don't want to expose this entire thing in the model. So what I'll do is I'll create a DTO, which is another Java class, which will be a subset of this information. And this is the information that I want to expose, and only that information will be exposed. So it is just a lightweight representation of original objects tailored specifically for data transfer purpose. Okay. And by using DTOs, you can retrieve the necessary data from other systems and map them to other DTOs as well to transfer across the network. Okay. So all of those things are possible. Now let us talk about how we are going to work with it. So here you have this user model, you have address model, you have a data transfer object that you will be creating. And this data transfer object will have fields from user as well as address. And then the end user or the client, whoever is consuming these APIs, will see only these selected fields that exist in DTO. So I hope this is making sense as to what we are doing, why we are doing, and why we will have to make use of this pattern. So now let us begin implementing the DTO pattern in our application. So what I'm going to do is, here we have this user entity. We have this address entity. I'm going to come over here and I'm going to create a new Java class, and I'm going to call this class as user request. Okay. So I'm going to create DTOs for request as well as responses, and I'm going to create this within a sub package called DTO. Okay. And the sub package resides under this main package. Okay. So I have added this, and I'll have one more over here. I'll call this as user response. Okay, so this is for request as well as the response over here. Now, request response will have their own fields. Okay, and first let's start defining the user response. So I'm going to say private string ID over here. Okay, something like this. Okay, or what I can do in fact is I can copy things from here. Okay, something like this. And I can come over here and I can simply paste it like so. Okay. So instead of long ID, I can say string ID. Okay. I can send it as a string. First name, last name, email, phone. I can also have a user role over here. Okay. So user role will come in something like this. And this is done. This is for user response. Lastly, I'll have address information. So I'll have address DTO, and I'll say private address DTO, and then I'll say address DTO, something like this, or address over here. Okay. This does not exist. So I'll say create this. Okay. So I'll hover on this. I'll say create class address DTO, and I'll say okay. And then over here within this address DTO, I'll add some fields that I want to be present for an address. So I'll copy this over here, this all the fields, and I'll have them over here. Okay, I can have string. Okay, so this is done. We have ID. So I don't want to add ID over here for address. Let's skip ID. So I'll have street, city, state, country, and zip. Okay, this is done. I'll come over here to user response. This issue, this error that we are getting is gone. I'll just add this data annotation over here so that we have, we have the getter, setter, required args constructor, toString, and all of these generated by Lombok. I'll add it to this class as well. Okay, then it's taken care of. And then I also now need to define the user request over here. Okay, so user request will look somewhat like user response only. Okay, so I'll just get this entire thing over here. I'll just add it over here, user request. And here we have first name, last name, email, phone. I don't need to accept role over here because role is something that we are auto assigning. I'll also accept address over here. Okay, so this is done. I'll just get rid of unused import statements and I'll add data annotation over here. This is done. Okay, now these classes are defined. Now what I will do is we'll have to make use of this in the controllers, right? So I'll come over here because in controllers, the way right now the responses are being done is with the help of the model classes over here. You can see this is the model. This is coming in from model. So here instead of model, we will make use of user response over here, something like this. Okay. Now, the moment you make use of user response, it's of course you are going to get error, right? So how do you get away with this error over here now? Okay, so I'll come over here to fetch all users. Okay, this should also return user response. Okay, user response, something like this, right? But here we are directly returning the response from this particular method over here, find all, which we are getting from repository. And this is giving us the list of user, but we want the list of user response. So what we will have to do is we'll have to define a separate method. Okay, so I'll say over here, private user response over here, and I'll say map to user response. So this is a separate method using which we will be mapping a particular user object to that of user response. So this mapping will be doing manually. It's a little bit of manual work, but just once, which is good to build long-term scalable systems. Okay, so this will accept the type of argument called user, and here I'm going to say user response, something like this, and I'm going to say response, and I'm going to say new user response, like so. Okay, I'm going to say response dot set ID, and I'm going to pass in user dot get ID over here. Okay, and you can see I'm getting an error because it needs string, so I'll add string value of over here. Okay, I need to add the first name over here, so I'll say set first name. I'll say user dot get first name. Okay, and I'll say response dot set last name. So I'll do this same thing for all the one second. So user dot get last name. Okay, so I'll do this for all the fields over here. Okay, so instead of getter, I'll use setter, set last name over here. Okay, so I'll do this for all the fields, and we'll have to repeat this same process wherein we are making use of setter over here, and for getter we are making use of this user. Okay, so I have modified, or I've added a lot of code over here. Okay, a lot of code was repeated, so I just paused the video and I added it myself. I'll explain you what I've done over here. So first of all, for user response, I have set every field over here using a setter, and I'm getting everything from user object that is being passed over here using a getter. Okay, and I'm doing this for all the fields. So for last name, for you can say email, the phone number, the role. Okay, and here, since response also has address DTO, what I'm doing is I'm creating an object of address DTO. This does not have anything. Okay, so I'm first checking if address exists for this user. If it exists, then only I'm entering this if statement and I'm creating an object of this address DTO. Then I'm setting this street using setter and getting the data from user using getters. I'm doing this for city, state, country, zip, and so on. And in the end, for this response object that we have created outside, I am setting the address as well over here. Okay. And after this, what we need to do is we are seeing a red mark. So we need to add a return statement. So I'll say add return statement and add response over here. So this mapper, which is mapping or which is doing the job of mapping a user to that of user response is ready. And what I will do is I'll scroll up over here. And now when getting all the users, what we need to do is I will cut this, I'll paste it over here. Okay. And here I'm going to get the list of users over here. Okay. So list of user, and I'm going to say user list over here, something like this. And then I am going to map this entire user list to that of user response. So in fact, if you are making use of streams, you don't even need to create this variable. Okay, so let me show you. You can basically take this method. You can say product repository dot find all, and I can say dot stream over here. And then on the next line, I can say map. So what this map will do is this will apply this function to everyone. So I'm going to say like every instance or every item in this particular list. So we are applying this function map to user response, and then I'm saying dot collect. What are we collecting it as? Collector. So I'm going to say collector. Okay, so I'm going to say collectors dot. Okay, so I'm not getting that suggestion. So I'm going to say collectors dot to list. You can see this. Okay. So this is what we are doing over here, and we don't need this line in fact. So everything is done just by a single return statement. Okay. So what we are doing is we are getting the list of users. This is returning the list of users. We are converting this list of users into a stream since it's a list, right? So it becomes a stream of user. You can see over here. These suggestions from IntelliJ are beautiful. Okay. You can see what we have right now on this first step is a stream of user. Then we are saying like apply this function map to user response to every item in this list. Okay, so you can see if you hover on this map, okay, so it will process this according to the given function. Okay, and then we are collecting it as a list again, and it becomes the list of user response. Okay, so this is something that we have done over here. And now if you come over here, okay, we have modified this and the error is also gone over here. Okay, this is done. I'll get rid of these commented things over here. If you want, you can just get rid of these. Okay, so I've deleted these, and here now what I'm going to do is instead of user over here, I'm going to get user response over here. Okay, and right now we're getting this error over here. So I'm saying fetch user ID, and then what is happening is I'm checking for this. So fetch user should also return user response, something like this over here. Okay, but what is it returning? It is returning a type of user over here. So I'm going to add an enter over here, and I'm going to say dot map, and I'm going to say this. Okay, we had an auto suggestion which is map to user response. So this is also now returning the user response. Okay, come over to controller again. Let's take a look at the next one. So this thing is returning a string over here. Okay, so this is fine. There is nothing to be done over here. Here, this is also returning a string. Okay, so this is okay. So these two we have updated. If you go to user service, okay, these two are returning Boolean. Okay, and this is taken care of. Okay, if you take a look at here in the request body, we are not making use of user request. So I'm going to say user request over here, and I'm going to say user request. Okay, and I'm going to pass in the object of type user request, because of course you have changed the response for all. So the request also has to be changed. This will be of type user request over here, right? And this is user request. Okay. Now, how do you convert this user request to that of type user object, right? That is something that you need to do over here. So what I will do over here is I will create a new user object. So I'm going to say user is equal to new user, something like this. And I'll create a method which will do the job of updating this user, which is newly created. with the values that exist in this user request. Okay, so I'll say update user from request, something like this. This is the name of the method that I'll create. I'll pass in user over here and also user request over here. Okay, something like this. And then I'm going to say user, or let me get rid of this. Okay, here you can say user.save and you have user over here. So this is done. Okay, so this is taken care of. Now we need to create this method. Okay, so this method should be created. I won't create it over here. In fact, I'll just cut this and let me just add it above over here. Okay, here somewhere. Right now, what we are going to do over here is we have user. Okay, so we need to update user with the values that exist in user request object. So I'm going to say set first name. I'm going to say request dot get first name. Then again user dot last name. Okay, and I'm going to say user request dot get last name. Okay, user request dot get last name. Okay, something like this. So I'm going to do this for all over here. Okay, so this is a getter. It has to be a setter. Okay, set last name, something like this. Okay, so I've done it for all the fields over here. You can see there are 4 fields: first name, last name, email, phone. Okay, now there is something called as address over here. Okay, so we don't need to update the, so if you go to user over here, okay, we have set it for first name, last name, email and phone. Role is getting auto updated. There's a default role of customer. ID is being auto generated. Created at and updated at are being auto created. Now the only thing remaining is the address, right? So what I will do is I will come over here to user service over here. Okay, and here I'm going to say if request dot request dot get address over here is not equal to null. Okay, then what you do in that case is you create a new object of address, in fact new address over here. Okay, and then what you do is you start setting the fields for this address as well. So you will say address dot set street, not set state but set street. Then you will say address dot set. So all the setters basically you will need. So after street you can have state, address dot set zip code, address dot set city. You can have address dot set country maybe, and I don't think anything else is left. Address dot set. Okay, we have covered all. Okay, zip code is also covered. So 1 2 3 4 5 6 fields are there. Okay, ID you don't need. So 1 2 3 4 5 fields you have covered. ID is something that will be auto generated. So what I'm going to do over here is I'm going to say request dot user request dot get address dot I'm going to get the street. Okay, user request dot get address remains common, so I'll copy this and I'll say get state. Then I'll come over here, I'll paste this, I'll say get zip code, you have get city, and then you have get country. Okay, so I've updated it for all. Okay, now what I'm going to do is this is taken care of. There is no return type over here, right? So this is done. Now what happens is whatever you updates you want to do have been updated in user and the user gets saved. That is taken care of. Okay, now coming back to the controller over here, this is updated with user request. If you come over here, here you also have user. So I'll say user request over here because this also should be user request type, and this will be update user request over here. Okay, and I'll pass in over here update user request. And then let's go over here inside this method over here, and this will be of type user request. Okay, and updated user I'll say request, something like this. Okay, and then what we need to do is we need to do some sort of processing over here. Now here you're manually setting it this way. We don't need to do this because we have created separate method for this, right? So what I will do is I'll get rid of this over here. Okay, and I'm going to say existing user, or not existing user. I'll call this method update user. Not update user request. So it should be update user from request. This is the one. Okay. And I'm going to pass in the existing user first. And then I'm going to pass in updated user request. So this will make sure that this existing user has the updated values, and then we'll call save, and then we'll return true over here. Okay. So all the updates have been done, as you can see over here. Okay. There is no model now in the controller. If you observe this, there's no model now in the controller. And if you scroll up, you should see this user model is not being used, and you should just get rid of this. Okay. Instead of user model, what are you using? User request and user response. User request is for request. User response is for response over here, right? Now, what we will do is let us do a test and see if this is working absolutely fine and how things are panning out. Okay. So let the application run. Application is running successfully. Let us head over to Postman. Okay. Let's try getting the user. Ideally, you won't see any response. That's okay, because there are no users created yet. Now, let us create a user. So I'll create a user using this JSON. You can see it got created successfully. Let us get the user. You can see the JSON is coming in. Okay. But the address we are getting is the null over here. Not only address, the phone is also null. So let me take a look as to what the problem is. So here phone is going in. Is phone being set in the database? Let us check. So I'll just connect to the database again. Let us take a look at the user table. Address ID is null. Okay, which makes sense. Now where is the phone? Phone is also being set to null. So there is a problem, and the problem is likely with the way we are setting the user over here. Okay, so here we have phone, user.setPhone. We are getting user.getPhone. Okay, makes sense. Okay, so here's the problem. You can see for phone. Okay, so here user.setPhone, and you are saying user.getPhone. So user does not have a phone. User request is the one which has phone. So there is a small mistake over here, and glad we are able to spot. So we are getting the data from the object, the request object, and we are populating it to the model. Okay. But earlier what we were doing is, the mistake we were doing is we were getting the data from the model itself and populating in the model itself. So that was a problem. That is done. Okay. Now why address is coming in as empty? Because you're creating the address over here. You're updating the values, but you're not updating this address entity with the user over here. Right. So what we will do as the last step over here, we'll say user dot set address to that of address over here. Okay. This is done. Now let us rerun the application. It should work absolutely fine now. Okay, is what I can sense, because there are no mistakes. These were the only two mistakes. Let us come over here. Let us try creating the user. It's created successfully. And let us try getting the user. So you can see now you get the phone number, and now you get the address as well in the right way. Please make a note, you're not getting created at, updated at fields. Okay. You have better control on what is being shown to the user. All right. You can even get a user if you want. You can see created at, updated at are gone actually. You can update the user this way. And if you try to get a user, you will get the updated values over here. Okay. So this is working absolutely fine. And if you head over to the database, if you do a refresh and connect, you're going to see all the values being updated. You can see role, address ID. Okay, everything is working absolutely fine. Let me clear this and let me get the address. You can see this is the address. So it's working absolutely fine, and there are no issues as such. So I hope you had fun implementing DTO pattern into our application. What we did over here is we added these two DTO objects. In fact, three. One is user request. Then we have user response, this one. And then we had this DTO, which is the address DTO, which represents the address. And it can be used in both request as well as response. Okay. Why we did this? We did this for implementing DTO pattern. We wanted DTO pattern so that we have better control on what is exposed to the outer world. And tomorrow, if we add any sort of changes to the model over here, it's best that the changes are not reflected to the outer world unless and until we make change in the DTO. Okay. And this has given us a better control, a better sense of control in our application and how things are propagated to the outer world. I hope you have been able to follow along, and I hope this has been super useful. So now it's time that we begin setting up the product entity. And what I'm going to do is I'm going to come over here into our models over here. and I'm going to right click and I'm going to create a new Java class, and this Java class will be product. So this is the class that is representing the product that basically the product information that we want to store into our database. Okay, so that is what we are adding over here. First thing first, we would want to mark this as an entity. Why? Because we want to persist this information into the database. We can also add name over here. I can say products, something like this. Okay, I'll add things like data over here, and I'll add things like no args constructor. Okay, this is done. We don't need any other annotation right now. I'll add fields like private long ID over here. So these are all the information that I would want to store over here. Okay, so private ID, I'll say private string name over here, private string, I'll store description. Okay, so against a product, we will have description as well. So we have name, description. What do we need else? Or what else do we need? We need price over here. So price is going to be a big decimal, and I'm going to have price over here. We can have stock quantity. So yes, whenever you're working in an e-commerce setup, okay, you need stocks as well, right? Otherwise you will just keep selling items without keeping track of the inventory. So I'll say quantity, something like this. I'll have a category as well. So I'll say private string category, something like this. Oops, so this will be small c over here, and this is done. Then we can have private string image URL. So this is the URL that is representing the product image. Okay, so this is something that we will add over here. Okay, we will also need a boolean field. So I'll keep track of a boolean value over here, which will help me keep track of whether the product is active in the database or non-active. Okay, so I'm going to say private boolean, I'm going to say active, and I'll have default over here to that of true. So after setting up the value for active, what I'm going to do is I'm going to have two fields. I'm going to have local date time. Oops, not local date time over here. And this is going to be created at over here. And I'm going to add private local date time. This is going to be updated at. So this is just for housekeeping purposes or just for tracking purpose as to when we are creating a particular entity or a particular record and when we are updating it. Okay, so this will help us with that. Now over here, I'm going to add a few annotation, like I'm going to say ID over here. I'm going to mark this as generated value. Strategy is, I'm going to say generation type identity. Okay, so this is taken care of. I'll come over here. We need to add some annotation over here. So I'm going to say creation timestamp. Okay, and here I'm going to say update timestamp. Okay, both of these are coming in from the same package, as you can see. Okay, I'll get rid of this unused import over here. Okay, so both of these are coming from the same package, as you can see over here. Okay, so yeah, this is our product entity. This is what we need over here, right? What I will do as a next step is we also need a repository, right? So I'll come over here and I'll add a new repository, something like this over here. It will be an interface. So I'm going to say product repository, something like this. Come over here. First thing first, we'll mark this as a repository over here, right? And then I'm going to say extends JPA repository. And what is the type of repository this is representing? So it is representing the type of product over here. And what is the type of primary key? The type of primary key is long over here. Okay, so this is what we have added over here. So we have this thing set up now. We have a product entity and we have the product repository. I'll restart the application. Let us see if this product entity is being populated into the database. Okay, and the application is up and running. Come over here. If you refresh and if you say connect, you'll see products is over here. Okay, you can see all the fields over here, or you can do select star and you can see all the fields being added over here. Okay, right now there is no information, no sort of data that is available in this. Okay, but soon we will have everything populated over here. All right. So I hope you have been able to follow along, and I hope it's useful so far. A quick mention over here that this course is a part of complete Java, Spring Boot, Microservice, e-commerce masterclass over here, e-commerce project masterclass hosted on Udemy. Okay, the link for this you'll find in the description below. You will find the link to the discount coupon in the description below. Okay, so do check that out. So the link will take you to my website over here, and if you click on enroll now, you will get the best possible discount, the lowest price discount at that particular point in time. Okay, and right now this course is available at the lowest price. I've updated the coupons on the website, so please take a look. And always I make sure there is at least one coupon available for my learners whenever they decide to enroll. And yes, Udemy of course has a limited coupon policy, so there is a limit on the number of coupons that I can distribute. So if you're planning to enroll into the full course, if you are enjoying this experience, then please check out the description, the link in the description below. It will take you to this website over here. You can read more about the course, and after enrolling, you get a lot more. Like you get 6 months of IntelliJ Pro, lifetime updates, and people who are enrolled into my courses, they know I update my courses a lot. Okay. It's not like you enroll and I forget. It's not like that. I keep on updating with new technology, new versions. So you get lifetime access to all the future videos. And yes, it's a 75-hour plus course over here. It's huge. It has hands-on labs and a lot of other content. So you can see over here. If you scroll down, you should see things like labs over here. Mock interviews. A lot of it is there inside the course. And yeah, we cover a lot of concepts in depth. You have access to notes as well. So it comes with a lot of features as well. So do take a look at this particular course over here. And first, you check the description. You click on the link and go to this website, and then unlock this coupon that you see over here. So this is a coupon right now, but I keep on updating the coupon. So when you are watching the video, you might see a different coupon that is valid at that particular point in time. And yes, there are tons of learners who have enrolled into the course. It is one of the highest rated courses. Bestseller first of all. And being bestseller on such a large platform or global platform like Udemy in this popular niche of Java, Spring Boot and microservices is not a joke. Okay. So there are a lot of learners who have already enrolled, and you can take a look at the ratings. These ratings are real, managed by Udemy. If ratings are on the platform, it's not managed by me. Okay, it's managed by Udemy, right? So it's not on my platform wherein I can go and edit the rating. It's not like that. It's Udemy, and the ratings here are genuine, and these are all genuine learners that have posted a lot of ratings. You can go and check out the real ratings over here from the real learners. A lot of people have upgraded their careers, got better jobs and increments as well. Okay, and you can see there are so many learners, and this count keeps on growing every now and then. Okay, so I hope this will be useful. And yes, of course, this is my website, embarkx.com. Here you will find this Java full stack. This is another course wherein we build. So if you are not familiar with Java Spring Boot, and if you need a portfolio project over here, so we build a full stack advanced e-commerce project over here. We cover everything like React, JavaScript, everything needed for full stack development. So that is this course for. Okay. We also have DevOps course over here. DevOps, you can see over here, this is a DevOps course. And we master a lot of stuff like CI/CD, Terraform, deploy apps to production. And this is a multi-cloud course. We cover AWS, Azure, and GCP as well. And then we have Spring Security. If you are facing difficulty with Spring Security and JPA, we have 2 courses for them as well. And we have a lot more. You can check out the website over here. Okay, but what I told you are the flagship courses. So yeah, do check this out, and thank you. So now it's time that we start defining some endpoints that will enable us to work and add some data and interact with this product entity. Okay, so what we are going to do is we are going to come over here, and here we are going to add a new controller. Okay, now this is a controller that will expose a certain endpoints related to product to the outside world. So I'm going to call this as product controller, and I'm going to come over here. First thing first, what we will do is we'll mark this as a REST controller. This is done. Now over here, I'm going to add a endpoint over here, or a mapping is what I can say. Okay. So the first endpoint I'm going to add is of post mapping. It is going to be an endpoint which will help us create the product. So I'm going to say over here public, and I'm going to say response entity. So we'll make sure that the responses are wrapped in response entity. Here I'm going to have product response. Okay. So we are implementing DTO pattern over here, wherein we are making use of a DTO over here. I'm not adding the model over here as a response, but I'm adding a DTO over here. Okay. Now DTO does not exist yet, so we'll see few red marks. So I would encourage you to just ignore these red marks. We know these are errors. Okay. We'll fix them one by one. First, let us define the structure. So I'll say create product over here. Okay. And now over here, I'm going to say request body. So I'm going to accept the entire product data in a request body, and I'm going to accept it as product request object. Okay. I'm going to say product request, something like this. Now this product request that we have added also does not exist. Okay. It does not exist. It needs to be created, and we'll be creating it, like I said, step by step. Okay. So I'm going to say return, and here I'm going to need a object of type a product service. Now product service also does not exist, so I'm going to say new response entity. Okay. And here I'm going to say product service. This does not exist. Product service dot create product. Okay. And I'm going to pass in product request over here. Okay. And this would return the status code of let me go to the next line. So status code that it is returning is HTTP status dot, so HTTP status over here dot created. Okay. This is what it's returning, and I'll add a semicolon. Okay. Now let us go through the errors, all the red marks that we are seeing one by one. First thing is product response. So let us create a class that represents the product response. So I'll create this class. Where are we creating this? We'll have to create this in the DTO. Okay. So let me create it in controller right now. Okay. I'll create it in controller, and then I'll say DTO over here. And then if you hover on this, I'll go to more actions, and I'll say move to package DTO. Okay. So this is move to product response over here. If you see product response. Okay. So now what I'm going to do is this product response is going to have all the fields that I want to expose to the outer world. So from product.java, I'm going to copy all of this. Okay. And I'll come over here and I'll simply paste it. So what do I have? I have ID, name, description, price, stock quantity, category, image URL, and Boolean. And I'll remove this default assignment to this. So whatever is there in the database will come over here. Okay. Just in case you change the database value and update it manually to inactive and mark it inactive, and you can mark it inactive by assigning false over there. So you will get false as a response over here. And then I'll make sure there are getters and setters generated for this particular class. This is done. This is our product response. Now come over here, just import product response. So this error is gone. Now let us create product request. I'll create product request over here, create a class, create it, just go over here and just update this to DTO. Just hover on this and go to more actions and just move this to package DTO. It confirms, this confirms that it has been moved to the DTO package. Come over here. Now for request also, we need to define the structure. So what do we want to have in the request? Okay, so I would want to have things like name, description, price, stock quantity, category, image URL. Okay, so here I'll copy this information. I'll paste this information. I don't want things like ID over here because ID is something that is system generated. So I don't want to bother end user to pass in ID into my API. There is name, description, price, stock quantity. I have a category and image URL. I don't want active to be passed in because initially when the product is created in the entity over here, we are having a default value assigned. So we are hard coding it to true. So we want all the products that are being created to be marked as active. Okay, and this is something that we are hard coding in entity itself. So this we are doing from requirement standpoint. Okay, if you don't want to hard code this as active, you can move it to, or you can add this field over here and you can accept it from the end user. So it's totally based on requirements, but I believe whenever a product is being created, it should be active unless and until it is marked as inactive manually. So the user or the seller does not want to sell it. Okay, so this is my requirement and that is why I'm setting it this way, but depending on your requirement, you can modify things of course. Now here, I'm going to have data annotation again, and this becomes our product request. Now coming over here, you will have to like import this class product request. So just get this imported. You can see product request. This is done. Now we need a service. So what I'm going to do is here, I'm going to add a field called private product service, and I'm going to say product service over here. Okay. Now this product service does not exist, right? So I'll mark this as final. And what I will do is I'll add a required args constructor. Okay. So let me tell you one thing. This service will be a Spring managed component. Okay. Let me show it to you. So let me create this class first of all. I'll create this class in the controller and then I'll move this to service package. Okay. Over here. And then over here, I'm going to say move it to this package. So we have this service created over here, right? Product service. And I'll mark this as service, right? Something like this. So this is now a Spring managed component and we want Spring to auto inject this over here, right? How do we make sure that Spring auto injects it over here? So one is by adding a constructor. So if Spring identifies this as a constructor. Okay, first of all, controller is also Spring managed component. So it will create an instance of controller and it will see that, hey, controller needs service as a dependency. What is product service? Do I have a type of product service? So since product service is also a Spring managed component, Spring will likely have this. So Spring will inject it over here and this product service will get initialized. Okay, or if you don't want to add a constructor manually, you can make use of auto wired annotation over here. You can say auto wired, something like this. Or another approach is you can make use of Lombok based annotation, which is required args constructor. What does this do? This will generate the constructor with required arguments. Now required arguments are final fields and fields with constraints such as not null. So which is the final field over here? This is the final field, right? So a constructor will be created with this over here. Tomorrow, if I add a field over here, private object, I'll say object over here. Okay. If this field is added, will this be added to the constructor using required args constructor? No, because it is not final. Okay. So only this will be used. Okay. So remember this, I'm making use of required args constructor and then this is taken into consideration. Okay. Now the error related to product service is gone, but we have got a new error where it says that, hey, product service does not have create product, which makes sense. It does not have. So we'll have to create a method inside. I'll just click on the suggestion and you can see the method beautifully being created. Okay. And now over here, I'm going to have the entire logic for basically creating the product. Now understand this. We have a repository. We are going to make use of repository. So this is a product repository. We are going to make use of this product repository to save the product. Okay, so I'm going to say product repository. Okay, so we need an instance of product repository as well. So again over here, I'm going to say private final product repository and I'm going to say product repository, something like this. And here I'm going to add required args constructor. Okay, so this is done. And now over here, what I'm going to do is product repository dot save. Now for saving this, I need an instance of product over here. You can see the suggestion product entity. Okay. I don't have an instance of product. I have an instance of product request. So what I would do is I would map or convert this product request to that of product. Okay. So I'll come over here. I'll create this product over here. I'll say product is equal to new product. Okay. And this will be saved over here. Oops. So this will be saved over here. Now the thing is, does this product have anything? No, it's empty, right? So we need to convert this product request to product. So what will I do is I will create a new method over here. I'll say update product from request, something like this. And I'll pass in product over here and the product request also. Okay, this is done. And then we are saving the product. Okay, and then what I would do is I would say product over here, and I'll get the response as saved product. Okay, so I'll get the saved product over here after saving the product, and I will have to return this saved product. But I cannot return this saved product because I need a response of product response, right, after saving. So I'm going to come over here. I'm going to say return map to product response, and I'm going to say saved products. Okay, so what this method does is it is going to map a product object to that of product response, and it is going to return that. So we need these two methods that will be a sort of helper methods, and they will help us do these kind of things. Okay, so I'll quickly create this first one, update product from a particular request, and I'll also create this one, map to product response. Okay, let us start defining this. So first we'll define this map to product response. So I'll say product response over here, and I'll say product response is equal to new product response, something like this. Okay, I'll just shorten the name of this object, otherwise we'll have long lines of code. Okay, response is also fine. Now over here I'm going to set everything. So I'll say response dot set. I'll set the ID first. I'll say response dot set. We need to set the name. Response dot we need to set whether the product is active or not. Response dot I'll say set the category. Response dot set the description. So we need to do this for all the fields you can see over here. ID, name, description, category. So I'll say set what is pending, price over here. Response dot set image URL. I think all are covered except the stock quantity. So I'll say response dot set stock quantity. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and over here we have 8, and these two are auto generated. Okay, so this is done. Now I'll come over here, and actually we don't need to update this active over here. Okay, or let us have this active, okay, just in case as a future from future standpoint, but it's not going to impact if you are hard coding the value in the product entity. Okay, but I'm still keeping it. Okay, so now I'm going to say save product dot get ID. Okay, so I'll just copy this. Okay, this part will repeat. Save product dot get name over here. Save product dot get active over here. We need to get category. Then over here we'll get the description. So you can see IntelliJ is smart enough. It is suggesting the right getter against the setter. So if I'm calling this in set image URL, it will give me get image URL as a suggestion, the first suggestion. IntelliJ is smart enough that way. Okay, you get this, and what I'm going to do is I'm going to return over here the response, something like this. Okay, so this is done. Now let us work on this wherein you update the product from the given request. So what I'm going to do is I'm going to say product over here. Okay, product dot set name. Okay, so let me copy this part. In fact, okay, this is going to be repeated. So I'll say product dot set, and we'll start with name over here. Okay, and in fact what I can do is there is an overlap in what we are going to write now, right? So what I can do is I can just copy this part until image URL and stock quantity, this much. Let me copy this and let me paste it over here rather than typing in again. Okay, and here we are updating it against the product. So I'll update all the response type to that of product. Okay, we are updating the name, description, we are having price. Okay, let's check if we are updating all the fields. So I believe we are updating all the fields. We don't need active over here, so I'll get rid of that. Okay, and over here instead of save product we have product request over here. So I'll just keep getting this. Okay, so here you can see we have updated this. Okay, so this is done. We have these methods defined and the create product defined over here. So what we will do is we'll also have to define a endpoint over here. We have not defined the endpoint, okay, the right endpoint. So what I will do is I'll first of all map this entire controller to, so let me say REST controller over here, and I'll add, so REST controller is already added. Okay, so what I will do is I will, okay, not the REST controller, I'll add it's called RequestMapping, right? I forgot the annotation. Here I'm going to say /API/products, okay, something like this. And what I'm going to do is for this post mapping, I'm going to leave it as it is. So if there's a post request being sent over here, it will be redirected to this mapping over here, right? And let me run this. Let us see the kind of response we get. Okay, it should not throw any sort of errors whatsoever. So you can see it's running successfully. Come over here, and what I will do is I'll just close all of that tabs. Okay, so close all the tabs. Now here under eCommerce, I'm going to add a folder. Okay, this folder will be user over here. I'll move all these requests under user. Okay, something like this. And then I'll have one more folder. So we are segregating requests now. Okay, I'll add a request. Okay, and let me close this. So here now I'm going to say create product. Okay, and I'm going to create the JSON over here. So I'm going to say API/products, and I'll leave this like this. And I'm going to say post request. I'll say save. And here under body, I'm going to select raw, and JSON is selected. Now here, what I need to do is I need a JSON for the product, and JSON for the product will be depending on the product request, right? Now over here, I'm going to add something like name over here. Okay, and I'll simply add all the fields like name, description, price, stock quantity, category, and image URL over here. So you can see over here, this is a JSON that I've created. Name iPhone 15 Pro, latest iPhone. In fact, I can add this to 16 or 17, that's okay. Price, random price, stock quantity, category, and image URL. Okay, this is some dummy image URL of some placeholder image, which I've added right now. Okay, now what I can do is I can trigger this request. Let us see what we get. So you can see we get this as an output. You can see, okay, ID is created. We did not pass ID. Active is being marked to true, which is the default. Okay, now if you come over here in the database, let me refresh this. If you say connect, okay, you're going to see products table. Go over here. You're going to see all the details that we passed in have been added into the table over here, right? So this is working absolutely fine, and we are able to create the product in our database. Now let us talk about updating the product in the database. Okay, so for that, what we are going to need is we are going to need a new endpoint. So I'm going to come over here. I'll quickly replicate this endpoint because the functionality is going to be much more similar. So instead of create product, I'm going to say update product, something like this. And here I will have this response as product response. This won't be post mapping. This would be put mapping instead, right? Put mapping. And I'll need something else. I'll need the value of the product ID that we want to update. So I'm going to say over here, ID over here. Okay, something like this. All right. And we need to get this ID in the as a parameter over here. Okay, so I'm going to move this to a new line. Okay, and come over here, and here I'm going to say @path variable, and I'm going to say long ID. Okay, so whatever value you're passing in over here in ID is being reflected over here. And what you can do is here, so this is done. This part, the definition part is done. This is what we need. We need the request with the updated product details, and we need the ID against ID of the product against whom the update is supposed to be performed. So after getting these two things, I need to make sure that I call the right method over here. I'll say update product over here. Okay, so here I'll say update, something like this, and I'll pass in product request, and I'll also pass in the ID. So I'll say ID as well over here. Okay, and then here I won't return created because created is for creating a new resource. I'm going to say OK over here. All right, this is done. Now This is a red mark, so I need to create this method inside the service over here. Okay. Now what I'm going to do is here we need to first get the product from the database, and then we need to perform the update against that particular product. So what I'm going to do here is I'm going to come over here. Okay. I'm going to say user repository. Sorry, not user. We are in the product. So I'm going to say product repository dot find by ID. Okay. Find by ID over here. Now this find by ID is being exposed to us by the repository. Okay. These are the set of JPA methods that are exposed and allow us to do CRUD operations. So we make use of that. I have ID over here. So when we are saying find by ID, we need to pass in ID. Okay. Then I'll say dot map over here, and I'll say existing product over here, and I'll make use of something like this, and I'm going to say update product from request, and I'm going to pass in existing product and updated product, or sorry, not updated product, it's product request over here. Okay, so this has to be product request. Okay, something like this, because that has the updated product information. And then I'm going to say product repository over here, product repository over here dot save, and I'm going to say the existing product over here. That is what we need to save. I'll add a semicolon, and then I'll say return true over here. This is done, and then I'll add else clause or else false, something like this. Okay, so this is being taken care of, and what we can in fact do is we need to return product response, right? So I'm going to say over here return. Okay, so this should return product response. So what I will do is I'll say product saved product over here. Okay, so this save method will return the product that is saved. Now for this saved product, I'm going to transform this into product response. So I'm going to say map to product response, and I'm going to pass in saved product, something like this. Okay, and here I can get rid of this over here. Oops, so I can get rid of this over here. Okay, now we are getting these red marks because we removed that else clause. These red marks tell us that this is returning an optional. Okay, so what we will do is we will say over here dot or else throw. Okay, so we'll throw an exception if the product is not found. We'll say something like this, and we'll say new runtime exception, and I'll say product not found. Okay, so let me scroll down, product not found, and I'll mention the product ID over here. Okay, so I'll say ID over here, something like this. Okay, so this product is not found, and that is why we are raising an exception. Okay, so this is done and it's taken care of. Okay, as you can see over here, product controller, we have this also being managed. Okay, so one thing I like about this is we are returning product response, but the problem over here is this would raise an exception if the product is not found, and it won't return a valid status code like 404 or not found or something like that. Okay, so I want to have valid status code as well. So what I will do is I'll just revert this code that we've written. I'll just get rid of this over here, this part. Now this will give an error. It is saying like it is returning an optional. So I'll say update this to return an optional. Now in the controller, what I will do is I'm getting an optional over here. Okay, so I'm getting an optional, and what I will do is I'll handle this to manage optional over here. So here I'll tweak this over here. So I'll just get rid of this entire thing. Okay, I'm going to say service over here. Okay, so what is the name? Product service. Oops, not request, but product service dot update product, and I'll send in ID and product request over here. Okay, then I'll say map, and I'll say response entity colon okay over here, or else I'll say or else over here. So it's or else get, and we'll say so here we'll say response entity dot not found dot build. Okay, So this way is the ideal way of handling things rather than throwing a internal server error over here, runtime exception. So I was not just happy at the back of my head, so I just thought I'll change it right away. Okay, so this is done. Okay, and if you run this, okay, you can run this. Let us take a look as to how this works. So you can see the application up and running successfully. Come over here. We'll have to duplicate this request because the update request will be same as or similar to that of create product. So I'll say update product over here. And here I'll pass in the ID. Okay. And keep in mind that this product does not exist yet. Okay. This product does not exist in the database because we have restarted the application and the database has reset. So if you take a look, there's no product. Okay. So if you come over here and if you try to update this, you can see, oops, we are getting 405 method not allowed. Makes sense. So this has to be put request, right? So I'll say send. You can see 404 not found. The requested resource could not be found over here. Okay. So you're getting not found over here. Now what you can do is we'll create a product over here. Product is created. Now I'll say iPhone 16 Pro updated. Okay. So if you come over here, if you run this, you'll see iPhone 16 Pro. Okay. iPhone 16 Pro is the name. So if I update this, iPhone 16 Pro updated, you'll see iPhone 16 Pro updated and you can see the updated response. And now if you come over here and if you run this, it is updated in the database is what you will see. You can see it is updated. Okay. So this is working absolutely all right. And I hope you have been able to follow along. I'll just save this request. I hope this has helped you to see as to how things are working, and I hope you are understanding as to what we are doing, why we are doing, and I hope you are able to follow as well. So now it's time that we add more endpoints like getting all the products and searching for a particular product and so on. Okay, so what I'm going to do is I will come over here. Okay, so the endpoints that we are going to have is like getting all the products, deleting the product, and searching for a particular product. So first we'll begin with getting all the products. Okay. So I'll come over here. I'll just duplicate this endpoint over here wherein we are creating the product. And here I'm going to say get mapping. Okay. And it is returning a response entity product response. So the return type we want to have over here is list. And I'm going to add this thing over here. Okay. Now instead of create product, I'm going to say get all or get products. Something like this. Okay. We don't need a request body over here. So I'm going to get rid of this one. Something like this. And then coming over here. Okay. So here we are saying return new response entity. And we'll say get all products. So I'll get rid of this. Okay. So I'm going to say response entity dot okay. And then I'm going to say product service dot get all products. Something like this. Okay. So this is something we'll have to do. And the rest of the job is being taken care by the service class over here. Okay, so service class needs to have this method called get all products and it will give us all the products. So I'll just create this. Okay, so this is being created as a field. Okay, so I don't need to create this as a field, but this should be as a method. Okay, so now I'll say create method over here. So this method gets created. Okay. Now, what is it returning? So it will be returning the list of product response over here. Okay, list we need to import. We'll do that. Now coming over here, we are going to say return, okay, product repository dot find by. So I'm going to say active true over here. Okay. Now what I need to do is I need to get all the products that have active flag set to true. Okay. Now this method does not exist. So what I will do is I'll hover on this and I'll say create a method find by active true in the repository over here. And this should not return product response, but it should return product because this is a repository, right? Now we have not defined what or how this particular thing should fetch the data from the database. Okay. But let me tell you over here, JPA is smart enough. Like if you follow a particular syntax, it is going to translate it automatically into the queries. So here, for example, we are saying find by. So JPA knows like this is a select query. Okay, when you say find by, it means that it is a select query. So if you go over here and if you take a look, so we have find all. Okay, so it won't be there in this particular service because we have not defined it yet. But find all meaning it is finding all. So it knows that it is select star all. Okay. When you say find by, it knows that it is select query. And we are saying find by. So it is looking for the field. So we have mentioned active over here. Now active is a field in product. Okay. You can see active is a field. So we have mentioned this exact field name over here, find by active, and we are saying true. So true is the value. So JPA knows, okay, so this person wants the data to be filtered by this active field, which he has mentioned over here, and the value is supposed to be true. So it generates the query in the hindsight. You don't have to mention anything else, and it looks for the return type, and the return type is the list of the model, like the model type. So it is just returning the list of products. Okay. JPA is smart enough and it does the job for you, provided you follow the convention. So this is the convention. Be sure to make a note of these capitalization over here in between. So I've mentioned by. So this way JPA is also able to understand. Okay. So I'll come over here to service and I'll say, so where we were. So we were over here. So we are saying find by active true. Okay. And I'm going to convert this to stream because we're getting list as the response. So here, if you see, okay, we're getting list as the response. So I'm going to say stream. So it will be converted into a stream. Now I'll say enter. I'll say map. Now we need to map this because this is giving us the output in the form of product model. So I'm going to say this and map product response. So I'm mapping it to product response type, and then I'm going to collect it as a list. So I'm going to say collect.toList. Okay, so I'm not getting that over here. I'm going to say collect, and I'm going to say collectors.toList. Okay, collectors.toList. Okay, something like this. Okay, this is taken care of. Okay, and what we can do now is let us try running this and let us see if we are getting the list of all the products in one go. All right, so we are getting an error over here. Incompatible types, no instances available. Okay, so it confirms that response entity dot product response. So this is not the type of let me see over here, list of response entity and then product response. Okay, so there's a mistake over here. Response entity should be on the outer end. Okay, I'm sorry about that. So it is list of product response and then it is wrapped in response entity. That is how it should work. Okay, so mistake from my end. That's absolutely okay. All right, and we'll wait for a while until this application runs completely fine. It is running and it's done. We'll come over here. We'll try creating a product. You have this product created. We'll come over here. And then here we'll duplicate this and then we'll say get all products, something like this. And here we'll get the products this way and then we'll get it this way. Okay, we'll say get mapping and I'll say get. So you can see over here, this is the output that you're getting. Okay, now if there are more products, so let me repeat this post request again. If there are more products, so you can see it will be returned as an array. So this is working absolutely fine and you can see the array over here, okay, the response. So this is done and now let's move on to the next endpoint over here, which is you should be able to delete any product that you want from the database as well. Okay, so let's move to that. So now I'll come over here to the controller and let us start defining the endpoint for being able to delete the product from the database. So here I'm going to come over here and I'll just duplicate this part over here. Okay, I'll duplicate it over here and here instead of put mapping, I'm going to say delete mapping. I'll accept ID over here. Okay, and response entity, there should be void over here, something like this, void. Okay, so we are not returning anything. Instead of update product, I'll say delete product over here. Okay, and I'll accept ID over here as the request parameter. Okay, so let me also take this to the same line. And here now I'll say product service, delete product. Okay, and I'll pass in the ID over here. Okay, So this ID is being passed in, and of course we need to return something. Okay, so I'm going to say over here, we won't be returning this. So let me cut this return from here, and I'll come over here. I'll say return ResponseEntity dot no content. Okay, no content dot build. Okay, so this is done. Okay, so this is taken care of. Now this delete product does not exist. So what we need to do is we need to create a method in service. So we have this method created over here. Now what we are going to do is I am going to say over here product. So product service or product repository dot delete, and you can pass in the product type over here or the product object over here. Okay, but this is not how we are going to delete stuff. Okay, we would be marking the product as inactive. That is what we are going to do. Okay, if you want to just get rid of the product from the database, you can simply delete it. Okay, but deletion for us is something else. So I'm going to say product over here. Product is equal to product repository dot find by ID. Over here, I'm going to pass in the ID. Okay, and I'm going to say dot or else throw, and I'm going to add something like this, and I'm going to say new. So I'll throw an exception here. If the product is not found, I'm going to say product not found. Okay, something like this. And then over here, I'm going to say product dot set active. Okay, and I'll say false over here, and I can say product repository dot save to, and you can pass in the product over here. Okay, now here we are throwing an exception. Okay, which is not the ideal or the best way, but let me run this application and let us take a look. Okay, so the application is up and running. Now I will have a delete request over here. So I'll just duplicate this, or let me duplicate update product, in fact, because it has a similar URL structure. So I'll say delete product, something like this. And here instead of put, I'll say delete. Okay, and let us send this. So you can see you get an internal server error because this product does not exist. Okay, what I will do is so if you come over here in the stack trace, you can see product not found. Okay, because we restarted the application and any product with ID 1 does not exist. We can optimize this a bit. All right, so what we will do is I will return a boolean over here, and I'll tweak this method in a way. Okay, so what I'm going to do is here I'm going to say return product repository. Okay, and I'm going to find by ID over here like we are doing over here. So I'm going to copy this, paste it over here. Then I'm going to say dot map, and I'm going to say product, something like this. And here I'm going to say product dot set active to that of false over here. Okay, and I'll say product repository dot save product, something like this, and I'll be returning true from here. Okay, return true, like so. Okay, or else I'll say, or else throw, or sorry, not throw, return false, something like this. And then we can get rid of these statements over here. Okay, so this job is done in single line. But now if you come over here to controller, you can handle this boolean over here. Okay, so what you can do is you can check. Okay, so I'll say boolean deleted, something like this. Okay, boolean deleted, and then over here you can check for deleted. If it is deleted, and you can make use of ternary operator. Okay, so if it is deleted, then you show no content. Okay, otherwise you say ResponseEntity dot not found. Oops, so you can say not found dot build over here. Okay, so if it's deleted, then you say no content, and if it's not deleted, you say not found. Let us test this. This has to be a better approach. Okay, so the application is up and running. You can see over here, no issues as such. Come over here, and you can try running the same endpoint, and you can see 404 not found. The requested resource is not found. Makes sense? Let me create the product. And let me try deleting it again. So now you can see 204 no content. So you're seeing this green mark 204 no content, which means there is no content in the body. Okay, so this is working fine, and I'm glad like we have been able to manage to get through this delete product endpoint. So now let's talk about the endpoint for searching the product. So I'll come over here, and what I'm going to do is I am going to replicate this endpoint over here. Let us replicate this. And here, instead of delete mapping, we are going to add get mapping. Okay. We won't be passing in ID over here, but instead we'll be saying search over here. And here we would need to return a list of product response wrapped in response entity. So we'll add this over here. Okay. I'm not typing in to save some efforts. I can say search products over here. Okay. And we don't have a path variable, but we will need a request parameter. Okay. So request parameter is something that we'll need. So I'll come over here. I'll just get rid of this. I'm going to say request parameter. Okay, this is the one. And I'm going to say string keyword. Of course, this has to be, we need to know the keyword as to using which keyword the user wants to search and get the list of products, right? Now over here, what I'm going to do is I'm going to get rid of all of this. Okay, we don't need this. I'm going to say return straight away response entity dot okay. And I'm going to say product service dot search products. So of course this does not exist yet, but I'm going to pass in the keyword over here. Okay. So this is done. Okay. And what we need to do now is I'll create this method called search products within our product service. Okay. So you can see over here. All right. Now here, what I'm going to do is I'm going to say return product repository dot search products. Okay, this does not exist yet. All right, it will take keyword as the parameter. So this is a custom method that we need to define inside our repository. We'll be defining that shortly, but this is going to return a list. Okay, list of products, and I'm going to convert it into a stream over here like so. Okay, and then I'm going to say dot map. Okay, so this is not working because we don't have search products defined. So let us define search products first. I'll create the search product. So this won't be optional, but instead what this will be is it will be list of products. Okay, list, and then over here it will be list of products, something like this. Okay, sorry, not products, but product. Okay, that's the model. Okay, now we have the keyword over here. Okay, and what we will do is I will add a custom query over here. Okay, so I'll say @query. Now using this query annotation, you can see over here, this is the annotation that you need to make use of. Okay, and it will come in from this particular package. So using this query annotation, you can specify any sort of complex conditions that the inbuilt methods of JPA repository does not fulfill. So inbuilt methods that you're getting like find by ID, find all, save. If you have any sort of custom requirement, you can define your own query as well. So that's the power, that's the flexibility that you get over here. So I'm going to say over here, select, okay, select P from product. Okay, so product, something like this, P, where P dot, I'm going to say P dot active over here. Active is equal to true. Okay, so we need to first filter the products that we are getting using the active flag, wherein active is equal to true, and I need to say and P dot stock quantity. So stock quantity, it should be greater than 0. Okay, so all the products that you're getting as a response over here should be in stock. And you need to say lower over here, and here you need to say P dot name. So you are converting the name of the product to lowercase. Okay, and then what you're doing is you are saying over here like lower, something like this, and here I'm going to say concat. Okay, and then over here you're going to add percentage like so, and you will pass in comma and colon keyword like so, and I'll add comma over here, and the percentage, something like this. Okay, like so. So this is done. This is taken care of. Okay, and let us understand as to what is happening over here. Okay, so this part query, like I said, it is part of JPA query. It is also known as JPQL, which is JP query language. Okay, so that is what QL stands for, query language. Okay, Java persistence or Jakarta persistence query language. So this is used to fetch product entities from the database. Okay, what this is saying is, this is making sure that only active products are being picked up from the database. This condition is ensuring that we have the product that is in stock. Okay, this condition is making sure that we are basically matching the product name properly. So we are converting it to lowercase first, and then what we are doing over here is we are finding the products where name contains the given keyword. So this entire thing looks for products where name, what is name? Name is the name of the column. So where name contains the given keyword. So this is a given keyword anywhere in the name. Okay, so with the help of percentage, so we are making use of percentage over here to concat everything over here. Okay, so this keyword that we are passing in as the parameter, this keyword will have percentage in the beginning as well as in the end. Okay, so if you're passing in the keyword as iPhone, so the keyword will become as percentage iPhone and then percentage. Okay, this is used for pattern matching. Okay, so this is how it will be converted using this concat over here. Okay, and then it is converted to lowercase because it is a possibility that user might have sent this keyword in the uppercase. So we are converting everything to lowercase, the name of the product in the database as well as the keyword to lower, so that the match is perfect. Okay, and then we need to add one annotation so that this keyword is being passed in as param. So we are saying param over here. Okay, and I'll say this is keyword. Okay, this will be passed in as a keyword. So this keyword becomes a parameter. This keyword becomes this keyword parameter, which is then being passed into the query over here. Okay, I hope this is making sense. Okay, so this query is a custom query that we have defined over here, and we are making use of this in the product service. I hope this is making sense. So we have this list of products over here. What I will do is I'm converting this to a stream here. I'm saying dot. Now you are seeing all suggestions. Okay, map. So what you will map this to product response. Okay, and then I'll say collect, and I'll say collectors dot to list. Okay, so collectors dot to list, something like this. I'll add a semicolon over here, and we are done. So let us test this and let us see if this is working fine. So we'll run our application and we'll see if application is running fine. So you can, oops, so we get an error. What is the error? Let me see the error over here. Okay, so we are getting could not resolve the root entity product. Okay, and where are we getting this? So we are getting this likely in this thing over here. Okay, in the repository. So here we have defined product. Okay, so what is happening over here is here in the product model we have the entity table name as products, but here in the repository we are referring to it as product. So I'll add S over here. Let me rerun the application. Let us see if it works fine. It should ideally. Yes, so this time, oh, so there is still an issue. Let me take a look. So we are getting this error again because if you scroll up, okay, let me see what's the problem now. So here, if you see, could not resolve products. So let me update this to small p and see, because here in the product model, we have it with small p. So let me run this. Let us see if this works. You should be able to recognize now. So it works now, I believe. Yeah, the application is working now. So everything is set. Now if you come over here, let me like duplicate this. Okay, this get mapping, and this I will be search products. Okay, search products. Okay, products. Now here what we need to do is, so I'll just save this delete product. So for searching the products, we need to pass in the request parameter. Okay, so first I need to add search over here, search, and then over here I need to say keyword, something like this, and the value is iPhone. Okay, and let me search. So you can see there are no products matching iPhone. Now let me create a product. I'll create a product. Let me search for it. You can see iPhone. Okay, now if I search for iPad over here, iPad, if you search, you won't get iPad. But if you create a product name iPad over here, you can say iPad. Oops, so let me get rid of this. So say over here iPad. Okay, let me just have iPad. I'll just say create. Get all the products. You'll have iPhone and iPad, right? Now I'll go to search products here and I'll just search for iPad. So you'll see you get iPad only. There is no iPhone. If you search for iPhone over here, okay, iPhone, and if you say send, you will get iPhone 16 Pro. Okay, so this is working absolutely okay. Okay, I won't save it with the iPad name. I'll just do Control Z. But you can see how this search is working, and this is the request parameter that you're passing in. Okay, so let us quickly review as to what happened. And you can see over here, my console is open, and when we searched, you can see this is a query that has been generated. You can see this is a query, and this is a query that we have defined in the repository as well, if you see, right? So this is working absolutely okay. And if you come over here to controller, we are hitting this endpoint, right? And we are passing in the keyword as a request parameter. Keyword is being passed into search products. Inside search products, we are calling this search products method from repository, which is giving us the list of all the products. And we are making use of JPQL over here, JPQL, I'm sorry. So this is allowing us to define custom query for our benefit, because we have a different use case and we want to write a complex condition matching our requirements. So we have done that. We are passing in keyword as a parameter to the query, the custom query that we have written, and this goes and sits in over here. Okay. And once this is done, we get the response over here in the service, and we are mapping it to product response, and we are collecting it as a list. Okay. So I hope you have been able to follow along, and I hope this has been useful. So now it's time that we begin working on the user cart, and for the same, we are going to set up a model and a repository. So here I'm on the project, and I'll come over here to this model package over here, and I'm going to say new Java class over here, and I'm going to call this model as, or the entity as, cart item. Okay, cart item in fact. Okay, so this is created now, and the first thing that I'm going to do over here, like we have always done, is mark this as an entity. And we don't want a custom table name for this. Okay, so that's fine. So I'll have data annotation added over here from Lombok. Now, what are the fields that we would want to have in this cart item? So I'm going to have ID first of all. So I'm going to say private long ID. Yes, this is going to uniquely identify every cart item that is added inside the user's cart. Then this is a user's cart, so it has to be associated with a user. So I'm going to say private user, and you can have a user over here. Okay. So this, every cart that we add over here, we need to have a link to the user. Of course, we'll be creating relationship in a bit, and we also need over here, we also need product. So something like this. I'll also need things like quantity, price as well. So I'm going to say private integer quantity and private big decimal as a price over here. And then I'm going to say, I'm going to add a couple of fields which for housekeeping purpose, like local date time created at, and I'll say updated at. Okay, so I'll add a semicolon. Let me duplicate this, and I'll add this, and I'll say updated at, something like this. Okay. Now let us work on this entity and let us add some annotation. So first thing first, I'm going to mark this as ID. I'm going to add generated value, and strategy is identity. Okay. Then over here, this is a link to the user entity, right? So I am going to have a many-to-one relationship over here. Okay. Now many-to-one because one user can add many cart items, okay, into his cart. So one cart can have many items over here. So I'm going to say many-to-one. Then I'm going to define the join column. I'm going to say name over here, and I'm going to define the column as user ID, and I can say nullable false, so it cannot be null. Okay. Then this is a link to the product entity, and this again will be many-to-one. Okay. So I'm going to say many-to-one. And I'm going to say join column over here, name as a product ID, something like this. Okay. And I'm going to say nullable as false. Okay. Integer and big decimal price is fine. For this, I need to add a couple of annotations over here. So I'm going to say creation timestamp over here, and this will be updation timestamp or update timestamp. Okay, so this will be auto populated by Hibernate. Okay, so this is what our entity looks like. And now if I run the application, let us see if this entity is created into the database. So the app is running fine. I'll come over here. Let me do a refresh. We'll be asked for login. Absolutely fine. We'll see this cart item appear over here. And here you can see price, quantity created at, ID. Then you have product ID, updated at, and user ID. So product ID and user ID are foreign keys to this table, user table over here. So you have this user table, and then you also have the product table. So they both are foreign keys to these tables. Okay. So this is done. Now what I'm going to do is I'm going to also define a repository. So I'm going to come over here, and here I'm going to create a new repository. Okay, and this is going to be an interface, and I'm going to say cart item repository, something like this, and I'm going to hide this. Okay, let us do like this, and I'm going to say extends JPA repository, and over here cart item long. Now we need to mark this as a Spring managed component, so I'm going to add the repository annotation. Okay, so with this setup, we have cart item entity being set up, which will be persisting to database, and we also have a repository in place which will do the job of interacting with the cart item table in the database. Okay, so that's about the setup. I hope you have been able to follow along so far. So now it's time that we go ahead with creating the endpoints that will help us work with the user cart. So we have the cart item .java, which is our entity that is persisting to the database, and we have the repository. These both are created. So what I will do is I'll come over here, and I'll first start by creating a controller, like always. Okay, and I'm going to call this as a cart controller. Okay, and we have this controller set up. First thing first, I will add the annotation over here. I'll mark this as a controller officially. Now what I need to do is, okay, I also need one more annotation, which is request mapping. Okay, so I need to map the endpoint to this particular controller, and the endpoint will be /API/cart over here. Okay, so this is what I have mapped, and what I'm going to do is I'm going to add the first endpoint wherein we'll allow users to add to the cart, or he can add the item to the cart essentially. So I'm going to have this as a post request. I'm going to say public response entity, and I'm going to add in void over here. Okay, and then I'm going to say add to cart over here, something like this. Okay, and then over here I'm going to add in request header, like so, and we'll accept a request header. So the request header will be with the name X user, and I'll pass in ID over here. Okay, and here I'm going to say user ID, something like this. Okay, so this is our first parameter that we need for this particular method. Then I'll also need cart item request object. Okay, and I'll say request over here. Okay, so understand this. What is happening is we have a post mapping on this particular endpoint /API/cart. So it's domain name or the host /API/cart, and you have to send a post request along with two things over here. So one is the object of cart request, and that you have to send in the request body. So I'll say request body, Okay, so you have this come in the request body, and then you also have to send in the user ID. Why are we accepting user ID? Because we want to know like this cart that you are trying to add is against which user, because every cart belongs to a user, right? So we need a user ID as well over here. Okay, and once this is done, so I'll take it over here, and once this is done, what I will do is I'll say cart service. This cart service does not exist yet, and I'm going to say add to cart over here, and I'll pass in both user ID as well as the request over here. This is done, and I'm going to pass in return response entity dot status, and I'm going to say http status dot created over here. Oops, so dot created, and I'm going to say build, something like this. Okay, so this is done. And here now we need to start defining things that do not exist. So first is we'll define cart item request. So I'll come over here and I'll create a class called cart item request, and you can see the destination package is controller, which is absolutely okay. I don't want to navigate right now, so I'll just say okay. It's created in controller, but I'll move this to DTO, and I'll come over here, hover, and say under more actions, say move to package. This is the package. Okay, now what comes in cart item request? So in cart item request, I will be accepting two things only. So one is private long, and I'm going to say product ID over here, which is the first thing. The second thing is integer, and I'm going to say quantity. Okay, that is it, and I'll mark this as data. Now what does this signify? This will tell us like which product this user is willing to add to the cart. So that is what we are accepting, product ID, so that we can identify the product, and then we want to know the quantity of this product. So how many quantity should I add for this particular product? Okay, so these two things comprise of cart item request over here. Okay, so this is taken care of. I'll just get an import over here, and this is done. Now what we need is cart service. So I'm going to come over here. I'm going to say private final cart service over here, and I'm going to create cart service object. Now this cart service does not exist, so I'll say more actions, create class cart service, and I'll make sure it's created in service package over here, and I'll hover on this. I'll say more actions, move to package service. Okay, this is done. Now this needs to be imported over here, cart service. So this is imported. Now I'm getting a red line over here because this might not have been initialized, of course, right? So I need to either add a constructor parameter this way so that Spring can inject this on the runtime, or I can make use of Lombok because I'm making use of private final already. So I can say required args constructor, something like this. So this is taken care of with less code and more annotations. Okay, so this is done. Now I'm getting a red mark over here, which is add to cart method does not exist. So we need to define this method, and the simplest way to define this method right now is to click on this suggestion where this method will be created into this particular service class. Now over here, what we are going to do is I am going to do the process for, or follow the process, or add the process over here, or define the process, whatever, for adding this particular product into the user's cart. Okay, so what are we going to do? First, we are going to get the product, because cart item request has something called as product ID. So we need to first fetch the product. Okay, we will add a validation wherein we'll check for the stock quantity as well, because validation should be there, right? And there'll be a validation for if the product exists or not. So that will be the first validation. So first we try to get the product. We'll see if product exists or not. And if this is done, then we'll check for the stock quantity. And then if this is done, we will get the user. So we have this user ID also over here, right? Let's not forget this. Okay, so we have this user. So we'll get this user, and then what we will do is we will add this particular product to the cart over here. So let us begin with the code. Okay, so first thing is we will look for product. Okay, so look for product over here. So how are we going to look for product? So I'm going to say product repository, which does not exist in this service class. Okay, so what I'm going to do is I'm going to say private final. I'm going to say product repository and product repository over here. I'm going to say private final. I'm also going to get the cart item repository. Okay, not cart item request, but cart item repository, because we are going to work with it. I'll also need the user repository because we are going to query the users model as well. So I'm going to say user repository, and I'm going to say user repository over here, something like this. Okay, now all of these need to be injected, right? So I'm going to say this is a service class first of all, and then I'm going to say required args constructor. So this is done, right? Now over here we need to make use of this repository. So I'm going to say product. Okay, this will return an optional, and I'm going to say product repository dot find by ID over here, and I'm going to say request dot get product ID, something like this. Okay, now what is the type of this over here? So this is going to return an optional of product type, something like this. Okay, and I'll have to import this. Okay, so this is done. We are getting the product in the optional form. Now I'll check for this. So I'll say if product opt is empty. So I'm checking if this is empty, then what you do is return false. Okay. Now, since we are doing validations over here, we would be returning a Boolean. So I've added void over here. So I'll just change this to Boolean for a while. Okay. And we'll handle this Boolean thing in the controller. Okay, so we'll do this. So what I'll do is here I am returning false. So if this is empty, so if product is not found, we are returning false over here. Then what I'm going to do is I'm going to look for product over here. So if the product was found, then what we need to do is we need to say product opt dot get over here. Okay, so we have the product now available in this product object, right? Now I'm going to add another validation over here. I'm going to say product dot get stock quantity. So we need to check for stock quantity. So if product dot get stock quantity is less than request dot get quantity, then in that case again you return false. Okay, this is done. So this is the second validation. Another validation is I need to check for user, right? So I'll say user over here. Okay, this is the user model. I'll say user opt. Okay, and here I'm going to say user repository dot find by ID over here, and I'm going to say user ID, something like this. Okay, this is going to give red marks because of the incompatibility, but I'll say wrap using long dot value of. Okay, this is done. Now what I will do is I'll check for this again. Okay, so we'll have a similar kind of condition over here as well. So instead of product opt over here, I'll simply say user opt over here. Okay, user opt is empty, right? So this is done. Now what I will do over here is I'll get this user object. So I'll say user is equal to user opt. Okay, user opt dot get over here, something like this. Okay, so this is done. Now what we need to do is as a next step, so all the validations are done. So this user would exist if the code has reached here by this point, the user is existing, the stock also exists, then the product also exists. So everything is valid. Now the next thing, what would you do is there are two ways to add the item to the cart. One is you first check if the product that the user is trying to add to the cart already exists in the cart or not, right? So if this product already exists in the cart, then what we'll be doing is we will be updating that particular cart with the additional quantity that is being requested over here. Okay. And if this product does not exist in the user's cart, then what we will do is we will basically add this particular product into the cart with the requested quantity, right? So this is how you should manage ideally, because on Amazon or anywhere, whenever you are adding an item to the cart, and if that product already exists in the cart, then the quantity against that product is updated in the cart. So that is what we are going to do, right? So I'm going to say cart item over here, cart item. I'm going to say existing cart items. This is the object. Okay, I'm naming it clearly so that we know what it stands for. Now over here, I'm going to make use of a method that does not exist. Okay, and we are going to define that method. So I'm going to say find by user and product. Okay, find by user and product, and I'm going to pass in the user and product over here. Okay, This is what I'm passing in over here. So this method, of course, does not exist. Now what we need to do is we need to head over to the repository and we need to create this. But I'm going to hover on this. I'm going to say create a method with this name, this return type, and these are the parameters. Okay. So what is this doing? So this method name will be translated to query in the hindsight by JPA Hibernate, right? So here you are saying find by. So it means there is a selection that you need to do and by a certain condition. That is what you're saying. That is why you're saying by for, right? Now you're mentioning user and product. So there has to be an AND clause and you have to get the cart item where this is the user and it's against this user first of all, and the product is this that is being passed. Okay, that is what it means. So we are trying to get the cart item for this user wherein this product is added. That is what this means, right? So once we get this, what we need to do is we will be having a condition on the basis of this. Okay, so let's come over here. I'm going to say if existing cart item is not equal to null over here. Okay, something like this. Then you perform the update over here. Okay, otherwise what you do is you create a new cart item. Okay, so understand this. So here what you will do is if the existing cart item is not equal to null, which means existing cart item for this user for this particular product exists. So what you will do is you will update the quantity over there. Update the quantity. Something like this. If it does not exist, then in that case you will create new cart item. Something like this. Okay. So what I'm going to do is I'm going to say existing cart item dot set quantity over here. And I'm going to say existing cart item dot quantity. So we are getting the existing cart item quantity and we are adding the quantity from the request. So that is how we are performing the update, right? I'm also updating. So let me also update the price over here. So I'm saying existing cart item dot set price. I'll say product dot get price dot multiply. Okay, let me multiply. And what am I multiplying it with? So I'm going to multiply it with existing cart item dot get quantity. Okay. Now there will be some incompatibility issue. It is going to ask me to wrap me into big decimal. So I'm going to do that. Okay. So what I'm doing is I am setting the price over here with, I'm getting the product price and I'm multiplying it with the updated quantity after setting the quantity, because quantity updated, right? So price also should update. So that is what, these are the changes that we are doing over here. Now what we need to do is we'll say cart item repository dot save, and I'm going to say existing cart item, something like this. This is done. So this is for updating the quantity. Now what we need to do is we need to create a new cart item, right? So I'm going to say over here cart item, something like this. I'm going to say cart item, and this will be a very new cart item with nothing in it. Oops, so I realized I'm creating this outside this block, which should not be the case. It should be inside this block, right? So you have created a new cart item. Now what are you going to do? You are going to update this cart item with the values that you need. Okay, so I'm going to say cart item dot set, and you can see you have to update all of this: product, user, quantity, and price. So these 4 things, because ID, created at and updated at are auto generated, right? So first let's update the user. So I'm going to say user. Okay, then I'm going to say cart item dot set product over here. I'm going to say product, and then I'm going to say cart item dot set quantity, and here I'm going to say request dot get quantity, and I'm going to say cart item dot set price over here, and then I'm going to say over here product dot get price dot multiply, and here I'm going to say request dot get quantity, something like this, and I'll wrap this in with big decimal. Okay, so this is being taken care of, and then I'll say cart item repository dot save, and I'll add cart item over here. Okay, so this is done. So this is where we are creating a new cart item, and I hope it is making sense as to why we are doing and what we are doing. Now there has to be a return statement over here. So missing return, and I'll just return true, because if the program control has reached over here, okay, then either of these blocks are executed and the addition of the item into the user's cart has been successful. Okay, so now let's come over to the controller, and here we are not accepting the boolean value that we are getting from add cart, right? So what I'm going to do is I'm going to wrap this inside the if block, something like this. Okay, so I'll get rid of this semicolon. I'll add this inside this if block like so, and here I'll add this. Okay, now over here I'm going to say if, I'll say okay, sorry, this if is done. Okay, so I'm going to say I'll reverse this condition. So if this is giving away false, then in that case what you will do is you will return, I'll say ResponseEntity dot pad request, and I'll say body over here, and in the body I'll say product out of stock or user not found, or product not found, So we are throwing this error as a bad request. Okay, and yeah, this is doing it. Okay, and here we're getting this error because the return type is void over here and we are returning a string. So I'll just change this to string over here. Okay, this is done. And then here we'll say HTTP status created, and we can return like a string if you need. Okay, but I'm not returning that. All right, so this is done. And let us go through the entire flow again. Okay, so I'll just revise what we did over here so that you have some clarity as to what we did and why we did. Okay, so we created an endpoint for the user to add products to the user's cart. Okay, so what will happen is we need the cart information from the user. Okay, so as to what product he wants to add. So that we are accepting in the form of cart item request, which is a DTO, wherein a user is sending us product ID and the quantity. Now, once we get the product ID and the quantity, what we are doing is we are passing it to this service over here. Okay, and we are also getting the user ID because we need to know against which user is this request being executed. So where are we adding, or in which user's cart we are adding this product ID and quantity, right? So that is also we are accepting over here, and we are passing it to add to cart in service. Now inside service, there are a few checks that we are doing. Okay, let's talk about validations. First is we are checking if the product actually exists. If product does not exist, we are returning false. Okay, then we are checking if stock exists. Okay, so there is a requested quantity that is coming in from the request. So is the current stock less than the requested quantity? If that's true, then we are returning false again. Okay, this is the second validation for checking stock. Third is we are checking for user, if the user exists by this ID. If the user does not exist, we are returning false again. Okay, now if the program control has reached over here by this line, then it means that stock exists, user exists, and product also exists. So the request has passed these three checks. Now the challenge over here is we have a product that user wants to add into his cart along with the specified quantity. Now there can be two scenarios over here. One is that product already exists in user's cart and he's just adding one more quantity. The other scenario is that product does not exist in user cart and he wants to add this new product into his cart. So to verify which scenario this request is for, we have made use of this method in the repository, which is find by user and product. So we are finding cart item by user and product. So whether this cart item exists for this user and product. If it exists, then what we are doing is we are updating the existing product's quantity like this. And if it does not, we are creating a new cart item. So that's the entire logic of how the request flows and how it's working over here. Okay, now it's time that we test. So I'll just rerun this application. Let us see if we are getting any sort of errors or issues over here. Okay, so you can see the application is up and running, right? Now I'll come over to Postman, or let us come over here. This should also be okay, right? So this is okay. Now come over to Postman. I'll first create a user. Okay, so here I'll just open this. Okay, I'll just close this update product, delete product. We don't need this search product right now. Okay, and here I'll first create a user. So let us create this user. This is user added. We'll add a product. This product should also be added. Okay, this is added. Now what I will do is I'll come over here. I'll add a new folder. Okay, so I'll say add a folder. Folder name is cart. Oops, so I just typed in A twice. So it's cart. I'll say add a request, and this will be, so this will be the cart request. So this will be cart over here. Okay, and this will be post request, add product to cart. Okay, something like this. And then over here, I need a request body. Now what is the request body? It will be raw JSON format. And here I'm going to pass in two things. Okay, so what are the two things? One is product ID, something like this. And product ID can be 1. And how much is the quantity? So I'm going to add over here quantity, something like this. So quantity can be 2 over here, something like that. Headers, I'll need header as well. Okay, so I'm going to add this header that we just defined here. So it's X user ID. So be sure to have the right name. Okay, if you don't add the right name, there is a chance that there could be a problem. So I'll just add 1 over here and let me send this request. So I'll say send. You can see 201 created. And now if you come over here to database, let me go to cart item. You can see the cart is created with the right quantity. It's created now. The product ID is 1 and the user ID is also 1. Okay. Price and all is also updated. Okay. Now, if you come over here, if I try to add the cart for user 2, if I send this, you'll see 400 bad requests. Product is out of stock, or user not found, or product is not found. Something of the 3 validation is missing. Okay. And this is true for even the stock over here. So if I come over here in the body and if I update this to like absurd quantity of 2000 or 20,000, I'll say send, you'll get like out of stock or like 400 bad requests. Okay, so this is not going to work. Also, the product ID has to be valid one. I cannot add 10 over here and send it, right? So this is being taken care of. Okay, so yeah, this is the request, and I hope this is clear to you as to how this is working. And yeah, we have been able to successfully allow users to add items to the cart. So I hope this has been useful so far. Now, after the product is added to the cart, we would of course want to have the functionality wherein we would want users to delete the item from the cart as well, right? Addition, deletion is a process, right? So what I will do is I will come over here to our application and we'll begin with the controller, wherein we start defining the endpoint, which is the delete mapping, wherein we would allow users to remove item from the cart, right? So I'm going to come over here. And just below this, I'm going to add a endpoint. So what should be the endpoint? So we can have an endpoint. I'll say public. Okay. So public response entity, and I'll say void over here for now. We can update this return type once we have some clarity. I'll say remove from cart, something like this. And we'll accept few parameters. Okay. So first thing is, we need the product that needs to be removed from the cart. And we also need the user ID as to from whose cart you want to remove this particular product, right? So first thing is I'll need user ID, and then I'll need long product ID, something like this. Okay. So these two things is what I'm going to need, right? So that users or the application can successfully remove the item from the cart. Now the question is, how are you accepting these two? So this thing user ID can come in the same request header like always. So I'll just take this and I'll just add this. And the product ID can come in as a path variable. Okay. Path variable, something like this. And with that, we can define the endpoint over here. So I can say delete mapping over here. I can come over here and I can say items slash, okay, it would be slash items slash, and I'll add product ID over here. Okay, something like this. I'll say product ID. Okay, this is done. And then over here, I'm going to call the cart service. Okay. Now, when calling cart service, what we will do is I'll say cart service dot delete cart or delete item from cart. Okay. And here I'm going to pass in the product ID and also the user ID. Okay. So we need user ID first. So I'll pass in the user ID first. I'll maintain the order. This is done. Now this is going to return a Boolean value. Okay. So I'm going to accept a Boolean. Okay. Boolean is the result over here. Okay. This is the result of the operation. Okay. Now what are we doing with this Boolean value? Okay. So I am going to say return and okay, instead of the result, I'll call this deleted. Okay. Something like this. So I'll say for deleted, we'll add a ternary operator and we'll do something if it's true and we'll do something if it's false. So if it's true, then I'll say ResponseEntity dot no content dot build over here. Okay. So that is what we are saying. And if it's not deleted, then I'm going to say ResponseEntity dot not found dot build. Okay. Something like this. And I can move this to the new line, something like this. Okay. So this is done. So it's readable, right? So this is done. With the help of this deleted variable, we are checking if the item is actually deleted or not. Okay. This is done. Now what we need is we are seeing a red mark over here. So we'll just get this method created wherein we'll say we need to delete the item from the cart. Okay. Now this method is created. What I will do is we'll first add the validation. Okay. So we are having user ID and product ID. So we can add this validation, which we have already. Okay. So this is the product and I'll copy this. Okay. So this is the validation for product over here. And we have the validation for user as well. So this is the validation for user. So I'll come over here. Okay. This is done. And this is done. Okay. Now over here, instead of product ID, I like request.product ID, I'll say product ID. And here we have the user ID in the right way. Okay. So if product is not found or the user is not found, we are returning false. Okay. Now what if they are found? So what I'm going to do is I'm going to say return and let me scroll down so that it's visible to you all. So here I'm going to say over here. So return won't come over here. In fact, I'll say user opt dot flat map over here. And then over here, I will come over here. I'll say user. Okay. And here, okay, I won't add this, but here I'll say product opt and I'll say map again. Okay. So map over here and then I'll say product. And then I'll add these two curly braces and here I'm going to say card item repository dot. Now I need to add a method over here which won't exist. So I'll say delete by user and product, something like this. And I'll say user comma product over here like so. Okay. And for this, okay, so I need to add a return true over here. This would be there. And then let us close everything with the semicolon. Okay, so this is done and we are getting an error in the end because return statement is missing. So I'll just return false because if this true was not returned, then false should be returned over here. Okay, so what we are doing is we are making use of this optional and we are making use of this flat map over here. Okay, and we are going inside and we are making use of map over here on product optional and we are deleting the item from the repository. Okay, now this does not exist, so I'll just create this method inside inside this repository. So it's delete by user and product. So we want to delete the cart item by user and product. So the cart item should belong to this user and this product. Okay, that is what we are telling. And the underlying queries, like always, is being generated by JPA. So you don't have to worry about. Okay. This is done. Now what we can do is let us restart and let us check if this is working absolutely fine. All right. So the application should start without any issues for sure. Okay, it started. Come over here and I will come over here and I will add a delete request over here. So let me add a request and I'm going to say Okay, so this can be API/cart and it will be delete, and I'll say delete. Okay, and here, what is the endpoint? So we'll come over here. Let's check the endpoint. So it's items/product ID. So I'll come over here. Okay, so it's /items/product ID. Okay, so what is the product ID? The product ID can be 1 for now. Okay, what is the header? There's no header. So I'll just add the header. So not for user, but over here, when adding product to the cart, we had this header. So header is X user ID and 1. Okay, so X user ID and 1. Okay, so this is done. This is a delete request. Now let us trigger this delete request. Right now the database is empty, right? So if you trigger this, you should not get any sort of confirmation. So you can see 404 not found, all right, which is fair enough because here we are returning not found. Okay, this is done. Now here we'll add the product to the cart. Okay, so you can see the product and the user does not exist. So I'll create the user first, then I'll create the product, and then I'll add the product to the cart. Okay, something went wrong. So 1 second. So user is added. Okay, is this product being added as well? So let me come over here. Okay, this product ID does not exist. So I'll add 1 over here. So you can see the product is now added to the cart. Okay, now if you try to delete this, you should get a confirmation. Okay, we get an internal server error. So interesting. Okay, let us come over here. So if you see this error, it says transaction required exception, which means that currently in our application, we don't have the transaction enabled and we are not marking this operation of delete as transaction. Okay, so since we are getting this error, we should mark this as transaction. Okay, because this is to ensure that delete operation runs safely and smoothly. So I'll come over here in service. So this is a service over here. Okay, and here I'm going to mark this as this entire controller. I'll mark this as transactional. Okay, so this is done. And now let me run this and let us check if this is okay. So this should ideally work fine now. Okay, so you can see the application up and running. I'll come over here. I'll create the user first. I'll create the product. Now I'll add the product to the cart. This is also done. Now I'll delete the product. And now you can see, oh, 404 not found. Why is that so? So cart item 1. So user ID is also 1. So what's the problem? So I'm getting 404 not found. And if you come over here to console, you will see the delete query is being generated. So the item is getting deleted. But why is this an issue? Okay, so it's likely because of this logic we have written in the service. Okay, so what I would do is I would simplify this logic. All right, so I'll get rid of this over here. Okay, let us, and I'll get rid of these validations as well. Okay, like so. Okay, and here I'll say if product opt dot get is, so I'll say is present otherwise. Okay, so I'll say is present, and user opt is present. Then in that case, what you do is you delete. So I'm going to say cart item repository dot delete user and product. Okay, so this will be taken care of, and I'll just pass in user opt, and I'll have to get the item, and I'll say product opt. Oops, product opt and get over here, something like this. Okay, this is done, and I'm going to say return true over here. Okay, otherwise I'm going to return false, something like this. Okay, so this is much more simplified, and let me take a look as to what is happening over here. Okay, so I'll just rerun this. Okay, and you can see the application up and running. Let me come over here. So I'll say create the user first, create the product, then add the product to the cart. Let us see if the product is added to the cart over here. So I'll just connect. I'll say cart item. You can see product is added to the cart. Now if you come over here, let us delete this. So now if you delete, you can see 204 no content, and you should also see this being deleted. Okay, so there was an issue with the logic that we had early on. Okay, and that is why we were not getting the right response. So this is much more simplified, and now you can see you have a delete request. or delete query, not the request. Delete query being generated by Hibernate like before. Okay. So now what we are doing is we are checking for this. Okay. In fact, we are not checking. We are getting the optional over here. And then we are checking if both are present. If they are present, we are deleting and returning true. If they are not, we are simply returning false. Okay. So I hope you have been able to follow along, and I hope this has been useful. So let us take our application forward and let us add one more endpoint in our controller, which will help us fetch the cart of a particular user. So we'll be having a get mapping, and if you trigger that get mapping, you are going to get the cart for whatever user ID that you mentioned. Okay. So let's take this up as a challenge. Okay. So I would want you all to try this endpoint yourself. What we are expecting out of this challenge over here is you will have a get mapping. Okay. It's pretty simple. Get mapping that would return a list of cart item, and as an input, you would be taking user ID as the request header. Okay. So pause the video right now, attempt this challenge, come back and watch the solution. Also remember that getting correct answer is never a criteria. Okay. The goal of these encouragements, these challenges is to get you hands-on with coding. The more you go hands-on with coding, the more you start writing code, the more confident you will become. So pause the video and attempt it. Welcome back. I hope you all had a chance to attempt this challenge. Let me go ahead and let me do the solution for you so that you can compare it with yours. If you are not able to, that's absolutely okay and understandable, but it's best you complete this after watching it. Okay. So to begin with, I'm going to add a get mapping here in the cart controller, and I'm going to say public response entity. Okay, response entity over here, and I'm going to say list of cart item over here. Okay, and I'm going to say get cart over here. Okay, and then you will have a parameter which would be user ID over here. Okay, now how is this user ID coming in? This user ID will come in with the help of a request header. So I'll quickly copy this annotation and I'll add it over here. Okay, so this is how we are getting the request. Sorry, not request. This is how we are getting the user ID. All right. Now what I'm going to do is I am going to return the cart over here, or the list of cart items. So I'm going to say return response entity dot okay, and I'm going to say cart service dot get cart, and I'm going to add user ID over here. Okay. So this is added. Now, of course, this method does not exist, so we are going to get this method created. Okay, so this method is created in cart service. Now, what we are going to do is pretty simple. So I'm going to first check for the user, and also we can then get the cart by user. So first thing first, I'm going to say return over here. Okay, I'm going to say user repository dot find by ID. Okay, find by ID over here. Okay, and I'm going to pass in user ID over here. Of course, this is going to give us some sort of red errors because we need to wrap this in long over here. That is what I'm going to do. Then I'm going to say map over here. Okay. And I'm going to say cart item repository. And I'm going to say find by user. Okay. Now this find by user method does not exist. Okay. Now this find by user method does not exist. So what I'm going to do is I'm going to get this find by user method created over here. Okay. And this would return the list of cart items over here. Okay. And okay, so this list needs to be imported as well. Okay. And I'm having find by user, which accepts user over here. Okay. So come over here. Okay. We are done with this. And then what we will do is I'll say or else get I'm going to add. Okay. And I'm going to say list of. Okay, something like this. Okay, and I'll add a semicolon. Now what we are doing over here is first we are getting the user by ID. Okay, so you can see over here, this is returning the optional of user. You can see on the right hand side. Okay, then we are making use of map over here. Okay, to fetch the cart item. Now this is executed only if the user exists. If the user does not exist, we are returning the empty list over here. Okay, so if no user, this returns the empty left. Now let us take a look as to how this works over here, and we'll wait for the application to run. Okay, so you can see over here the application is running. We are not seeing any sort of errors over here. So I'll come over here, and what I will do is we'll come over here and I will duplicate this request over here. So let's duplicate this. Okay, and I'll say this is get carts. Okay, or get cart over here. We are not getting multiple carts, we are getting a single cart. And then I'll convert this to get request over here, and we have headers. We don't need body, so I'll say none over here. Okay, now if you run this, you'll see you get 200. Okay, but the result is an empty array. So you don't get any sort of cart because there is no cart right now in the database. Now if we add a card over here, so I'll just create a user, I'll create a product, and I'll also add the product to the cart. So I've added this, and if you come over here now, okay, let me reconnect because we restarted the application. Now if I say cart item, you'll see there is an item in the cart. And now if I come over here and if I say get cart, you'll see we have access to the user cart items. You can see over here. So, okay, so we are getting this user, then we have product. So we are also getting the entire user over here, and we are getting the product as well. Okay, you can see over here. So this is working absolutely fine. You can see the response over here. And coming over here, if you have any sort of difficulties in understanding what we did over here in the service, okay, so let me explain it to you. So we'll start with controller. We have a get mapping, a simple one, wherein we are returning the list of cart items wrapped in response entity. We are accepting user ID as the request header. We are calling in the cart service.getCart over here with the user ID that we receive in the header. Okay, along with response entity. Okay, so this is wrapping the entire response. Then we come over here, and here we are basically doing our first call, wherein we are calling the user repository.find by ID to check if this user exists. Then we get a response as optional of user. Okay, now if the user exists, which means optional is present, then we are calling this over here, wherein we are saying from cart item repository find by user, and we are passing in user that we got in the previous step. So that thing is being passed automatically. And then over here we are calling or else get. So here this case is handled where user is not found. So instead of returning null or causing any sort of exception, what we are doing is we are actually returning an empty list. So we are saying or else get, and we are just returning an empty list. So that is how it works. Basically, we are first finding the user, then we are passing in that user to find by user from cart repository, and then if the user does not exist, we are actually returning an empty list. And if the user exists and if this is executed, then we return the response of this over here itself. So that is how this thing works. I hope you have been able to follow along, and I hope this has been useful. Now it's time that we begin talking about the order part of our application. So we have a user cart, we have products, user. We now want user to place an order into our application. And the first thing that we would need for placing the order is a entity which represents an order. All right. So I'm going to come over here, and just under model, I'm going to say new Java class, and I'm going to create a new entity called order over here. Okay. And here I am going to define all the fields that I need to represent my order. And here I'm going to say entity. This is the first thing that I'll do. I'll also mark this as data over here. Okay. And I'll come over here. Okay. And here I'm going to say private long ID over here. Then I need user. So basically every order that we create in our application is linked to a user. Okay. And I'm going to also have private over here. I'm going to also have a total amount. So I'm going to have big decimal add that. Okay. Or big decimal represent that amount over here. Okay. I need order status over here. Okay. So I'm going to say private order status. This order status does not exist. This will be an enum over here. Okay, so what I will do is I will get this enum created. Okay, and this is going to represent the different order statuses in our application. So I'll come over here. I'll say create enum order status, and I'll go over here, and this will be created. Okay, now here I'm going to say it order can be pending, confirmed, it can be shipped. Now, whatever your requirements are based on which you want to have different statuses for your application, you can actually add them over here. So I can say delivered over here. I can say cancelled. Okay, something like this. So this is done. And then I'll come over here, order status. So this is imported already. And then what I'm going to do is I'm going to say order status, and I'm going to have a default order status assigned over here. So the order status that it will be assigned initially is pending. Okay, because the order is just created, so it has to be pending, and we have to mark it manually to make it confirmed. Also, order will have the list of order items. So I'm going to say private list of order items. Okay, list of order. Okay, this is okay. So this does not exist. So in fact, we need to create this as well. Okay, we'll be creating this in a bit. Okay, I'm going to say items over here is equal to new array list, something like this. Okay, so this is done. And then, oops, so I missed a semicolon. Now, what I will do is I will add a couple of fields as private local date time, and I'm going to say created at, and I'm going to say private local date time, and I'm going to say updated at. This is just for housekeeping so that we can keep track of when a particular entity is created and when was it updated. Okay, so taking a look at cart item, I believe we have added all the other, all the annotations over here. Your data is taking care of everything over here we need. So one thing we are missing, one annotation is no args constructor over here. So I'll add that. Okay, and I'll also add over here in cart item. This is something that we missed. Okay, so I'll add this, and I'll come over here then. Okay, and here now what I will do is I'll have the definition for order item, because this is the one that is representing a single item that has been ordered from the application. So I'll come over here. I'll say more actions. I'll say create a class over here, and this is what it's getting created. Okay. Now what will order item have? So it will have long ID over here. Okay. It will also have private product, and it will have product over here. Then it will have private integer. Oops. So I'll say private integer, and I'll say quantity, something like this. And then it will have private big decimal over here, and it will have price, and we need the order as well. Okay, so we need the linking to the order over here. So I'm going to say order over here. So which order does this order item belong to? So that is what we are adding over here. Okay, so this is done. Now I'll mark this as entity as well over here. So I'm going to say this is an entity. It also has a no args constructor, and it also has a data annotation over here. Okay, I'll mark this as ID. I'll say generated value, strategy as generation type, identity, something like this. Okay, and then you come over here and you're going to say many to one relationship with the product. Okay, I'm going to mark this as join column. Okay, and join column, I'll have join column defined as product ID over here, something like this. And I'm going to say nullable false. Okay, this is done. And we have quantity, price, and then we have order over here. So here I'm going to say many to one, and then I'm going to have join column again, and here I'll say name. So the join column will be order underscore ID over here, and I'll say nullable is false. Okay, so this entity is done. We are done defining this entity, which is order item. I'll come back to order over here. Okay, now in order, this order item error that we were getting, like order item is not found. So define it, that is gone because we just defined it. But now we need to import this list. So we imported this, and that error is also gone. Now what we need to do is we need to start adding more annotations. So I'm going to say ID over here, and I'm going to say generated value, and strategy is generation type as identity. So this is done for ID over here. Now for user, I'm going to mark this as many to one over here. Okay, because one user can have multiple orders created, and I'll say join column over here, and this will be name as user underscore ID over here. Okay, and I'm going to say nullable is equal to false. Okay, something like this. And then I'll come over here and I'll mark this as enumerated, because this is enumerated. It is getting values from enum type. So I'm going to say enum type dot string over here. Okay, so this is also marked over here. Now this is the class that we just created, which is order item. So I'm going to have one to many mapping over here, one to many mapping over here, because one order can have multiple order items. So I'm having one to many mapping, and that is why we are representing this with list, right? One order can have multiple order items. So I'm going to say mapped by, I'm going to say order, and we are going to have cascade over here, cascade as cascade type all, and I'm going to say orphan removal also set to true over here. And you can hover on this if you wish to know what orphan removal is. So whether to apply remove operation to entities that have been removed from the relationship, and to cascade the remove operation to those entities. So basically any orphans will be removed over here, provided the order is deleted. So all the order items for that order will be deleted, and we are cascading all the operations to order item. So that is being taken care of. Now here I'm going to add a couple of annotation as creation timestamp. So this is auto generated, and this will be update timestamp. So this is also auto generated by Hibernate over here. You can see this is coming in from Hibernate. So yeah, all the definitions are done. Let us run this application and let us see if we get any sort of errors or issues, and whether we are seeing the tables being created in the database in the right way. So you can see the application is up and running without any issues. Come over here, refresh this and connect. Now over here you will see order item. You can see this is order item. You have order ID, product ID, and the order item ID as well, price and quantity. And then you have over here, okay, you should have had order table as well. So we are not seeing order table over here. So there is some problem. Go over here to IntelliJ and scroll up to see the stack trace, and you'll see some exceptions. Okay, we are seeing some exceptions. Let's debug this. So I'll scroll up to the top and I'll start scrolling down as to where this exception occurred. So you can see over here, these Hibernate queries were executed, and then here you can see one query wherein we started creating the order table. So you can see over here, this order table is throwing an error. So yeah, so this exception tells me that this order seems to be a reserved keyword. So which means like you cannot have table with the name order. So what I will do over here is I'll say over here name over here, and I'll say orders, something like this. I'll create a table with this name. Now let me rerun this. Let us see if this is working fine. We'll wait for a while until it finishes starting. So now if you see, there are no issues as such. Okay, so whenever you're getting these kind of issues wherein table creation is not possible, try changing the table name, because it's possible that you are creating a table with a reserved word in that particular database. Now different databases or different database vendors have different reserved words, but ultimately most of the words are same. Like for example, user is a reserved word in most of the databases, right? So basically have a check there. Okay, so I was able to identify the issue. Now if you come over here, let me refresh, connect, and now you can see orders and order item both. So if you run for order item, you can see here, this is the structure. If you go for orders, you'll see this is the structure over here. You can see it's linked to user ID, it has updated at, created at, total amount, and then it has status as well. Okay. Now what we will do is, since we have the database set up, I'll come over here and I'll start setting up the repository. Okay. So I'll say right click, close tabs to the left. Okay. I don't need this as well. I'll come over here. And here I'm going to create so not here, we have repository package. So I'm going to create a new Java class and I'll select interface as the type. Okay. And I'll have order repository, something like this. Okay. And this order repository will extend JPA repository. And here you will have the type defined as order and long over here. Okay. So this is being taken care of, and then you will have repository. So you will mark this as a Spring managed component. Okay. So you have this JPA repository, you're extending this JPA repository, and then you have order and long. So order because you are creating this repository to work with this entity, and then you have this long, which is basically the type of primary key. Okay. So this is defined. Now what we will do is we will also create a controller over here. So I'll come over here and I'll create a new controller. So I'm going to say order controller, something like this. And then over here, first thing first, I'm going to mark this as a REST controller. This is done. And here I'm going to have an instance of, so I'm going to say private final order service over here. And I'm going to say order service. Oops. So I'm going to say order service. This is done. Okay. Now I'll create this service over here. So I'll say create this class order service, and I'll move this to service package like so. Okay. And I'll hover on this and I'll say move it to this package. So this is done. And I'll also mark this as service. Okay. Now over here, I'll get this service imported. So this is done. And of course it is throwing an error that this order service is not initialized. So you can either add this constructor parameter, something like this, so that Spring can inject this order service when the application runs. So it will find this object of type order service, and it will find it because you have marked it as a Spring managed component. But I want to do this. I will have lesser code and I'll work more with annotation. So I'm making use of Lombok. So I'll say required args constructor. So it will just add the constructor for fields that are marked as final. Okay. So a constructor for order service will be automatically added by whom? Lombok. All right. Now let us create an endpoint which will allow us to create an order. How will you do that? So of course, since we are creating something into the database, since we are creating a resource, I'm going to mark this as a post mapping. I'm going to say public ResponseEntity over here. You're going to have a return over here. Now for returning over here, we are going to create a DTO. So I'm going to say order response over here. This will be the DTO that we'll be creating. Of course, it does not exist yet, but we'll create it in a bit. I'm going to say create order. And here I'm going to say mark this as request header, something like this. Okay. And then over here, I'm going to say x hyphen user hyphen ID, something like this. And then over here, so you have x user ID, and then you'll say string user ID, something like this. Okay. So what you're doing is you are getting the user ID for which, for whom you want to place an order, not for which, but for whom you want to place an order. Okay. So this is done. And what I'll do is I'll say return new response entity, and I'll say order over here. Okay. So order. Okay. 1 second. So before calling this, I'm going to say order response. Okay. Order response. And then I'm going to say order over here, and I'm going to say order service dot create order. So this will be the method in order service. Okay. I'll pass in user ID, right? I'll get rid of this order response over here, and I'll say order comma http status dot created, like so. Okay. This is done. Now I need to map this endpoint to a URL. So I'll add RequestMapping. Okay. So RequestMapping coming in over here. I'm going to say /API/orders, something like this, like so. Okay. And now this URL is pointing to this. Okay. Now let us start solving these errors, which are like because of which we are getting all these red marks. So first, order response. I'll hover on this. I'll come over here and I'll say create a new or create a class order response. So I'll get this class created in controller right now, and then I'll move this to the DTO package. And then I'll hover on this and I'll say move to package DTO. So now this order response is in DTO package. Okay. Now this order response gives me the liberty to define as to what I want to send to the user as the response for a particular order. Okay, that is what the liberty I get. So I'm going to have my own fields. I'm going to say private long ID. I'm going to say private big decimal. I'm going to say total amount over here. And then I'm going to say private order status. And I'm going to say, oops, so order status needs to be imported. And then I'm going to say status over here. I'm going to say private list of order items. Oops, not order. It should be item over here. And okay, I should not make use of model over here. So for order item also, I'll need a DTO. Okay, this will be one more DTO that we'll be creating. Okay, which does not exist yet. I'm going to say items over here. Okay, and then I'm going to say private local date time over here. And then I'm going to say created at something like this. Okay, so this is taken care of. Okay, and if you compare this to the order table over here that we have order. So we are having ID. We are not passing in the user information, but total amount, status, items, and created at. We are not also sharing the updated at over here. Okay, so this is fine. We have better control with the help of this class where we are masking in certain fields that we have in the database. Okay, I'll get rid of the unused import from here. Okay, so that it looks much more cleaner. Now let us create the order item DTO. So I'll hover on this. I'll go to more actions. I'll say create a class for order item DTO. And here we have the class. Okay, and here I'm going to say private long ID. Then I'm going to have private long product ID, something like this, private integer, and I'm going to have quantity, something like this. Then I'm going to say private big decimal, and I'm going to add price, and let's have private big decimal subtotal. Okay, so this is what I'm adding over here. Now this is inspired from order item over here. Okay, you have ID. So instead of sending in the whole product object, I'm sending in only product ID. Quantity I'm sending in, price I'm sending in. I'm not sending in the order ID or order anything. Okay, or anything related to order. So we are sending in these pieces of information. We have subtotal as well, which we can get rid of. I don't think we should have subtotal, so I'll just get rid of. We just have the price. Okay. Now what I will do is I'll add the annotations like data over here. And for order response also, I'll add this data annotation. Now you can see order item DTO was throwing error. That is gone because we created the class. Now list is throwing error. So we'll get the list imported from java.util. This is solved. Okay. And now we'll come back to the controller and we'll import order response. And now order response related errors have gone. So what we need to do is this error is something that we need to resolve. So this create order does not exist, of course, in the service. So what we need to do is we need to define this. And here I'll say create method. Okay, so this method is created. You can see over here, right? Now we are going to make, what we are going to do is we are going to add or create the order over here. Now here, what I'm going to do is I'm going to start defining the logic for creating the order. Now, of course, when creating the order, there will be like some set of validations that we'll do. So first is we will validate for cart items. Okay, validate for cart items. Of course, if the user is trying to create the order, he should have items in his cart which will be transitioned to the order, right? Then we also need to validate for users. Okay, validate for user. So we need to see if the user ID that we received in the request or which we are receiving over here, that has to be a valid user ID, right? So that is something that we'll check for. Also, one thing we'll do is we'll calculate total price. So this is not a validation, but this is a step that we need to do. and then we'll finally go ahead and create order. So I'll say create order, something like this. All right. Now let us go ahead and okay. Also one more step here in the end, I'm going to clear the cart. So if the order is placed, we don't need, or the items from the cart should be cleared because those items have moved to orders now, right? So that is something that we are going to make use of, right? Or that is something that we are going to do over here. Now over here, what I'm going to do is, first thing, I'm going to validate for cart items. So I'm going to say list of cart item over here. Okay, so we should import list over here. List of cart item is cart items is equal to cart service. So this service does not exist. So we will have to like create the service over here. So I'll say private final, and I'll say cart service over here, and I'll say cart service. Okay, and I'll add a required args constructor, something like this. Okay, so I'm going to say cart service dot get cart, and what I'm doing is I'm passing in the user ID over here. Okay, now what is this returning? This is returning the list of cart items. Okay, so I'm going to say if cart items is empty. Okay, if it's empty, then do something. So we're going to do something over here. Either we throw an exception, or we can return an empty order response or something like that. So for now, I'll leave this empty. We need to also validate for user. So what we can do is over here, I'm going to say list, or let me say user repository. Okay, so user repository does not exist. So I'll say over here, private final user repository. Oops, not user request, user repository, and I'm going to say user repository, something like this. Okay, so we have an instance of user repository now, and I'll come over here. I'm going to say user repository dot, I'll say find by ID, and I'll pass in user ID over here. And of course, this will give us an error, so we need to wrap it using long value of, and this is returning an optional. So I'm going to say optional, and I'll say user over here. Okay, and I'll say user optional over here, something like this. Okay, so this is done. Now if we have this user over here, so I'm going to say if user optional dot is empty, then in that case what you do is you handle the validation over here. So whatever the validation is, we'll take care of that. Okay, and if this is passed, if this thing is passed, then what we are going to do is I'm going to say user is equal to user not user ID, user optional dot get over here, something like this. Okay, so this is done. We have access to the user now. Okay, now what I can do is here, just in case the validation fails, I'm going to return, we can return an optional over here. Okay, optional dot empty. Okay, so I can say optional dot empty, something like this. So I'm returning an empty optional over here. Same, I'm going to return an empty optional over here. Okay, now the problem is here we have defined, or we are saying like we will be giving order response. So what I'll do is I will say let this be of optional type. Okay, so we'll return optional. Okay, so we'll return order response, but it will be of optional type. Okay, so this is how it will be. Okay, we'll have to do some changes in order controller because of this, but we'll come to that. Okay, so this is done. We have access to user now. Now what I will do is I'll calculate the total price. Now what is total price? So for total price, we need to take a look at the cart item over here. Okay, so if you scroll up here, we are getting the cart items, right? Now if you take a look at cart item over here, it has a price over here. Okay, and one user can have multiple cart items in the cart, right? He can have multiple items against a particular cart. So this can be multiple. So what we need to do is we need to get the price for every item, and we need to sum it all, right? So for that, we can make use of there are different ways of doing things. You can make use of for loop, you can make use of streams. So it's totally up to you. I'll make use of streams over here. Okay, oops. So I'll say big decimal should be the output. I'll say total price over here, and I'll say cart items. dot stream. So I'm converting this into a stream over here. I'm going to say dot map over here. Okay. And I'm going to say cart item, and I'll say get price, something like this. Okay. Then I'll say reduce this to big decimal. So I'll say big decimal dot 0, and here I'll say big decimal add over here, something like this. So this is going to give us the total price. So what this thing does is, I'll just explain this. So first I'm converting the cart items to a stream. Okay. So this list of cart items is converted into stream for processing. All right. Then I'm making use of map over here. Okay. So this step over here. So you can see over here in the first step, the stream is of cart item type. And then in the second step, what we are doing is we are picking out the price of each cart item. Okay. So we are just getting the price of each cart item. So what we have in place now, we have a stream of big decimals because price is of type big decimal. Okay. So we have extracted the price from cart items. So now earlier we had cart items. We don't need cart items in a way. We just need the price of all the items in the cart. So we have extracted the price over here. You can see it's a stream of big decimal now. Okay. And what is big decimal? So if you go to cart item, okay, 1 second. So if you go to cart item, you will see price is of type big decimal here. Okay. So here we simply have, if you scroll down here, we simply have on this step, the second step, here we simply have the stream of big decimal. Okay. Then we are making use of reduce over here. What does reduce does? Reduce is used to combine all the values in the stream. So here, if you hover on this, you will see performs a reduction on the elements of this stream using provided identity value and associative accumulation function. Okay. So you can see it is equivalent to this for loop. So you can write this for loop to add all the elements of, to add all the prices essentially. Okay. But we have made use of reduce. We are saying reduce dot big decimal 0. Okay. So what does this mean? This is the initial value. So this is a starting point. Initially it's 0, and then we are adding all the values. Okay. So this is adding each item's price one by one because of this. Okay. And in the end, we have this one single value, which is the total price. That is how it's working. So I hope this is making sense as to how this is reduced to total price. Okay. So now what I'm going to do is I'm going to create an order. So I'm going to create order over here. Okay. So order needs to be imported. Order, and I'm going to say is equal to, and I'm going to say new order over here, something like this. And then I'm going to update all the fields. So I'm going to say dot set. So if you say set, what all you need to set? So you need to set items, you need to set user, you need to set status, you need to set total amount. So we'll start with the user over here. So I'm going to pass in user over here. We have access to user object. I'm going to say dot set. Now I'm going to set in status. So I'm going to say order status dot confirmed. So we have order status enum. If you remember, we have created it, order status enum. So you can see we are making use of confirmed. Okay. Now I'll come over here, and here I'm going to say order status is set. Okay. I'm going to say order dot set, and now we need to update the total amount since we have access to the total price over here. Okay. So this is what we are doing. And then what we need to do is we also need to update the order items. So if you say set, you have the list of order items over here. Okay. Now take a look over here as to what we have. If you scroll up, we have the list of cart items, right? We have list of cart items and not order items. So we need to transform this cart item into the list of order items, right? So what I'm going to do is I'm going to scroll down over here. Okay. I'll just get rid of this. Okay. I'm going to say, oops. So here I'm going to say list of order item because we need the list of order item. I'm going to say order items, and here I'm going to say cart items dot stream. So I'm making use of streams again. I'm converting the cart items. This is the list of cart items. So I'm converting it to stream over here. Okay. And I'm going to say dot map over here, and I'm saying item. Okay, and this will be new order item over here. Okay, this is what I'm doing, and then I will start assigning this values. Okay, so I'll say null first of all. Okay, so this is 1 second. So if you hover on this, okay, so this has to be this needs to have ID, product, quantity, price, and order over here. Okay, so I'm not adding ID over here. Okay, because ID should be auto generated, right? So I'll come over here. I'll say null. I'll say item dot get product over here. Okay, then I'll say item dot get quantity over here. Then I'm going to say item dot get price over here. Oops, so get price, and then I'm going to say order over here, something like this. Okay, so this is set, and now what I'm going to do is I am going to convert this or collect this as a list. So I'm going to say collect, and here collect to unmodifiable list. Okay, so you can make use of unmodifiable list, but I'll just say to list, something like this. Okay, I'm getting an error over here. What is the error? So expected 0 arguments but found 5. So create a constructor. So clearly the constructor for order item does not exist. So we have no args constructor. So I'll say give me a all args constructor. Okay, let me see if this is the thing. So after adding all args constructor, okay, Lombok should take care of this. If you come to order service now, you can see the error is gone. Okay, and you have this over here. Okay, so now it's asking me to replace this collect to list to just to list. So I can make use of that as well. Okay, a bit of optimization for me. All right, and now what we need to do is we'll update this. So I'll say order dot set items. So for order object, this setting of order items was pending. Okay, for which we got the list of order items, right? So now I'm going to say order items over here. This is done. Okay, so now all the fields for order have been set, right? Now I'll come over here. Okay, so I hope this what we did over here is clear to you all. We converted cart items. This was a list of cart items to that of stream, and then we mapped it. So we are making use of this, and for every item in the cart item, we created a new order item, and then we collected this order item to list. So essentially we have cart item as the input, the list of cart item as the input, and we got list of order item as the output for this, right? This is done. Now what we will do is I will save the order. Okay, so I'm going to say order, saved order over here, and I'll say order repository. Okay, so we have not created the instance of order repository over here. So I'm going to say private final order repository over here, and I'm going to say order repository. Okay, and I'll come over here, order repository, and I'm going to say order repository dot save. Okay, and I'll add order over here, something like this. So this is done. We have the order saved now. So this creation of orders is done into the database. Okay, so this is done. Now what we need to do is, the last part is we need to clear the cart. So I'm going to say cart service dot clear cart over here, and I'm going to pass in the user ID. Okay, now this method does not exist, of course. So what we will have to do is we will have to define this method. So what is the goal of this method? The goal of this method is to delete all the carts for a particular user. Okay, so I'll head over, I'll just hover on this, and I'll say create method clear cart in cart service. And here what I'm going to do is I am going to add some code that will clear everything. So here I'm going to say user repository. Okay, so first thing is we need to get the user because we have the user ID. So I'm going to say find by ID, and I'm going to pass in user ID. Okay, now this will give me an error, so I'll have to wrap this using long.value of. So this is done. Now I'm going to say dot if. Why I'm adding if over here? Because this is returning an optional. You can see if you hover on this. Okay, find by ID is returning an optional over here to me, right? So once I get this, I'm going to say if present. So if this is present, what you can do is user. Okay, user, and over here I'm going to say cart item repository dot delete by user, and I'm going to pass in user over here. Okay, so I have the entire user object, right? Now, of course, this also does not exist. So what I will have to do is I will have to hover on this and I'll have to say create method void delete by user. User is the parameter. So what this means is this method name will automatically be translated into query in the hindsight. Okay, so when you have to make use of sensible method names that JPA can understand. So here you are saying delete. So it understands, JPA Hibernate understands that, hey, this is a delete request. You're saying by. So it means that, hey, I have to delete the entities by something. And when you're saying by user, it is expecting user as a parameter because you want the deletion to happen by user. So the deletion for cart items will be done by user over here with this method, like I said. Okay. And it is asking me to replace this with lambda with method reference. So I can do that happily. Okay, let me check over here. So you can see this is how it will work. And yeah, this is it. I just got rid of semicolon and the error is gone. Okay, so this is taken care of, and we have this method defined clear cart. Okay, so this is going to remove all the cart items for a particular user. And if you come over here now, this method is working absolutely fine. Earlier we were getting an error, but now we have defined it. Okay, now what we need to do is we have done all the operations, right? For now. Now what we need to do is we need to return an optional over here. We need to return an optional of order response. Okay, so I'll come over here. I am going to come over here and I'm going to say return. Now what do we have in hand? We have the order object. This order object is the saved order object, right? And this is saved into a database. So we need to transform this order object into the type of order response. So I'm going to say optional. So it has to be wrapped in optional, right? So I'm going to say optional.off and I'm going to say map to order response over here. And I'm going to pass in saved order. Now, of course, this method does not exist yet, right? So we will have to create this. I'll get this created. Right, and we'll have to define this as well. Now, the goal of this method is actually to basically transform the order object over here into the type of order response. Okay, that is what the goal of this method is, right? So what I will do is I will start over here. I'll say return new order response. Oops, not order, and it will be order response over here. Okay, now what happens over here? So here we're going to say order dot get ID. Okay, so saved order dot get ID. In fact, instead of having this saved order, I can just call this as order. Okay, and this will be order. Okay, so that it looks a bit cleaner. So order dot get ID. I'll say order dot get, and you can say total amount over here. Then I'm going to say order dot get status over here. Then I can say order dot get items. Okay. Oops. So I'm going to say order dot get items over here. Okay. And then I'm going to convert this into a stream. Now, why am I converting this into a stream? Okay. So understand this. This is order over here, right? And we are mapping it to order response. Now, if you go to order response here, this is of type order item DTO and it is not of type order item, right? So we have order item over here, which needs to be transformed into the type of order item DTO, right? So for that purpose, I'm converting this into a stream and I'm saying over here, I'll press enter. I'll say map. Oops. So I'll say map. Something like this. I'm going to say item over here. So I can say order item and I'll say new order item DTO. Something like this. And within this, I am going to have all the definition. So what I'm saying is convert this order.getItems. So convert the list of order item. So this is returning the list of order item. So convert this list of order item to that of stream. And then for every order item, create a new order item DTO, right? So I'm going to say item dot get ID. Okay. And then I'm going to say item dot get product dot get ID, something like this. Okay. And so what does order item have? So it has ID, product ID, then it has quantity and price, right? So I'm going to say order item dot get quantity, and then I'm going to say order item dot get price over here, something like this. Okay. And yeah, this is it. I believe we don't have anything else. In fact, I had removed one field from here, which was subtotal. So if you want, you can add that, and you can add a calculation wherein the price. So this is the price of the product, right? So this price can be multiplied with the quantity and shared. So here what you can do is you can say private, and I can say pick decimal subtotal, something like this. Okay. And here you can come in and you can say comma, and you can say order item dot get price dot multiply. Okay. So we are going to do a multiplication, and I'm going to say new, pick decimal over here, and I can say item dot get quantity. Okay. Not ID. So it has to be get quantity, something like this. Okay. So this is done over here. Okay. So yeah, we are set with this. And then what I'm going to do is we are getting an error. So that's absolutely okay. This is because we don't have a constructor. So you can see it's saying there's no constructor. So for adding the constructor, I'll come over here. So ideally the constructor should be added. So here required args constructor we have. Okay. So I'll say all args constructor is what we need. Okay. Now this should be taken care of in the, okay. So what is the problem now? Okay. So this error is gone now, and we are getting one new error in order response wherein there is no constructor defined. So I need to say all args constructor again. And now if you come, okay, this should have gone. Okay. So now there is one more new error. So it's saying you have provided stream, but this has to be list over here, right? So of course it has to be list. What I'm going to do is I'm going to say dot to list. And this is done in that case. And then I'm going to say order dot get created at, something like this. Okay. So this is done. This new order response object is now created, and we are returning it, right? So I hope this is making sense. What we did over here, let me reiterate. We have the instance of order object. What does order have? Order has order item over here. All the other fields along with order status, along with order item over here. Order item and order both are models. Okay. So I wanted to keep them away from the presentation layer. Okay. So what I'm doing over here is I am basically creating order response over here. I'm passing in fields like ID, total amount, status, all of this. Now when I say order.get items, I'm getting the list of order item over here. You can see list of order item. Okay. Now my goal is I need to pass in the list of order item DTO, because that is what order response has, right? So what you will do is you will transform this order item to that of order item DTO. And that is what we are doing over here. We are transforming this into stream first, and then we are converting this into a map, and then into a list. And then we are assigning this order.get created at. So this is done. And we are getting an object of order response along with the list of order item DTO. All right. I hope this is making sense. And now you are not seeing any sort of error in service, but you are seeing some error in the controller. And this is small error. Okay. So we'll just fix this. Here, what we are doing is we are willing to accept the type of order response, but this is returning the optional type, right? So we get this. But what I will do is I'll have a better way to define this. Okay. In fact, so I'll say return. I'll say order service dot create order. Okay. And I'll pass in the user ID, and then I'll say dot map over here. Now I'll say order response, and I'll say new response entity. And here I will add order response. Okay. And I'll say HTTP status dot created. Something like this. Okay. So this is taken care of when we have a response, but when we don't have a response, we can say or else get over here, and I can say something like this. Okay, inside over here, I'll add this, and I'll say ResponseEntity dot bad request dot build. Okay, so I'm just throwing a bad request error. That is what I'm throwing. Okay, so if any of the validation fails, we'll get a bad request over here. So here, if you come to order service, you're returning an empty optional over here. So if cart items is empty, you'll get a bad request. If user does not exist, you will get a bad request, and so on. Okay, and here if you come to order controller, this is taken care of. Now let us run this and let us see if we are able to see this in action. Okay, so the application is up and running. So there are no issues as such. I'll come over here, and we don't have anything in orders right now. Okay, we don't have anything in orders. Oops, so I'll connect. So we don't have anything in orders. So what I will do is I'll first create a user. Then I'll create a product. Then I'll add the product to the cart. Okay. Now if you come over here, you will see cart having a product. This is the product. Okay. Now what I will do is I'll convert this into an order. Okay. So right now, if you see, there's no order, right? Oops. So there's no order over here, but cart has cart item. Okay. So let us place an order. So I'll come over here. I will collapse everything over here. I'll just create a new folder, and I'll call this as order folder. Okay. And this has to be at the root level. Okay. So order is there. And now I'll add a request over here. And this request will be for API/cart. Okay. And I'll have orders over here like so. Okay. This is the endpoint that I'm calling in. Now, how do I call this? I have to call this with a post request. And I also have to add a header over here. Okay, and I'll collapse this. I'll say X user ID has to be 1. So I'll come over here. I'll say X user ID is 1. Oops, not 2, 1. Okay, and okay, so I'm adding this as a parameter. It should not be a parameter, but it should be an header. Okay, so this is done. Okay, I'll save this, and I'll call this as place order. Okay, now let me trigger an order request. So I'll say place order. You can see the order is confirmed. You have price. So let us take a look at the response. You have ID, you have total amount, order status is confirmed. These are the items. Item is this product ID 1, quantity of 2, price is this, and then subtotal is this. Okay, so basically subtotal is the price multiplied by the quantity. Okay, this is the logic that we have defined over here. So it's, if you come over here to service, it's, so here it's price multiplied by quantity. You can see this is what we are getting over here, right? And you have created that as well, right? So this is taken care of. And if you come over here, if you run select star on cart item, you'll see no cart items exist. And if you go to orders, you'll see order has been created and the status is confirmed. Okay, so this is placed. And if you come over here, you'll also see the deletion request for cart and the creation request for order items. You can see this, all of this. Okay, so this is taken care of. Okay, and you can see all the Hibernate requests as to what is happening over here, right? We are inserting into order item, and then we did a select star on where is this happening? This is on cart item. Okay, and then we deleted the cart items. Okay, so this is taken care of, and the request is working absolutely fine. Now let me just reiterate as to what we did, why we did. Okay, so we created an endpoint for creating the order, which accepts user ID as a header, and then we created the order over here this way. Okay, now for creating the order, we are basically making use of this create order functionality. Okay, and for data transfer, we are making use of two things. One is the order response. Now if you go to order response, it has all the details that we want to expose to the outer world once the order is placed. For example, total amount, status, and instead of list of order items, it has list of order item DTO. This is again masked from order items that we are storing in the database. Okay, so if you go to order item DTO, you have things like these, wherein we have ID, product ID, quantity, price, and subtotal. Now make a note, subtotal is something that we are not storing at the database level, but we are calculating this when returning this response. Okay, so that's the benefit of DTO when you're detaching it from the model over here. Okay, and here then in service, we have a series of operations that took place. So first is we validated for cart items. We checked if the cart exists for a particular user. If it exists, then we returned an empty optional. Then we validated for the user. We checked if the user exists. If user exists, we returned an empty optional. And if user did not exist, we returned an empty optional. And if user exists, we got the user in the user object. And then we calculated the total price over here, something like this. Okay, because we need total price to be calculated. What is the order? What is the total value of the order? So that is what we did over here. And we made use of streams over here this way to reduce the cart item list to a single value, which is the total price with the series of operations that we have over here. Then we have create order, wherein we created the order object. So we set all the fields and then we realized that, hey, we need to set order items as well. But we don't have order items. Instead, we have cart items over here. So what we did is we made use of cart items to convert and transform it into order items. So order item was created over here this way. And then we set order items to the order just before saving it. Now, after the order is saved to the database, we cleared the cart because then it does not make sense to have cart in picture. So we cleared the user cart. He can create a new cart and place an order again. And we returned an optional of order response. Now we did not have an object of order response. We had an object of order over here. So what we did is we defined another helper method, which will do the job of converting the order to order response. And this method then helped us by creating order response over here by setting in the fields. And it also allowed us to transform the order item field over here to order item DTO this way. And then we collected everything as a list. And we also set order.created@, and we returned this item. And that is the result that you see over here. This is the order response object over here. You can see there is no updated @. So if you compare this response with order response, it would match. Okay. So, and this over here, order item DTO, this is this item within the array, order item DTO. You can see it has subtotal. All right. So I hope you have been able to follow along, and I hope this has been very fruitful and useful. I hope you found it super valuable, and yeah, I hope this helped. So let's start talking about what is a Spring Boot Actuator. So Spring Boot Actuator is an integral part of Spring Boot applications, and it provides built-in production-ready features to monitor and manage your application. So basically, it's an interface or a tool that you can say using which you can monitor and manage your application. It gives you insight about your running application as to what is happening with it. And you can have like a dashboard or a panel on your application, which lets you what's happening when your code is being executed. So you can think of this like a dashboard that you have in front of you when you're driving a car. Okay, it will show you all sorts of useful information as to how fast you're going, the speed, how much fuel you have left, the temperature of engine, and so on. So essentially, it's showing you the health of the car. And that is what Spring Boot Actuator aims to provide you. So Spring Boot Actuator provides a similar dashboard for your Spring Boot applications, and it lets you peek inside your running application to check things like application health, metrics, the information of the applications, and many more things. Okay. Why is this so important? So if you're running your application in production, having the ability to monitor and manage your applications is crucial. And Spring Boot Actuator exactly gives you that. So when you're building a Spring Boot application, no client or your company won't tell you to have a dashboard like this. You as a developer are responsible to make sure that your application is up and running. So this is like a dashboard which developers or engineering team in the backend can use to keep a status check of whatever is happening with their application. Now, Spring Boot Actuator comes with number of features, and it includes a lot of built-in endpoints that can give you a wealth of information about your application that is running. So this is the number one feature, which is it has tons of built-in endpoints. Then it has the ability to view real-time metrics. So you as a user get a dashboard wherein you can view real-time metrics. Okay. And there is an endpoint for this /metric endpoints. And it offers you a detailed look at your application metric like your CPU usage, as well as application specific features such as number of active database connections and so on. So despite having so many features, it is also customizable in the end. Okay, so you can create your own endpoints, modify the contents of existing endpoints, and even control the security. So you can add a security aspect, or you can control who you want to access the actuator. Okay, so essentially Spring Boot Actuator gives you something ready out of the package or out of the box, which you can plug into your application to keep track of whatever is happening. And if you want to extend this functionality or want something custom, it has you covered. So you can customize it as well. So that's about Spring Boot Actuator. So now it's time that we begin setting up the Spring Boot Actuator into our Spring Boot application. So what I'm going to do is I'm going to head over to pom.xml over here. And this is a file wherein we would be adding the relevant dependency that would enable us to add Actuator into our project or work with Actuator into our project. So to add the dependency, I will head over to our favorite website onto our browser, which is start.spring.io. Okay, so just head over to this website and here you have it. So here we'll select Maven over here. Feel free to select Gradle if you're making use of Gradle. I'll make sure I have Java selected and the relevant version of Spring Boot. Now I'll go to Dependencies and I'm going to select Actuator. Now here you can see the description of Actuator. Supports built-in or custom endpoints that let you monitor and manage your application, such as application health, metrics, session, and so on. I'll select this. I'll go to Explore and scroll down over here. And here you'll find this dependency, which is for the Actuator. So I'll copy this dependency. I'll come over here and like always, like adding any dependency. So this is the process of adding any sort of dependency into your Spring project. So I've added this dependency over here between these dependency tag. Okay, this is the dependencies tag. And this is one of the dependencies that we just added. Now what I'm going to do is, the moment you make any sort of change in pom.xml, you will see this Maven reload icon. So I'll just click on this. So it will like fetch all the files that are needed for Spring Boot Actuator to work, and it will resolve the dependencies and get everything for us. If you don't see this Maven reload icon, you can go over here and do a Maven reload. Okay, you can click on this icon. So this is what we'll do. And now you can check if Actuator has been added. So here, if you go to external libraries, you should find Actuator over here. So you can see this file and these files that are for Spring Boot Actuator, and they have been added into our project in the external libraries section. Okay, so yeah, this is done. Now what I'm going to do is I am going to restart and rebuild the application. So after adding the dependency, we need to rebuild our application, and Spring Boot will then auto configure Actuator for us. And now that we have added this starter over here, okay, so Spring Boot Actuator or Spring Boot auto configuration will come into picture and it will do the job for us. So I'm just going to start over here, like restart the project, and that is going to rebuild the project for us. Okay, so we start seeing this error which is related to Lombok. So I'll go over here. I think there is some problem with the setting. So I'll go to annotation processing over here under build and execution, compiler, and I'll select ecom application, and I'll make sure I select obtain processor from class path. And I'll just restart the application. Okay, so now the application should work absolutely fine without throwing any sort of errors over here. Okay, so now you can see the application is up and running. I'll just expand this console, and here if you come here in the console Okay, so there are quite a few logs. So what I'm going to do is I'm going to do Control F over here and I'm going to search for Actuator. You can see. So you can see this exposing one endpoint beneath base path, which is Actuator. Why is this exposed? Because, we have added the Spring Boot Actuator starter dependency into our pom.xml. And because of the auto configuration capabilities that Spring Boot has, it has exposed this particular URL for us to use without us doing anything. We have not done anything. We have just added dependency. And because the dependency is added, Spring Boot thinks that, hey, this person or the developer has added the Actuator dependency. So probably he might want to make use of Actuator. So I should probably expose the endpoint because I already have this dependency added, right? So that is where Spring Boot auto configuration comes into picture. Now, if you search a bit more for the Actuator, you will find the libraries being loaded over here. You can see all these libraries being loaded. These are the libraries that we saw, right? So these are being loaded, and if you go down, okay, you'll see quite a few occurrences of Actuator, and then this is the last one. Okay, so this is the most important one. We don't care about the other ones, okay, what libraries they are loading and all, but it's good to see that them as well. But this is the most important one wherein our Actuator is being exposed. Now, what would be the next step? So next step would be to go to localhost 8080 and check out this URL. So I'll copy this. I'll come over here and I'll say localhost 8080 over here, and I'll switch over to this URL. So now you can see this is the result that I get. This is the default result that I get. Now, one thing I would like to highlight over here, I'm seeing these results that are JSON formatted. Okay, so it's well formatted. You might not see it well formatted. You might see it in the text format. Okay, but I'm seeing it formatted because of a plugin or a Chrome extension that I have added in my browser, and it's called JSON Formatter. So you can Google for JSON Formatter, and here, if you scroll down, you will find this JSON Formatter for Chrome Web Store. If you're making use of any other browser, be sure to check out the JSON Formatter for that particular browser. But for Chrome, if you search for JSON Formatter, Google Chrome or JSON Formatter, you should see this Chrome Web Store URL, wherein you can add this extension. So you can see, I'm seeing this remove from Chrome button. So I've added this into my browser. So you can see this is how it is. It will format the JSON for you automatically. And if you're a developer, I would highly recommend making use of JSON Formatter. Now, if you don't want to add any sort of extension, what you can do is you can go to JSON lint. So this is jasonlint.com. There are so many JSON formatters you can see. You can pick any of them, but I frequently use JSON lint. And you can simply copy this JSON and paste it over here. And you can say validate JSON. So it is going to format the JSON for you, and you can see over here. Okay, this is JSON, right? So yeah, this is the tool that you can make use to format if you don't want to add the Chrome extension. But I've added the Chrome extension, and you can see this is how I see the response. Okay, now since you're clear on why it's formatted and how you can format it for yourself, let's go through this response. Okay, so you can see this first thing over here. Okay, the first thing in the format is _links. So this is the top level object that contains the links to different Actuator endpoints. Okay, then you have within this, you have this self over here. What is self? So this link points to the base Actuator endpoint, which is this one, and this is something that we have added over here, or we have accessed. So this is the base Actuator endpoint. Then you have the health path over here, and this represents the health path. Okay, and you can see over here, it also contains the path parameter. And this indicates that the additional path segments can be added to the health endpoint URL. For example, you can access http localhost 8080 actuator health /xyz to get the health information of the specific path segment XYZ. So all that you can do. Okay, so you can add parameters over here. That is what it simply means. Then you have health thing over here. So this is the health, and here you have this health endpoint. Now this link points to the health endpoint, which provides information about the health status of the application. Okay, so in summary, this response indicates the Actuator endpoints that are available and can be accessed with the provided URLs that you see on the screen. Okay, and the health endpoint is very commonly used endpoint that provides the information about the overall health of your application. Okay, Now on the right hand side, you are seeing these two buttons. You might not see these two buttons because these buttons are coming in from the Chrome extension that I've added. Okay, the JSON formatter. Okay, so if I don't want to see this formatted result, I can click on raw, and this is how I'm seeing it in the raw text format. Okay, so this is how you will see if you don't have the extension. Okay, I would recommend extension because this is not readable, right? We are developers and we frequently work with things like JSON, right? If you're hitting an API, if you get an API, if you do an API call, a GET request in the browser itself, you will get a JSON response. So it's best to see the parse response this way so that you can read it. You can see how much more readable this is, right? So this is about the Actuator endpoints or how you can enable Actuator into your Spring Boot application. I hope you have been able to follow along, and I hope this has been super useful. So Actuator is just not about these many endpoints. Okay, this is the default configuration that we have enabled. And if you take a look at how we are getting these endpoints, is we have literally just added the dependency into our pom.xml, and we have tried accessing the Actuator endpoint from the browser, and this is what we see. We have literally done no sort of custom configuration ourselves. This is just Spring Boot auto configuration coming into play and exposing these default endpoints to us. But if there are any sort of custom requirements, Actuator actually has many more endpoints which are not exposed over HTTP by default for security reasons, right? So these endpoints can provide sensitive information about your application. So they are hidden to prevent any sort of potential leaks. But for the purpose of learning, we would be going ahead and exposing all the Actuator endpoints so that we can see everything transparently. So what I will do is I'll come over here to our application, and here you can switch over to pom.xml. Okay, here. And in the pom.xml, what we are going to do is, so you can add this property. So if you're making use of like application.properties file, so you can say management.endpoints.web exposure, and you can say include over here, and you can say is equal to star over here. Okay, now how do you translate this same thing to that of YAML file? So since I'm making use of YAML configuration, I'm going to paste it this way. Okay, and it would automatically be pasted as YAML configuration, and I'll replace the equal to in the end to that of star over here. Okay, now what we are telling over here is we are actually doing a setting which is exposing all the Actuator endpoints over HTTP, which is helpful for development and debugging. However, in production environment, be careful. You should be careful as to what to expose, and you should only expose the endpoint that you need to minimize the risk of leaking sensitive information about your application. Okay, so be careful about these settings in the production grade environments. Now I'm going to restart the application so that the configuration that we have added into it are taken into consideration. So we get an error over here. Okay, so I'm getting this error while scanning the reader. This is a problem, that star is a problem. So if you're making use of YAML configuration, you have to add it in a single quote. Okay, oops. So I'll just get rid of this and I'll add it over here, something like this. Okay, so this is fine. This is not needed in properties file, but this would be needed in YAML. So let me rerun the application and let us see if this is picking up in the right way. So you can see it got picked up in the right way, and now you are seeing the application being started over here. Okay, so if you search for Actuator, let us see if you are seeing any sort of special logs over here. So we are not seeing any sort of special logs. Okay, it's just the Actuator endpoint has been exposed, and you can see over here this message exposing 14 endpoints beneath base path. So we were not seeing 14 endpoints early on. You're just seeing it right now. So if you want to see, I can comment this out, restart, and let us see what was being seen earlier over there. Okay, so if you see, okay, I'll just do Actuator over here. Okay, Actuator. Okay, so you can see exposing one endpoint. So it was exposing one endpoint early on, right? But now if you add this over here, it is exposing 14 endpoints. Okay, so you could see that. And this is the magic of adding any sort of custom settings. So you can see 14 endpoints beneath base path actuator. Now if you come over here, we just need to hit refresh and you're going to see tons of URLs over here. Okay. So we have exposed all the URLs in a way. All right. And you can see different kinds of URL that exist. And these different URLs are exposing different set of information about your application. Okay. And this response indicates that all the actuator endpoints are now accessible and that you can use the provided links to access specific endpoints and retrieve relevant information about your application. So when working with Actuator, there are quite a few endpoints that might seem overwhelming, okay? But the goal of this lecture is to take a look at some of the key endpoints, and these are the endpoints that are quite popularly used when building Spring Boot applications or when working with Spring Boot. These are all the built-in endpoints, okay? So I would also want to mention that Spring Boot also lets you add endpoints on your own, okay? So let us take a look at the table which talks about the popular endpoints. So this is a table that I have. So we have health endpoint, and this endpoint shows the health information, okay, which is useful for checking the status of the application, like database connectivity, disk space, custom health checks, and so on. We have info endpoints, which displays the arbitrary application information that is commonly used to display. Okay, and it is used to display application version, git commit information, and so on. Okay, then we have metrics, which talks about the metrics of the application. Okay, and it lets you understand the performance and the behavior of your application. Then you have loggers, which allows you to query and modify the logging level of your application. So if you wish to change the logging level, you can do so using loggers. Then you have beans endpoint, which provides you a complete list of beans that are being managed by Spring in your application. Okay. Then you have shutdown, and it allows you to shut down your application gracefully. So these are some of the commonly used endpoints that exist with Spring Boot, and these are sorted in the order of their popularity. Okay. Now, popularity also depends from company to company. So there will be a company which might be using this particular endpoint a lot. Okay, so this endpoint becomes a lot more popular in that particular company. But overall, in general, this is what is generally being used in the market. So these are the important endpoints that I wanted to share with you all. Now, when talking about actuator endpoints, there is one specific endpoint, which is the health endpoint, which comes up over here. Now, this is the endpoint that is one of the most useful endpoints that is provided by Actuator. It provides basic health information about the application. And in the production grade environment, this endpoint is commonly used by infrastructure management software to monitor the application status. So there will be a separate team, depending on your team structure. There can be a separate team, or same team can also manage it if your team is relatively small. So they can take a look and manage the application uptime, downtime, and health. So if you open this link over here in a new tab over here, you are going to see this kind of a response. And by default, this provides the basic information like the application status. So what is the status of the application? Our application is up right now. And this indicates if the application is running, right? So up means app is running, down means it's not. So that is what actuator endpoint, this endpoint means over here, right? Health. And this is what the status parameter also tells us. Now, we can do more with health endpoint. This information just tells you up and down, okay? Nothing much about health. But you can enable this endpoint to do a lot more. It can include several health indicators, each representing specific aspect of the application's health. So Spring Boot Actuator already includes a number of auto-configured health indicators like data source health indicator, disk space health indicator, MongoDB health indicator, Redis health indicator, and so on. Okay. For example, how these work is if you have a SQL database configured in your application and you have the necessary Actuator dependencies as well. So Spring Boot actually knows that your application is dependent on SQL database. So the health endpoint wherein which is being exposed by Actuator, will automatically check for the database connectivity, and it will include its health in this response. Okay. But to get that kind of response, you have to do some additional configuration. By default, like you can see over here, we are seeing this basic information that is being shown up over here. Now, like I said, to expose more, you need to head over here and you need to do some sort of configuration. So I'll come over here, and here I'm going to say endpoints, endpoint over here. I'm going to say health. I'm going to say show details, and I'm going to say always, something like this. Okay. Now, if you are making use of properties file, you can absolutely make use of this kind of a syntax. Okay. Wherein, oops, so I'll just do Control C and I'll just paste it. So instead of, having these colons in the end, you can replace these with dots. Okay. So application.properties file, I hope you are clear as to how you can change these properties to that of from YAML to application properties. I believe it should be clear by now, right? So going forward, you can like take care of the application properties format over here. All right. But this is how you can expose. You can expose the details of the health endpoint. Now remember over here in the previous property, we have endpoints, but here we are making use of endpoint over here. There is no S over here. So let me restart the application because we have added some configuration over here. And for the configuration to take into effect, you will have to restart the application. So here you will see the application is up and running. Come over here and now refresh this health endpoint. Now you're going to see a lot more information than what you were seeing early on, right? So this is what the response would look like the moment you add additional details. And you can see over here, the first thing you see over here is status up. This is the application status. And then you have different components for which you are seeing statuses, right? You're seeing status up over here, ping status up, SSL up over here. Okay. So the health status of each component can be seen, okay, under the status tag. And the status can be any one of up, down, unknown. It can also be out of service. It can also be maintenance. Now maintenance indicates that the component is under maintenance over here. Okay, so this is this about the status tag or the status property that you are seeing over here. Then you have components over here. You can see components. Now within components, this section would provide information about different components or subsystems of the application. For example, you can see over here, one subsystem is DB. Now, DB represents the health status of the database components. In this case, the status is up, indicating that DB is functioning absolutely properly. And the detail section provides the additional information of the component over here. So you can see over here, the database type is H2 over here. And that is why you are seeing H2 over here. And there is a validation query which says is valid over here. Okay. So this is the database component. So automatically it knows that we have configured H2 database into our application. How does it know? Actuator knows from pom.xml file and the configuration files. Okay. It knows that this application is making use of H2. If you had MySQL, you would see the changed database over here, right? You would see MySQL over here instead of H2. Now the next component you have is the disk space. Now this represents the health status of the disk space component, and the status is up, indicating there is sufficient disk space available. And this section provides detail about the disk space, like you can see details like total disk space, what is free, what is threshold. This is the path of the project. Now if you are configuring this for some other project, you will see the appropriate path over there, and you can see exist over here set to true. And this indicates whether the path exists or not. Okay. Then you have ping over here. Ping represents the health status of the ping component, and in this case, the status is again up, indicating that the ping is successful and no other details are provided for this particular component over here. And then you have SSL component, okay, which also shows status up and some details about SSL. Okay, so this response indicates that application's overall health is up and the individual components are also up. Now over here, if you come, you can configure this property. So right now we have added always, but you can add things like never, which means these details are never shown, and this is the default. Like initially we were not seeing all this information. So never is default you can also have things like when authorized. So if you add, instead of always, you change this to when authorized, something like this, when authorized. So it will only show to authorized user. Okay, so if you want to have some sort of security mechanism there, you can absolutely do that. Also, I would like to show you this document over here, which is about the health endpoint, since health endpoint is one of the important important endpoints when it comes to Actuator endpoints. So you can take a look at the documentation over here. It's under docs.spring.io, Spring Boot, API, REST, Actuator, and health. And you can see this is what it talks about. So this is something that I already explained to you all, and you can see the details over here. Okay, so yeah, this is about health endpoint. I hope this has been useful so far. The next endpoint that we should talk about is the info endpoint. So if you scroll down over here on the main Actuator page /Actuator, you will see this info endpoint appear over here. Okay, and let us try to access this endpoint over here. So by default, you're going to see an empty JSON over here. Okay, now what is this info endpoint? So info endpoint in Spring Boot Actuator provides miscellaneous application information, and this information can be statically configured or dynamically generated. It's a fantastic tool for exposing information about your application, like versioning, git commit details, or just about any information you think would be useful to others. Okay, so right now by default, the info endpoint does not expose any information like you can see over here. So when hit, it just returns an empty JSON object like so. And you can add some static information to the info endpoint by adding properties to your application properties or application YAML file. And this can be useful, right? So I'll come over here, and what I'm going to do is here, I'm going to say info.app.name, and you can call, oops, not this. I'm making use of YAML format. So I'm going to say info app, and I'm going to say name over here. And here I'm going to say job, or I can say my new app, something like that. And you can say app. So here, instead of app, you're going to say description, something like this. And you can say app built by us over here. And you can say version over here. And you can say 1.0.0, something like that. Okay, let us run this and let us see how this works. So the application is running fine, and we'll come over here. Let us refresh this. Let us see if we are getting this information. Okay, we are not seeing anything. So what we need to do is here, I'll come, and here I need to add one more property to enable this information up here. So I'm going to say, okay, so I already have management added over here. So it will be management dot. Okay, so under management, I'll say info, env, and then enabled to that of true, like so. Okay, let me restart this. Let us see how this works. So the application is starting fine. If you come over here and refresh, you're going to see the information that you added into the application.properties or application YAML. You'll see it appear over here. So you can add any sort of your application name if you want to expose the description, which version we are on. So all of that, the static information can be exposed. All right. And whatever you add over here, you can see it being exposed. So you can see over here, I'm exposing it for info over here, and info, under info, I've added this information, and I'm exposing info under management over here. Okay, so this is how you can make use of info endpoint to expose stuff or any sort of static information. Now let us talk about the metrics endpoint. The metrics endpoint is one of the most powerful features provided by Spring Boot Actuator. It provides a comprehensive overview of your application's current state, including various system and application level metrics. Okay, now if you take a look at all these URLs, if you scroll down here at the somewhere in between, here you will see this metrics endpoint. So these two things. Okay, first let's talk about this first one over here. Okay, so here if we access this endpoint, it's actuator/metrics. you're going to see the list of all the available metrics that exist in your application. Okay. Now you can see over here, this is the ready time, application started time, disk free, the total disk space, executor is active or not. Okay. So all of this you can see over here, HTTP server requests. You can see JVM related information, JVM buffer count, JVM buffer memory use, JVM buffer total capacity, how many classes are loaded in JVM. So JVM classes loaded, JVM classes unloaded, compile time. So a lot of information, JVM memory max, JVM info, JVM memory committed, how much of memory is committed in JVM, process CPU time, process CPU usage. So tons of metrics you can see over here. You can even see active sessions on Tomcat server. Okay. So these are all the list of available metrics that exist in under the Actuator endpoint, like metrics endpoint, I should say, within Actuator. Now, if you want to see the value of any such metric, you have to make use of this second endpoint over here. Okay. You can see there were two endpoints for metrics over here. This was the first one. This was the second one. Right. So you have to make use of this second endpoint over here. So this second endpoint, if you open, okay, it will throw an error. So here you can see this last part of this URL is required metric name. So what you have to do is you have to take this metric name from here. This one, for example, if I want to see disk free space, so I'll take this, I'll come over here, and instead of this required metric name, I'll paste this and I'll say enter. So you can now see the details around that particular metric. Okay. So these were the list of available metrics. And this is how you see a specific metric for your own use case. So you can see disk space. So description is usable space for the path. And the base unit is in byte. So whatever values you are seeing is in byte. Now this is a value. Okay. This is the path and this is the value of the path. Okay. So this is what you can see. Okay. Now if you come over here, you can even see the total disk over here. Okay. So this was disk free. You can see total disk as well. Okay, it will be similar, but the value would change. Okay, you have, if you scroll down over here, you can see HTTP server request. So this is something that you can see over here. Okay, you can see total time, max, available tags. You can see all of this. Okay, you can see this information. Okay, then if you come over here, you have information like JDBC, active connections, JVM buffer count. Okay, so this is all JVM related information that you're seeing over here. So you can check the JVM information. Okay, that is something that you can check. So let me go to this link again. Okay, the link went away. And now if you paste this again, you'll see JVM info. So you can see JVM info, JVM version info. You can see the vendor is Oracle Corporation and runtime is OpenJDK runtime environment. The version is this one. Okay, so depending on which version you are running, you are going to see the appropriate version. JVM memory committed, JVM memory max, JVM memory used. Okay, so all of these information, you can see process CPU time, process CPU usage. You can see the CPU usage as well. So this is very helpful to do some sort of monitoring of your application. You can see the usage over here. Okay, 0.09. So this is the recent CPU usage for JVM, Java Virtual Machine Process. Okay, and you can see process uptime, system CPU count. So this will give you the CPU count of your system. So if you're running this on a server, this will give you the CPU count of the server. So you can see there are, so this represents the number of processors available to the Java virtual machine. So right now in my system, there are 12 over here. So if you're running this on a server, you can take a look at how things are working. You can see system CPU usage. So what is the system CPU usage right now on your system? So you can get this. So you can see 0.07, which is, it is less than 10%, right? So 0.10 is 10% over here. Okay. So you can make use of these things, like these metrics, basically to get a comprehensive overview of how your system is doing and how the metrics related to your system are doing in a way. Okay, this is very helpful and used pretty often. So I hope that you are clear about what this metrics endpoint is. Remember, there are two metric endpoints. One is to get the list of all the available metrics, and to view a specific metric and details about a specific metrics, you can access localhost or your host name /actuator/metrics/ the metric name. And how will you get metric name? You will get metric name from here, like the list of available metrics. Okay. So I hope you have been able to follow along, and I hope this has been useful. So now it's time that we begin talking about the loggers endpoint. Now, if you scroll down over here, and here somewhere, you're going to see this logger endpoint over here. Now, what is this logger endpoint? So the logger endpoint in Actuator is used for monitoring and managing the application logs dynamically. It allows you to view and modify logging levels for different packages or classes without restarting the application. Now you will say, hey, why this is important? You can just change the logging level in application.properties or YAML file and restart it. But this is not that simple. Let me tell you that. So in production grade environment, to restart your application means that there will be a downtime. And if it's a production grade environment, and if it's a very popular application that is being used by thousands and millions of people across the world, then that downtime is considerable, right? So in that case, this endpoint can be used to modify the logging levels dynamically. Okay, so here you can see these two endpoints. So here, if you try to access this first endpoint, loggers, you're going to see the information over here. Okay, so you can see different logging levels of the different packages in your application. So for example, here you can see the levels. Okay, so this talks about the logging levels and what logging levels can be in your application. Okay, so here you can see this is off. Off means the logging level is off, so there are no logs. Then you can see error logging level. So this is this level is only for serious failures over here, right? Then you have warn over here. Warn means when something might cause a problem later on. So if your program detects something that can cause problems later on, it will add that log in the warn or as warn category. Then there is info. And this is for general application flow like startup, user actions, and so on. This is the info. Then you have debug. Now, when any sort of actions happen in your application, you will see debug logs, and these are much more detailed and fine-grained logs as compared to info, and they can be used for debugging the application. And then you have trace, which is with the maximum details. Okay, it is even detailed as compared to debug. Right, so trace is the one with maximum details, like every method and every step that has been happened, and it is useful for doing detailed logging. Okay, so these are different logging levels that exist when it comes to Spring Boot application. And here, if you scroll down, you're going to see the levels configured for different packages in our application. So here you can see root, then you have org, then this is for Spring Framework. Spring Framework Web is set to info. Okay, now if you scroll down over here, you can see this is our application, ecom application. So if you access this endpoint for any other application, you will see that application name over here, right? So if you have, let's say, job application, you will see job application over here. If you see recipe application, you will see that over here. Fitness application, you will see fitness application over here. Okay, this is the main package of my application right now where I have configured this. So for main package, this is what is the configuration right now. So if you update this, or if there is any other application, you will see this package name change and reflect accordingly. Okay, so you can see over here the different logging levels for different packages over here. Okay, now there is another endpoint over here, which is logger name over here, and this is the templated endpoint, which means you can pass in the package name over here. So if I open this in the new tab, it won't work because I need to add the package name. So let me scroll up over here. And what I will do is I'll add my main package name over here, which is com app ecom, and I'll add it over here, something like this. And now you'll see the effective level of logging over here is info. Okay. Now what I can do is I can change the logging level of a package without restarting the app, right? And that is what this endpoint allows us to do. Okay. So this is the current logging level of this particular package over here, which is the main package of my application here. But if you have any other package or any other package name, feel free to change that. It will automatically show that updated package name over here, and you can add that over here. Okay. But now what I will do is I would show you how you can update this logging level dynamically. Now to update the logging level dynamically, you have to send a post request to this particular endpoint. Okay. So what I will do is I'll make use of a REST API client like Postman, and I'll switch over to Postman. Now here I'll add an endpoint. I'll add a request over here. Okay. And here I'll paste this endpoint. Okay, and I'll convert this request to a post request. And here in the body, I'll have to add the information about what logging level I wish to change for this. Okay, so I'll come over here and I'll say configured level, and I'll set this to, let us set this to debug over here. Okay, so this is the value. Okay, so if you see over here, this is the, if you scroll up, okay, let me scroll up. So you can see debug is one of the logging levels, and right now it is at info. So info is the default. So I'm adding debug over here, and what I will do is I'll trigger this endpoint. You can see the response was 204. So the request is successful, which means the update is done, and you can see there is no content to display over here. That is what it means. So green means you're seeing it's successful, right? Now if you come over here, if you refresh this, you're going to see debug over here. You can see the update has been done to debug over here. And here also, if you do a refresh, so without refreshing, you can see this is info. If I do a refresh, you can see this is updated to debug, and it is updated for this over here, right? So this ecom application exists under this package. So for this package, it is updated to debug, and you can see for this also, it is updated to debug. Okay. Now without restarting the application, you have this change done. Okay. And you can see the configured level and the effective level. Now, what does this configured level and effective level means? Earlier, you were just seeing effective level. Okay. So configured level means the logging level, which is explicitly set by the application. So right now it is debug. And effective level means this is the actual logging level being used. So this is also set to debug. Okay. So both are debug, means the debug is the actual logging level for this particular application. Now this is really useful. Okay, this is very useful. The benefits are like real-time debugging. So if you spot the need of enabling debug logs in a production grade environment and your application is already live and you want to see what sort of logs are happening because you spot some potential issues in the application. So you can enable the logging dynamically this way for the production grade application without having a downtime, and you can monitor the logs and then you can switch it back to info level as well. So that's the benefit you get. Now there is no need to restart the application. Now in production grade environment, restarting the application can be complex. It could be dependent on multiple applications. If one application, or if there is a microservice architecture, imagine like if one microservice is down, and if there are multiple microservices dependent on that one, it could lead to a like an issues, right? So that's a problem. And restarting the application is generally not easy in production grade environment. It can cause business loss as well, right? So there's no need to restart, and performance is also better, right? So if, for example, if you accidentally deployed the application onto production with debug logs enabled, okay, now you don't need to redeploy after making the change in the application YAML. You can just do this dynamically, and you can get rid of the debug logs and you can switch back to info. So the mistakes that you did with respect to logging, or like you accidentally left debug logs enabled in production environment, so you can do away with them and you can manage such issues without unnecessary restart. So that's the benefit of this particular endpoint, right? And from production grade standpoint, this endpoint is really useful. So I hope this information is much more clear to you all as to why, what, and how this is supposed to be used. And I hope you're clear about the different logging levels as well. So logging levels, just remember, it helps you control how much information gets printed in logs when your application runs. And if you're not clear what logs actually are, you can see logs over here. In any Spring Boot application you run, you will see these logs. These are the logs. So this gives you an idea of what is happening when your application is running, because this is like a message over here. So you can see over here, it is exposing 14 endpoints beneath base path actuator. Tomcat has started the application over here. After Tomcat is started, the application started. So you can see logs tell you the events that are happening with respect to your application, right? And depending on the level enabled for your application, you will see the granularity in logs. So if you are at trace level, you will see a lot more logs than the logs that are happening at info or the error level. Okay. So I hope this has been useful, and I hope you have been able to follow along easily. a quick mention over here that this course is a part of complete Java, Spring Boot, Microservice, e-commerce masterclass over here, e-commerce project masterclass hosted on Udemy. Okay, the link for this you will find in the description below. You will find the link to the discount coupon in the description below. Okay, so do check that out. So the link will take you to my website over here, and if you click on enroll now, you will get the best possible discount, the lowest price discount at that particular point in time. Okay, and right now this course is available at the lowest price. I've updated the coupons on the website, so please take a look. And always I make sure there is at least one coupon available for my learners whenever they decide to enroll. And yes, Udemy of course has a limited coupon policy, so there is a limit on the number of coupons that I can distribute. So if you're planning to enroll into the full course, if you are enjoying this experience, then please check out the description, the link in the description below. It will take you to this website over here. You can read more about the course, and after enrolling, you get a lot more. Like you get 6 months of IntelliJ Pro, lifetime updates, and people who are enrolled into my courses, they know I update my courses a lot. Okay. It's not like you enroll and I forget. It's not like that. I keep on updating with new technology, new versions. So you get lifetime access to all the future videos. And yes, it's a 75-hour plus course over here. It's huge. It has hands-on labs and a lot of other content. So you can see over here. If you scroll down, you should see things like labs over here. Mock interviews. A lot of it is there inside the course. And yeah, we cover a lot of concepts in depth. You have access to notes as well. So it comes with a lot of features as well. So do take a look at this particular course over here. And first, you check the description. You click on the link and go to this website, and then unlock this coupon that you see over here. So this is a coupon right now, but I keep on updating the coupon. So when you are watching the video, you might see a different coupon that is valid at that particular point in time. And yes, there are tons of learners who have enrolled into the course. It is one of the highest rated courses. So it's bestseller first of all. And being bestseller on such a large platform or global platform like Udemy in this popular niche of Java, Spring Boot and microservices is not a joke. Okay. So there are a lot of learners who have already enrolled, and you can take a look at the ratings. These ratings are real, managed by Udemy. If ratings are on the platform, it's not managed by me. Okay, it's managed by Udemy, right? So it's not on my platform wherein I can go and edit the rating. It's not like that. It's Udemy, and the ratings here are genuine, and these are all genuine learners that have posted a lot of ratings. You can go and check out the real ratings over here from the real learners. A lot of people have upgraded their careers, got better jobs and increments as well. Okay, and you can see there are so many learners, and this count keeps on growing every now and then. Okay, so I hope this will be useful. And yes, of course, this is my website, embarkx.com. Here you will find this Java full stack. This is another course wherein we build. So if you are not familiar with Java Spring Boot, and if you need a portfolio project over here, so we build a full stack advanced e-commerce project over here. We cover everything like React, JavaScript, everything needed for full stack development. So that is this course for. Okay. We also have DevOps course over here. DevOps, you can see over here, this is a DevOps course, and we master a lot of stuff like CI/CD, Terraform, deploy apps to production. And this is a multi-cloud course. We cover AWS, Azure and GCP as well. And then we have Spring Security. If you are facing difficulty with Spring Security and JPA, we have 2 courses for them as well. And we have a lot more. You can check out the website over here. Okay, but what I told you are the flagship courses. So yeah, do check this out, and thank you. So now it's time that we begin talking about the Beans endpoint in the Spring Boot Actuator. Now Beans endpoint in the Spring Boot Actuator. Okay, if you go over here and if you see this particular endpoint over here. So this provides a complete list of all the Spring Beans in your application. Now remember, whenever you are working on a Spring Boot project, you will have different beans available in your application, and there would be dependencies between them. So if you want to understand the project composition, you can take a look at this particular endpoint. So this is the endpoint, okay? And if you open this over here, you will see this kind of a JSON appear over here. Now let us understand what this JSON is. So let me tell you this, it is pretty long. You can see like there are tons of beans that exist in any Spring Boot applications. I'm just scrolling really fast. It's a very huge JSON. So depending on how big your application is, you will see the number of beans over here. Okay, so I'll just scroll up to the top, the maximum level. Okay, so I'll come over here at the top. And now let's talk about the different things and understand how this JSON is structured and how you can make the best use of it. Okay, so first thing, at the root, you find context. Now this contains the context within the application. Okay, so here you can see this is ecom application that we are referring to over here. So whatever your application name is, for example, if you're building a fitness application, job application, you will see the relevant application name over here. And then over here, you have nested, you have beans over here. So this contains bean definitions within the application context. So this is the application context, and within this application context, what all bean definitions you have. So all that you will find over here. So you can see there are around 400 items, as you can see over here. Okay. Now, if you open this, here you can see this is the name. Okay. And here you will see different tags related to this bean. So you will see tags such as aliases. Now, what does aliases mean? Aliases mean alternative name or aliases for this particular bean that exists. Scope. What does scope mean? So scope talk about the scope of the bean, whether the bean is a singleton or it's a prototype. Now, what do you mean by singleton? Singleton means only one instance of the bean is created per Spring Boot application context and not more than one. Okay. That is what singleton means. And prototype means a new instance is created every time a bean is requested. So that is what prototype means. And other scopes are also there. Okay, if custom ones are defined, okay, you will see them over here. But this is what scope talks about. Mostly you will see singleton over here. Then you have type over here. So this indicates the type of the bean. So here you can see this bean is of this type over here. Okay. Then you have dependencies. So dependencies means these are the dependencies that are required by this particular bean to function well. Okay, so now you can see this is another bean which has this aliases. You can see the scope is singleton. This is a type. Okay, this is a resource, meaning the resource as in it indicates basically the path to the source code of the beans class. Okay, so where is the class of this particular bean? That is what is being indicated over here. And then you have the dependency array that you see over here. Okay. And then you can see over here, this is the health endpoint groups. So there are tons of beans and you can go through them. Okay. Now, if you create any sort of classes or controllers, services, repositories, you will see them appear over here as well. Okay. So here, a lot of beans that you're seeing is coming in from org.springframework.springboot.autoconfigure package. Okay. So the Spring Boot auto configuration or the libraries that we have added, they are coming into picture, and there are a lot of beans that are doing the job in the hindsight for us. We have not created these beans, right? They are available by default to us for our application functioning. So if you take a look at controller, so if you have created controller over here in your particular project, you can just search for controller. So I have order controller, a bean called order controller into my particular class or into my project. So you will see over here order controller up here. You can see aliases. There's no aliases for this. You can see the scope is singleton. The type is this. Okay, this is the package over here, and this is where the class resides. And here you will see the resource file. So this is the resource means this is where the source code for this bean exists. Okay, and this is a path on my local system. And then you can see the dependencies, which means like this particular controller has this dependency. So it's dependent on this particular bean order service. Okay. So this is one controller. Okay, you can take a look at more controllers as well. Okay, so there are so many controllers that are inbuilt. Okay, so you can see cart controller. This is something that I have created again. So you can see aliases, scope. You can see this is the cart controller. You can see the resource over here, the dependencies as well. Okay, so there are tons of things that you can see over here. User controller, you can see. So this is all, if you have created service class or repository. So let me search for repository. Okay, so you can see repository is being used as a dependency over here. You can see this user repository. Okay, so you can see over here, this is the name of the bean. This is the aliases. You can see scope over here, the type, resources, and under resources, you can see this is a repository defined in enable JPA repositories. Okay. and it has dependencies on beans such as these. Okay, so you can see and you can take a look at different beans that exist if you wish to. Okay, now remember, this endpoint exposes quite a lot of sensitive information about your application's internal structure, how it's organized, the composition, and this should be protected in the production grade environment. You cannot just expose all the bean related information of your application for anyone to see over here. Okay, right now we are able to access it easily, but this should not be the case in production grade environment. Always use something called a Spring Security or something similar to secure your Actuator endpoints, particularly when they're exposed over the internet. Okay, and over here, if you come to application YAML, you will see we have the management endpoints web exposure to include all the endpoints over here. So we are exposing all the endpoints, right? So if you scroll here, we're exposing all the endpoints from the actuator. Instead, what I would recommend is if you just want to expose bean over here, you can just include beans over here and it would just expose beans endpoint and not all the endpoints. Okay, so from the security standpoint, that is important because anyone taking a look at this particular endpoint, he's going to understand how your application is structured, what is dependent on whom, and there's a lot of sensitive stuff that comes into play over here. Right, so this is not recommended. Like exposing this over the web is not recommended, and yeah, be careful when you're working with this. All right, so that's about the beans endpoint, and I hope it has given you some clarity about it. Now it's time that we begin talking about the shutdown endpoint. Now, what is a shutdown endpoint? So shutdown endpoint is a built-in Actuator endpoint in Spring Boot that allows your application to be gracefully shut down. Now, a question you might have, or you might ask me, a question you might have in your mind is, a shutdown is a shutdown, right? So why have an endpoint for the same? You can shut down the application directly, right? No. So when I said, or when I introduced this shutdown endpoint, I mentioned graceful shutdown. Now, by graceful shutdown, we mean that it will complete all the ongoing requests before the actual shutdown takes place, and it will terminate gracefully. Okay, it won't abruptly shut down. Now, if I come over here to my application and if I just press the shutdown button, that's abrupt shutdown, right? But in production grade environment, you might want to do this in a very graceful way, wherein every existing request and all the housekeeping thing or anything that you might have that you want to gracefully end would take place, and then the application would shut. So this endpoint can be very useful, especially in scenarios where you want to control the lifecycle of your application from a sort of an external system, and you want to manage the shutdown and everything from that system using the endpoint, right? Now, if you come over here to the Actuator URL, and if you scroll down over here, you are not going to find shutdown endpoint over here. So understand this, it's disabled by default. And for obvious security reason, this is disabled. The shutdown endpoint is not enabled by default because it can be a significant risk, because anyone can access the endpoint and can shut down your application. Therefore, it has to be used very carefully with the appropriate security measure, which means like you can only expose this particular endpoint to a particular IP or something, an IP that is internal to your organization and an IP that you trust. Okay, so the question is, since it's not enabled by default, how do you enable it? So for enabling it, you come over here to application.properties or application.yaml, and here you can add management. I can say endpoint. I can say shutdown over here, and then here you can say enabled, something like this, and you can add true. Now I'm getting this red mark over here because this management key is already added over here, right? So I'm getting this duplicated error. So what I will have to do is I'll have to cut this, and I'll have to get rid of this management tag, and I'll have to paste the part that I've cut under this management tag. So you can see over here, this is the management tag at the top. Okay, so endpoint is also duplicated over here. So what I will have to do is I will have to cut this shutdown part over here, and I'll have to go over here. I'll have to paste it over here, and endpoint I'll have to get rid of, right? So you can see management.endpoint shutdown.enabled true over here. Okay, And what I will do is I'll restart the application. So this is applicable for any sort of Spring Boot application that exists. Okay, so I've restarted the application, and now if you come over here, okay, you will have to access a particular endpoint. So you can go over here, Actuator / and you can say shutdown, something like this. Okay, and you can press enter. Now you're going to see this kind of an error if you try to access this endpoint. And it won't work as a GET request, because if you are hitting this endpoint in the browser, you are basically triggering a GET request on this endpoint. So GET request on this endpoint is not enabled, again, because of the security measures, because anyone can hit this endpoint this way and shut the server, right? So how do you shut your application using this endpoint? So the answer is it supports HTTP post method. So you have to make use of a post request. So rather than typing this in the URL, you have to copy this URL and you have to head over to Postman. And here I'm going to add a new request over here, HTTP request. And here I'll paste this request. Okay, so I'll save this, the rest of the things. Okay, and then I'll come over here. I'll save this as well. Okay, and here what I will do is I will select post over here. Okay, so just save this request the way you want, wherever you want. And you can see this Actuator shutdown over here. It's a post request. There's nothing in the body and all. Okay, so I'll just say shutdown and I'll just run. So the moment I say run, you'll see the message you get over here, shutting down by. Okay, which means that the shutdown was successful and you're getting 200 OK as the response. Now, if you go to your application over here, you will see the application has shut down already. And if you scroll up a bit, you will see few logs over here. Okay, so the first log is, we'll start from here. This is completed initialization, which means the application was started at this point. And then we got this message over here, which means request method get is not supported. Why did we get this? Of course, because we tried to access this endpoint via browser. So we got this log over here, which we are seeing now that get is not supported. If you scroll down over here, after doing this call from the browser, we did this call from the Postman. And now we see this log over here, commencing graceful shutdown, waiting for active requests to complete. Okay, so active requests are completing. You can see over here, graceful shutdown complete. And then you can see closing entity manager and everything. Basically, the shutdown related task, shutdown initiated, and then the shutdown happens. Okay, so this is what graceful shutdown is. Now, you can also add one more property over here to basically explicitly mention over here that shutdown should be graceful. And what is that property? You can say over here server, and you can say shutdown, and then you can say graceful, something like this. Okay, so you can add something like this, and you can restart the application. And then too, you will see graceful shutdown happening, because you are already seeing graceful shutdown happening, but this is an explicit way of mentioning that you want the shutdown to be graceful. So I'll come over here, I'll say shutdown, and you can see 200 OK, and you will see graceful shutdown happening over here. Okay, so this is one property that you can have just in case the shutdown is not happening graceful. But remember that shutdown endpoint, like I said, is potentially risky. Okay, this endpoint over here is potentially risky. Why? So this endpoint is not risky. This exposing this endpoint is potentially risky. Okay, so exposing this endpoint can be potentially risky if not handled correctly. And always ensure that you have a good control on whom this endpoint is being exposed to. Because if this endpoint in production grade environment is exposed to the world, then anyone can come and shut down your application. Okay, be sure to have appropriate or right security measures over here. You can enable access to this particular endpoint only at a particular internal IP of your company or so. Okay, so I hope this has been useful, and I hope you have been able to follow along. So I want to talk a little bit about exposing endpoints when it comes to making use of Spring Boot Actuator in your application. So here you can see I've exposed all the endpoints that I could with Actuator. Okay, but this won't be the ideal way when you're working in the production grade scenario. So here in the application.yaml file, instead of exposing all the endpoints with the help of this property, we have added star over here. You can add a specific endpoint that you wish to expose. For example, if I wish to expose the bean endpoint, I can like mention bean instead of star, and I can run the application. And then once the application runs, if you refresh, you're going to only see, okay, we are not seeing beans over here, so it should be beans, okay, something like this. So let me restart the application. And once the application restarts, you will see that specific endpoint being exposed. So if you come over here, now if you refresh, you'll see beans endpoint being exposed. Now, if I want to expose multiple endpoints, okay, so rather than enabling all, what you can do is you can come over here, you can say, so here I've mentioned beans, I can say health as well. So adding a comma and mentioning the endpoint name, and Spring Boot will do the job of enabling that particular or those particular endpoints for you. Okay, so don't enable all the endpoints unnecessarily. Okay, so you can refresh and you can see Actuator health endpoints have been enabled. Okay, so here we enabled everything for learning purpose. If you're enabling it for learning purpose, it's absolutely fine. Okay, don't stress on that. But when taking your application to production, make sure you enable only things that you need, and that is really important because Actuator can have some sensitive information. Like these Actuator endpoints can have sensitive information that might get exposed to the outer world. Now, talking about security, these endpoints should be exposed to a certain IP which is internal to your organization, and it should be accessed by only trusted people in the organization, and that is why it should be open only to the internal IP of your organization and not to the external world. So you have to make sure like whoever accesses these endpoints has or is an authorized person who should be allowed to access them. Okay, so that's a thing. And I also want to point out to the official Spring Boot documentation over here. So you can come over here to docs.spring.io/springboot, and you'll see API/REST Actuator index.html. So just hit this URL and you should see the Actuator thing over here, and you should see everything about the Actuator over here. So you can see over here beans. So this is the beans endpoint. Okay, you can read more, learn more about this. Okay, and you have tons of stuff. Okay, so if you see here environment, so env, so this is the env endpoint. Then you have the health endpoint. You can see the health endpoint. Okay, you have things like metrics endpoint. So you can take a look at the official documentation for anything, and you can have it as a reference point. And in future, if anything changes with regards to Spring Boot Actuator, this is your place where you should first look up for the information. All right, so I wanted to just highlight this official documentation for your purpose, and hoping that it will help you always in future. So I hope this has been useful. What's going on, everybody? So in this lecture, we are going to talk about Docker. Now, I would like to teach Docker and give you an introduction with the help of a scenario. And we are going to first understand the problem that Docker solves. And then we are going to discuss what actually Docker is. So let us consider a scenario wherein we have a software development firm and we have two developers working there. So we have Sarah and then we have John. So Sarah is a software developer working on a team that develops a web application. And John is also from the same team. And this team uses a shared development environment where multiple developers work on the same code base. So John is also Sarah's teammate, and they use the same code base to push the latest version of the code and also to pull. Now, when working in their code base, they are using several libraries with different versions. Now, let's say John updates a library on his local system. Now, there is a library which has a local version available. So John updates this library on his local machine and he pushes this code to the shared environment. Now, the shared environment also has the updated version of the library which John has just updated. Now, what happens is when Sarah pulls the latest version of the code, she gets the latest version of the library on her system. And this leads to bugs in her application on her local machine because that version of the library which John has updated is not compatible or does not work on her system because of some environmental issues or some conflicts on her system. So the problem that I'm trying to highlight over here is that the developers are working in a shared environment where library versions and dependencies are not well managed. When one developer updates a library, it can cause issues for others due to version conflicts or compatibility problems. Now, this leads to inconsistencies in development environment and makes it difficult to reproduce the issue or debug them. Okay. Additionally, it brings us to a scenario wherein an application is working fine in one developer's machine but fails in a different environment of other developer. Okay, and this causes frustration, and like the team has to resolve these issues, and it delays the development process. Now, what is the solution to this? Okay, so the solution to this version is Docker, and to solve this problem, Sarah decides to use Docker. So what she does is she containerizes the application using Docker. Okay. Now, what this means is, so the code base moves to a container, okay, which includes the application code, its dependencies, and the required environmental configuration that is needed for application to run. Okay. Now, this is what the scenario will look like then. So Sarah has the container in which her application is running, and this container is like an isolated environment, okay, which has everything that the application needs to run well on her system. Okay. Now with this, Sarah has no longer to worry about conflicting library versions or incompatible environments or any other issues that may be caused because of any version conflicts. Okay. And this issue which Sarah faced just now, wherein the application was working fine on one of her teammates' machine, but it was not working on her own machine, is something that you as a developer might have also encountered several times. And she decided to use Docker for the same. Okay. Now, what will happen in the team here now is, since Sarah has a container or an image of her code, everybody upgrades to Docker. So we have in the shared environment, we have the code base residing into a container, and also on the John's system, we have a container. So everybody has started using the isolated containers which they can use. And this container has everything that the application needs to run and work well. So to summarize this entire scenario, Docker solves the problem of dependency management, compatibility issues, environmental inconsistency by providing with containerization. Okay, it enables developer to pack their application in and their dependencies into container, and this ensures consistent execution in different host operating systems. Okay, and it eliminates all the version conflicts that were happening early on. So let's define Docker. So what is Docker? So Docker is an open source platform that allows you to automate the deployment, scaling, and management of applications using containerization. Okay. Now, containerization is a lightweight virtualization technology that enables you to package an application along with its dependencies into a standard unit, which is called a container. Okay. And with Docker, you can create containers that have everything that is needed for an application to run. Now, this can include the code, the runtime, libraries, and even the system tools. And these containers are portable, which means you can move them across the systems and can be deployed on any system that supports Docker or has Docker up and running. Okay. Now, this ensures that the same container which is running on my system will work on someone else's system the same way like it was running on mine. And this ensures consistency, and it eliminates this phrase in your team that it works on my machine. I don't know why it's not working on yours. Okay. So this is completely eliminated, and you must have heard this phrase many times, like it's working on my machine. I don't know why it's not working on yours. Okay. So this is completely eliminated and managed with the help of Docker. So this is a Docker container that we spoke about. It has code, the runtime, libraries, and all the system tools that are needed for application to function properly. Now, what are virtual machines? So I want to talk a bit about virtual machine, and we will even discuss how virtual machines differ from that of Docker, because if you have been working with virtual machines, this concept of containerization can be a bit confusing as to how it differs from each other. Virtual machines act as computers inside your computer. So what is a virtual machine? It's a virtual machine that exists on your computer. So you can think of a virtual machine as a emulation of a physical computer system. Okay. So if you have a Windows running on your system, you can run Ubuntu as well on your system using this technique of virtualization. Okay. So it allows you to run multiple operating system and applications within them on a single physical machine, as if you have multiple computers within that machine. Okay. And you can imagine this as a powerful computer, and you want to use it to run different operating systems or applications that may not be compatible with each other. So for example, if I want to use a specific software that works only on Linux and I have Windows installed, so I can install Ubuntu as well, or any Linux software, with the help of virtual machines. Okay. So this technology, virtual machines, will help me create an instance of a Linux operating system on which I can use that application. So that is the problem that it solves. So without virtualization, you will have to buy a separate physical computer, or like delete your own host operating system to install the other operating system. Okay. But with virtualization, you can create your instance of virtual machine on your host system. So that is what this means. Like, it acts as a separate computer inside your computer, and each virtual machine behaves like a separate computer. Like I said, it has their own virtual hardware, CPU, memory, storage, and everything. Okay. So it shares some of these resources from the host operating system. Okay. Virtual machines are created and managed by virtualization software. So you need a software to create virtual machines. And there are many such softwares available in market. Like, you have VMware, then you have VirtualBox as well. So these softwares provide the necessary things or the infrastructure that you need to run and manage virtual machines on your system. Okay. It also allows you to allocate resources, and you have complete control on that. So let's say if you have a 10 core CPU, so you can decide, if you have 5 virtual machines running, I want one core to be allocated to each virtual machine. If you have 10 gigabytes of RAM, you can think of allocating 1 GB each to each virtual machine. So something like that. So it gives you complete control as to what is allocated to which instance of virtual machine. And you can even control their startup and shutdown. Okay. Even you can take the snapshots of their state and take backups and restore. So these are what virtualization softwares. Okay. And the advantage of them is they provide a flexible and an easy way to completely utilize your hardware resources. So you can run multiple virtual machines on a single physical machine, saving space, and you can even reduce costs. Okay. So this is what virtualization is. Now let's talk about how Docker differs from virtual machines. So when we talk about virtual machines, this is what the architecture will look like. So you have your machine over here. Then you have the host OS, which is nothing but the operating system that you have installed on your system. For example, if I have installed Windows on my machine, so I have Windows as my host OS. Then we have something called as hypervisor, which enables us to create and interact with virtual machines. So Once you have these things, okay, you can create virtual machines. So this is one virtual machine that I have created. So it has its own copy of operating system. As you can see, it has all the libraries or binaries that are needed for this particular application to run. Okay, so this entire thing is packaged as a virtual machine, and it will use the system resources that can be allocated to this particular virtual machine using the virtualization software. Okay, so this guest OS can be any OS, like you can install like Linux, or you can install any other instance of Windows as well. Like you can install the same OS as host OS as well. So it's up to you. Okay, so you can have multiple versions of virtual machines running on the same system. So you can have one more instance which runs a completely different app. Okay, and this is in a separate space and a separate environment than this one. So for example, this is running on Windows. Let's say the guest OS is Windows. Here you can install Linux and you can run the app B. Okay, so it will have its own libraries and binaries installed again on this particular thing. You can even run the same app again as a separate instance. So here you have a same instance of app B, or not the same, but the separate instance of the same app B. And you have libs and bins, like libraries and binaries installed with any OS of your choice. Okay, so this is what virtual machine is. So you can see like it's a separate computer inside your own computer, which is the host over here. So this is your machine over here. Okay, and you have installed multiple operating systems on top of this, okay, which are running like multiple computers on a single machine. So this is about virtual machines. Now, how does it work with Docker? So with Docker, you have your machine. So this is a machine hardware. You have host operating system, and then you have something called as Docker engine. So this Docker engine is responsible for containers. So you will have like this app. Okay, so this is one container which has application A running. It has all the libraries and binaries. Now, one thing to note over here is it does not have the guest OS. Okay, so this is very lightweight. Okay, so by installing guest OS, you make it a bit heavy. Okay, it needs then high resources and all. But over here, we don't have guest OS. So we don't have an operating system running. So this becomes really lightweight. So it just has the necessary things that are needed for your application to run. That is it. Nothing more than that. Okay. So this is container 1. Then you have another container which runs the app B. And again, this is without the OS. Okay. Then you have the same instance of app B running again as a separate container. So there are 3 containers that are running. Okay. And they are lightweight as compared to the virtual machines that we have over here. And virtual machines become a bit heavy because the entire operating system is installed from scratch as if you're doing a new installation. Okay. So this is about Docker and virtual machines and how they differ from each other. Also, I would want to highlight some of the differences. So I have some parameters over here and I'm comparing virtual machines and Docker containers. So the number one difference is in terms of size. So virtual machines are large and resource intensive. Docker containers are lightweight and resource efficient. Now, the startup time of virtual machines is longer, of course, because a full operating system needs to start. But with Docker containers, almost instant. So the startup is instant as no OS boot is required. So it's pretty quick in startup time. In terms of resource utilization, virtual machines use more system resources like CPU, memory, and so on. But Docker container, on the other hand, will utilize really few system resources. In terms of isolation, there is a strong isolation between multiple VMs because they each have their own operating system. But in terms of Docker container, it is isolated, but it shares the host operating system kernel. That is it. And this is completely fine, I would say, provided that's the requirement. Okay. Then you have the difference of portability. So virtual machines are portable, but they require the compatibility in terms of operating system. And Docker containers are highly portable and independent of host OS. Then we have some more differences, like in terms of scalability. So scaling virtual machine requires creating new VMs. Okay. But with Docker container, it is easy to scale. Like you just need to create more containers. And these containers, like I said, are very lightweight. So when it comes to VM, you need to create highly resource intensive VMs to scale. But Docker is really easy because you are scaling something that is already lightweight. In terms of ecosystem, you need VM specific tools and frameworks. But with Docker, you have Docker ecosystem with a lot of tools out there. Okay. Now, how does development workflow work when you work with virtual machines? So the setup is fairly slower because you are setting up an entire operating system. Okay. But with Docker, the setup is pretty much faster and you need to manage the dependencies for the application that you are running. How is it different in terms of deployment? So in terms of deployment efficiency, VMs are larger in size and they have more overhead. Okay. But for Docker container, it's easier to apply. Like it's easy to deploy Docker containers. All right. So these are some of the differences between Docker containers and virtual machines. So overall, I would say Docker containers are much more efficient, portable, fast, and they're isolated when compared to virtual machines. All right. And that is why this technology is growing really fast and it's becoming very popular in the dev community. So that's about Docker and how it works. I hope you all have a complete understanding of how this particular thing works. And I hope you all enjoyed this explanation. Let us start talking about the Docker architecture and let's understand how Docker works under the hood. By understanding architecture, you will be aware of the important terms and how things are managed behind the scenes. So you have your host operating system, which is your machine OS that you have. So for example, you might have installed Windows or Mac or Linux on your system. So that is what your host operating system is. Then you have these components from Docker, which is Docker daemon, Docker API, and then Docker CLI. Together, they form Docker engine. Now, Docker engine interacts with Docker containers and Docker images with the help of daemon, which in turn interact with Docker registry. Now, what does each component mean and what is their role? Okay, so let us start talking from Docker CLI. So this is a command line interface. So CLI stands for command line interface. It's a client that allows users to interact with Docker. So if you are a user and you want to communicate to Docker, you will execute some commands on the command line, okay, and you will interact with CLI, okay, which is the command line interface. Now, Docker CLI will interact with Docker daemon to get those commands executed. Now, what is Docker daemon? So Docker daemon runs on the host operating system and is responsible for building Docker images and managing containers. So it listens to the user's command via the Docker CLI. And it also interacts with the Docker API and it manages all the Docker objects. So that is what Docker daemon is. Now let us talk about what are Docker containers and what are Docker images. So let's talk about image first. So these are templates with instructions for creating something called as containers. Okay. So you can think of Docker images as a blueprint for creating a container. Okay. So that is what Docker image is. Now from one image, you can create multiple containers. So for example, let's say I have a Docker image for app A. Now for application A, I have already defined a Docker image. So I can create multiple containers for using that image for application A. if I want to make any changes to the container, I have to edit the image. So Docker container is a running instance of Docker image. It's a running version of Docker image. That is what a container is. So these two things like Docker images and containers are managed by Docker daemon. Now here we have one more component called Docker Registry. So what is a Docker Registry? So Docker Registry is a service that stores Docker images. Okay, and the images that you store in Docker Registry can be public or private. Okay, so if the image is public, it can be accessed by anyone across the world who is using the Docker Registry. Okay, and if it's private, it's only private to you, and no other person in the world can pull those images. So to get the Docker images from the Docker Registry, you have to pull the image, and you need to run the image in order to get the containers. Now, if you have a Docker image locally, and if you wish to get that image onto the Docker registry so that you can access it from anywhere, you need to push the image to the Docker registry. So you need to pull the image to get it to your system and push the image to send it to the registry. And all of this is managed with the help of Docker commands. So you can think of registry as a central repository for all the Docker images. Okay, so the use case of why Docker registry exists is because the images are meant to share and distribute across different systems. Okay, so this is the internal version as to how the Docker architecture works. And then I have a different version wherein you can see here you have machine, host operating system, and Docker engine, and you have multiple containers that are running different apps with their own binaries and libraries. Okay, and these are all called containers. Okay, so this is how Docker works, and I hope you all have a fair understanding of the Docker architecture and what are different components beneath. So let us talk about and cement the understanding of some of the concepts that exist in Docker. So the number one concept that we'll talk about is images. So Docker images are like templates that exist, or you can think of them like blueprints that define the container and the dependencies that exist within a particular container. Okay. Now image are the base on which containers are built. So you can say containers are built from images. Then you have containers, and these are lightweight and isolated runtime environments that are created using Docker images. And they provide an isolated and reproducible execution environment for applications. Then you have Docker engine, and this is the runtime that manages the containers. And it provides all the necessary tools and infrastructure that you will need to build, run, and manage Docker containers. Next, let's talk about Docker file. So what is a Docker file? So when you're creating a Docker image, you need to have some sorts of instructions as to what needs to exist in that blueprint. Okay, so that is what Docker file is. So it's a file that contains an instructions to build a Docker image. It specifies the base image, like what all application code that needs to include, the dependencies that it needs to include, and all the other configuration settings. So that is what a Docker file is. Then you have Docker Hub, which is a cloud-based registry that hosts a vast collection of Docker images. You can make use of Docker Hub to share, access, and download public images, and also provide a platform for storing and sharing your own images. So these are the different concepts that exist in Docker. Let us start talking about a bit in depth about Docker registry. So Docker registry, like we know, it's a storage and distribution system for Docker images. So you can think of it like a version control system, like a Git you have for source code. Okay, so this system allows you to store Docker images with different versions. So every Docker image that you have, you can tag it with a version name. Okay. For example, if you have a web server Docker image, for example, in your project, so you can say version 1.0, version 2.0, and so on. And these images can be pulled from the registry and deployed onto your server. Okay. So if you have a new version of the image available in the registry, what you and your team members can do is you can access them and deploy onto your server. Now, why do we need a registry? So number one reason will be it acts like a centralized resource for all your Docker images. So if you are working in a team and you have multiple developers, then you will need to access these images. Okay. Even if you have servers located at a different location, then someone would be deploying the images over there. So how would you share them? So the sharing of images is made simple with the help of this centralized resource registry. Then it allows for easy versioning. So versioning your Docker images becomes easy. So you can have multiple versions of the same Docker image in the registry, and each version is tagged with a different version number. And this allows you or your team members to quickly roll back to the previous version if needed. Lastly, Docker registry allows your images to be shared with the public. So if you are working on an open source project and you containerize it, you would want that image to be shared with the public. So you can do that with the help of registry. So for example, popular databases like PostgreSQL, MongoDB are all available on Docker. Okay, so they have their official images on Docker, and anyone who wishes to use the database, and if they have Docker installed on their system, they can happily use the image and create a container out of that image on their local system. And that will give them a running instance of database without installing the database on their system. So you just pull the container and you just run the container. You have a database up and running. That's the power of Docker and Docker registry. Now we have spoken enough about Docker registry, but what are the different Docker registries available and how do I get my image onto them? Okay, so let us take a look at different registries that are available. So here in the browser, I am on hub.docker.com, and this is a default registry that is being used by Docker CLI and most of the Docker tools. Okay, it is a host for a lot of thousands of public images that are supplied by both individual developers and software vendors or big corporations, making it one of the most essential tools for Docker developers. Okay, so here you can see you have Nginx, MongoDB, Alpine, Node.js, Redis, you have Python official. Okay, so there are a lot of Docker images, as you can see. If you scroll down, it talks about the technology. So it says ship anywhere, collaborate, and automate. Okay, and you can scroll up over here. You can create your account as well, and you can search for different images on Docker Hub. Okay, and if you can even click on these images at the bottom, so you can see the image for MongoDB. So you can pull this image, and this is an official Docker image. You can see it's tagged as official one. It has 1 billion plus pulls, I would say, and you can see over here there are different tags or versions available. So these are the recent tags or versions. Okay, and you can go to the tags page and you can see different tags and versions along with the command. So you have the command as well to get as to how you can get this particular version. Okay, so you can even search for any of your image you want to. So you can say Python, and you will have okay, so there was a spelling mistake here, Python. So you will have a lot of images in and around Python. You have the Python official Docker image as well. Okay, which is insane. So this is the hub. Okay, this is something that you should be aware of. Apart from Docker Hub, you have something from Amazon. Okay, so this is Amazon ECR, or it is called as Amazon Elastic Container Registry. Okay, so if you are using Amazon Web Services for your infrastructure Amazon ECR also provides the Docker registry as a part of their service. So if you don't want to go outside the Amazon ecosystem, you can use this right on AWS, okay? And it integrates really well with other AWS services, and it offers a lot of features also, okay? So you can see the pricing over here. So it has 500 MB of private repository storage per month. So they keep changing this. So you might see something else when you watch this video, okay? And you can scroll down and read a bit about this tool. Then if you're using Google, okay, like Google Cloud, you can make use of Google Container Registry, okay, which is also known as Artifact Registry, okay, and it allows you to register and store your Docker images. It integrates really well with Google Cloud Services, okay, it's a part of Google Cloud infrastructure. So you can read a bit more about this particular tool. Then you have from Microsoft, okay, so this is Microsoft Azure Container Registry, okay. And if you're using Azure services, you can use this one if you wish to, and if you wish to stay in the Microsoft's ecosystem, okay. So this is also a similar registry that is offered by Microsoft, okay, and you can take a look at how it works. And then you have Quay.io, okay, which is provided by Red Hat, and this is another option, okay. So it was one of the first Docker registry that existed, okay, and it still has a lot of features that you can explore, okay. So this is another option in the market, but Docker Hub is most popularly used right now, okay, but depending on your requirements, you can choose the one that match for you. So that's about different Docker registries that exist in market. Hello everybody, welcome to this class. So let us start talking about how Docker works with Spring Boot. So initially, we'll discuss what all Docker needs to Dockerize an application, and then eventually we'll take this conversation as to how this works with Spring Boot. So to Dockerize any existing application, you need a Docker file. And Docker file is a file that will look something like this. It's a text file that contains a list of commands that Docker daemon uses to build a new image. So each Docker file is a script that has various commands which can be termed as instructions and arguments listed to automatically perform the actions on the image in order to build an image, okay? So here you can see this is a example file, and now let's debug, or let's go through this entire file and understand what it means. So the first line tells Docker to use official OpenJDK 11 image from Docker Hub as the base image for this image that we are creating, okay? And this base image includes all the file settings that are needed to run a Java application. Then the next line creates a mount point with the specified path, and it marks it as holding externally mounted volumes. Okay, so this is like a volume that we are creating with the name temp. Okay, then we add the jar file from our target directory to the Docker image. So we have our application ready, and we are assuming that it's ready in the form of a jar file. And we are moving this file into the Docker image, and we are naming it as myapp.jar. Okay. Then we are exposing 8080 port to the host machine, which will allow us to access this application right from our system. So since the application will be running inside a container, we need a way to access our application, and that is what this line will do. And then we have this command, which is entry point, which tells Docker what command to run when the container starts. So when the container starts, we are simply running our jar file. So this is a Docker file. It's an example file, and I'm just giving you an example as to how the file is created. Okay. Now let's understand how Docker works with Spring Boot. So with Spring Boot, you don't need to define a Docker file. Okay. And let me switch over to IntelliJ to explain what I mean. Okay. So Here in pom.xml of our application, we have something called as Maven plugin. Okay, so you can see Spring Boot Maven plugin. So we have configured this plugin in our Spring Boot application. Okay, so you can either make use of this Spring Boot Maven plugin that already exists in your Spring Boot application, or you can go with the other approach that I just showed you using Dockerfile. Okay, so you can either create a Docker file in your project here. Okay, so here in the root directory, you will have to create a Docker file. So you can either create an image that way, or you can make use of Spring Boot Maven plugin. So these are the two approaches as to how Docker can work with Spring Boot. Now, if you're making use of Maven plugin, like everything is automated. So you don't have Docker file, and Docker automatically knows and understands with the help of this plugin as to what all needs to be included into the image for this application to be Dockerized. And that is based on the dependency. So what all is needed is figured out based on the dependency that you have defined here. Okay, and all the properties as well. So on the basis of that, an image is automatically created and you don't need to set a Docker file. So that's the benefit of using Spring Boot with Docker. Okay, there are less hassles. So how does this entire process work now? So let us talk about this a bit. Okay, so Spring Boot internally leverages cloud native build packs to create Docker images without the need of a Docker file. Okay, now what are cloud native build packs? So this is a specification created by Cloud Native Computing Foundation, which is CNCF. Okay, so this is a foundation that has created this specification, and it is designed to create container images from the source code without the need of a Docker file. So whenever you are using cloud native build packs to create images, the build packs will analyze your project entirely, and they will choose the right tools and libraries for compiling it. So what I mean by right tools and libraries is, for example, you might need a specific version of JDK or for running Java applications. So that is something that it will figure out. Okay, and it will package everything that your application needs into a Docker image. Okay, and this includes determining the dependencies which would all be combined into this image. So you don't have to worry about this. So if you are using Maven plugin, you are actually using cloud native build pack under the hood, because Maven plugin or Spring Boot uses this internally. Then you have Spring Boot Maven plugin. We spoke about this. So this is a plugin that is configured and which triggers the cloud native build packs. Okay, and it packages your entire application into a jar file first, and then it hands it off to the build packs, which will then take it ahead from there. Also, there is a process called layering. So build packs use layering to create separate different parts of the Docker image. Okay, and they call it layers. For example, one layer may have the JVM, and another layer can contain the application dependencies, and third layer may have your application itself. So this allows Docker to cache layers separately. And if you're building Docker images again and again after few changes, so let's say you make one change and then you create a Docker image, and then you do another change and you create one more Docker image. So if you're creating subsequent builds of Docker image, then this layering technique is cache. So all the layers are cache, and it speeds up the subsequent builds that you might create later on. Okay, and this is because you might only change certain parts of the application and not everything. Okay, so it does not need to repackage and redo everything itself again. Okay, so this layering technique helps speed up the process. Then we have something called as Paketo build packs. So the Spring Boot team works closely with Paketo build packs project. So it's a project to ensure excellent support for Spring Boot application. Now, what are Paketo build packs? So these are implementations of cloud native build pack specification, and they provide JVM and other tools required to compile a Spring Boot application into Docker image. Okay. Now, after all of this, we have the result, and the result of the process is in the end is a Docker image. And this Docker image can run in any Docker compatible runtime. Okay. It has everything that your application needs within the Docker image,
And this includes JVM, your application dependencies, and your application itself. Now, what is the benefit of using this approach? So the number one advantage is there is no Docker file needed. Okay. So the build packs handle everything that would be normally done in a Docker file, and they do it automatically based on the analysis of your project. Then you get sensible defaults. So the build packs provide sensible defaults for a wide range of project types, including Spring Boot applications. Then you have consistent environments. So this ensures that your application will run in the same environment where it was built. Security. So build packs can keep the base images and libraries they use up to date, which helps in maintaining the security. Layering and efficiency. So the separate layers about which we discussed right now, okay, these layers can be cached and reused, okay, provided that you are changing. So when creating a new image, if you're changing only a particular part of the application, the rest of the layers will be unchanged and they will be reused. So which will increase the speed dramatically and it will give you images faster. Also with Spring Boot, the process of building Docker image looks really easy, and it's really simple, so it can be compared to running a single command, okay, or running a simple application without needing to understand the specifics of how Docker images are built. So with Docker file, you need to put in the step-by-step information of what all your image will need. But all of this you don't need to do when you are using the Maven plugin and Spring Boot. So that's the benefit that you have. So that's about this class, and that's about how Spring Boot and Docker work together.
So now is the time that we Dockerize our Spring Boot application and we convert it into a container. So it's time to containerize. So for that, we will have to make use of a terminal. Now you can make use of any terminal available on your local machine. And if you're making use of a local terminal, be sure to navigate into your project's root directory. And if you don't want to make use of a local terminal, you can use terminal within IntelliJ. So you can click on this terminal icon here on the bottom left, and you should have an inbuilt terminal for your access. And if you do pwd, which gives you the path of the current working directory from the terminal, you can see that you are in the root of the project directory. So you can basically use inbuilt terminal of IntelliJ, or you can use the local terminal on your operating system, whether it's Mac, Linux, or Windows. Okay. So I'm making use of this terminal over here. Now we'll be making use of a command over here to basically create an image of our Spring Boot application. And here is the command. Okay. So I have already written this command over here on the notepad. I'll just zoom in a bit. Okay, so we'll take a look at the first one over here. Okay, so this particular command is what I'm going to run over here. So here you can see this first part of the command. This is making use of Maven wrapper using this syntax over here. So we are saying make use of Maven wrapper. Okay, Maven wrapper is invoke, and this is used to run Maven based commands. Okay, and if you're making use of this, we are making sure that the dependencies are downloaded and plugins are executed correctly. Next, what we are doing is we are executing this part over here of the command. Now, this is a Maven goal that tells Spring Boot to build a Docker compatible image automatically. Okay, and you don't need a Docker file because of this, because Spring Boot automatically creates the container image with all the dependencies inside. Okay. Now, one thing about I forgot about this thing over here, the previous part of the command over here, which is mvnw. And it was preceded by dot and /. So if you have Maven installed globally, you can just make use of mvn over here. So something like this, mvn. Okay. If you have Maven installed globally onto your system, you can install Maven globally. But I am making use of Maven wrapper. Okay, over here. So I'm making use of this. And then we are specifying this goal over here, wherein we are telling Spring Boot to build a Docker compatible image automatically. Okay, and then we have this part of the command over here. So this part sets the name of the Docker image, and here what we are going to do is we are going to replace this part with the actual Docker Hub username and our image name. Okay, which brings us to the second part over here. Okay, this is the second part of our command over here, which we have formed. Now, what I would request over here is, here I've mentioned my Docker username, like Docker Hub username. So I already have a Docker Hub account and I've already set it up and I know my username. But if you don't know your username, then what I would so just head over to the browser and go to Docker Hub over here. Okay, go to Docker Hub. And here on Docker Hub, so you have this sign up button. Okay, so I'm already signed up, but you should see this sign up button. So let me open this in incognito. Okay, so I'm going to say Docker Hub over here. Okay, and you will have this sign up over here. Okay, so this is the sign up page of Docker Hub. So if you go to just Docker Hub over here, okay, Docker Hub, something like this. I'll show you how you can go to sign up page right from home page as well. So here you can see this sign up on top right. So you can click on sign up, or if you already have an account, click on sign in. So it's pretty simple. It's a generic sign up flow like for any other website. You enter your email, password, select personal, because if you're using it for personal use, select personal. For work purpose, select your select the work tab and enter your details over here and just sign up. You can either continue with Google and GitHub as well if like filling form is a bit lazy for you, right? Is making you a bit lazy. So you can do that as well. I often make use of, social login options because they save time. So you can choose your options and then you will be prompted for a pricing plan. Now they keep changing the flow of the sign up. So I'm not sure if they prompt you or if they don't prompt you. So depending on when you're watching the video, they might prompt you. So select a free plan or something like that and just proceed ahead. Okay, and you don't have to pay anything, and then you will get a Docker Hub username like I have over here. Okay, so here if you see, here you can see this is my Docker Hub username. Okay, decode 007. I have quite a few images that I have created. Okay, but I would request you to like get your username and come over here and add the username over here, and then over here you can basically add the image name. So I'm going to say ecom application or whatever you want to add. If it's a job application, you can mention the job app or something like that. Okay, so depending on what you're building, mention this, and then you just copy this command over here and then come over to the terminal, and then you have to simply paste this command and just say enter. Now, one thing before I press enter, I have not started Docker yet. So of course I'm going to get an error. Okay, because Docker has to be up and running. So I'll make sure that Docker desktop is up and running onto my local machine. Okay, Docker desktop takes some time to boot up. Okay, so you can see over here, I started Docker desktop and it is starting the Docker engine. So it will take some time depending on your system speed, but I have Docker desktop up and running now. And now I can run this command. Okay, so this is giving me an error over here. Okay, so this is not a recognized internal or external command over here. So since I'm on Windows, I'm getting this error that dot is not recognized or as an external or internal command. Okay, so if you're on Mac or Linux, this should work. But for Windows users, I will suggest a tweak right now. So you can basically get rid of this like dot and / and just run it like this. Okay. And the moment you press enter, I'll just zoom out a bit so that you can see like there are lots of logs over here. You can see all the logs. The Spring Boot application is also starting up. You can see. Okay, we'll wait for a while. All right, and you should see like it's building the image. So it started the application first, then it built the image, and now you can see over here it's pulling the builder image over here, which is Paketo build pack over here. You can see over here. Okay, so it's pulling in all this stuff and it will do the job of getting it onto your local machine. You can see the progress over here as well. Okay, and how it progresses will depend basically on your system speed, like I've always said, and also the internet speed that you have. So we'll wait for a while until this processing completes. So now you can see the image is created, and you can see over here successfully built image. This is the image name. I can see build success, and this is the total time it took for the image to finish. Now scroll up, and I would recommend that if you're doing this for the first time, I would recommend you watch and check the logs and learn what happened. Okay, so here when we ran the command for the first time over here, you can see over here, this was a command. It started booting up the Spring Boot application. Spring Boot application started. You can see all the logs over here. Everything started. You can see all the JPA related queries as well. Okay. And whichever application you are Dockerizing, this is what the process will be. The application will start, it will boot up. You can come over here, and then here it started pulling in the Paketo build pack. Okay. So, oops, I think I scrolled down over here. Okay. It started pulling in the Paketo build packs over here, and you can see it pulled it by 100%, and then it made use of it to create something called as layers over here. So there was some processing happened, and then it started creating layers over here. So you can see all the layers were created, and then together they all formed the image over here. So you can see image label, all of this processing happened, and then they added the layer over here and added the label, and then the Docker image was saved over here, and then the build was successful. So this is what happened. And now what we need to do is we have the image locally available. So the image is created. And if you go to Docker desktop over here, you're going to see the image. So go to image tab over here, and you should see, so you can see over here, I do have quite a few images, by the way. Okay, so I'll just expand this. So here, let me unselect everything. So you can see this, and this was just created over here. So these are Paketo build packs that were added. And then ecom application is the image that was created. I have these other images also, which I'm working on right now. Okay. But these three things were just created is what I want to highlight over here. Okay. So this is done. And so now once the image is created and you see them over here in Docker desktop, what I would recommend is we should push this image to Docker Hub over here. Okay. This is where we need to push. So the image should come up over here as the image, okay, onto the Docker registry. So I'll come over here. Now, in order to push the image over there, what you need to do is you need to authenticate over here. So you have to say Docker login over here. Okay. I might already have a authenticated session, but let me check over here if I do. Okay. So I don't have an authenticated session, and it is asking me for authentication. So, it's asking me for making use of, so you can see over here, to sign in with credential on command line, use Docker login -u username. Okay. So right now I'm making use of web-based logging, but to sign in with credentials on command line, it is saying you have to make use of this command. Okay. And the one-time confirmation is over here. Now what I need to do is I need to go over here on this particular URL and enter this device confirmation code. Okay. So what I will do is I'll authenticate myself over here right now. So I finished the authentication in the browser. After I clicked on the URL, I was asked for credentials and I entered the code over here. Now if I close this, you'll see that the login has succeeded over here, and like it was waiting for authentication in the browser, and it says login succeeded. So this is important because your command line should be authenticated with the Docker Hub or Docker over here, so that you can push images right from your command line. If you don't want to make use of browser-based authentication method, I have already spoken about the command line based authentication over here. So you can say Docker login -u and enter your username, and then on command line itself, you will be asked for credentials, which you can enter and say after entering, you can get it authorized. Okay, these are two alternatives. Okay, so right now I'm done with this. Now what I'm going to do is I'm going to say Docker push over here, and I am going to enter the image name. Now here I would need the image name, so I'll come over here and I'll just get this image name over here. Okay, make sure that the image name is correct, and I'll just paste it, and then I'll say enter. Now you can see it's pushing this image to the remote Docker Hub over here. Okay, so we'll wait for a while until this process is complete. Okay, it will take some time depending on, again, your system speed and the internet connectivity speed as well. So we'll hang in there. Now after the processing is done, you can see the image is pushed over here. Okay, and you can see over here the success. Now if you come to the browser and in your Docker Hub account, just do a refresh, and ideally, if you're authenticated into the right account, you should see your application over here. So you can see over here, I can see this application. Okay, this is the application we just pushed 1 minute ago. If you click on this, okay, you will be taken to the detail of this particular application. You can see, and you can so this is now hosted on Docker Hub. So congratulations, you have your first Docker image being available on Docker Hub. And here you can add a description, select a category, you can tag it, a lot of stuff you can do. Okay, so I hope you have been able to follow along, and I hope this has been super useful to you. Let us start discussing about different Docker commands that exist and are commonly used. Now, I'll mention one thing before talking about Docker commands is this might seem a little bit overwhelming, but don't worry and don't get afraid, because these Docker commands you will eventually learn when you start using Docker regularly. So it might seem like a long list, but actually if you are using Docker in your day-to-day life or when building applications, you will get quite familiar with a lot of commands. So the intent of this lecture is not to tell you to memorize all the command, but just understand like these are the different commands that are available and this is how they are used. And these all things you can also do with the help of command line tools. So that's the goal. So let's start talking about. So this is the first command that I want to talk about is docker pull. So this command is used to pull the image from the Docker repository. Like let's say we have pushed an image to Docker Hub, and you can use this command to get the image from Docker Hub onto your system. Okay. This command is used to push the Docker image to Docker Hub. So you can specify docker push, then your username /image. This command is used to run Docker container from the image. Okay. So you say docker run and then you have IT. So I means interactive. Okay. IT stands for interactive. D stands for detach mode. Okay. Detach mode means you can, so basically if you run in non-detach mode, you can't do anything else on the terminal. Okay. And if you close the terminal, the container stops. So if you run in detach mode, it runs as a separate process. And -P stands for port mapping. So you might want to map the port of the container to that of host machine. So you can do that using port mapping. So here you can specify host port and the container port. Okay. And here you are making use of name, and this is the name of the process and the image. Then you have docker stop command, which is used to stop a running container, and you can specify the container ID or the container name. Then you have a command to start a container. So you have container ID and or container name that you can specify. Then you have docker rm command, which is used to remove a stopped container. So if you want to delete a container that has been stopped, you can make use of docker rm. Then you have docker rmi image ID or image name. So this command is used to remove an image from a local storage. So images that you create will occupy some storage. So you can get rid of them when you run this command. Then you have docker ps, which is used to get the running Docker containers. And this will give you all the containers that are running. Then you have docker ps-a, which is used to show all the containers which are stopped as well as running. Then you have docker images, which is used to list all the images on the host. Then you have this command, which enables you to access a running container. So if you want to log in to a running container from the terminal, you can use this command wherein you say docker exec it and you specify the container name or ID followed by bash, and you will log in from the terminal into that particular container. Then you have docker build -t username image. So this is used to build an image from the Docker file. So if you have a Docker file defined in the registry, in the current directory, so this dot over here specifies the current directory. So it picks up the Docker file and creates the image, and the image is created with this name. Then you have docker logs. So this particular command is used to get the logs of a particular container that is running or a container that exists. So there might be scenarios wherein you might face some issues running the application within the container and you might want to check the logs.
So this command is really helpful there. Then you have Docker inspect, which gives you the detailed information of a particular container. So these are all the Docker commands that I wanted to highlight. Okay. You can even run these few commands in your terminal and check yourself. So here I am in my terminal within IntelliJ. I can say Docker images. And this is going to give you the images that exist on your system. Okay. So here you can see we have created the image for job app. So you have that image. Then you have Paketo build pack builder and run image as well. Okay, which is needed for Spring Boot applications. Then you can say Docker PS, which gives you the list of all running containers. So we don't have any running container. Okay, so we didn't get any response over here, but it will give you container ID, image, command, and all the other information. So this way you can try out some of the commands and play a bit. So now is the time that we run our application with the help of Docker, and we'll run it inside a Docker container. So before proceeding further, just make sure you have Docker desktop up and running, something like this. Okay, so it's running for me. And what I'm going to do is I'm going to minimize this. It runs in the background. Just don't shut it out, because it's not going to, it will throw you an error. Any sort of Docker commands you run without Docker desktop being in the background, it's going to throw an error. Okay, so be sure like whenever you are working with Docker, you have Docker desktop up and running. All right, now what are we going to do is we are going to take a look at some commands, and then we will see how we can run our application. So first is I'll say Docker images. So this command gives you the list of images that you have on your local machine. So of course I have quite a few images on my local machine, but this is the one that got created today. Okay, which we while creating the eCommerce application, this is also the one. So Paketo build packs and these two are the ones that were created when we created the image for this ecom application. Okay, then there is another command which is Docker PS, which gives you the list of running containers. We don't have any sort of running containers, but you will normally get the container ID, image, command, created, time and date, status, ports, and names. Okay. So what I'm going to do now is I need to run the Docker container or Docker image over here as a container. So I'm going to say Docker run. I'm going to say -p 8080 8080. We'll understand what this means. And then I'm going to paste my image name over here. Okay. So be sure to have the right image name like this. And we are adding the image name because we have image locally available. If you don't have the image available locally, you have to pull the image first. So you have to say Docker pull and you mention the image name. So Docker will pull this image onto your local machine, and then it will be available in the list of images like this if you run this Docker images command, and then you can run this particular command over here to run a particular image. So I'll just say enter over here, and then what is going to happen is Docker is going to run this particular image for you onto your local machine. Okay, so all right, so you are seeing over here error, port is not available. So 8080 port is not available. Why? Because I have my application already running on 8080. So just be sure to stop your application that is running locally. Okay, the port needs to be available. And now let me run this command. So I'll just press up arrow, which will bring the previously run command, and I'll just say enter. And now you can see the application is running, and you're seeing the entire stack trace along with the entire, you can see over here, the application is up and running over here. Okay. Now, if you go to Docker over here, Docker desktop, and if you can see the images here in image tag, right? Now, if you select containers over here, you will see the containers also running over here. So you can see this ecom application up and running. You can see this application, right? So this is the application that is running. Okay, you can see this one, the last entry. So this is up and running right now, right? And if you click on this, you will be taken to logs. Okay, so you can see logs over here as well as over here. Okay, and you have different, you have different tabs over here to see stats and all of this particular container. Okay, but this container is running successfully. Now what I'm going to do is I'm going to head over to Postman, and now from Postman you can of course create a user. The moment you create a user, you will see the user being created, and you can see the queries and everything being run over here in the
command line, okay, because I have some logging enabled and I'm printing the SQL. So I have a setting wherein I am showing the SQL onto the logs, okay. So whatever is happening over here, I can create the products as well. You can see the product is created over here. You can see insert into products. This is the query that was executed, right? So it's working absolutely all right, and you can get the products as well. Okay, it's totally, so you can see everything over here. So everything is working fine as expected. You can see over here, all right? And now to shut this container, you can see over here, this command on this particular terminal, I can't do anything. So I have to just say Control C on Windows or Command C on Mac. The moment I say this, it shuts the container over here, right? And there is a problem, right? So it's not a problem actually. Your one terminal gets blocked. So another way is to run the container in a detached mode. Okay, so what you can do over here is you can come over here, and for the same command, just press up arrow and the same command will appear like this. Okay, or let me like just do a control clear screen. Okay, so let me just clear this out and let me say clear. Just press up arrow. So you will have this command appear. And now what you can do is you can come over here, and here just ahead of -p, you can say -d. So this will run this container in the detached mode. So which means like this terminal won't be blocked. So you can run it this way and you get this container ID as the response. And now how do you see if this container is up and running? You can run docker ps. Okay, so you can say docker ps and you will see this container up and running. You can see 13 seconds ago. Now how do you see the logs of this container? So you can copy this like container ID and you can come over here. You can say docker logs and you can paste the container ID. You can see the logs, right? And whether you run it this way or that way, all right, it's all going to work absolutely okay. You can see like I restarted the container, so there are no products. I can create the product and I can say get all product. It is going to work absolutely fine. So all the endpoints are working fine. Okay. Also, let's take a look at the command over here, which we just executed. Okay. So what did this command do? Okay. So what are we doing over here? We are saying docker run, wherein this is a command to run a new container. Okay. When we say -d, we are running it in detached mode. Okay. When we say -p and when we mention the port number this way, we are mapping the port of 8080 in the container to 8080 onto your local machine. So if you query the port 8080 onto your local machine, it will be routed to port 8080 inside the container, right? Because our application is running inside the container, right? So I want to access the APIs using 8080 on my local machine. So I'm mentioning this command over here, okay, 8080. So 8080 is being mapped to 8080 inside the container. That is how it mentions. And here you are mentioning the image name that is available on the local machine. So with this, you are able to run the container successfully, right? So that is how it works, and I hope it's pretty clear as to how did this entire process work. Okay, so it's pretty straightforward as to how things work with Docker. If you follow the guide step by step, and if you're clear with what commands you are running and why you are running and how things work, it's totally easy for you. Okay. Now, in order to save some space, like the Docker images might take good amount of space onto your local machine. So if you want to save some space, you should terminate the container from here. Okay. Or you can basically stop the container over here. So you can say docker ps, and I can like say docker stop, and I can pass in the container ID over here. So just pass in the container ID, the container will stop, and then if you run docker ps, the container will be stopped. And now if you run the APIs, you will get an error like the connection is refused because the app is not running, right? So the container is stopped. You can stop it this way, or you can stop it from Docker desktop. It's totally your choice. Okay. And if you want to clear the image or delete the image, you can delete it from here. You can say delete, and there will be space that it will take in GBs onto your local machine. So remember that. Okay. So that's about containerizing Spring Boot applications and how you can run it on your local machine. I hope this was useful, and I hope you were able to follow along.
Welcome to this class. So let us start talking about PostgreSQL and why we should use it. So what is PostgreSQL? So PostgreSQL is an object relational database management system, or you can say ORDBMS. Okay, and it is often referred to as Postgres. So this is an database management system that places a strong emphasis on SQL compliance and extensibility. So it's free and open source, which means that it is accessible for anyone who wants to use their database for their needs. So we'll head over to the browser, and here I'll search for PostgreSQL. Okay, so I'll say PostgreSQL, and you'll see this official website over here. Okay, so it's postgresql.org. So I'll go to this website, and you can read more about this tool over here. Okay, so it's a powerful object relational database system. Okay, and it has been in development for 35 years. Okay, and it's known for its strong reputation for reliability, robustness, and performance. Okay, so it's a quite popular database management system out there. Okay, you can check out the website, and back to the slides. So why is PostgreSQL popular? So the number one reason is SQL compliance. So PostgreSQL follows the SQL standards more closely. Okay, and it makes the life easier, using which you can create more and more applications. It is also known for extensibility. So PostgreSQL allows you to define your own data types, operators, indexes, and so on. Okay. Performance. PostgreSQL has a reputation for being robust and good with performance, especially when you write complex queries. Also, PostgreSQL is known for strong community support. Okay, so since it's an open source platform, this particular database management system has a large community. Okay, and there are regular updates, improvements, and development that happens. Data integrity. So PostgreSQL has strong emphasis on data integrity. Okay, and if you are building an application that needs data integrity, so PostgreSQL might be the best choice. Let us talk about why are we choosing this particular database. So we will be moving our application to PostgreSQL. So why would we do this? Why choose PostgreSQL over H2 database? So H2 is a very capable database and has an advantage of being embedded in Java, which is really convenient. Okay. However, when it comes to building large application, like large production grade application, PostgreSQL has lots of advantages. So the number one advantage would be scalability. So PostgreSQL is really scalable, and it enables you to work with high volume of data and supports lots of concurrent users. Feature set. So PostgreSQL has richer feature set as compared to that of H2. Okay, and it supports a broad range of SQL standards, data types, and functions. Ecosystem and tools. So PostgreSQL is really popular out there, and it has a very broad ecosystem. Okay, it has a wide range of GUI tools like graphical user interface. You have libraries, third-party support, community support, and so on. So PostgreSQL is really ahead in the game here. Durability. So I would say PostgreSQL is much more durable, and it is often the best choice for production grade environments due to its durability and robustness. While H2 is the best choice for development and testing for quick start. So to summarize, while H2 has its own use cases, okay, especially when you are building lightweight applications and doing some rapid prototyping, but PostgreSQL comes out to be more powerful, flexible, and scalable solution, making it a superior choice for developers building production grade applications. So that's about PostgreSQL. It's time to understand the dependencies that we need for our application to function properly with PostgreSQL. So what I'm going to do is here, I'm going to come over to our favorite website, which is start.spring.io over here. And this is a website that we'll make use of to get the dependencies. Now here, I'm going to make sure that I select Maven. Be sure to select Gradle if you are making use of Gradle by chance.
and rest of the settings we don't need to touch in, but I'll go over here to add dependencies, and I'm going to touch on this this particular dependency. So I'm going to search for PostgreSQL over here. So you will see this PostgreSQL driver appear over here. So it's a JDBC or R2DBC driver that allows Java program to connect with PostgreSQL database. So our application is also a Java program, and we need to make use of this dependency so that we are able to interact with PostgreSQL, right? So I'll select this, and you can see this database being added. Now I'll say explore over here. The moment you say explore over here, you are going to see this pom.xml over here. And our goal is to get this dependency. So this is the dependency that we need to add in our application. So I'll copy this dependency. Okay, I'll just zoom in so that you can see clearly. I'll just copy this dependency, and I'll come over here to our application pom.xml. Be sure you are in the pom.xml, and here you can paste this dependency. Right now, this could be any Spring Boot application that you have. You paste the dependency, and here you'll see the load Maven changes icon because you have made changes to the Spring Boot pom.xml file. Okay, if you don't see this reload Maven changes icon, so once you see, you can click on this. But if you don't see it, you can go over here and you can manually reload the Maven projects. Okay, but I have reloaded the Maven changes, and you can see over here the dependencies are being resolved. And you can go and manually check the dependencies here under external libraries, and you should be able to see the dependency with the PostgreSQL over here. Okay, so if you scroll down over here somewhere, you'll see PostgreSQL. So you can see over here, this is the PostgreSQL dependency that has been added under external libraries. All right, so our project now has the dependencies added, and we should be ready for the next step. Also, I would recommend, like, if you have any other database configured, so just comment that dependency over here, okay? Because this is good to avoid any sort of conflicts, okay? And just do a Maven reload again. So this is something that I've done because I had H2 database dependency added. Now, as a next step, what we need to do is we need to configure our application to work with PostgreSQL. Yes, we have added a dependency, but it's also important that we tell our application as to how it can connect to the database and how it can make use of it. Okay, just by adding this, Spring Boot knows that, hey, this application makes use of PostgreSQL. But what it does with it and how it connects to it, all those things you need to define. And for that, I'm going to come over here and under resources over here. So under src main resources, I have this particular configuration file, which is application.yaml. Okay, so if you're making use of .properties file, that's absolutely fine, but I'm making use of YAML file. So just come over here. Okay, somewhere over here at the bottom is where I'll come in. And what I would do is I would add some settings related to PostgreSQL. Okay, so I'm going to say Spring, and I'm going to say data source over here, and I'm going to say URL over here. Okay, now one thing over here, the property with Spring over here. So Spring is already added, and that is why I'm getting an error saying this key is duplicated. So I can just cut the database and URL, and I can get rid of this over here. Okay, and let us scroll over here, and here we have the setting related to the H2 database already added over here. Okay, so what I'm going to do is I'm going to comment this off. Okay, we are not making use of H2 database now, but I'll come over here. Okay, and I'll add the configuration for the PostgreSQL. Okay, so the setting is Spring data source URL over here. Okay, Spring is already added over here, so I'm not repeating it. So I'm saying data source URL, and you need to specify the URL over here. Now there is a format in which the URL is supposed to specify. Okay, I'll talk about the format a bit, but let me tell you why are we specifying URL over here? Because we have added a dependency for PostgreSQL, right? And our application or the Spring Boot knows that this application makes use of PostgreSQL. So it will immediately look for the configuration as to how it can connect to the database. And for the configuration, we need to tell our application that, hey, this is where you will find the database. And that is why you are specifying the URL, so that you can tell the application that, hey, this is where the database resides. So I'm going to first say JDBC over here. This is a protocol using which we are going to connect to the database. Then I'm going to specify I'm going to specify the database type. Okay, so it's supposed to be PostgreSQL over here. Okay, and then I'm supposed to add a colon again, and then I'll add 2 forward slashes, and then I'm going to actually specify the URL. So I'm going to say localhost over here, colon. Now PostgreSQL runs by default on this port 5432. Okay, so I'm going to add that, and I'm going to say slash, and I can say ecomdb over here, something like that, or whatever your database name is. Okay, so I'm going to add that. Now, what this URL says, let me reiterate. It first talks about the protocol using which it can connect to the database. Then we have the database name or the database type, you can say. This is PostgreSQL. If you have MySQL or any other database, you will change this accordingly. Okay. Then we have the database URL, okay, followed by the forward slash and colon. And then we have the database that we create in PostgreSQL. Okay, so these things we have specified over here. Now coming to the next property, I'm going to say data source. Okay, data source is already added. So I'm going to say over here username, something like this. And I'm going to say over here, so whatever username is there, you can specify it over here. Now the username I'm going to specify is embarkx, and the password I'm going to specify is embarkx, something like this. So this is a username and password. And then I'm going to specify the property like JPA over here, JPA colon, and I'm going to say database. Now, what is the database over here? So the database we are going to make use of is PostgreSQL, something like this. Okay. And then over here, I am going to say show SQL to true. So here we have already made use of this show SQL true. So I'll just copy this over here, something like this. And then I'm going to say Hibernate DDL auto. So I'll add this also over here. Okay, so here I'll say Hibernate and DDL auto. So I'll keep this to update, for example. Okay, so it is going to update whenever there are any sort of changes into the entities, it is going to update it over there into, or it is going to reflect it in the schema of the database, is what I mean to say. I hope it's clear as to what sort of settings we are adding, why we are adding. It is really important. And if you're making use of application.properties file, don't stress. So how you can convert this into application.properties is you can say spring.datasource.url. Then the next property is spring.datasource.username. Then spring.datasource.password. So something like that, you can have the properties created. For this part over here, you can say spring.jpa.database. Okay, then spring.jpa.sql or show SQL. And then you have spring.jpa.hibernate.ddl auto is equal to update. So instead of colon, this will become equal to for application.properties. All right. I hope this is making sense, and I hope you are able to follow. And one more property we need to add over here is JPA. So within JPA, so it's spring.jpa. I'll say database over here, something like this, database. Sorry, not database. It has to be database platform. Database platform over here, and I'm going to say org.hibernate. So here we are specifying the dialect dot PostgreSQL dialect. Okay. Now what does this dialect do over here? So what happens is whenever Spring Boot application interacts with the database, it creates queries, right? And different database vendors will have different ways of query writing over there. Like for example, there are like majority of the stuff is similar between different database vendors. Like for example, if you compare MySQL and PostgreSQL, most of the queries are similar, but some queries will have little bit of differences because the database vendors are different. So specifying the dialect enables JPA and Spring Boot application to make sure that the queries are generated properly for the right database vendors. So that is what it means over here. Okay, so what we have done is we have specified the dialect over here. This is also important. So there are quite a few properties that we added over here. First is data source, wherein we specified these connection details. Then we had spring.jpa dot these properties, which helped us mention about the database, whether we want to show or hide the SQL. So what this will do is this will show the generated SQL onto the console when you run the application. And then you have DDL auto, which does the schema management for you. So if you make any sort of changes into the entities, and if there is an update specified, then what will happen is the schema, the underlying schema in the database will also get updated. Okay, you can specify different values like create drop over here. If you specify create drop, then what will happen is for any sort of change over there, the tables will be cleared, the database will be cleared, the data will be cleared, and then the schema will be recreated. So if you don't want to lose data, you can make use of update. And then we have specified the dialect. So I hope you have been able to follow along, and I hope this has been simple for you. Now it's time that we begin talking about this wonderful concept of Docker networks and understand what it is. And for understanding it, we are going to need to create a few containers, okay? A few meaning a couple of them, and we will try to establish network within them, right? And we'll see if there is no Docker network between these two containers, how things work, and what is the advantage that Docker network provide us. So that will help us understand what is this concept and why it's important in today's world. So for the sake of the understanding, I'm going to make use of the popular database system, okay, which is the world's most advanced open source relational database. Like you can see on my screen, it is PostgreSQL. Yes. So it's a pretty common. If you're a developer, you must have heard of PostgreSQL. It's free and wonderful to use. So we are going to make use of this. We are going to make use of Docker. Of course, when we are talking about Docker networks, we will be making use of Docker as well. So let us head over to our terminal. We'll be making use of some commands there. So here I am on my terminal and I have navigated to a particular directory where I want to execute the commands. And I have also made sure that I have Docker desktop up and running. Now you can see over here, I have Docker desktop, which is up and running. So if you don't have this onto your system, be sure to install Docker desktop onto your system and make sure you have it up and running, because you won't be able to run any sort of Docker commands without this. Now here I'm going to start typing in the command. Now the command that I'm going to type in is going to run the Postgres database container for myself, okay? And I'm going to pass in environment variable to it. So let me show it to you. Okay, so I'm going to say Docker run. Okay, I got this as a suggestion here. And so this is a command. Now what does this command do? So Docker run. So Docker run is the command that is used to run a container out of an image. Okay, so I'm executing this command. Then I have -d. Now -d makes sure that the container that you are running runs in detached mode. Now what I mean by detached mode, if I just run it without -d flag, what will happen is this particular terminal will be then for this container to run. So you will see all the logs and all happening, and you won't be able to run any more commands on this particular terminal. Okay. And if I want to run subsequent command after this one, okay, I should make sure that I should execute it with -d flag. Then this terminal won't be occupied. And if you want to check any sort of logs and all, you have a separate command that you can run. Okay, so that is the benefit of having -d over here. Otherwise, this terminal will be occupied by this command, and you will see all the logs coming in over here. And if you try to stop it, the container will also stop. So it's basically this terminal interface will just be for this image or the container to work. Okay, so that's why -d. I'm running it in detached mode. 2 times -name, and I'm specifying the name over here as db. Now the container that I'm running, I want to have a name to it. Okay, so I'm saying this is my name that I wish to have, and I want to run this container with this name. So I'm specifying name over here, nothing special. Then I have -e, and I'm specifying the environment variable. So -e is a part of -e is used to set an environment variable onto the container. So here I'm saying like this is the environment variable that I'm setting in, and this variable is used to set the database password. Okay, and then I'm specifying the image name, and the version of the image. Now you can specify any version you wish to. Okay, so here if you come over here and if you search for Docker Postgres, you will see this hub.docker.com and /Postgres open up over here. Now this is the page that will give you a list of all the images that are available for PostgreSQL. So you can see there are different tags for different versions of images. You have 13, version 14, 15, 16, 17. You can pick any of the image you wish to. Latest one will also do. And by the time if you're watching this video, there will be more and more latest images that might have come up. Okay, but I'm making use of this one. Okay, so I'll just press enter. Since you are clear with what this command is, I'll just press enter. Now the moment you press enter, it will look up for this image over here, Postgres version 14 onto your local machine. And if it's not able to find it locally, like you see the message over here, it was not able to find it locally. So if it's not able to find it locally, it will start pulling it from the remote repository or the Docker registry. And you can see it is downloading it in chunks, and you can see download complete quite a few times. It will take some time to download depending on your system speed and how powerful your internet is. But wait for a while, have patience, it's done for me. And in the end, I see this unique string, like alphanumeric string over here. Okay, what this is the container ID using which you can identify the container. Okay, so if you come over here now to Docker desktop, you will see one image being added over here. You can see this image, it's of size 152 MB. Okay, if you go to containers over here, you will see this is the container ID. Okay, so here if you see, you can see 6122 FEE. Okay, and you can see 6122 FEE. So this is a container ID that you're seeing. So you're seeing the part ID over here, not the complete one, but here on the command line, you're seeing the complete ID over here. Okay, and this is done. So we have this container up and running. Now what I will do is I will run one more container, because we need two containers running to demonstrate the ability of Docker networks. Okay, so what I'm going to do is I'm going to say Docker run. I'm going to say -d -name. I'm going to say pgAdmin over here. I'm going to say -e pg. So I'm going to say pgAdmin. I'm going to say underscore over here. And I'm going to say default underscore email. So I'm setting in the default email, and here I'm going to say user@domain.com over here. I'm going to say -e, then pg. I'm going to again say pgAdmin. So I'm setting in some environment variables, underscore, and here default, and I'm going to say password, and I'm going to say super secret, and I'll say space d page / pgAdmin4. Okay, pgAdmin4. Now what is pgAdmin? pgAdmin is a web-based PostgreSQL management tool. So we have just got the PostgreSQL database over here in the previous command. Okay, I now want a admin interface using which I can connect to the database and can see what sort of tables are there. So it's basically a UI that using which you can connect to the database and actually do some tasks like querying the database, or creating the database, creating tables. It's basically an interface. So that is what pgAdmin is. So I'm saying Docker run -d. So with this I'm running in detached mode again. I'm specifying the name, okay, which is pgAdmin. I'm saying -e to set the environment variables. So I'm setting in the variables like default email and the password over here. Okay, and then I'm specifying the image name. All right, now I'll say enter over here. So it will again look for this image locally like it always does in previous command. Also it does that. It did that in fact. So you can see it did not find this image locally. So it is going to find or pull this image from remote. And you can see the download is pretty quick. And once the download is finished, we will see another container running over here. Okay, so you can see this is the Postgres image that we have right now. We'll wait for a while. We'll see one more image. Okay, so you can see one more image has come in. You can see pgAdmin4, and if you go to containers, you will see this container also up and running. Okay, now we have two separate containers running, and we don't have any concept of Docker networks yet. Now what I will do is I will try to access the DB container from the pgAdmin container. Okay, so if you say docker ps, you will see the list of all the containers running. You can also make use of the interface like the UI over here. Okay, so what I will do is, like I said, I'll try to access this pgAdmin container. Okay, so I'll try to access the DB container from the pgAdmin container. So here, this db container is what I'll try to access, from the pgAdmin container. How will I do this? So there is a command, okay, using which you can run or execute commands within a Docker container. So I'm going to say docker exec -it. I'll say pgAdmin over here, and I'll say ping db. So what this is doing is, it is executing this command in the interactive mode. IT means interactive mode, okay, and I'm specifying the name of the container where I want to execute this command. So docker exec it pgAdmin. This is the command, and this command is making sure that I am executing a command in this container, okay. And then which command I'm executing? I'm executing ping db. So ping basically is a command using which you can check for network connectivity. So here I'm checking the network connectivity. So when I say ping db, I'm checking the connectivity to db container, because the container name is db, right? So the moment I say enter, okay, let us see what happens. So the moment I say enter, it won't work and it gives an error. It says ping. So ping, this error is coming in from ping, okay. So ping says bad address db, which means db is not accessible to pgAdmin, right? Now, the thing is, now one thing is clear, okay, you cannot access another container from one container, okay, and if you try to access the other container from one container, you get this kind of error. Now, talking about Docker networks help you fix this. So there will be scenarios wherein you want to talk to other containers, okay, from one container, and you can do that via Docker network. So you can create a network that exists, and because of that network, what will happen is the communication will be simplified, and these kind of issues won't happen, okay, because when you're working on a production grade environment, it's likely that you will have multiple containers up and running, and you would want to basically have some sort of communication between them. So that is where Docker networks come into picture. So what I'm going to do is, I'm going to say Docker network, I'm going to say create my, and I'm going to say network, something like this. So this will create, okay, it says, okay, so it says the network with this name already exists. So I must have created this in past. So what I'm going to do is, I'm going to say Docker network prune over here, which will delete all the networks that exist, okay. So it will delete all the network, and you can see my network is deleted, okay. So I'm recreating this network now so that you can see how the creation happens. So I'm going to say Docker network create my network. I'm running the same command. You can see this network is created, okay. So now we have a network, okay, but this network is not being used because the containers are already running, and we did not start the containers by specifying the network, okay. So what I will do is, I'm going to remove or delete both these containers which are up and running, because they are not making use of this concept of Docker network, right? So I'm going to say Docker rm-f, I'm going to say db and pgAdmin. So this is going to remove both these containers. -f is for force, okay. So Docker rm-f, db and pgAdmin is the name of the container. So this removes both the containers. Now if you go to the containers list over here, you'll see no containers are running. Now what I'm going to do is, I'm going to run the same command, docker run -d-name db, and here you see this was a command that we ran previously to basically start the PostgreSQL database. What I'm going to do is, just after db, I'm going to specify the network as well. So 2 times hyphen, and I'm going to say network over here. I'm going to say my -network, because my -network is the name of the network that we have created over here. You can see this is the name of the network that we have created. So I'll specify the same network over here when starting this particular container. So this will make sure that these containers are making use of this network. So I'll say enter. So now this time it found the image locally. I had not deleted the image. I had just deleted the containers. The images were there locally, right? So it quickly created the container from the image, because image was there locally. What I'm going to do is, I'm going to press up arrow over here, okay, and I'll do the same for pgAdmin. So this is the command that we ran for pgAdmin, and by pressing the up arrow, you can access the previously executed command, right? So now after we specify the pgAdmin name over here, I'm going to say network over here. Okay, network over here 2 times, and I'm going to say my hyphen network, something like this. Okay, and I'll again say enter. Okay, so this time again the container is started for pgAdmin. Now if you come over here, you'll see both these containers are up and running. Okay, now what I will do is I will run this ping command again. So I'll say docker exec, which is execute in interactive mode, which is -it on container pgAdmin. And what is the command? Command is ping db. Now if I say enter, you will see the ping db command working fine. So I'll just shut this by pressing Control C on Windows. So if you press Control C, it will terminate this command. And if you press Command C on Mac, it will terminate this. Okay. So this termination is important because this will keep on going forever. Okay. And it will keep pinging it forever. Okay, so you can see 6 packets were transmitted and 6 were received, which means the network is healthy and you are able to now communicate to other containers between because of this Docker network. So this is the importance of Docker network. Now Docker network is important, because containers that are in the same network, they can communicate with each other using container names as the host name. And this command that we are making use of, we made use of this execute command, exec. Okay, so this is a command to run so this is actually a command to run a command inside a container. Okay, that is what this command is for. And you can see how it worked this time, whereas earlier, like when we tried to run it, if I scroll up, you can see we got bad address over here. Okay, and then we created Docker network, and we basically removed the container and we recreated the container by making use of the network over here. Okay, so this is the importance of Docker network over here, wherein if you have containers within the same network or using the same network, then they can communicate with each other using the container names as the host name. All right. So I hope it's clear, and I hope I have been able to successfully demonstrate as to why Docker network is important. And I hope it's pretty clear to you all with this. Demos like these help you understand concept better rather than me showing theory and stuff. This is actually a demonstration of Docker network, which you'll remember because you have seen it, and you can also try it on your local machine. And once you know it, no one can take away that knowledge from you. So that's really important because you now understand what Docker network is, and you understand it in a very hands-on way, not with the help of slides and all. Okay, so I'm happy that you are clear on this. So now it's the time that I'm going to create PostgreSQL and pgAdmin service using that of Docker. And we're going to make use of the concept of Docker network as well over here. So these are few commands that I already have on my system, and I'm going to take you through this, okay, and then we'll execute them one by one. So first thing is over here that you see is I'm creating a Docker network. Now using this command, the Docker network created is called as Postgres. Okay, this is pretty simple. I'm creating this so that both these containers can make use of it and they can communicate between each other. All right. Then I have this first command, which is making use of PostgreSQL, which is actually creating PostgreSQL, and it is making use of PostgreSQL image over here. Okay. Now let us go through this command. So here, first thing, I'm saying Docker run, and I'm making use of -d flag. Okay, so this runs the container in the detached mode, and then I'm making use of name Postgres container over here. So this is specifying the name of the container as Postgres container, and then I have the environment variable set using -e flag. So I'm setting this environment variable Postgres_user, and I'm setting it to embarkx. So this sets the username for the PostgreSQL database as embarkx. So this is the username that we can use, and this is a password for this username. So Postgres password. So this is another environment variable. Then I have -e pgdata, and I'm setting it to /data/Postgres. So this is specifying the data directory for the PostgreSQL as this one. Okay, /data/Postgres, and then you have -v over here. Okay, which is mounting the Docker volume as Postgres to the data/Postgres directory in the container. Okay. Now this volume is important because we want to persist the data that we have in the PostgreSQL. Okay, so that is what we are doing over here. Okay, then what I'm doing is I'm saying -p. So this is for port over here. So I'm saying map the containers port 5432 to the port of host, which is 5432 again. Okay, so this will allow us to access the PostgreSQL database using localhost or the host URL. Okay, then I have this network. So the network that we created over here, I'm making use of this network over here. I'm saying create it using network Postgres, and then I'm specifying this restart unless stop. So this specifies that container should be automatically restarted unless explicitly stopped. So this is one one setting that I'm adding over here, and then I'm specifying the image name over here. So this is the Docker image that this command can use, and this is the official PostgreSQL image. Okay, then I have the similar thing for pgAdmin as well, wherein I'm making use of the detached mode over here. You can see, and then I'm setting in the container name like this, and then I'm making use of -e to set these environment variables. Okay, so here this first one, pgAdmin default email, is setting in the default email for pgAdmin user as this one over here. Okay, then I have pgAdmin default password set to admin over here. Okay, and this sets the default password for the pgAdmin user as admin. Okay, and then I have pgAdmin config server mode on. So this disables the server mode for pgAdmin. And then I have -v for volumes over here. You can see, so I'm mounting a volume named pgAdmin. Okay, and here you can see this. This is a path over here, right? So this is a directory in the container. So this directory is not on your machine. This is inside the container, which is used to persist pgAdmin data. So that is what I'm doing over here. And then I'm saying this is port mapping. So here I'm saying like map the containers port 80 over here to the local host port 5050. So I will be able to access pgAdmin web interface from 5050. Okay. And then I'm adding the network as Postgres, and then I'm saying restart unless stopped. And then this is the image that I want to make use of. So you can even run these commands in the terminal now to start the containers based on the configurations that you have defined over here. Okay, but we are not going to do that. I'm going to show you a different and a better way to do things. Now this is a way of running containers. Okay, you can create these sort of commands on your text editor or coding editor, whatever you use, and then execute it one by one onto the terminal. Okay, but there is a better way, because I'll tell you, it's a matter of time wherein your application will grow and you will soon have too many containers up and running. You will have to take care of too many containers, manage them at once, and managing all these commands in a file is going to be cumbersome in future. Okay, so there is an amazing way of doing things, which is with the help of Docker Compose. So I wanted to show you this way as well, because then you are aware of where we are going and where we are coming in from, right? So this is one way. But another way is with the help of Docker Compose. Now, what is Docker Compose? So take a look at this YAML configuration. So this is a YAML configuration, and this is the configuration for Docker Compose file. Now, Docker Compose is nothing but a tool for defining and managing multi-container Docker application. So you as a developer, you can define applications, services, networks, volumes in a single YAML file as a configuration, and then you can save that particular YAML file as Docker Compose YAML file, and then you have to just run this particular file, and all the containers configuration that you have defined in this single file will be up and running for you. Okay, so rather than defining the containers this way, okay, wherein you are running individual commands, debugging them individually, you just have a single file to maintain. And how many number of containers you have, even if you have 10, 20, 50, you just have to take care of this single file, and this single file will have everything. So any developer taking a look at the single file will know what sort of services we are running, what are the configuration for different services, and you can specify different the details of these services, like Docker image to use, the port to use, port to expose, the networks, the volumes, everything in this single file. And this makes this particular setup or this particular process far less cumbersome than what we just saw over here with the help of command line. Okay, so yeah, I hope you have the clarity of the importance of this. I wanted to show you the command version as well, so that you know how commands can get complex over time. Like as your containers grow, as your configuration grow, you might want to add more environment variables over here, and maintaining it this way is just not the way to go, right? So this is the way. Now let us take a look at the file and what we are doing over here. So this is a file which will soon move to IntelliJ, but over here you can see at the top you have services tag. Okay, so this services tag is the keyword that is used to define the services that make up your application. Now services are nothing but containers in Docker, and each service that you're seeing over here is going to run a single image. So you can see this is one service, okay, and this is another service which is pgAdmin. So this Postgres is one service, and then you have pgAdmin, okay, and within these services you have the configuration for the respective service, you can see, okay. So let us take a look at Postgres over here, okay. So here you can see over here Postgres, it has the container name over here, which specifies the name of the container. So if you start the container, you will have this container being created with Postgres container name. Then you have the image that you're specifying. Then you have the environment that you've specified. Then you have the volumes that you want the container to make use of, and you've specified that over here. You have the ports that you are exposing, networks, and the restart related settings over here. Okay, so here you are seeing the network it's making use of is Postgres. But where are you defining the network? So if you scroll down, you have this network over here, like network Postgres, and driver it's making use of is bridge driver over here. Okay, now taking a look at the other container, which is pgAdmin. Here you have some similar structure wherein you are saying the container name, which is the pgAdmin container, not controller, it's container. Then you have the image name, which is a pgAdmin 4. You are setting the environment over here. Then you are setting in the volume, the ports, you can see you are exposing the port 5050 on local machine, and you're mapping it to that of port on container, which is 8080. Okay, so basically this 8080 port in container is being mapped to the local host 5050. So you can access pgAdmin using 5050, right? And then you have networks over here, and then this is a restart related setting. And then over here, you're defining the networks tab, wherein you're saying like these are the networks that should exist. And here you are specifying the volume related information, which is Postgres. This is the volume over here. You can see this is the volume. And then you have pgAdmin, which is another volume that you have tagged over here. Okay, so yeah, this is the single file. And now if there are more services that come in future, what you can do is you can just update this file and add the services one below the other, and things will be taken care of. Okay, so this is much more easier to maintain, as you can imagine. All right. Now what I'm going to do is I'm going to head over to IntelliJ IDEA, and I'm going to move this configuration there. So I'll copy this entire thing and head over to IntelliJ. Now in IntelliJ, you can have any sort of project open. Okay, any sort of Spring Boot application, Java application, whatever. You come over here, and here in the root directory of the project, I'm going to say new, right click new. And here you can see you have a option for file over here. So I'm going to select this, and here I'm going to say docker-compose.yaml file. Okay. Now I'll create this file and I'll paste this configuration over here. Now, as soon as you paste this configuration over here, you are going to see these marks over here. Okay, which is for running these services. So IntelliJ actually identifies that this is a Docker compose YAML file. Okay, and it has a very good support for it. Okay, now as soon as you paste this over here, it's likely that you might not see these kind of marks and arrows over here, right? So it's because I'm seeing this because I have added a plugin. So if you come over here to settings, okay, there is a thing called plugins over here. Select this, and here you have a plugin for Docker. So this offers the Docker support. Now, sometimes what happens is if you don't have this plugin, you will see a suggestion over here when you create a Docker compose file, which will ask you to add this particular plugin. So just go ahead and add this plugin so that you can get some support in terms of syntax highlighting and on. Okay, so here, now this is the configuration, and now you can see this very well. There is some bit of syntax highlighting as well, right? Now, if you hover on this, okay, let me hover on this. You'll see this Docker compose up command. If you hover on this play button, right? This double play button, the top one. So if you click on this, what will happen is all the services that have been defined under services tag will start running over here. okay, along with the network and the volumes. Okay, this is what it will do, and it internally it will run this command docker compose up. So docker compose up is a command that helps you turn up all the service basically that is defined in the docker compose file. Okay, then if you hover on this, you will see docker compose up Postgres. So if you don't want to run all the services, what you can do is you can say docker compose up and specify the service name. Service name over here is Postgres. Okay, if you just want to run pgAdmin, so just say docker compose up pgAdmin. Okay, so these are the commands that you should know. All right, now this is done. Now what we can do is we should head over to terminal and we should actually turn up or run the docker commands. Okay, so what I can do is here you have this option for terminal, so you can click on this, and from here also you can run these docker related commands. But what I'm going to do is you can run from here if you wish to, but I'm going to actually make use of an external terminal. Okay, just from the convenience standpoint. If you're not keen on having a separate terminal, you can feel free to make use of the inbuilt terminal within IntelliJ. And be sure to have your Docker desktop up and running. I'll come over here. Just make sure that you are in the project directory. So if you do ls over here, okay, you will see this Docker compose YAML, which we just created over here. So I'm in the project root directory over here. Okay. Now what I'm going to do is I'm going to run clear and I'm going to say Docker compose up. Okay, so this is a command that I'll run. Okay, and the moment you say enter over here, okay, you'll see it's running Postgres and pgAdmin. So these are the two services that you have defined over here, right? And what it's doing is it is pulling the images. You can see the image is not there on the local machine. Okay, and you'll see this pull happening. If you have the image locally, it is not going to pull the image and it is just going to skip this step and move on to container setup. Okay, but you can see over here, it's pulling the image now, and depending on your system speed, it will take some time. Now, if you had more services defined in Docker Compose YAML over here, you would have seen more images being pulled over here. So if you have 10 services defined, you will see 10 images being pulled at once. This is way better than running individual commands. Okay, so we'll wait for a while until this process is complete. Now you can see one image is pulled, which is of pgAdmin. Okay, and there are so many logs that came up suddenly. All right, so if I scroll up, let us scroll up and let us see what happened over here. Okay, so you can see over here, both the images were pulled. Okay, they were pulled in around 60 seconds, 65 seconds roughly. You can see the timing on the right hand side. Okay, but after pulling, there was some gap. I don't know why this came up, but you can see now it started creating network over here. The volume was created. These were the two volumes that we needed. The two containers were created after the network and volumes were created. Okay, because the network and volumes need to be used by these containers. So that was done. And then you can see over here, the pgAdmin container and Postgres container were started. And now you can see the logs over here. Okay, you can see the logs. Okay, now you won't be able to run any sort of command over here because you are not running this particular command in the detached mode. So you have an option to run this in the detached mode as well by specifying the flag -d. So what I'm going to do is I'm going to just shut this. Okay, you can take a look at the logs, create database and everything. Okay, this is all around PostgreSQL. You can see Postgres container logs. Okay, you can see everything. pgAdmin container logs also coming in over here. Okay, so it started on 80 over here. Okay, and it will be exposed on 50/50. All right, on our local machine as per the configuration. All right, but you can see the logs of all the containers that we are running. Now what I will do is I want to make use of this terminal as well to run some more commands. So I'm going to say Control-C to stop this. Okay, so it's going to gracefully stop it. You can see, and it's stopping both the containers. Now if you're on Mac, you will have to press Command-C. Okay, so the container is stopped. It'll take some time. And we are seeing a confirmation, but we are not seeing the terminal appear over here. So now the terminal comes in. Okay, so this is done. Now what I'm going to do is I'm going to show you how you can run this in detached mode. Now to run this in detached mode, you're just going to specify -d over here. Okay, now with -d you will see container started. So there was no pulling process, like image pulling process, because the images already existed, right? We have just started the container, and now you are not seeing the logs. Okay, but you can see the containers up and running. You can see over here. Okay, So under ecom application, you have these two containers up and running, right? So the containers are up and running. Now, how do you see logs of these containers? So you can say Docker PS. So this will give you the list of containers that are up and running. You can see the information like the container ID over here, container ID. You can see these two IDs. Now, if you want to check the logs, you can say Docker logs, and you can copy this container ID, paste it over here, and you'll see the logs of this container. You can see, okay, complete logs. Now, this is for the database Postgres, okay. Now, you can check the logs for this second container. So you can say, you can come over here. You can say Docker logs, and you can get the logs of second container. So this way you will have to get the logs of each container if you're making use of Docker Compose, but you have the containers actually up and running. And if you want to shut the containers, you can say Docker Compose down over here. So up is for turning up the containers, down is for like terminating the containers. And once you do this, you can see stopped, removed. Like containers was stopped, both the containers and the network was also removed. And if you go over here now, you'll see no containers are running, but images exist. All right. So I hope this is giving you clarity and the importance of Docker Compose. It's a really important tool if you are like containerizing your applications, and once your applications scale, it's a matter of time. Like I said, applications will scale and the code will become much more complex. You will have more and more services being added. And at that time, running commands on terminal is not good. Okay, so switch over to Docker Compose. They make your life much more easier. I hope this has been useful, and I hope you have been able to follow along. So now it's time that we begin setting up the database with the help of pgAdmin into Postgres. Now, Postgres is our database and pgAdmin is the UI. So first thing, make sure to have our container up and running. Containers are not running currently. So I'll run them in the detached mode. Containers have started. Now, what I will do is I'll come over here, okay, in the browser, and I'll say localhost : 5050. Let us see what we see on this system or on this UI over here, okay. So here you can see I was automatically navigated or redirected to /browser, okay, which is the browser basically for accessing pgAdmin, okay. Now over here, you can see it's asking me to set master password. So you can set the master password. I'll just set it something simple like admin. You can set it to whatever you want, all right. Now over here, you can say, you'll see the list of servers. There are no list of servers. So this is a UI, right? So I need to create a server, right? So I'll say register a server, and here I'll specify the details, okay? So the name is Postgres. I'll specify the name over here, okay? So this is the name, and then I'll go to connection tab. Now in the connection tab, I'll have to specify the host name or the address. So I'll say Postgres here again. So this is the name of the container basically, or the host name that you have to specify. 5432 is the port. So if you come over here in IntelliJ, okay, so here we have specified so if you take a look at Postgres service, okay, what is the name of the container? Postgres, right? So you can specify host name as Postgres, okay, and service name is Postgres. Then you specify the port as 5432, and what is the username? User is EmbarkX. That is what you have specified, unless you have changed it. So come over here and specify EmbarkX, something like this, okay. And then what we will do is we'll try testing the connection. So we'll say save over here, okay. It says unable to connect because, okay, so username is incorrect, EmbarkX, something like this, okay. And let me say save over here, okay. I'm not able to connect, so I'll also specify the password like so, and let me say save. And now you can see once I specified the credentials like username and password, I was able to connect to the database, okay. So you can see, expand this, you'll see the list of databases. So you're seeing these two, right? Now if you come over to our application, for our application we need this ecomdb. So I'll copy this ecomdb, okay, and I'll come over here. Whatever is your database name that you've specified in your application, just create that database and you'll see the database being created. So it's pretty simple. Right click, create a new database, okay, something like this, create a new database, and just enter the database name, Okay. So whatever name you mention over here will be created, and make sure like this name matches the one that we want to connect through our application. All right. So now it's time that we test everything after we have everything set up. So what I'm going to do is I'm going to hit this run button for our application and let us test if we are able to see the changes in action. So now you'll see this stack trace over here, and you can see our application is up and running successfully. Now I will tell you something over here. Okay. I was getting an initial error over here. Okay. If the application is starting successfully with JPA integrated, then it means that your application has been able to successfully communicate to the database. But just in case if you are getting any sort of error on the startup that, hey, it's not able to authenticate, then one possible error that, or one possible mistake could be that you already have a instance of PostgreSQL installed on your local machine. So I'm on Windows and I have PostgreSQL running in Docker, right? And I also have a PostgreSQL instance running on my local machine. And if you head over to services over here, so if you search for services in the start menu, and if you open this, go for PostgreSQL over here, find PostgreSQL, right click and stop it if it's started. If you're getting authentication error, okay, that it's not able to connect to database. So what is happening is this might be on the local instance, or the one that is locally installed on your server, on your local machine, that might be on, and it's possible that the application is trying to communicate with this instance and not the one that is running in the Docker. But the database and the credentials that we have added is for the Docker instance and not this one. So that could be one reason. So just stop it from here, because that will save you a lot of time. Okay, I was facing this issue and I had to stop this because there was a conflict. Right. So this is something for you to remember. And if you're on Mac also, just figure out if you can stop the service of PostgreSQL that is running on your local system if you're not able to authenticate from the application despite having everything correct. So now coming to pgAdmin over here, you can see a lot of activities over here. And this activity happened when we started our application. So you can see a lot of like transactions, database session, all of this happening over here. Okay, now what I will do is we'll head over to ecomDB over here because our application is up and running. Okay, if you want, you can do a refresh. Okay, refresh, go to ecomDB, select schemas, and under public, you will see this thing called tables. And here you will find that all the tables that we have defined in our application have been created. Okay, so if you go to user table, right click and take a look at the data. You won't find any data, of course, because no data exists. And we need to create some data over here, right? So this table exists. Now what we need to do is we need to make use of Postman to query the application and get some data over here. So I'll head over to Postman and I'll go to create user and I'll start creating a user. So after get the request, I get this user added successfully. And now if you come over here and if I rerun this query again, if I press this execute script button, you will see this Docker instance now has one user added. Okay, I can do this test for everything. Okay, for products as well. So if you come over here, you'll see the products also being added over here. Okay, so for example here, and you should see products being added. Okay, something like this. Now what you need to do is here I can also, okay, I can come over here, I can create a cart and I can do order as well, but everything will work absolutely okay because we have these two APIs up and running. All right. So what is happening right now is we have, and you can see the queries as well being printed over here. So we have our PostgreSQL running up and running in Docker, and our application has been able to successfully connect to it. All right. So I hope you have been able to follow along, and I hope this has been super useful for you all. Now, one thing I would like to mention over here, if you don't want to just access phpMyAdmin and create this kind of schema, and you want to save yourself from this step, what you can do is you can make use of the database that is associated with the user. Okay, so let me explain this. So you can see this database automatically created, which is EmbarkX. Now, how is this created? This is created because here in Docker Compose, you have added a user called EmbarkX. Okay, so what happens is whenever you add a user, the database associated with this user is automatically created. So if you don't want to log in to PHP or pgMyAdmin and create a database manually and save yourself from that step, what you can do is you can copy this username over here, which you have specified in the Docker container, and add that user over here in the like URL over here. Okay, and then restart the application. So what will happen is we will connect to the database that is associated with that user. That is what will happen. And you can see the application is up and running successfully. And now if you come over here, let me go to, or let me close all over here. I will go over here and I'll go to EmbarkX and let me open this database and let me scroll down. You will see tables over here. You can see few tables here, right? Now if I run the queries here, so if I create a user and if I create a product, so I created both of them. And now if I try to access the user, you can see one user added over here, and product also, one product will be added. Okay, why did this happen? Because now the app is pointing to the EmbarkX database, and yeah, this saves us from that one step wherein we had to log in and log into pgMyAdmin and create a database with the name that you have specified over here. So that one step can be saved, but it won't refrain you from logging into pgAdmin. Okay, you will have to log into pgAdmin to have a easy way to access your data from PostgreSQL. Okay, rather than relying on command line, pgAdmin is a really nice interface from where you can access the database. All right, so that's one thing that I wanted to add. And one more thing I want to talk about is over here. Okay, so one thing is, if you're not able to connect to Docker, what I mean by when you're not able to connect to Docker is you're not able to connect to the PostgreSQL instance running on Docker. Be sure that all the services that are related to PostgreSQL installed locally. So if you have any local instance of PostgreSQL installed, be sure to stop those services. And on Windows, what you can do is you can search for services in the start menu and you will see this window appear. Search for PostgreSQL over here and just right click and say stop. Okay. On Mac, you will have to figure out a way as to how you can stop the service of PostgreSQL, or you can uninstall it as well. Okay, so do that. And one thing I would like to mention is here on Docker. So I had a situation wherein I had reinstalled Docker and it was not working properly onto my system. So what I did is I went over here into this system tray. I did right click and I clicked on troubleshoot over here. Okay. Now, when I clicked on troubleshoot, I could see these kind of options. So this is for Windows, but on Mac also you will have this kind of an menu or this kind of a screen from the top menu icon. Okay, so there is a system tray at the top in the Mac OS, and you have Docker logo appear over there. So from there you can access it over here. Okay, something like this. And this troubleshoot thing has options like clean, purge data, reset to factory default. So what I did is I had to clean, purge data. So if there is any conflicting data or anything that is not cleared from Docker, so that was cleared, and I was also able to reset it to the factory defaults. Okay, and once you do that, be sure to restart Docker. Okay, so there were some weird issues wherein I was not able to run a container on my local system. So doing this, just clean up, it saved me from troubleshooting those errors. So I just did a cleanup and everything started working fine. So it was just a system related issue and some issue that had to do with some, dangling data on my local machine. So that's what this thing is for. Okay, so I'm sharing all the troubleshooting steps over here so that you if you face these kinds of issues, it's easy for you and you save some time of learning. Okay, so that's a tip. I hope this was useful. So now it's time that we begin talking about how world designed softwares before microservices came into picture. So before microservices came into picture, the softwares were designed and built as monolithic architecture. Now, what is a monolithic architecture? So as the name suggests, it's a unified model for designing a software application So you can think of it like a big container where all the functionalities of the application like user interface, business logic, data processing, database operations, everything around that application will reside in a single indivisible unit. And when you build monolithic application, you are essentially creating one large code base where all the different function of your applications reside. Okay, so that is why the term monolithic, and that is why you see unified in the definition. Unified means everything at one place. Okay, so it's an architecture design where all the components of the applications are interconnected as well as interdependent. Now, what does this mean? So this means that the server side, client side, database operations, everything is in a single code base, and hence it is interconnected, interdependent, and there will be dependencies, like it's tightly coupled. That is what you can think of, right? So that is what monolithic application or monolithic design style is. Now, this is an diagrammatic representation of what a monolithic application will look like. Okay, so here you can see this is the main code base. As you can see over here, there is module 1, module 2, module 3. Now, I've just given an example over here wherein I have 3 modules. There could be more modules, like 10 modules, 50 modules, something like that, depending on the scale of the application. And I'm calling it modules over here, but you can even call it components. For example, if you're building an e-commerce application, you might have a user component, a product component, or a product module. So module and components can be used interchangeably. Okay, over here in the diagram. So it could be payment module as well. It could be order module, cart module. So a component or a module is a thing which is taking the responsibility of a single functionality. That is what I mean to say over here. So there will be multiple modules, multiple components within a single code base or a single application. There will be one database wherein all the components of the application, all the modules will store data in this single database, and they will reside on a single server. Now, this application, okay, this together is a single unit, and this application can be accessed via a browser. It can be accessed via a Postman client. It can be even accessed via a mobile application or a front-end application running in the browser. So that's how this is what it looks like, and I hope this diagrammatic representation is giving you some clarity as to what monolithic application is and what this architectural style has. So I hope this has been useful. So let us start talking about the problems with monolithic architecture. So monolithic applications are tightly woven fabric. Okay, so they are like a tightly woven fabric, and if you try to pull one thread out of it, it can cause the entire structure to unravel. Okay, so this means if you wish to, or if you want to update or modify a specific feature, we might have to redeploy the entire application. And this can lead to longer development cycles, okay, and also deployment cycles, increasing the time it takes to get the changes out to the user. Okay, so let us take a look at some of the problems that we typically face with monolithic architecture. So the number one problem would be difficulty to implement the changes. Okay, so like I said, monolithic applications are like tightly woven fabric, and if you want to implement a single change, there is a possibility that you might have to touch upon multiple modules because they all are interlinked. Even if you don't have to touch like different modules, if the change that you are making is specific to a single module, then to get the changes to effect, you have to deploy the entire application. Okay, so even if it's a small change, it results in all the components being redeployed. Okay, and if your application is huge enough, the deployment cycle can be longer. So a small change will lead to difficulty depending on the size of the project. The next problem that we have is the lack of scalability. Okay, so with this architecture, we face challenges when it comes to scaling our applications. Okay, so you can't just scale a specific function or a module. So for example, if you have a lot of users signing up, okay, so let's say you are working for a e-commerce application, okay, and let's say you have a lot of users signing up and there is a lot of traffic on the inventory module, okay,
because there is a huge sale going on, let's say. So suppose it's Black Friday. Okay, so lots of users are signing up and there is lots of traffic on the inventory module. Okay, so there are sellers accessing this inventory module, there are like users ordering stuff, so inventory is also moving fast. So inventory module is getting a lot of traffic. Now how do you scale inventory module? Okay, because there is only one module that is being used a lot as compared to the other modules. So there might be different modules, like let's say you have a module which allows users to raise a support ticket. There might be a module which allows users to, let's say, make payments and so on. But like if a specific module is getting a lot of traffic, you can't just scale that module with monolithic architecture. Okay, so in order to scale that module, you have to scale the entire application. Okay, and what I mean by scaling the application, I mean like creating more instances or scaling up the servers and all. Okay, and just scaling up everything for a single module is not at all cost effective or resource efficient. Okay, so this leads us to another problem where we face challenges in the lack of scalability. The next problem that you will have or everybody faces is long-term commitment to a single technology stack. Now, what does this mean? Okay, so monolithic applications require you to commit to a single technology stack for a long time. Okay, and this can limit your flexibility to try out new technologies. So technological world, like if you see around, technology changes really fast. Okay, and you absolutely want to make best use of the tools that are coming out in market. Okay, because this particular field of technology is rapidly evolving, and not being able to adapt to these new changes can leave your application lagging behind. For instance, let's say you have used a particular language or a framework for building your monolithic application, and few years later, let's say a more efficient language comes along. Okay, and you want to use it, but because your entire application is built with this old framework or old technology, migrating to a new stack will involve rebuilding the entire application and a total overhaul, which is costly, and it will also be resource and time consuming. So you might want to stick to the old stack in that case, okay, because that would be the best decision. And in that case, you are then committed in long term to that particular stack. So that's the third problem. The next problem that developers often face is application complexity and its effect on development and deployment. Okay, so in the beginning, monolithic applications are simple, but as your company grows and as the application scales, the complexity grows. Okay, and complexity makes it harder to understand the entire application. Okay, it slows down the development, it makes the deployment task like a huge task. Okay, so even if you want to deploy a small thing, you have to deploy everything, like redeploy everything. And there are increased chances of bugs, okay, because everything is interlinked. Okay, so this is another problem that typically developers face. Another issue is slowing down of IDEs. Okay, so since the code base grows really large in size with the scale, it can lead to slower performance, and you might need a powerful CPU, like a machine with a powerful CPU or higher RAM, and you might even face challenges in using the IDEs because you are loading a huge code base and you are doing the local development. So this can impact the productivity of your team members, the developers, and also impact the overall speed. So this is often overlooked when it comes to monolithic application, okay? But large code base is not good, okay? Then with large code base and a lot of components, you will also face issues like increased application start time, okay? Because you have a lot of components in your application, and there might be several tasks that might happen at the application start. So you might want to initialize different components, you might want to fetch different dependencies and so on. So even if a small part of the application is being used by the user, you still need to load everything, okay? And this can lead to slower like application start time. Okay. Then the large project size. Okay, so this is of course related to the large code base. Okay, so large project size makes it challenging to manage and maintain the application. Okay, and then you have like deployment for small changes. So if there is a small change, if you tweak even a small thing, you need to redeploy the entire application. So this is not good. Okay, also team collaboration and autonomy. Okay, so there are multiple teams that are working on different parts of a monolithic application. Like for example, if you have an e-commerce app, you will have a team for like e-commerce store, and you will have team for e-commerce inventory or the seller side and so on. So there are different teams working on different files. Now coordinating the changes, managing dependencies, resolving conflicts, okay, leads to a lot of issues. Okay, and this could lead to a lot of delays. It leads to difficulty in maintaining a smooth development workflow. Okay, so team collaboration and autonomy is a problem. Okay, so that's about different problems and challenges that developers typically face when working with monolithic architecture.
Now let us begin talking about what are microservices and why do we need them. So microservices is an architectural style that structures application as a collection of small autonomous services. These services are modeled around business domain, right? So you can think of an application over here like an e-commerce application. Now there will be multiple components within that application, right? Order, payment, there can be product, there can be user. So what you can do is you can break down this single application into multiple services. For example, handling of order and payment, there can be one service. Handling of users authentication, there can be one service. Handling of products inventory, there can be one service. So you divide or structure your application as a collection of small autonomous services modeled around each business domain or modeled around a business domain. Now, each of these services run a unique process. So they will run as a separate process and they'll communicate through a well-defined lightweight mechanism to serve the business goal. So you can compare this with the analogy of small interlinked island. Okay, so small interlinked islands, each with its own rules and processes, but it's a part of the same cluster. Okay, so each in a similar fashion, like microservices is in an application is a self-contained unit. Okay, so for the outside world, it's not like multiple services running in the hindsight. For outside world, it's just a single application that is functioning as single unit to deliver a business goal, right? So if you're building, let's say if you're breaking down an application or if you're building an application for e-commerce store, I'm just giving an example, and you have created 10 services. Okay, for the outside world, it's not like he's communicating with the 10 services. He's communicating with your e-commerce application, and those 10 services in the hindsight should function as one single unit. So that is what the crux of microservices is. Okay, so you can think of microservices architecture something like this. Okay, so here I've given an example. Like you can see over here, this is microservice 1, microservice 2, and microservice 3 over here. Right? So this is one single application that is broken down into multiple services, and these are core functions, and each function is then developed and deployed as a standalone service. And these services will also communicate. So communication is important, like communication between microservices, because they are functioning as one single unit. So there has to be some inter-service communication within these services so that they can deliver the business goal seamlessly. And for that, they make use of protocols like HTTP or HTTPS to do inter-service communication. So that's what microservice is. And I hope this has given you some good clarity of what things look like when you transition to microservices architecture. Now let us talk about some core principles of microservices. So number one is single responsibility. So if you're building an application using microservices architecture, you will have multiple microservices running and serving a business goal, right? So how should you define the responsibilities for every service? So one principle that you should keep in mind is having a single responsibility principle. So each microservice should have one job and it should do that one job really well. For example, if you're building an e-commerce website, there could be individual services for user management and authentication. Another service could be for product management, which also takes care of inventory. Or you can separate inventory as well if your application scales, right? You can have one service for order processing, like order management, payments, and everything, right? So this way you could have a single responsibility principle, right? Independence. So each service should be able to operate and evolve independently. It should not be dependent on other service, and a change in one service should not require a change in another. So that's what independence means. Normally, if you're building a monolithic application, like an application using monolithic architecture, components are interlinked and there is no independence there. Like components are dependent and interlinked, right? Here, the components should, or the services should operate and evolve independently. Change in one service should not require a change in another. That's what the principle. Next principle is decentralization. So instead of having a single governing body, each service manages its own database, its own data model. So this leads to decentralization, wherein each service has the power to basically choose the kind of database they want to use, choose the kind of data model they want to follow. That's decentralization. Then you have failure isolation. Okay. So failure isolation means when one microservice fails, it doesn't take the entire system down with it. Okay, because one service has failed, so entire system should not go down. The rest of the application should continue to function as it is. Continuous delivery and deployment. So each microservice we should be able to deploy and update every microservice independently. Okay, and this leads for further decentralization, because then different teams can update microservices or their service, whichever service they are working on, and they can do it more frequently, and releases can be much more reliable. So earlier what used to happen is, if there is one major project, updating that project just for a single functionality change would be a tedious task, right? You have to deploy all the components because it's not microservices architecture. But with microservice, let's say if you want to make a small change in order flow, then you have to just deploy and update the order service. Changes are not needed in the rest of the service. So this is another principle that you should keep in mind. So these are the principles of microservices. I hope you have been able to follow along, and I hope this has been useful. Let us start talking about what are microservices and why do we need them. So what are microservices? So microservices structures an application as a collection of small autonomous services. Okay, what does that mean? So in monolithic architecture, you have everything as a single application. But with microservices, you can separate the components into different services. Okay, and they all work together as if they are a single application. Okay. So each service runs a unique process and communicates through a well-defined lightweight mechanism to serve a particular goal. Okay, and goal can be anything. Now, the term microservices is nothing but an architectural style, okay, which is used to structure a particular application in a particular way. Okay. You can compare microservices with the analogy of islands. So there are small islands that are interlinked. Okay, they have their own rules, processes, but they all are part of the same structure. Okay, so in microservices, every service is a self-contained unit that works with other microservices that exist. Okay, and under the hood, they all complete the application. Okay, so let us talk about how microservices work. So microservices work by breaking down the application into small services which form the core function. And each function is deployed and developed as a separate standalone services. Okay. So you can think of this like we have our application job app. So you have three core components, like we have company, job, and review. So you can separate these components. Instead of having a single app that has three components, you can have three different apps
with each component in it. And they all have their own copy of database. Okay, so database is also separate. Now the question is, how do these microservices communicate? So they communicate with each other with standard protocols like HTTP or HTTPS. Okay, and the communication is essential because they are functioning as a single application and not the separate one. So this is our job application, but if you think of this from another example like e-commerce application, you can have microservices for handling inventory, for handling user authentication, for handling payments processing, like for handling the seller side of the application and so on. Okay. So each service that exists is responsible for having its own data, own functionality, and handling their part of the role on their own. Okay. Let us talk about some of the principles on which microservices operate. The number one principle is the single responsibility principle, which says that each microservice should have one single job. For example, if we take an example of e-commerce website, there can be individual services for product, inventory, order processing, and so on. And they all, like every microservice, has a single responsibility. Independence. So this principle says that each service should be able to operate independently without having any dependency on other service. And a change, or if you are making any change or functionality change or code change in any one service, it should not impact the other service. Okay. Then decentralization. So instead of having the entire application as one body, okay, each service manages its own database, its own code base, and its own data model. So this is decentralization. Failure isolation. So in case of a monolithic architecture, if a particular component fails, the entire application fails. But when a microservice fails, it doesn't take the whole system down. Okay, the rest or the other microservices continue to function as normal, but only one service could be down. So this leads to this principle of failure isolation. Continuous delivery and deployment. So since each microservice is independent and isolated, each microservice can be updated independently, and it gives room for doing more frequent and reliable releases for every microservice. Since the code base is also small, and this gives a lot of autonomy to the developers. So that's about microservices. So now it's time that we begin restructuring our application. And what are we going to talk over here is we are going to understand what changes are we going to do as a part of that restructuring. So this is what our application looks like currently, wherein we have a browser or a Postman client from where we are calling the APIs over here. And we have APIs for user, product, order, and then these APIs are hosted on a server. And this entire application or this entire setup is talking to a database in the hind side. Now, this browser, from the browser, you can have a front-end application accessing this, or you can directly access the GET request, or you can even have a Postman client. So I've just mentioned browser over here. But what are we going to transition to? So we are going to transition to something like this. So we are going to have a browser or a client who is consuming our APIs, and then we'll have different microservices. So in the previous architecture or in the current version that we have, we don't have a different microservice for every module, I would say. So with this, what we will do is we will have a new microservice for every module. So for example, user over here is a separate microservice. We have product, that is a separate microservice, and then we have order, which is a separate microservice. So there are 3 microservices. So the application will split into 3 different microservices, and you're free to make use of different sort of database as well for these 3 microservices, and that is what we are going to do. So you can see over here, there is database 1, database 2, and database 3. And user microservice will talk to its own database, which is the user database, wherein all the data related to user will reside. We'll have product microservice, which will talk to its own database, which is the product database, and all the data around product will reside over here. And then we have a separate database for order, wherein, and all order related information will reside. Now, the benefit of this setup is a lot. Okay, you can have modular teams working on different microservices who are free to select the technology. So, for example, if they want to host the database in the cloud on Google Cloud, they're free to do so. And this product team decides that they want to host the database on AWS. They are okay to do so. And order team decides they want to host it elsewhere. That is completely fine. So it's totally their choice. Okay, but this is what we'll be doing locally, and we would be delivering this in this section. So yeah, this is what the plan is, and in the coming videos you will see all this materialize. Now let us understand how we are going to structure our microservices. Now, since there are 3 different services running in our application, we have the liberty to choose the port numbers. So we are going to have this kind of a setup wherein we'll have the product microservice running on 8081, user on 8082, order on 8083. So this is what the port number will be, and this is what I'm going to follow. You're free to change this if you wish to have some other sort of port numbers, but this is what the course and I'm going to follow over here. All right, so now is the time that we begin setting up our user service. And whenever we talk about the setup or setting up a new project in Spring Boot, we need to head over to our favorite website, which is Spring Initializer at start.spring.io. And that is where I have landed. Now what I'm going to do is I'm going to make sure that I select all the relevant settings and I enter all the relevant details like dependencies, and I get the project zip onto my local machine. So I'm going to make sure I select Maven, Java, and the latest non-snapshot version of Spring Boot. Now regarding this version, you must be aware that you might see a different version number depending on when you are watching this video, because Spring Boot releases every now and then a small minor version, every now and then with some fixes. So this number might be something different for you, but don't worry about having a different version number over here for Spring Boot, because that is not going to impact anything. A lot of changes or a lot of releases are improvement fixes, and if there is any major change, I'll make sure I update things over here. All right. So yeah, be sure to select the non-snapshot version like this over here, whichever is available. Now in group, I'll enter details like com.eCommerce over here. This is the group, and here I'll enter user. Right. So this is the package which gets auto-generated. Description, you can write a description like user service for e-commerce app. E-commerce application. Something like this. Whatever description you want to add. Make sure you select jar and the latest version of Java. All right. Now, talking about dependencies, we are going to need a few dependencies. So what dependencies should we add? So the dependencies will be web, the first thing, because we are building REST APIs. And I'll need Lombok that will help us reduce the boilerplate code. So that is what I'm going to add. Next, we need JPA, and I'm also going to need H2 database. So we'll begin with H2 database, and then we can migrate to different databases as well. So let's begin simple. H2 database. So apart from these, I don't think we need anything else. If we need anything, we can revisit this page later on. Now you can explore the project structure over here that Spring Initializer will generate for you. You can explore it from here. Otherwise, you can just say generate and get the project zip file downloaded onto your local machine. So what I'm going to do is I'm going to say generate and get the zip file on my local machine, and I'll save it into a folder that is my workspace, and where I'm building this particular project. So I'll just do that. So here you can see like this is the folder where I'm adding all the microservices. You have this additional folder that you see over here. So under this additional, I have a couple of apps like ecom application and first Spring. So I have
organized it in such a way that additional has additional projects and all the other main e-commerce related microservice will come over here. So this is the user microservice. I'll just say right click. I'll say extract over here and you'll see this user folder come in and just delete this other folder, which is a zip file, because we don't need that. Now what we need to do is we need to open this particular user project in IntelliJ. And for that, I'm going to head over to IntelliJ. So I've opened IntelliJ over here and this is a kind of welcome screen that you're going to see. On the right hand side, I'm seeing all my recent projects. Okay, if you are not a user of IntelliJ, you're not going to see the recent projects like I do. Okay, now what I'm going to do is I'm going to say open and quickly navigate to user microservice that you have unzipped. And within that folder, select form.xml. Once you do that, say OK. It will ask you whether you want to open this particular file as a file or you want to open this as a project. So just say open as a project. The moment you open this as a project, you're going to see some sort of processing here on the bottom right, which just happened for me. And when you see that processing, it generally means that Maven is downloading all the dependencies after reading the pom.xml file. So IntelliJ has identified this particular project as a Maven project, and based on the contents of pom.xml and the dependencies that you have added, it is fetching all the dependencies and the necessary libraries for your project to function normally. All right. So with this, if you are able to reach until this step, we have successfully created user service in IntelliJ, and we are ready to take it to the next step. Now, since we have the project setup done in IntelliJ, what I'm going to do is I'm going to head over to SRC folder, and here under main package, I need to add all the relevant files like the controller, repository, models for the user service. Okay, so you come over here to the monolithic application. So in another instance, so I have one more instance of IntelliJ running, and in that particular instance or in that particular window, I have opened the monolithic application from where we want to migrate all the source code to individual services. Okay, so I'll close everything, and now here, if you go to src main and Java folder, you will see different packages, and if you open all the packages except the main package, you're going to see a lot of files. And out of these files, we need to migrate some files that are related to user microservice into the project that we have created. Okay, so what I'll do is I'll press Control since I'm on Windows, and press and hold Control. Since if you're on Mac, press and hold Command to select multiple files. So I'll just start selecting user controller. I'll scroll down, and then I'll select user request, user response. Scroll down, I'll select user role, user and user role. Then scroll down, select user repository and user service. You also need to select address over here in model and address DTO because they are also a part of user. So just make sure after you have all the selection, just make sure you do Control C on Windows and Command C on Mac, and then head over to this particular project that we just created and paste everything over here. So you can see I have pasted all the files over here. Okay. And this is not how we want to structure our project, right? So we will have sub packages over here, of course, from the organization standpoint. So I'm going to say repository. This is the first package that I'm creating over here. I'm going to have a package for services. Then I'm going to have package for, of course, controllers. Something like this. And I need to have package for models over here. Something like this, and I need to have package for DTOs. So organize it the way you want, okay, but this is the organization structure that I'm following. So first comes the controller. So I'm going to move, or let us start moving address, user and user role into model first. So I've refactored it. Then I need to move user controller to controllers. Then I can move address DTO, user request, user response to that of DTO package over here, user repository to that of repository, and then user service to that of services. Okay. So now with this, what we have done is we have added all the source code that is needed for user microservice to function in the right way. Okay. And we are not seeing any sort of red marks or errors right now. which means, or it confirms that everything is fine, at least at the source code level, and all the relevant dependencies, like whatever dependencies the application need have been added. Otherwise, you will see all the red marks that this class is not found and all, and it usually indicates that there is some dependency that is missing. Now, what we need to do as a next step is we need to update the configuration for the project. Okay, so what I'll do over here is you can continue using application.properties, but I'll switch over here to that of YAML configuration. Okay, so here I'm going to say YAML over here. Okay, and I'm going to get rid of this. Okay, I'm going to change it to YAML configuration. So I'm going to say spring.application, and I'm going to say name over here is user service, something like this. Okay, now what we need is we need to define the port number as well. Now, what is the port number for user service? So it's server port. So we'll specify the port as 8082. This is done. Now we need the configuration for the database. So we have added the dependency for H2 database. Let me see over here. Is it added? Okay, it's added over here, right? So what we need to do is we need to add the configuration for H2 over here. So I'll come over here, and here in application.yaml file of Monolith application, we have the configuration for H2 database over here. Okay, so you can see this configuration over here. So it's spring.h2. Okay, so this is how the configuration is. Here the main tag is spring.h2. So I'll just copy this and I'll come over here. Okay, and I'll paste it over here, something like this. And I'll just get rid of the comments over here, something like this. Okay, so yeah, what we are saying is H2 console enabled. So we are enabling the console. This is the data source URL that we are setting, JPA. Okay, so these are JPA related settings that we are adding over here. Do we want to see the SQL? Yes. And Hibernate related things over here, wherein we want to create the database on every restart. All right. So this is done, and we have the application set up for user service. Now, after making changes, it's time that we test our application, whether all the changes are with respect to what we expect, right? So I'm going to head over to our main application file, and I'm going to say run. Okay. I'll see this pop up, enable Lombok processing. I'll just say enable over here, and okay. There are few issues that I see, and these are related to Lombok. I'm getting all the issues on getters and setters. So I'll come over here. I'll go to settings. And here I'll head over to build execution deployment. Under that, I'll go for compiler, annotation processing, and here you'll see this annotation profile for user being set to processor path. I'll update this to obtain processors from project class path. I'll just say apply, okay, and I'll rerun the application. It should work fine without any issues. Even after doing these changes, if you are not able to see the application running and you are seeing like Lombok related issues, what you should do is you should make sure you hit apply over here. Okay, try these changes again, hit apply. Okay, and then come over here and go to build, and you rebuild the project, clean the project and rebuild it. Okay, and then basically you should have it up and running. Okay, now you can see over here the application has started fine. Okay, so if you go through the logs, of course you will see like initialization completed, Hibernate ORM version is printed. If you come over here, you will see the tables also being created. So you can see drop table if exist. Why this is happening? Because we have mentioned over here the DDL auto type as create. So it will drop everything and it will recreate everything, right? So you can see it created address, it created user table as well. Okay, which is absolutely okay, and that is what we expected. And now if I head over to Postman, we can query the database, right? So I'll come over here, sorry, not the database, we can query the application. So I'll come over here to eCommerce Monolith, and I have this user folder. So this is for Monolith application. I'll just do duplicate of this, okay, and I'll create a new blank collection, and I'll call this eCommerce Microservice. Okay, and I'll move this user that I've created under this eCommerce Microservice. Okay,
and I'll rename this from user copy to that just of user over here. Okay, I'll close this, go to create user, update user. I'll open all the APIs. So create user, I'll say update user, and then I'll say get users, and I'll also open get a user in a new tab. Now come to create a user. Now for this, a port number has changed. So if you try to query 8080, it won't run. Okay, unless and until you have some other app running over there. So I'll just change this to 8082. And we have this body over here, which is doing the job of creating the user. So I'll just query this. You can see user has been added successfully. You can confirm if the user is added or no by heading over to stack trace over here. You can see the insert query here. This is coming in because we have show SQL set to true over here. JPA show SQL, right? So you can see the user has been created and the data is inserted into user table. You can also confirm this by heading over to localhost colon 8082 slash console slash h2 console. Okay, something like this. So this is the h2 console, and make sure you have this string that you have inserted or that you have added in the configuration file. Okay, so add that over here. I already have it configured, so I'll say test connection and I'll say connect. The moment you connect, you will see address and user table. So you can say select star from user table. You can see the user has been added. Okay, and in address also you will see one address appear because you have added that address. Okay, now I'll save this. Let me get all the users. So here I can change this to 8082 and I can say get. You'll see this is the user that you're getting. So it's working fine. You have an option to get a particular user. So I'll update this endpoint to 8082. Save, send. You can see this is working absolutely okay. You can update the user. So let us update the user with this JSON. You can see John updated and Do updated is the value. I'll push it. Okay, I forgot to change the port number. Push it. You'll see user updated successfully. And if you come over here, you'll see the changes being reflected over here. You can see John updated and Do updated. All right. So our application is working absolutely fine, and we have been able to successfully segregate the code for user related functionality into a separate service that is running independently on a different port number along with its own configuration for the database. I hope this has been useful and I hope you have been able to follow along so far. All right, so now is the time that we begin setting up our user service. And whenever we talk about the setup or setting up a new project in Spring Boot, we need to head over to our favorite website, which is Spring Initializer at start.spring.io. And that is where I have landed. Now what I'm going to do is I'm going to make sure that I select all the relevant settings and I enter all the relevant details like dependencies, and I get the project zip onto my local machine. So I'm going to make sure I select Maven, Java, and the latest non-snapshot version of Spring Boot. Now, regarding this version, you must be aware that you might see a different version number depending on when you are watching this video, because Spring Boot releases every now and then a small minor version, okay, every now and then with some fixes. So this number might be something different for you, but don't worry about having a different version number over here for Spring Boot, because that is not going to impact anything. A lot of changes that or a lot of releases are improvement fixes, okay, and if there is any major change, I'll make sure I update things over here. All right, so yeah, be sure to select the non-snapshot version like this over here, whichever is available. Now in group, I'll enter details like com.eCommerce over here. This is the group, and here I'll enter user. Right, so this is the package which gets auto-generated. Description, you can write a description like user service for e-commerce app. Okay, e-commerce application. Okay, something like this. Whatever description you want to add. Make sure you select jar and the latest version of Java. All right. Now, talking about dependencies, we are going to need a few dependencies. So what dependencies should we add? So the dependencies will be web, the first thing, because we are building REST APIs. And I'll need Lombok that will help us reduce the boilerplate code. So that is what I'm going to add.
Next, we need JPA, and I'm also going to need H2 database. So we'll begin with H2 database, and then we can migrate to different databases as well. So let's begin simple. Okay, H2 database. So apart from these, I don't think we need anything else. If we need anything, we can revisit this page later on. Now you can explore the project structure over here that Spring Initializer will generate for you. Okay, you can explore it from here. Otherwise, you can just say generate and get the project zip file downloaded onto your local machine. Okay, so what I'm going to do is I'm going to say generate and get the zip file on my local machine, and I'll save it into a folder that is my workspace. Okay, and where I'm building this particular project. So I'll just do that. So here you can see like this is the folder where I'm adding all the microservices. Okay, you have this additional folder that you see over here. So under this additional, I have a couple of apps like eCom application and First Spring. Okay, so I have organized it in such a way that additional has additional projects, and all the other main e-commerce related microservice will come over here. So this is the user microservice. I'll just say right click. I'll say extract over here, and you'll see this user folder come in, and just delete this other folder, which is a zip file, because we don't need that. Now what we need to do is we need to open this particular user project in IntelliJ, and for that I'm going to head over to IntelliJ. So I've opened IntelliJ over here, and this is a kind of welcome screen that you're going to see. On the right hand side, I'm seeing all my recent projects. Okay, if you are not a user of IntelliJ, you're not going to see the recent projects like I do. Okay, now what I'm going to do is I'm going to say open and quickly navigate to user microservice that you have unzipped, and within that folder select form.xml. Once you do that, say OK. It will ask you whether you want to open this particular file as a file or you want to open this as a project. So just say open as a project. The moment you open this as a project, you're going to see some sort of processing here on the bottom right, which just happened for me. And when you see that processing, it generally means that Maven is downloading all the dependencies after reading the pom.xml file. So IntelliJ has identified this particular project as a Maven project, and based on the contents of pom.xml and the dependencies that you have added, it is fetching all the dependencies and the necessary libraries for your project to function normally. All right. So with this, if you are able to reach until this step, we have successfully created user service in IntelliJ, and we are ready to take it to the next step. So now let us begin working on the product microservice. So what I will do is here I also have the monolithic version of the application open, and I'll head over to src. Okay, and here we have all the files for the entire application, and from here we need to get the relevant files for product service. So I'll start selecting the relevant files like product service over here. I'll make sure I hold control on Windows or command on Mac whenever I'm selecting a file so that I can do multiple selections. So I'm holding control and I'll do the selection here. I'll release it. I'll come over here. I'll select the product over here from model, then product request in product response, and then the product controller. So I have these many files selected. I'll do Control C and I'll come over here and I'll paste it over here, like under product, something like this. Now all the files have been added over here. Okay, and this is not, of course, the way how we would organize. So I'll have this set to repository. Okay, repositories. Okay, and then I'll have models over here. So here something like this, and then I'll have controllers, and then I'll have model controllers, and then I need DTOs, something like this. Okay, now I'll move this to, okay, one second, let me expand this a bit so we can see complete package names. I'll move this to controller. This will go into repository. We will have request response go to DTOs, and we have service go to, okay, service is not created, so I'll create that, but this product goes to models. Okay, I'll right click, I'll say package, I'll say services, And then I'll move this service to services, something like this. This is done. Now what we will do is we'll have to come over here in application.properties, and I'll rename this application.properties to that of application.yaml. You can continue using properties file if you wish to, if that's your preference, but I'll switch over to YAML configuration. And here I'll say Spring application, and then then I'll say name over here, and then I'll say product service, I'll say, right? Now here I'm going to define the port server : port over here is 8081, something like this. Okay. Now we need to add some configuration related to the database, right? So for that, I'll have to head over to our main project over here, which is the Monolith application. I'll head over to resources, and I'll get this H2 configuration from here. Okay. And what I will do is it has to be pasted under Spring over here. So I'll just paste it over here. Something like this. Okay. So I'll paste it like this. And then I'll remove the comment form. Okay. Like so. This is done. And yeah, we have the database setup as well. Okay. So this is done. I don't think we need any other sort of changes here in the application. What we can do is we can actually test this application. So I'll head over to the application file and let me run this project. So I'll enable annotation processing because I'm being prompted for. Okay, I'm seeing an error related to, this is all the issues related to Lombok that might have occurred when we imported the project. So just head over to settings, go to build deploy over here. Okay, annotation processing, select the file. Select this profile for product and select this obtain processor from project class path. Say apply and say OK. All right. And then just run the entire project. Okay. Now it should work fine. And let us see if what all we see on the console. So you can see the database connection has been established. You can see the tables are being dropped over here. Okay. And if you scroll down over here, you can see the application is also started. And H2 console is also available over here. Okay. So I'll come over here to Postman. I'll close everything. And I'll go to collections. We need to test our application, right? So I'll come over here to Monolith. And I already have this folder for products. So I'll just duplicate this. And I'll move this products to Microservices. And I'll just rename it over here. Okay. So I'll rename it to something like this. Okay. And then from here, I'll just open the product. Okay. And here, I'll just change this to 8081. Okay. So now let us try querying and try creating the product over here. Okay. So this is a JSON that is set. Okay. I've just updated the port number. The request is entirely same. Okay. Come over here. Okay. Now here, I'm going to head over to H2 console. And this won't work. Okay. So I'll update this to, so this is the H2 console open on 8082, right? So I'll just navigate to 8081/H2 console. Like so. I'll say test connection. Test is successful and say connect over here. So the connection is established over here, and you can see over here, like you have the product, like the product model up here over here. Okay, I'll create a product. Let us see how it's created. So I'll just say send over here. So you can see 201 created. Okay, and if you come over here, if you say run, you'll see the product being created. You can see, okay, without any hassles, right? And now you can, you have the ability to update the product as well. So I'll update this to 8081. I'll say update it with this name. So iPhone Pro updated and all. Okay. So I'll just send this. And now if you come over here, if you run it, you can see it's iPhone, latest iPhone. So it's iPhone 16 Pro. That is what the name is. If you run this, it'll become iPhone 16 Pro updated, right? So indeed, the update query is working absolutely fine. The update endpoint. Okay, this is done. I'll try to get all the products. Okay, so I'll get it from ed1 over here. You can see all the products here. We just have one. Search the product. So you can search for iPhone over here and we'll update the port number. You can search it. You can see iPhone, and if I say iPad, it won't work, right? But it is working for iPhone. So if I add iPhone here, it'll work, right? So this is working fine. You can delete the product as well. So I'll change the port number to 8081 and I'll try deleting this. So you can see this is deleted and now you won't see any sort of products over here. Okay, so deletion means it's being marked to active as false. So yeah, none of the products are active. That is what it means, right? So this is done and all the endpoints are working. So better I'll save all the endpoints like this. Okay, just make sure you save so that you have all the endpoints up and running over here. Okay. So yeah, that's about product microservice. You can take a look at the console as well. The stack trace, you will see all the queries depending on which API you are calling being printed over here. All right. So yeah, that's about the product microservice, and I hope you were able to follow along easily. All right, so now is the time that we begin working on the order microservice, and we set up the entire microservice to work in our microservices architecture. Now, I want you to take this up as a challenge. So set this up, set the entire order microservice. You are already aware of the steps that we are supposed to take. And I would encourage you to take this up as a challenge wherein you set up the entire order service on your machine. Okay. And yes, I will be doing here as well and I'll be showing it to you, but I want you to take up the charge and take it up as a challenge and try to do it yourself. So the goal of the challenge that we have over here is to get you hands-on with writing code. And basically when you go hands-on with writing code, you gain confidence, and that is what my aim is. So I would encourage you to take this up as a challenge. Set the order microservice onto your system. If you're not able to, no worries, don't get scared, no worries. You can come back and watch the solution. Mistakes can happen. Don't worry and don't get discouraged about the mistakes. Like I said, the goal of the challenge is not to get the right answer, but it's to get you hands-on with doing stuff. So pause the video right now and attempt this challenge. All right, welcome back. I hope you all had a chance to attempt this challenge. Now I'll go ahead and I'll set up the order microservice. So what I have done is I've opened this start.spring.io, which is Spring Initializer. And I already have the setting for product microservice, which I'm just going to edit, right? So I'm going to make sure, in fact, that Maven is selected, Java is selected, latest version of Spring Boot, that is non-snapshot, is selected. And now over here in the project metadata, I'm going to update artifact to that of order over here and product service to that of order over here. Okay, this is done. And packaging is jar and Java version is 23 over here. Okay, so all these things I'll make sure that I have selected over here. And on the right hand side, I will add dependencies like Spring Web because we are building a RESTful API. So we need this dependency to mark our project as a web project. I'll add JPA because we are persisting data to database. H to database because we want to make use of a fast, in-memory, easy to set up database. And that is why we are going ahead with H2 for now. And then we'll make use of Lombok, of course. It is going to help us reduce a lot of boilerplate code. Now say generate, and what you can do is you can get the zip file of this entire project set up onto your local machine. Now once you have the zip file on your local machine, extract it because zip is not the format in which we'll import it into IntelliJ. And then once you have the unzipped version, download the zip version. Okay. Now we have order over here. Okay. Now what we need to do is we need to head over to IntelliJ and get this project imported and set up as Maven project in IntelliJ. So I have IntelliJ open over here, and this is a welcome screen where on the right hand side I'm seeing all the recent projects. I'm going to quickly say open over here and navigate to order service that I've just unzipped. Select pom.xml from the folder and say OK. Now you will be asked whether you want to open this project as a file, or open this file as a file or a project.
Okay, so of course choose open as a project because we don't just want to deal with file, but we want to deal with entire project. Now after you select this, you'll see some sort of dependency resolution happening on the right hand side bottom, which just disappear for me. And what that does is it will fetch all the dependencies on your local machine. Okay, now you have the project set up and project is imported as a Maven project on your local machine. So with that said, we have successfully created order service on our local system. Now, once we have the project set up and open in IntelliJ, we need to add all the source code. And all the source code right now exists in the monolithic application, which I also have open over here in a separate window. Now, I would want you all to take this up as a challenge wherein you migrate all the source code and refactor the order microservice that you have created over here and add all the source code that exists in the monolith application and get it configured with the database. You should be able to do it. Okay, I trust you with that. So please attempt this and take this up as a challenge wherein you try this out yourself. And if you're stuck somewhere or if you're not able to, don't worry. You can play the video and watch the solution, watch me doing the same thing, and you can follow it as well. All right. So pause the video right now for trying it up yourself. I hope you all had a chance to attempt this yourself. What I'm going to do is I'm going to begin migrating the code. So here I'm here in IntelliJ. Okay, this is the another version of IntelliJ wherein I have this monolith app open. I'm just going to expand all the controllers, the repositories, models, services, and DTOs. Okay, and whatever is relevant to order microservice, I'll just select this. So order controller, cart item request, order item DTO, order request. I'll select all of these. Okay, then from here model, I'll have cart item, order, and order item, as well as order status. So order microservice or order service has everything related to cart and order. So I'm just selecting all of that. Okay, and repository, I'll select cart item repository and order repository. Then I'll scroll down, I'll select cart service and order service. I'll copy all of this, Control C, come over here, go to SRC, and I'll paste all of this over here. Okay, everything is added, and now we need to reorganize everything in the right packages. This is not how we should have it, right? So I'll just start creating packages for repositories. Okay, then I'll have a new package created for DTO, then one more package for controller, then one for services, and I'm going to have I don't think anything else is left. Okay, let's start moving everything. So I'll select controller, both the controllers, cart controller and order controller to the controller over here. Okay, then I'll have cart item, order, and order item being moved to that of the models. Okay, models is something that we have missed over here. So I'll just create models over here. Okay, something like this. And say cart item, order, and order item to models over here. Then I have order item DTO and order response and cart item request. So all of this I'll move to DTOs. Then I have service. So order service and cart service both move to services. And then I have repository, both the repository moved over here. So where should order status be? So in my opinion, 1 second. So let me check where order status exists over here. So order status is a part of model over here, right? So I'll move order status over here. So we have cart item, order, order item, and order status. So cart item, order, order item, and order status. Here we have request, cart item request, order item DTO, and order response. So here we have cart item request, order item DTO, and order response, which is perfect. These two controllers, and these are repositories and services. Okay, so this is done. We have added all the source code here, no errors as such, which means everything is good. Now we'll add the configuration. Now for configuration, I'm refactoring this to YAML file. So I'll just say YAML over here. Instead of having this as application.properties, I'm switching over to YAML file. If you want to continue with properties, that's absolutely fine. Okay, it's just a matter of choice. So Spring application name order service over here. Okay, and then I'm going to say server, and here I'm going to say port, and I'm going to say 8083 over here. Okay, so this is the port where I want my order service to run. And I'll come over here. I will add the configuration for the H2 database, which exists over here in application.yaml, and I'll paste it under Spring. Okay, so this is done, and then I will uncomment this. Okay, so this is done. We have everything like H2 console enabled, data source set, JPA properties also set. Okay, now as a next step, I will begin running this application. So I'll just run this. I'll say enable annotation processing. Okay, I'm bound to get this error. Okay, so this is a Lombok related error wherein all the getters and setters are not working. So I'll come over here. I'll go to settings, and like always, I'll go to build execution deployment, compiler, annotation processing, select obtain processor from project class path, say apply, and then restart the application. It should work this time. Okay, so we are getting an error over here. What is the error? So let us take a look. So com.app.ecom.model.product. Okay, so these import statements are not working. So I'll get rid of these import statements. And okay, so we need things like product repository over here. Okay, so we need to validate the product. Okay, so let us take a look. So why do we need product repository first of all? Product repository is needed to validate the product. Okay, so I'm going to get rid of this for now. Okay, because okay, so I'll keep things simple right now. I'll just get rid of this, and product over here, user. So these two things that are related to product and user, I'll get rid of them. Okay, I'm just commenting them off. Okay, we don't need user as well as the product repository over here. Okay, and then I will come over here, and here you can see I'm getting few errors here. Now if you come over here to cart item .java, okay, these are the models, cart item and order over here. Okay, you'll see there are references to product and user. Okay, but these models do not exist right now, right? So what I will do is I will get rid of these. Okay, like after ID, we have user and product. So I'm going to say, instead of the model references over here, I'm going to say private string user ID over here. And here I'm going to say private string product ID, something like this. Okay, so I'm converting the models that I had, the references to model, to that of the IDs, normal IDs. And for this user over here, okay, I'm going to just add user ID. Okay, we don't need anything else. So once this is done, okay, if you go to repository, let us check repository now. So cart item repository, you have these methods over here that are referencing the models over here. You can see user, and user over here. They're referencing product as well. So I'm going to like update this to IDs. Okay, so here I can say string user ID over here. Okay, and this will be product ID. So because model do not exist, right? It was fine in Monolith application. So here I'll work with ID, because we are going to store the references to ID over here. Instead of storing the entire user object and creating a join, I'll just have the reference as ID. Okay, so user ID. So this way we'll be able to do the linking. Okay, so that is what I'm doing over here. And here this method name will also change. So this will be user ID and product ID. Okay, and yeah, so this is done. Delete by user and product. So I'll just copy this, I'll paste it over here. So this also will be ID over here and ID over here, something like this. Okay, then I'll copy this and I'll say user over here. Okay, find by user, instead of user it will be ID, because you know these method namings are important. When you say find by user, it will look for the model. Okay, so there is no field called user. We have renamed it to user ID, right? So this won't work. So the field name should be user ID. if the field name, the function name, sorry, the method name here should be user ID because the field name is user ID, right? So that is important. Here also I'll update this to user ID, okay? And I'll rename this to delete by user ID, okay? All this is done for the repository. I will get rid of these imports, okay? And here I'll come over here, okay? And this is fine, this one. Now we'll come to service over here. So here I'm going to now pass in the user ID and the product ID, okay? Now after we are done with cart item repository, I'll come over to order item over here. And here we have a reference to product, okay? So this is also not needed over here. So I'll change this to private string, and I'll change this to product ID over here, something like this, okay? So this is fine, and let me see if I have anything else over here. Do I have no errors as such over here? Okay, so all the issues in the models have gone now, right? Now after making changes, let me explain what changes we did so far and why we did, okay, explicitly, so that you understand even more clearly. Here we had product, the reference to product model instead of product ID. Here we had reference to user and product, right? So all these references to models, we have replaced them with the user ID, with their respective user IDs, right? Now, why did we make this change? Because we are switching over to a microservices architecture. And understand this here in Monolith application. So here we have this Monolith application. We have, if you scroll up, we have order over here. Now this order has reference to that of user. Order item has reference to that of product. So here these references are possible because it's a monolith application, and this product model also exists in the same project, right? But here, those kind of references we won't want to have because we are switching over to microservices architecture. And in microservices architecture, the way services interact with each other changes, and hence we make use of ID, like IDs instead of direct entity relationships, right? So we are storing IDs over here. And this is because this service, like the order service, is going to have its own database, right? And in its own database, it is going to store the reference of the user who is having or has created this particular order, right? And since microservices do not share a database, direct relationships are not possible. So here direct relationships were possible. You did direct relationships over here with the help of, you can see over here, you did many-to-one relationship. Here, you also have many-to-one relationship. Because shared code base, it's a monolithic application, and shared database. So those linkings were possible. But here you have different databases. So how will you link them? How will you create relationship, right, between two entities residing in different databases? And they might even be stored in different form. So right now, you are making use of relational database. Tomorrow you might switch over. One service might switch over to MongoDB or NoSQL. How would you handle this? So that is why you cannot have entity references. You are having IDs over here for the betterment, right? And in future, like here, if you come over here to service, here I have commented this code just now. Okay, so here what we were doing is we were looking for product first, validating the user. So we were validating the product first, and then we were validating the user, right? So these all validation needs to happen with inter-service communication, okay, which we will be doing. So right now I've commented this code, okay, so that we get away with the error and we are able to run the project successfully, okay. But normally in microservices architecture, you have inter-service communication, wherein you have communication between two microservices, wherein these kind of validations and communication are possible. Okay, so what I will do is I'll now again take a look at users order service, okay, where all I'm getting red marks. So here you can see I have access to user repository. I don't need user repository. I'll get rid of it. Okay, I'll get rid of like the imports also from here. Scroll down. Here you're validating for the user. So I'll just comment this out. Will not validate for the user over here. Okay, this is commented. Scroll down over here. Instead of set user, I'm going to call this at set or user ID. Okay. Now, do we have ID over here in this method? Yes, we are accepting it as a parameter, right? And on the basis of this only, user ID, we were getting the user over here. You can see this on the basis of this user ID. So I'll scroll down and I'll add user ID directly over here. Now scroll down over here, you're getting a red mark over here because order item does not have product. So it has product ID. So I'll update that. Scroll down. Here you're getting product, and from product you're getting the ID. So since now it just has product ID, I'll just add ID over here. This is done. Okay. So this is throwing red mark because order item DTO has product. Okay. So let me see what is there in order item DTO. Is DTO a problem? Okay. So let me see. If you hover on this, it says, oh, so it says the second parameter of the constructor is long. So you should change it from long to string. So that is one thing that we can do over here. Okay. So one thing is I will come over here to order item DTO and I'll update this to string, to product ID, something like this. Okay. So this is done. And I think this is it for order service. All the issues are sorted. Now coming to cart service. Okay, I have already commented this product repository and user repository. We don't need it. So I'll get rid of these straight away. Okay. And here we have some code to basically look for product and then look for user. This is a validation step. Okay. So I'm not taking a look at it. This sort of validation can happen in microservices architecture with the help of inter-service communication, but we are not doing that right now. So I'll just comment this out. Okay. Now here cart item repository. So let us take a look at cart item repository. Where is repository? We have a method already, find by user ID and product ID. So I'm going to say find by user ID and product ID. And over here, I'm going to pass in user ID. We have access to user ID. And here I have access to, so do I have access to product? Okay, I don't have access to product, but I have access to cart item request. So I'm going to say cart item request dot, okay, wait a minute. So cart item request has this object request over here. So I'm going to say request dot get product ID. So that is what I'm going to get over here. Okay. So here now, okay, this is done. Okay. So this is taken care of. This is still throwing an error because, required type is string, but we have provided long over here. So what you can do is you can come over here, item request, and here I'm going to change this to string. Okay, this is done. Okay, or you can even, so let's have a way wherein you have all the IDs being stored as long. That is a call that we can make. Otherwise it will get it will be a problem. Okay, so what I will do is I'll change everything to long over here. Okay, so I'll just copy long, user ID is long over here, and let me come over here, order item, this is also long, cart item. Okay, so it has user ID and product ID. So this is done. Okay, long over here also long, and so now this is throwing in an error over here. Okay, because it requires string and we are providing long. Okay, so what I can do is I can wrap it using string.value of, or I can come over here. So this is coming in from cart item request. So this can be accepted as a string if needed. Okay, this is done. Then okay, in cart service again, if you scroll down, so here you have references to product, you can see over here. Okay, so here what I'm doing is when I'm setting the price this way. Okay, so you can see over here I am getting the price and I'm actually I'm getting the price from the product over here, the product object. Now over here we don't have access to price actually, because here we are just getting cart item request. Cart item request is just giving us a couple of things like product ID and quantity. Okay, and we don't have access to the product details. So what I will do is I will set a hard-coded value over here for now. Okay, we'll revisit this once we start doing inter-service communication. Okay, and when we do inter-service communication, that is when we will have the actual value. So I can set this to whatever value you want. Okay, so I'll hover on this. This is accepting big decimal. Okay, so here it is not accepting because this is not a big decimal. So I'll hover on this and you can see I get a suggestion, wrap using big decimal value. So I'm setting it this way. Okay. And here, so this is done. Okay. Here we are creating the cart item. Okay. And this is, so here if you see, if there is no cart item with this product, then this is created. Okay. And in the other condition, wherein we have to create a new cart item, we'll have to update this. So this will be set user ID, and instead of user, it will be user ID. This will be product ID. Instead of product, it will be cart item dot get product ID. Okay, or 1 second. So here, this will be, so this is not null, right? So this is not null, so we are updating it. Okay, but otherwise we'll have to get it from here, request, right? So here I'm going to say request dot get product ID like this. Okay, and then I'll say request dot get quantity. And then for setting the price, I'll again have a hard-coded number over here, something like this. Okay, so I'll change it to something like this. So this is done. Okay, for deleting the product from the cart. Okay, so we have user ID and product ID over here. Okay, and we are checking for this. Okay, so I'm going to say, so let me update this. So here we'll update this method to delete by user ID and product ID. Now what I'm going to do is I will get rid of these two. Okay, here what we are doing is we are looking for product and then user, and then we are checking if product and user is present, and then we are deleting this cart, right? Instead, what I will do is I will combine it into single thing. So I'm going to say cart item repository dot find by user ID and product ID. Okay, we have a method defined for the same. So you can see here I'll come and I'll pass in user ID and I'll pass in product ID as well. Okay, and here I'll just accept cart item and I'll say cart item. Okay, something like this. And then I'll change the condition to that of, cart item is not equal to null. Okay. And then from here, I'm going to say delete by user ID, or you can just say delete over here like so. Okay. And you have access to cart item, right? So you can just say cart item. Okay. This is done. And you can return true and return false over here. Okay. This is done. Now let us talk about this over here. So here what you can do is okay, here now I'll update this. So here what we are doing is we are like getting the cart of the user, right? So here I'll get rid of this entire thing over here. I'm going to say cart item repository dot find by user ID, and I'll pass in the user ID. So this will give us the cart for that particular user, right? And for clearing the cart here, I can simply say cart item repository dot delete by user ID, and I'll pass in the user ID. Okay, so I've updated everything mostly. Okay, there is an error that I have here, product ID. Okay, what is the problem with product ID? So I'm accepting it as a long, and here it is being accepted as a string. So I'll just change this to string. Okay. And in the controller, there will be a problem in the controller now. So if you come to, where's the controller? If you come to cart controller here, you can see this is product ID. So instead of this, you will have string over here. Sorted. I think we are all sorted now. Order controller, everything is fine. Okay. Let us try running this application. Okay. Let me run this. Let us see if we are getting any sort of issues, errors that we can fix. Okay, no issues so far. It's running and we have the application up and running. Let us come over here to I would say H2 database. Okay, so here I'll switch over to localhost colon 8083/H2 console. We'll have this H2 console, connect, and you'll see orders, order item, and cart item. Perfect. Now come over here, okay, and head over to order and cart and just duplicate these and just make sure you move these cart and order. So cart and order, we need to move over here. And I'll rename this cart copy to that of just cart. Okay. And I'll rename this order copy to just that of order. Okay. This is done. Okay. Now I'll start adding products to the cart. Okay. So here I'll change this to 8083. And I have this body wherein I'm adding this product ID 1 and quantity as that of 2. Let me send this. You can see 201 created. And here you can see, okay, there is no order, but there is a cart item. So you can see there is this cart item. Okay. Price is hard coded. That's absolutely okay. If you want, you can accept the price here, right here from the JSON. Okay. Like what is the price of this product, and then you can keep updating the price. Okay. So that is something that can be done, but right now I have hard coded it. That's okay. Now this is done. Cart item exists. Now what I will do is I will save this particular request over here, and I'll go over here to get cart. Okay. And I'll update this to 8083. Let's try getting the cart. Okay. You can see the cart of the user. So it's getting the carts of all the users. So I'll save this. You have delete the cart. Okay. So you can delete the cart you want to. I'm not going to delete right now because we want to test the order. So I'll just test the order first. So I'll come over here and I'll change this to 8083, save it. And here we have nothing in the request. I'll just say send. You can see order is confirmed, and whatever was there in the cart has now been moved to order over here. Okay, you can see over here, right? And here in the header we have this user ID, and user ID was 1, right? So you can see over here the order is moved to confirmed status. This is done, and now if you come over here, you will have order. You can see orders, right? This is confirmed, right? And this is done, and you can see everything appear over here. Now one problem that you'll notice over here, product ID is being set to null, which is not what we would expect. Okay, so let us check what's the problem. So here if you come to order service, I'm setting all the values for the order object. I'm setting the user ID, but I'm not setting the product ID. So I'll set this order dot set product ID, and I'll add the product ID order dot. So what is the product ID over here? Okay, 1 second. So here, okay, so we don't have access to product ID, but we have access to cart items over here, right? So just a minute over here, the product ID, this is the, so there will be multiple products in an order, right? So how are we setting it? We cannot set it over here. So I'll just get rid of this line that I just added, but instead it will be set as order items, right? So now the question is, why do we have this product ID field in order? Ideally, it shouldn't be there. So I'll get rid of this, okay? Because all the product related information is being stored where? In order item, okay? And if you come over here, not over here, but here, we'll have order item. So let me clear this order item. It will have all the product related information, like which product ID is ordered, what is the order ID, and this is the order ID, this is the quantity, and this is the price. So all the product related information is there. So we don't need to have the product related information here, because there will be a list of products, right? So you cannot have product ID related product related information here. So I will have to get rid of this, and that is what I did over here in the order class. I've got rid of this. Now let me restart, since we made change over here to the entity. So let me restart, and ideally it should start without any hassles. Come over here, refresh, connect, orders, take a look at orders. Okay, there's no product ID now. Now let me try creating an order. So first I'll add the product to the cart, then I'll get the cart, and then I'll place the order. Now once I place the order, if you see, all the fields are added, and an order item, all the fields are added. There's nothing in the cart item. So what I will do is I will add the product to the cart, and then I'll try deleting the product from the cart, because this API testing is pending. So I'll change the port over here to 8083. I'll save this and I'll say send. So you'll see this is deleted. So, okay, so we had added the item to the cart, but now it's deleted. We just deleted it. So it's working absolutely fine is what I mean to say. Everything is working fine. Okay. And just to give you an overview over here. So this microservice, which is order and cart, had a bit of refactoring. And there is a reason for this, because the way we were storing the information in the monolithic application, it was different, because we had all the models, and all the models were sharing the same database. Okay. But here we have multiple microservices. So we have split the microservices into multiple different services, and multiple different services will be running independently. They will have separate database, right? And for that reason, what we need to do is we need to make sure that we refactor a bit, and this involved a little bit of refactoring. And the refactoring that we did is here in the models, if you look. So I'll close everything here in the models. So I'll start with models. I'll open all the models. Okay. Now here in the models, you'll see we had references to user and product directly. Now we don't have references to user and product. So if you go to cartitem.java over here in the Monolith application, you will see there is references to product and user directly. And in fact, we have defined a join operation as well, like the join relationship. Okay. Here we don't have that. Why? Because that model does not exist. It's a separate database, right? So you cannot have join over there, but instead we need to store references, and that is the kind of refactoring we did. So here in order, also we changed this, and in order item also we changed this. Okay, and order status is anyways an enum, so no changes were required there. But once we changed over here, we needed some changes to be done at the repository level, wherein we changed the repositories to match the underlying model over here. Okay, so we updated the method names over here, like we started adding ID over here, this updated to user ID, and this over here. Okay, this repository and this repository did not have any sort of methods. Okay, so this worked without any issues. Then in service, there was quite a bit of refactoring. So in cart service and order service. So let me close all and just open cart service and order service. So in cart service, first we had a bit of validation which we have commented. So we are not looking for products over here. We are not looking for the product stock. We are not looking for the user over here, because these details are now in separate microservice, and there is a way to do this, which we'll be coming to. But right now, I didn't want to complicate things, so I have commented this out, trusting that the data that is being passed in the request is validated. Okay, it won't be validated. Ideally, there should be a validation on the engineer's side, like on the engineering end. Okay, so we need to validate this, but I'm not validating it, like I said, for the simplicity's sake, right? And we'll come to this, but right now I'm just creating cart items, hard coding the price, and we have the deletion and everything taken care of as usual. Order service also, I've commented out the validation that involved getting data from a separate microservice. So everything is working fine, and our microservices are up and running. I hope this has been useful, and I hope you have been able to follow along. So right now, as you can see over here, I have all the microservices up and running. Okay, so this is one window wherein you can see like there is this product service up and running. You can see if you scroll down, the Tomcat is running on 8081. Okay, so this is a service running on 8081. I have this other microservice, which is order, and there is one more called user. Now, if you see user microservice, this is running on port 8082. Okay, so this was 8081, this is 8082, and you have order, which is running on port 8083. So if you scroll down over here, okay, if you just go down, let me see. So, okay, I'm not able to find port number, but it should be somewhere on the console, but it's running at 8083 over here. Okay, now the thing is, these microservices have different views. Okay, so you can see here I have this one window of IntelliJ wherein I'm seeing product. I have one window of IntelliJ order, one window of IntelliJ for user. Now you can either continue developing the application this way wherein you have to switch between windows, but I would generally prefer having a unified view for all the microservices over here, right? And for that, what I'm going to do is I am going to open. So I'm going to come over here. I'm going to say open over here. When I say open, you'll see this kind of pop-up open up. Okay, and now what I will do is I'll come over here. So this is ecom microservices folder, and under this ecom microservices folder, I have all the three microservices, as you can see over here. Okay, and then I have additional folder wherein I have additional projects, which are Monolith application of ecom and the first Spring. Okay, so I'll just select this ecom microservices folder over here, which is the root of all, and I'll say OK over here. Now, the moment I say OK, I'm being asked for how I want to open this project. So do I want to open this in this window or in a new window? So I'll say new window. Okay, and I'll have this project open up. Okay, now what I will do is I'll stop all the other services. I'll just stop
order application. I'll stop user application. I'll just close them. Okay. You can close the order application as well. Okay. And I'll just expand this. Okay. So I'll just make, and I'll also shut product services. Okay. And I'll just expand this window of IntelliJ. Now here, you'll see all the folders over here. Additional, order, product, and user. And now you are seeing this pop-up at the bottom where it says Maven build scripts found. So it has identified that user, order, product, and all these like additional FirstSpring and additional eCom application are Maven projects. So do you want to load these Maven scripts? If you say load, you will see all these projects will be loaded as Maven over here and they will be imported. I'm not even seeing this M icon over here on the right hand side. Okay. Now you, of course, if you don't happen to see this kind of a pop-up, okay, what you can do is you can go to individual microservices over here. Okay. Right click on this. So when I say right click on this, meaning right click on pom.xml. Okay. This is a pom.xml file. So right click on pom.xml and here you have an option to add this as a Maven project. Okay. Why am I recommending this? Because here is where you're seeing this option. You won't see this option over here. So here on the right hand side, normally if you have Maven related projects identified, you will see Maven icon over here on the right hand side. Okay. So that we are not seeing. So what I would do is instead of like adding it this way, you can add it this way as well. Okay. I can just say add as a Maven project and you can see this project being identified as Maven project now. You can see, and you have this Maven icon coming over here as well. Right. And then you can add the rest of the projects from here. So once you have this Maven icon come in over here, what you can do is you can click on add Maven projects. Okay. And you can basically import all the projects. Okay. So you can say order. So we have added user, right? You can go to order and you can select pom.xml of user, or sorry, order. And then you can say, okay. So you can see now order also has that icon of Maven, right? So you can see user has that Maven icon, order has that Maven icon. You can do so for product. Okay. And that pop-up also went away for me. I didn't click. It was there for a while. Okay, but I'll add everything this way. That's absolutely okay. All right. So now it will get added over here. Okay. You can see, so all these projects now have been added as a Maven project. Okay. And now you can see like I have a unified view of everything. Okay. So normally this is a problem where people don't see this Maven icon because according to IntelliJ, there is no Maven project initially. Okay. Unless and until you click on load Maven scripts, of course, which I didn't do. So I didn't have that and I chose the difficult path because normally learners often face this kind of a situation, right? So how to get this? You can like add this as a Maven project and you can do this for all the projects over here. Go to Maven and here you will see add as Maven project and you will see the project being added as Maven. Okay. Now what you can do is provided like all the microservices that were running in the individual views have been shut, you can come over here and you can run all the microservices from here also. Okay. And the benefit of this is if you click over here, this is services tab. If you click over here, you can see all the microservices being added as a service. So let me show it to you. So you can go to add service. Okay. And here you can say run configuration type and you'll select application. Okay. So this is something that I've selected now. Okay. Nothing is happening now, but let me run one microservice. So I'll go to user, I'll go to SRC and I'll go to the main class and let me run this and I'll enable annotation processing over here. Now I'm getting an error. Of course, this is the Lombok related issue. So maybe the settings got modified. So I'll go to settings over here, build execution, go to compiler, Java compiler, and okay, not compiler, annotation processing. Select the annotation profile for all. Okay, so basically order, product, and user, and make sure for all you select obtain processor from project class path. Okay, and just say apply and say okay. And once you do this, try running user application. Okay, so I'll just say run. Okay, you should be able to see user application running. And now here you can see under services, since you ran this particular application, you're seeing user application running over here. Okay, and you can see the logs over here. Now let me run some other microservice. So I'll run the order over here. Okay, let me run order. I'll go to the file. So this is the first time we have to navigate to the main application file and run it, only the first time. Then it gets added over here. You can see as a service. and it also is added as a configuration over here. So you can run it from here as well. Okay. Now you can see this is also running. Okay. And then let me run the user service. Okay. So user is running, sorry. So let me run product. Product is not running. So I'll go to product here. I'll just run this. Oops. So I'll just run this. Okay. So this is running now. You can see there are 3 microservices running in their own unified view over here. You can see, and here you can switch between services to see the logs of respective services. So for user application, you can see this is started and it's running on port 8082. Product is running over here on port 8081. It started successfully. You can see over here. Okay. And then you have order that is running on, you can see over here, it started and it is running on 8083. Okay. We are not seeing the, okay, you can see the port over here, 8083, right? So all the 3 microservices are running, and now you can stop the microservices from here. So I can stop it from here. I can stop it from here. I can stop it from here, right? And I can even start it from here. So this is another way. These are run configurations. Okay. You can start them from here. You have an option to do so, or you can select all and start all at once over here. You can see, or you can select the application at the top and say run, and all will be started, right? So it's very simple to manage multiple microservices this way in a unified view with IntelliJ. Okay. And you can also take a look at Postman over here. Okay. And Postman, if you see, okay, you are going to see like everything working fine. So here you can add a product. So I'll add a product. You can see product created. I'll add a user. You can see user created, and I can add the product to the cart. You can see it being added. Okay. And you can place the order as well. Okay. The order is placed. You can see, and they all are running in their respective databases as well. So we have H2 database configured. So here, this is 8083, which is, so you can see the port number. This is for the order. So if you go to orders, you will see one order inserted, which we just did. Let me duplicate this. So I duplicate this and I go to 8082 over here. And on 8082, you will see all user related information, which is fine. Let me duplicate this and let me go to 8081 over here. And here you will see all the product related information, right? So you can see separate databases, separate consoles on different ports. So we have different instances of in-memory databases running on different ports. We have different APIs running on different ports and different microservices running in a unified view with IntelliJ. Now, why have I opened this root folder over here? One question you might ask, why have I opened this root folder? Okay, so the way my project is structured. Okay, so if you take a look at my project structure, this is my folder, the main folder, wherein you have like things like order, product, and user. And here under additional, I have like ecom application and first spring. Okay, and this is the .idea folder, which is generated by IntelliJ for storing some workspace related information. Okay. So yeah, this is how it's structured, and if more services are added, I can easily see those services over here in a single unified view. So tomorrow, if I add one more microservice over here, I can see them in a unified view over here itself. Okay, and I can add it as a service, and it's easier for me over here to navigate through the logs of multiple microservices and see what's happening. Okay, instead of having separate windows. And that will also consume a lot of system memory on your local machine. And you yourself will get confused if you open so many windows on your system. So this is better and easier approach to work on a microservices architecture. I hope this has been useful, and I hope you found a lot of value in this. So right now our applications are pointing to the H2 database. So what I'm going to do is here we have all the microservices running in a unified view. Okay, and we are all communicating, they're all communicating to PostgreSQL. So I would want to change, they're all communicating to H2 database, sorry, not PostgreSQL. And I would want to change that and point them to PostgreSQL. So what I'm going to do is we already have PostgreSQL configured over here in the monolithic application. So this is a monolithic application. For configuration, what we had done is, we have this dependency, okay, that we need to add. And here in the application.yaml file over here, we have some configuration that we need to add related to data source. So this is the configuration that we need. Okay. And of course, we also need the database. So that is something we'll be coming to. But first, let us configure the application to work with PostgreSQL. So I'm going to take this dependency, which is PostgreSQL dependency. You can even get this dependency from Spring Initializer, which is start.spring.io. But I'm getting it from here. You can come over here to the application, which is Microservices. And here you can open the pom.xml of all the microservices. So you can see this is for user, product, and then we have for the order. And then I'll add them over here. So here I'm going to add it above H2 database. So like so. And here I'm going to add it something like this. Okay. I'm going to resync this. Come over to product and here add this, and you need to comment this out because we don't need H2 anymore, right? And I'm going to reload Maven changes because after doing any changes to pom.xml, you have to make sure you reload Maven changes so that the fresh set of dependencies is updated and the things that you've commented is removed. Okay. So that syncing process is done over here for product, and then we come over here and for this over here for order, I'm going to add this, and I'm going to add H2 database, something like this. And I'm going to resync this or load Maven changes. So things are done. Okay. Now, once this is done, what you need to do is you need to update the configuration for individual services. So I'll close all the pom.xmls and I'll switch over to open application.yaml files of all the services. So I've opened for order. I'll open the same for product over here. Then I'll open the same for user over here. Okay, something like this, like so. Oops. So I've opened it for all. I'll collapse this and I'll come over here to our monolithic application and I'll copy the configuration. So this is the configuration that we need. So I'll just copy this, come over here. Okay. And here I'm going to update this. So here, right from this H2 part. So this thing we don't need, right? So I'm going to comment this out first of all. And then here I'm going to paste this, something like this. Okay. Just be sure of the indentation. It has to be below Spring data source. So data source is below Spring, right? So that is how it should come in. Okay. And I've added it over here. I'll add it to product as well. So I'll just comment this out like so. I'll come over here and here I'll paste this. Okay. I'll again come over here and I will add it under here. Okay. So this is done. And now we need to make sure that they point to the individual versions of the database. All right. So this order service will point to order over here, the order database. Product can point to product and user can point to user DB. Okay. I'm not creating a database with the name user because that might be a reserved word. So I'm having user DB just in case, right? So I'm doing this, product is over here, and then I have order. Okay. Now we need to make sure we have an instance of PostgreSQL up and running. And for that, what I'm going to do is, if you come to Monolith application, we already have an instance of, we already have the Docker Compose file. What I can do is I can copy this Docker Compose file. I'll come over here to Microservices project and I'll paste it in the root, which is Microservices. I'll paste it over here. So you can see I have a Docker Compose added over here. Okay. Now in Docker Compose, nothing changes. Okay. It's the exact same configuration that we need. Okay. So nothing changes. We have username, password as to what we need. We have pgAdmin as well. Okay. But to run Docker Compose and to make sure the database is up and running, we need Docker and a terminal, right? So what I'm going to do is I'm going to come over here. Over here. Okay. Here I have this terminal and I also have Docker up and running. Okay. Now, if you take a look at Docker, I have the containers running. Okay. I can get rid of these containers. Let me delete these containers. Okay. And let me also delete the volumes associated with the containers. Images is fine. I'll have the images. That is completely okay. Now what I can do is here, I have navigated in the terminal to the root directory of the project. You can see this is the root directory of my project. If I do ls, I'll have Docker Compose, which I just added. help.md, Maven wrapper. And okay, so this is not the root of the project. I have actually navigated to the root of the monolithic application. So I'll just come couple of steps above and I'll come to this ecom microservices folder. This is the folder where we have pasted the Docker Compose right now. Okay, ecom microservices. And now if I do ls over here, okay, so if I do ls, you can see Docker Compose YAML over here. Additional is the folder that I have. And then I have order, product, and user over here, along with readme md. So I'll just do a clear over here. Okay, so this is where we are. Okay, now what we can do is we can say docker compose up -d. Okay, this will start the PostgreSQL containers. And before running this, just make sure you are in the right directory and you have Docker up and running. I'll just run this. Let me see how this works. So you can see the container is started. Everything is started. Network volumes are also created. You can come over here to confirm. So here, if you see, you have containers up and running. Okay. So since these containers are running, what I need to do is I need to log into pgAdmin. Now, why I need to log into pgAdmin? Because every microservice needs a different database. So if you come over here, every microservice needs a different database. You can either point them to a single database, which is EmbarkX. So if you're creating a user over here, so in Docker Compose, we are creating a user, right? So database with this name will automatically be created. So let me show it to you. So if I come over here, okay, so where is our pgAdmin running? So if you scroll down, pgAdmin is running on 50/50. Okay. So if I come over here, I can see localhost : 50/50. So you can see pgAdmin being loaded. I can set the master password as admin and I can just log in. And I need to add a new server. So I'll say register server. I'll say Postgres. Okay. And I'll go to connection tab. I'll say Postgres over here. This is the instance name. And then I'll add the username as EmbarkX over here. And these are the credentials that you've added in the Docker Compose.yaml file. Okay. And I'll say save. You can see the connection is created, right? And you have two databases. One is the default Postgres and the other one is EmbarkX. Now, why is this EmbarkX database created? Because you are creating a user in Docker Compose file as EmbarkX. So a database is associated with that user that is created, right? Now, either you can have all the applications point to this single user or the single database over here. Okay, instead of product, user, and instead of UserDB, product, and order database, you can have just single database and everybody pointing to that. But that is not what we are going to do. Okay, we are going to have separate databases for different microservices. So I'll come over here and I'll get these databases created. So here I'll say create database and I'll say user DB first. I'll say save. I'll again create. I'll say product, something like this. And then I'll create one more database, which is the order database. Okay. All the databases are created now. Okay. This is done. Okay. Now what I'm going to do is I am going to run the application. So I'm going to stop all from here. The red button, I'll say stop all. Or you can even stop all from services. Okay. And you can start all from here as well or from services. So I'll just start all from here. Okay. And you can see all the microservices are starting now. Let us see. Okay. Order is giving an error. Product is giving an error and user is also giving an error. So what is the error? Let us take a look at the error over here. Okay. Okay. So it is saying unable to create. Okay. Let me scroll up. So it's saying unable to. Okay. So bean creation exception, entity manager factory. Okay. So it's failing to authenticate to the database. Even though our credentials are fine, it is still failing because in Docker Compose.yaml, we have mentioned the same credentials. User is EmbarkX, password is EmbarkX, and I've added this same username password over here in the application.yaml for all the microservice, but still all are failing. So why is this happening? So one reason why this is happening is I already have PostgreSQL installed on my local machine. Okay, so understand this. I have PostgreSQL installed on my local machine, and I have PostgreSQL up and running as a Docker container. So what is happening is when you are trying to connect via the application, so when this application is trying to connect to PostgreSQL database, it is trying to connect to the version on my local machine. So what I'm going to do is I'm going to hit start and I'm going to head over to services on Windows, and I'm going to stop the service for PostgreSQL. So I'll scroll down, and somewhere over here you will find this database service, you can see. And can you see it's running over here? So I'll just stop this. I don't need this service. Okay, this might happen. So if you have an instance of database installed on your system, manual, like non-Docker instance, okay, you have installed it on your local machine, then there is a possibility like the application is trying to authenticate with that instance, and that is why you might be getting this error. Now let me try running this. Since I have shut that instance, let me see what happens. Okay, so I don't think I'm getting an error now. The application is up and running. Okay, no error now. You can see all the instances are up and running. So indeed, that was the issue. It was trying to connect to the local instance of PostgreSQL and not the Docker version. And since that local instance is shut, you now have only one thing running, which is the Docker. Okay. So now if you see over here, you can see like in order here, you can see the Hibernate related logs, which means the database is created, the tables is being created. For product also, if you see over here, you can see like everything working absolutely fine. You can see Hibernate related logs over here, the tables being created. You can see products table being created, and the service is also running on this port. So this is the port over here, 8081. For order, this was the port. So if you scroll down, 8083. And for user, if you scroll up, you can see user related tables are also being created over here. Okay. And if you scroll down here, you're going to see the port also appear, right? So this is working absolutely fine. All three applications are running fine, and they are being able to connect to the database. Now, if you come over here, you can see a lot of activity here in the graphs, right? In the pgAdmin, right? You can see quite a few activity. In product also, you will see activity. Okay, we are not seeing any activity in product and user. Not sure, but in okay, the activity went. So if you select databases, now it's not showing the activity. Okay, it's probably we switched a little late to this tab, and that is why that graph is updated. All right, but if you go to user database over here under schema, if you go to tables, you will see address and user table over here. Okay, if you expand the product over here, you go over here to schemas. Let me expand under public. You'll see tables, you'll see product table. Okay. And if you go to order, you'll again see the table for, let me expand, table for cart item, order item, and orders. So indeed, all three microservices are able to connect to separate databases. Now you can also host this on different instances, but since we are on local host, in a single instance of PostgreSQL, I'm having 3 databases created, but you can make sure that they point to different databases in the cloud or different databases locally. All that stuff you can do. Okay, because they have their own set of dependencies, they have their own set of configurations, so you can point them to whichever DB you want. All right, so I hope you have been able to follow along, and I hope this has been useful so far. Now, once we have the connection established with the databases, it's time that we test our application. And we need to do an end-to-end testing. So I'll come over here to Postman. I'll close all the tabs. Okay, we'll go service by service. Okay, so all the services are up and running. You can see over here. Okay, all the services. You can see the logs as well. Come over here. We'll start with the user service. So I'll try to create a user. Okay, and first of all, I'll expand user DB. And we'll verify that no user exists right now. So you can see over here, all rows. You can see no user exists. And if you go over here and say all rows, no address exists. Now if I send this request over here to 8082 and let me create a user, you will see 200 okay. And now if you come over here and if you try to refresh or if you try to execute the script for address, you'll see one address added. And for user table also, you will be able to see like one user has been added over here. Okay, something like this. And this is done. Okay, so I'll try to get all the users. You can see you will be able to get all the users like so. You can get a single user as well. Okay, provided you pass in the ID, that this will also work fine. And you can even update the user. Okay, so I'm passing in John updated and Doe updated over here. And if I send this, and if you come to database, you can see right now it's John 2, Doe 2. So if I rerun this, you can see John updated, Doe updated. So the queries are working fine and even the updations are working fine. Okay, so user is done. User is working absolutely okay. So I'll collapse this database and I'll close all the tabs over here of the database queries. Now coming to Postman, I'll close all the tabs. I'll collapse user. I'll switch over to products. Now let us try creating a product first of all. And before creating, I'll first check if there is any product exists in the database. So here under product, if you go to schemas, public, tables, under product, you will see no data over here. So I'll just create a product. Let me create. Product is created, success. And if you try to run this, you'll see one product is being added. You can see this is the product. Okay, come over here. I'll try to update the product now. Update it with this name, iPhone Pro 16 Pro updated. So you can see over here, this is the name right now. The name is iPhone 16 Pro. If you run this, you'll see, if you scroll right, iPhone 16 Pro updated, right? So this is working absolutely fine. You can get all the products. You can search for a particular product with a particular keyword. You can update the keyword to something else and you won't get any response. Okay, all that is done. Okay, you can delete the product as well. So let me delete this product with ID 1. And if you come over here, if you try to query again, you won't find any records. Okay, actually the deletion means just updating this flag of active to that of false. So yes, that updation is working fine because initially the flag was set to true. Okay, so this product is marked as deleted by updating the flag. Okay, so this is working fine. Product is working fine. I'll just collapse this and I'll just close all the tabs over here. And now I'll test for carts and orders over here. Okay, I'll just open up. I'll just open this add product to cart. I'll come over here. I'll close all and I'll head over to order. And I have these 3 tables, right? So first we'll take a look at cart item. There's no cart item added. So I'll just add this cart item. Okay, I'll say add. You can see it's created. And here now, if you run this, you'll see it's created. Okay, it's working fine with all the fields coming in. Now, what you can do is you can get the cart. You should be able to. Yes, you are able to. Okay. And you can try to delete as well. So if I delete this, now you have one item in the cart. If you run this, you won't have any item. So it's working fine, right? Now I'll add one product to the cart so that we can test orders. I'll close all the tabs after adding it. And then I'll switch over to order. I'll come over here. I have the cart, right? I just added it. Now I'll go to orders over here. Okay, so let me close all. I'll go to orders. So you can see there are no orders. Go to order item. There are no order items. Okay, come over here. Just add order over here. So we are adding the order by, we're saying like place an order for user ID 1. And you can see order has been placed with what all items were there in the cart. And you can come over here. Okay. And here in the orders table. So here we have this order table. I'll say execute script. You can see one order, which is confirmed. And now if you go to order items over here and you can run this, you'll see one item has been added. Okay. You can place an order with multiple items as well. That's absolutely okay. But right now we have one order with one item inside it. And that is working fine. Okay. So yes, we are able to test everything and everything is working absolutely okay. You can come over here to logs and you can even take a look at the logs to all the queries that were generated. So you can see for user, which you tested first, you can see insert into addresses. Okay. There was insert into user. First address was inserted and then user was inserted. Then you have this query. Then we did a few select. So you can see, and then in the end, we deleted the address, right? So that also worked fine. For product also, you can see like all the Hibernate related queries that have been generated. You can take a look. Okay. And for order also, you can take a look at all the queries over here. Okay. So you can scroll down and you can see, take a look at all the queries. In the end, we deleted stuff, right? So it's working absolutely okay. Now this delete query that you're seeing in the end for order is because after you place an order, the cart items are cleared, right? So if you go to cart item, the cart item would be cleared. There was an item we added in the cart and then we placed the order. So cart has to be cleared, and that is why this query is coming in. Okay. So I hope you have been able to follow along, and I hope this is clear to you all as to how you can set up microservices and how you can convert a monolith application into that of microservices. And we tested everything and everything is working absolutely okay. So I hope this has been valuable. A quick mention over here that this course is a part of complete Java, Spring Boot, Microservice, eCommerce masterclass over here, eCommerce project masterclass hosted on Udemy. Okay. The link for this you'll find in the description below. You will find the link to the discount coupon in the description below. Okay. So do check that out. So the link will take you to my website over here. And if you click on enroll now, you will get the best possible discount, the lowest price discount at that particular point in time. Okay, and right now this course is available at the lowest price. I've updated the coupons on the website. So please take a look, and always I make sure there is at least one coupon available for my learners whenever they decide to enroll. And yes, Udemy of course has a limited coupon policy. So there is a limit on the number of coupons that I can distribute. So if you're planning to enroll into the full course, if you are enjoying this experience, then please check out the description, the link in the description below. It will take you to this website over here. You can read more about the course, and after enrolling, you get a lot more, like you get 6 months of IntelliJ Pro, lifetime updates, and people who are enrolled into my courses, they know I update my courses a lot. Okay. It's not like you enroll and I forget. It's not like that. I keep on updating with new technology, new versions. So you get lifetime access to all the future videos. And yes, it's a 75-hour plus course over here. It's huge. It has hands-on labs and a lot of other content. So you can see over here. If you scroll down, you should see things like labs over here. Mock interviews. A lot of it is there inside the course. And yeah, we cover a lot of concepts in depth. You have access to notes as well. So it comes with a lot of features as well. So do take a look at this particular course over here. And first, you check the description. You click on the link and go to this website, and then unlock this coupon that you see over here. So this is a coupon right now, but I keep on updating the coupon. So when you are watching the video, you might see a different coupon that is valid at that particular point in time. And yes, there are tons of learners who have enrolled into the course. It is one of the highest rated courses. Bestseller first of all. And being bestseller on such a large platform or global platform like Udemy in this popular niche of Java, Spring Boot and microservices is not a joke. Okay. So there are a lot of learners who have already enrolled, and you can take a look at the ratings. These ratings are real, managed by Udemy. If ratings are on the platform, it's not managed by me. Okay, it's managed by Udemy, right? So it's not on my platform wherein I can go and edit the rating. It's not like that. It's Udemy, and the ratings here are genuine, and these are all genuine learners that have posted a lot of ratings. You can go and check out the real ratings over here from the real learners. A lot of people have upgraded their careers, got better jobs and increments as well. Okay, and you can see there are so many learners, and this count keeps on growing every now and then. Okay, so I hope this will be useful. And yes, of course, this is my website, embarkx.com. Here you will find this Java full stack. This is another course wherein we build. So if you are not familiar with Java Spring Boot, and if you need a portfolio project over here, so we build a full stack advanced e-commerce project over here. We cover everything like React, JavaScript, everything needed for full stack development. So that is this course for. Okay. We also have DevOps course over here. DevOps, you can see over here, this is a DevOps course. And we master a lot of stuff like CI/CD, Terraform, deploy apps to production. And this is a multi-cloud course. We cover AWS, Azure and GCP as well. And then we have Spring Security. If you are facing difficulty with Spring Security and JPA, we have 2 courses for them as well. And we have a lot more. you can check out the website over here. Okay, but what I told you are the flagship courses. So yeah, do check this out, and thank you.